geography. There is something called as the principle of centrality. See, every atom has a nucleus. The moon is revolving around the earth is revolving around the solar system is revolving around the Milky Way galaxy, and this galaxy is part of the local cluster, and this local cluster is part of supercluster, and this supercluster is part of the universe. Now from this portion, okay, see, if you have to understand geography is the study of earth, then for studying geography you need to understand a bit of universe also. So that's why you'll be doing the basics of the universe. But this topic of universe is a mix of science and technology as well as geography. So I will not give much insights about science and technology, but again, whatever science and technology you have studied before, I'll be able to give more inputs than that only. And very, very important thing, don't be lazy now. Take running notes. Because as long as you're taking running notes, you'll be actively listening to the class. To understand geography means the study of the earth. So keeping the principle of centrality in mind, we'll be studying the universe now. Now only that part of the universe we'll be studying which will be useful for geography point of view. Now, if you want to study about the earth, then you have to study a little bit about the solar system. So if you want to study about the earth, you have to study a little bit of solar system. Now if you have to study about the solar system, you have to study a little bit about the universe. Now again, okay, since you haven't done the foundation very well, now geography is study of the earth, but which part of the earth you'll be studying? See, geography is nothing but the relationship between the man and environment. You can say human and the environment. So, since it is a relationship between the human and environment, so geography is equally human. So geography means you will be generally studying about physical geography. So if you want, I'll be sharing my class, okay, handwritten notes also. So in my handwritten notes, the people, okay, my students have written everything whatever I utter from the mouth. Okay. So this is very, very important aspect. In fact, in the first page you should be writing this only. So geography is, because this is very useful when you will be writing the mains examination. Though it is not useful now, but again I am telling you as a passing reference. So geography is equally human. See, even though the physical aspects has been asked in the examination. For example, okay, they have asked the question previously, okay, Pacific Ring of Fire. So you should not just talk about the geophysical aspects of the Pacific Ring of Fire, but also you should talk about the human aspects. Means how these physical aspects are affecting the humans. That is very important. So that is what this man-environment relationship is. In fact, the half of your answer should be human. And what you should be writing in the conclusion. So in the conclusion, you should always have the concern about the environment. So this you pinpoint in the first page itself. So what are the important points here? Geography is man-environment relationship. Geography is equally human, and the conclusion should be always towards the concern towards the environment, environmental destruction, etc. So if you understand these principles, then whatever current affairs might come, you will know what exactly to focus on. So physical aspect, it affects on human, and what will be the effect on the environment. Okay. So these three aspects we'll be focusing on, and if you look at the previous year questions, means especially after 2011, you will see a lot of concerns. Even if you look at the mains examination, you will have a lot of concern towards the environment. You see the paper 3 also, okay, of course environment is there, disaster is there, and even in paper 1, more than half of the questions they show a lot of concern towards the environment. For example, the earthquake is coming, tsunami is coming. they will ask, what are the impacts on the human, and then how the environment will be affected. Okay, so these things you should focus on. So this is what, okay, you should be drawing from current affairs, because whenever you read the newspaper, you'll be confused. इसमें क्या पढ़ना है, क्या नहीं पढ़ना है, क्या याद रखना है, नहीं रखना है. So through the various topics, I'll be telling you what to focus on, what not to focus on. Now next, talking about the universe. Now what is this universe made up of? Keep noting down all these things. So what the universe is made up of? So composition of the universe. If you take the composition of universe, I'll be drawing this diagram now. Now less than 4%, we can round it off to 5%. Round it off. See, figures always you should round it off, because for this examination you have to remember 400 to 500 figures. So you cannot exactly remember all the facts and figures. That's why it's always better to round it off. Now around 5% is matter. That is what you see. The stars, planets, nebula. Nebula is nothing but a cloud of gas, which we'll be discussing later on. Now this is the matter, and 23%, around 23% is dark matter. Now you'll be reading a lot of articles on dark matter. Then you'll be confused what to focus on, what not to focus on. So the dark matter is such matter which is not visible. It is not visible. Now why this is not visible? Because it does not emit light. Then how do you know this dark matter is existing? Because it affects gravity. So we'll be seeing 2-3 examples. So it has gravity, but it is not visible. It does not interact with the light. It does not reflect, refract, diffuse, or absorb light. So that's why it is called as dark matter. So there are certain phenomena here which you'll be studying in science and technology, called as this gravitational lensing, etc. Here also I'll discuss it a little bit. Now there is one more thing. Okay, there is some energy in the universe. Okay, so when you go to a Baba or somewhere, so they'll be saying that यहाँ पे positive energy है, negative energy है. Positive, negative energy कुछ नहीं होता है. So there is something called as dark energy. Now why it is called as dark? Because we don't know anything about it. We don't know anything. This also why it is called as dark? Because we don't know anything. But how do we know it is there? Because dark energy is responsible for the expansion of the universe. Expansion of the universe. Means there is some invisible energy in the universe which is pulling these galaxies apart. The galaxies are running away from each other. So there is some push energy. Now this dark matter is pull because it is affecting gravity. So in very simple sentence, if you don't have any idea about dark energy and dark matter, I'll tell you. For example, this is galaxy 1 and this is galaxy 2. So this galaxy is intact. So this galaxy is not diffusing away. It is held by some energy which we don't know. So it is dark matter. So within the galaxy you have the dark matter, and in between the galaxies you have dark energy. So even if you know these things, great. Now even I want to know how much you know. Yes? See, if you're familiar with all these things, then let me know. I will not be wasting your energy and time by explaining such kind of trivial things. Okay? I want your review. I want you to interact with me. You should guide me, because if you guys were in the class, I would have seen your faces and get to know what you know, what you don't know. Because if you want to know the formation of the earth, what is the earth made up of? You should know the formation of the universe itself. Universe. Now there are various theories, okay, which explain the formation of the universe. Now for example, okay, you guys go to the interview and the interviewer is asking, okay, beta, okay, one familiar question will be, okay, what are the priority areas when you enter into the civil services, okay? Or they can ask you, this question has been asked to me, so they have asked, now what kind of method you will prefer? Okay, will you go for a revolutionary approach or will you go for an evolutionary approach? Evolutionary means slow and gradual changes. Revolutionary means sudden changes. Sudden changes means, okay, one person will be coming on the TV at 8 p.m. and saying that, मित्रों, कल रात 8 बजे के बाद आपका जो भी पुराना नोट है वो पूरा delegitimize हो जाएगा, something like that. That is totally revolutionary, all of a sudden change. Okay, so what will you prefer? When you enter into administration, you want some revolutionary approach or evolutionary approach? See, your answer should be middle path. It should not be completely evolutionary, because evolutionary means slow and gradual changes. Revolutionary means sudden. Okay, so it should be both. Now, what is revolutionary and what is evolutionary in this? Now, if you take the earth, in the earth you have concentric circles. You must have heard this. The core, mantle, crust. They are so beautifully arranged. Again, if you take the solar system, all the planets are so beautifully arranged, right? So, such kind of arrangement must have happened by a evolutionary process. Evolutionary process. And this evolutionary process of the formation of the universe, the pioneers of this are Laplace and Kant. Something called as, they have come up with something called as the nebular accretion theory. Nebular accretion theory. Again, these kind of things, they will not be asking in the examination, but still, okay, you need to have a crux of what is happening here and why I have taken this topic. So, the universe is formed because of this slow evolutionary process. Because of that, things are so beautifully arranged. There is a set pattern for the things. But again, don't you think there is no randomness in the universe? Don't you think there is revolution also in the universe? Sudden changes? Yes. Now, what is this sudden change which happened in the universe? So, this is called as the Big Bang. So, the universe is a byproduct of chaotic processes and slow and gradual processes. Now, if you're going to the interview and they'll be asking, what kind of changes you will do in administration. Sir, okay, I believe in the theory of the universe. Okay, I'm a student of nature. Okay, since I believe that nature is the best teacher. Even in nature, the processes have been revolutionary. Also, they have been evolutionary. In the same fashion, I'll also do changes. So whenever the things demand, I will go for radical changes. And to adapt to the radical changes, I'll also go for slow and evolutionary changes in the administration. So like this. See, Kalyan Reddy, okay, you should be writing the notes. Okay, then only you'll be active. Or else, whatever I am telling, there is a hell a lot of material in the market. It's there everywhere. But still, if you want, okay, handwritten notes, you can message me. Okay, one of my students, have written all these things. I'll send it to you. Okay, because it's handwritten, it's not printed and all. I can't do that clerical work. So it's better. Okay, you write all these things. So the universe is a byproduct of a revolutionary process as well as evolutionary process. Now, what is lying in between, we'll see, right? So, from the Big Bang to the formation of the Earth, it has been around 13.8 billion years. Okay. Now, again, other things you'll be learning in science and technology, but again, I'm asking you. See, everybody knows. You guys told me that you know a lot of things, right? So, let's say assume the universe, the formation point is this. At this point, the universe has been formed. So, this is the point of the Big Bang. Now you all guys agree that nothing can travel faster than light. अगर कोई भी चीज यूनिवर्स में अगर लाइट से फास्टर जाती है, its mass will become infinite. Mass will become infinite. And mass infinite नहीं हो सकता है. तो इसी चीज के लिए तो आइंस्टीन को ओके ये नोबेल प्राइज मिला था. ये तो खोज किया था यही चीज बोलने के लिए कि कोई भी चीज लाइट से फास्ट भागती है तो उसका मास इन्फिनाइट हो सकता है, एंड मास इन्फिनाइट नहीं हो सकता है. दैट्स व्हाई नथिंग कैन ट्रैवल फास्टर देन लाइट. नाउ आई एम आस्किंग यू वन मोर क्वेश्चन. नो, नथिंग कैन ट्रैवल फास्टर देन लाइट. नो, व्हाट इज द एज ऑफ यूनिवर्स? अराउंड 13.8 बिलियन ईयर्स. मीन्स आफ्टर द यूनिवर्स हैज बीन फॉर्म्ड, सी चीजें इस तरफ गए होंगे, इस तरफ भी गए होंगे इन ए स्पेरिकल, दे हैव स्प्रेड राइट इन 3D. तो फिर व्हाट शुड बी द डायमीटर ऑफ यूनिवर्स? मीन्स इस तरफ 13.8, इस तरफ 13.8, मीन्स पूरा कितना होना चाहिए? 13 + 13 26, 8 + 8 16, मीन्स 27.6 बिलियन ईयर्स. So the expanse of the universe, you can say the diameter of the universe, अभी तक किसी को यूनिवर्स का शेप नहीं पता, but let's assume it's spherical in shape. So the diameter of the universe should be 27.6 billion years. ये सही है कि गलत है बताओ? Is this right or wrong? False. See, लेकिन एक गलत है. Sir, the expanse of the universe is 93 billion years. ये नंबर कैसे आया? So यहां से यहां कैसे जंप किया? See, मैं आपको सोचने की मजबूर कर रहा हूं. See, यूपीएससी में आप जितना भी पढ़ लो भैया, आपको 30 क्वेश्चन से ऊपर आप पढ़े नहीं होंगे चीजें. 70 क्वेश्चंस में आपको आपका दिमाग लगाना है, एंड जब भी आप पढ़ते हो आप पैसिवली नहीं पढ़ना है, आपको सोचते हुए पढ़ना है. ओके, यू टू हैव टू कम अप विथ योर ओन एक्सप्लेनेशन. सी, जस्ट नाउ आई हैव टोल्ड यू, यहां पे क्या बताया मैंने आपको? डार्क एनर्जी बताया ना भाई. एक्सप्लोजन हुआ था, बट इवन आफ्टर द एक्सप्लोजन देयर वाज डार्क एनर्जी इनसाइड द यूनिवर्स. And this dark energy is responsible for the expansion of the universe. So that's why nothing can travel faster than light. That is true. So इसके हिसाब से यूनिवर्स का जो डायमीटर है इतना ही होना चाहिए. लेकिन भैया बीच में ना डार्क एनर्जी आ गया, वो यूनिवर्स को पूरा एक्सपैंड कर दिया. That's why the expanse of the universe is around 93 billion years. So सब चीज में लॉजिक लगाना है, एंड जब तक आपको लॉजिक पता नहीं होगा यूपीएससी का क्वेश्चन सॉल्व नहीं कर पाओगे. ओके, सो दिस आर सर्टेन बेसिक्स अबाउट द यूनिवर्स एंड यूनिवर्स फॉर्मेशन. नाउ दिस इज हाउ ओके रफली द यूनिवर्स विल लुक लाइक. लेकिन ए यूनिवर्स कैसे फॉर्म हुआ था? मीन्स यू नो व्हाट आर द बेसिक एलिमेंट्स ऑफ द फॉर्मेशन ऑफ द यूनिवर्स. ओके, लेट्स सी दैट. See, again, you know, whenever you're getting doubt in the examination, go back from the basics. आपको जो भी चीज पता है पहले वो चीज लिखो. अभी मैंने आपको क्वेश्चन पूछा, so what is the matter made of? आपको क्या पता है? See, at least आपको ये पता है ना. See, you have the core, mantle, crust. Core, mantle, crust. Now what are these made up of? Okay, at least आपको पता है. Okay, these are made up of some elements. Okay. Now elements में क्या होता है? In elements में you have the nucleus. Nucleus में you have neutrons and protons, and you have the electrons. So you have the electrons in the fixed orbits. ये चीज तो पता है. अरे ये एटम कहाँ से बने? या न्यूट्रॉन, प्रोटॉन, इलेक्ट्रॉन कहां से बने? राइट. एंड व्हाट इज द मोस्ट सिंपलेस्ट न्यूट्रॉन ओके और प्रोटॉन कॉम्बिनेशन? राइट. सी, the very basic atom is hydrogen, which has proton inside the nucleus and you have this electron. भैया ओके ये चीज कैसे बना, ये प्रोटॉन हुआ और इलेक्ट्रॉन हुआ, ये चीज कैसे साथ में आया? नाउ दीज हैव बीन मेड अप ऑफ समथिंग कॉल्ड एज, सो ये होता है, ये चीज होता है, प्रोटॉन इज मेड अप ऑफ समथिंग कॉल्ड एज क्वार्क एंड इलेक्ट्रॉन जो है लेप्टॉन है. इसके बारे में इन डिटेल यू विल बी स्टडिंग इन साइंस एंड टेक्नोलॉजी, something called as standard model of physics. Very good. Okay, Ritika, Fatima, बहुत बढ़िया. Quark. क्वार्क भी है, लेप्टॉन भी है, आपने लेप्टॉन भूल गया, हाँ, राइट? नाउ what is this quark made up of? So quarks are made up of something called as quark gluon plasma. इतना तो पता है. Okay, very good Rohit. Okay, 2 up and 1 down. Good. Now quark gluon plasma ये किस चीज से बना है किसी को नहीं पता. No one knows. No one knows. Now it is an assumption that there is a light, or you can say energy, and there was humongous amount of energy in the universe, infinite amount of energy in the universe. And this infinite energy has been converted into matter. So basically in the universe there was only energy, and this energy has been converted into mass. And ये वाला फॉर्मूला हम अभी तक यूज करते E is equal to mc², लेकिन जितना सिंपली ये बोलते हो उतना सिंपल नहीं है. तो फिर because you know we know only about the matter in the universe, you don't know about dark matter and don't know about dark energy. So energy, how it has become quark and how it has become, okay, various elements, and how this iron, nickel which is there in the core, silicates, ferrous and magnesium silicates which are there in the mantle, and crust में lighter silicates, ये सब कैसे फॉर्म हुआ ये तो पता है, लेकिन ये नहीं पता है. Now one more question which is related to this, okay, I will ask you, okay, you should answer. अभी इसके रिलेटेड एक्सपेरिमेंट्स, भैया क्वार्क ग्लूऑन प्लाज्मा से क्वार्क बनता है, क्वार्क से प्रोटॉनवा बनता है, ये चीजों का एक्सपेरिमेंट कहाँ पे होती है ये बताओ. Where all these experiments like Big Bang are conducted? Very good. Okay, LHC, Large Hadron Collider. Okay, very good. So about these things you'll be studying more in science and technology. So basically LHC is one of the loops. This facility is called as CERN, CERN, means European Center for Nuclear Research. So once already the question has been asked, CERN में जो भी होता है, जब भी कुछ रेवोल्यूशनरी चीज पता होके आती है, यूपीएससी हमेशा क्वेश्चन पूछता है. सो प्लीज आप ध्यान रखना. सो ये यूनिवर्स कैसे फॉर्म हुआ? सो इनिशियली समथिंग कॉल्ड एज बिग बैंग हैज हैपेंड. So the Big Bang has released energy, and from here the universe has been expanding. यहाँ से universe expand हो ही रहा था. So in the initial stages, the universe was expanding at a accelerated rate. Means the rate of expansion of the universe also varies. कभी कभी बहुत ही expand हो जाता है, कभी कभी कम expand होता है. So this is called as accelerated rate. So initially बहुत ही ज़्यादा expand हो गया था, and this Big Bang, okay, has given rise to energy, and this energy has given rise to something called as quark gluon plasma, and from here the quarks have come, and from the quarks the first element has been formed. The first element is the proton, and also later on the leptons have been created, that is electron, and this is how the hydrogen has been formed. So hydrogen is the basic fuel of the universe. लेकिन जो पहले का जो हाइड्रोजन था, so that was okay located at okay a small location. Later on it started expanding and its hydrogen के clumps बने. It expanded and because of the gravity, so the hydrogen molecules they started coming together, okay, because of the accretion. And when the hydrogen they started coming together, because of the gravity, okay, so whenever the gravity increases, the temperature also has increased. And because of the increase in temperature, the nuclear fusion reaction has started. See, these things I am telling you, ऐसे बता रहा हूँ क्योंकि science and technology में पढ़ोगे आप. So, the hydrogen has come together, okay. Now, what is important as far as our geography is concerned, I will tell you. So, this is how the universe has expanded. So, the first stars have been formed around 400 million years ago. Then later on, the hydrogen, okay, has come together and more nebulas have been formed. Then the galaxies and planets have been formed, and because of dark energy, the universe is expanded. Okay. Now, more about this you'll be studying more in science and technology. So, this is how it started. See, initially, okay, have a diffuse cloud. This cloud is nothing but it is made up of hydrogen. And this clump of hydrogen, this dense gas of hydrogen is called as nebula. And because of the gravity, this nebula will be coming together. So, the center of nebula, you have concentrated hydrogen gas. And this concentrated hydrogen gas will be giving rise to the stars. So, a star will be born in the middle. So, I will explain you the process here. The first stage is hydrogen gas and this is nebula. Then because of the gravity, the gas will come together. So, in between you will have concentrated gas, and because of the concentrated gas, the temperature in the middle will increase. So, temperature will increase. So, because of the increase in temperature, the protons and electrons which are there, now they will start moving at very high speed. So, basically they will be moving in a very zigzag pattern. So, whenever two protons, when they come very close to each other, so when they come very close in a range of 10 to the power of minus 15 meter, because the force between the proton and proton is electrostatic repulsive force. So, you must have heard that likes repel, okay, unlikes they attract each other. So, the proton and proton will be having electrostatic repulsive force, but again if they are coming up with very high kinetic energy, so they will be attached with each other and two protons will be merged into each other. So, when you have an element with two protons, it will be called as helium, and this is called as the fusion reaction. So, this is how in the stars the protons, okay, or the hydrogen is converted into helium. अभी helium किससे टकराएगा? Again एक helium एक hydrogen से टकराएगा with very high speed, okay, almost near to the speed of light. Okay, so almost near the speed of light, then it will be converted into lithium. Then again it will fuse, it will be converted into beryllium, then boron, then carbon, etc. So, this is how the various elements have been formed in the stars. But again, if you want to form an element of higher order, आपको अगर iron form करना है, यूरेनियम फॉर्म करना है, देन स्टार में एनर्जी बहुत हाई होना चाहिए, बिकॉज जितना जोर से आके वो टकराएगा उतना ही वो फ्यूज होगा, और एल्स द फोर्स बिटवीन द प्रोटॉन एंड प्रोटॉन विल बी रिपल्सिव फोर्स. So sun is a very average star. So in a star like sun, see at max you will be forming hydrogen helium. So hydrogen helium will be formed mostly. Even now the composition of the sun, if you take, so it is around 75% hydrogen and 23% helium. And at max, if a sun is going towards the red giant phase, so यहाँ पे आप ओके एट मैक्स कार्बन फॉर्म कर सकते हो. So it must be having little bit of lithium, beryllium, boron, etc. little bit, very traces. But sun is a very average star. तो sun में इतना ताकत नहीं है कि वो higher order elements produce कर सके. Okay? Now I'll be asking you a question. See, अगर sun में या solar system में इतना ताकत नहीं है हायर ऑर्डर एलिमेंट्स प्रोड्यूस करने का, देन हाउ कम द अर्थ, इफ यू टेक द कंपोजिशन ऑफ द अर्थ, व्हाट इज अर्थ मेड अप ऑफ? द कोर इज मेड अप ऑफ द आयरन, मोस्टली आयरन एंड लिटिल बिट ऑफ निकल, एंड द मैंटल इज मेड अप ऑफ द फेर्रो मैग्नीशियम सिलिकेट्स, एंड द क्रस्ट इज मेड अप ऑफ लाइटर सिलिकेट्स. So basically it is made up of silicates and metals. Silicates and metals. The silicate nothing but pathar, rocks and metals. So how come the rocks and metals have been formed in the earth? In fact, most of the earth is made up of these rocks and metals only. So ये कहाँ से आया? Can you tell me? भाई सोलर सिस्टम में तो इतना ताकत नहीं है. वेरी गुड रितिका. ओके, सी आई टोल्ड यू, ओके, एवरीथिंग इज लिंक्ड विथ ईच अदर. सी जब सोलर सिस्टम फॉर्म हो रहा था सम टाइम इन द पास्ट, से दिस इज द सोलर सिस्टम विच इज इन द फॉर्मेशन स्टेजेस. So the time of formation of the solar system, okay, because earlier the universe was not as big as it is today. So somewhere in the vicinity of the solar system, so there must have been a supernova explosion, okay, or there must have been the collision of the neutron stars, or there must have been novas, etc. If you are getting confused of all these things, don't, okay, basically supernova means सोलर सिस्टम के विजिनिटी में, पास में इतना बड़ा धमाका हुआ, मीन्स इतना एनर्जी मिला स्टार को कि हाइड्रोजन ओके कन्वर्ट हो गया आयरन में. द हाइड्रोजन गॉट कन्वर्टेड इनटू हायर एलिमेंट्स सच एज यूरेनियम, थोरियम एक्सेट्रा. एंड ये विस्फोट होने के बाद, सो आफ्टर द एक्सप्लोजन हैज टेकन प्लेस, इसके टुकड़े आके सोलर सिस्टम में गिर गए. So sometime in the past you had a solar system which is mostly made up of hydrogen, means you had mostly hydrogen gas, and बहुत सारा hydrogen gas got concentrated in the middle and it has formed the star called as sun. And in the vicinity of the solar system के पास you had some supernova explosion, and because of that supernova explosion वहां से आके पत्थर आके सोलर सिस्टम में गिरे. यहां randomly सोलर सिस्टम में आके पत्थर आके गिरे. Now what will happen? The 99.9% of the mass is located in the sun. So the gravity will be towards the sun. So gradually what will happen, आपने स्कूल में सुना होगा, जैसे एक ग्लास में आप तेल ले लो, पानी ले लो, उसको शेक करो, थोड़ी देर के बाद उसको सेटल होने दो, तो क्या होगा? तेल ऊपर आएगा, पानी नीचे जाएगा. In the same fashion, after this event, in the solar system, the sun will be there as it is in the middle, and all these rocky fragments, they have come near. जितने भी पत्थर है, जितने भी सिलिकेट्स है, रॉक्स एंड मेटल्स, वो पास में आ गए, and the rest of the gases, the rest of the hydrogen, it was here. It was here. Okay, so this is the scheme. You can see here. Basically something of this sort. You can see it here. So somewhere in the middle, okay, you have the sun and you have a lot of rocky fragments. Now what these rocky fragments will do, these rocky fragments, they also will be attracted with each other. So because of the gravity, and they will hit each other. So when these rocks come together, they hit each other, enormous amount of energy will be released. And this energy is sufficient enough to melt the rocks. जब पत्थर आके टकराएगा क्या होगा? Rock melt हो जाएगा, and these rocks will be fused into each other. And छोटे छोटे पत्थर जो है एक दूसरे से वो टकरा के after collision they will melt and they will form a bigger rock. Okay, now see, okay, with this knowledge you have, if I am asking you why the planets rotate on their axis, can you tell me the reason? From where the planets have achieved rotation? See, collision, see, if the planets are colliding with each other, head on collision, सीधा सीधा के collide हो रहे एक दूसरे से. So rotation will not be achieved. But if they are having oblique collision, for example, you have an object like this यहाँ पे, and दूसरा object यहाँ पे ऐसा है, ये वाला fragment. So ये आके अगर यहाँ पे टकराएगा, oblique collision होगा, then they will start rotating. So that is how the planets have achieved a rotation. It's because of oblique collision, not head-on collision. सीधा सीधा collision नहीं ऐसा. For example, okay, two people are walking towards each other. So एक आदमी दूसरे आदमी को ऐसे कंधे से ऐसे टकराएगा तो दूसरा आदमी घूम जाएगा ना. So वैसे ही planets घूमते हैं and they have achieved the rotation. Now after this, numerous planetesimals, these are called as the small fragments of rock. They are called as planetesimals. So these planetesimals, they have collide with each other, and because of the heat, they fuse into each other and they have become bigger. So ultimately they have become bigger and the current modern day planets have been formed. Now here again let's go back to this diagram here. So you see in green, so जितने भी पत्थर थे वो सन के पास आ गए and ये पत्थर एक दूसरे से फ्यूज होके they have formed the terrestrial planets, or we can say rocky planets. Now beyond this you also have the gases. Now, these are the lumps of gas, and these gases will also collide with each other. So since they are far away from the sun, so they are icy, means OB solid hai because of the low temperature. So they will also collide with each other and they will also form the spheres. So these lumps of gas, they have formed the Jovian planets. Jovian means Jupiter-like. Means these are also called as the gaseous planets and these are called as the rocky planets. So this is how the solar system has been formed. So this is how they have been arranged. So you can see here, if you look at the size of the terrestrial planets, the size is very small. Means the rocks were very less. Rocky planets are, and the gases have been formed. They have been formed as the Jovian planets. Means gaseous का मात्रा ज़्यादा था and rocks का मात्रा कम था. Now don't you think in between these two, there should be a belt where these rocky fragments were unable to collide with each other? Means either they were very small objects or the gravity is not sufficient enough to collide them. Okay, so Adhiraj Pratap Singh is asking, after the supernova state, neutron or black hole is created, so rock are formed in between. Okay, yeah, you're true. So in between these two, in between the gaseous and the terrestrial, you'll be having the rocky fragments which are unable to fuse with each other. Okay, and they are randomly revolving around the earth, and this is called as the asteroid belt. So in asteroid belt, you can say you have the planets which could not be formed. Okay. Now don't you think after this also you should be having a belt which could not form the planets, but these are made up of gases. So here we'll be having the gaseous fragments which could not become the planets. And this is called as the Kuiper belt. And the Pluto is part of the Kuiper belt. So there is an order in the universe. So in between the solar system, you have a very heavy object, सबसे भारी. उसके बाद then ये पत्थर है. पत्थर के बाद fragmented पत्थर है, which could not form the planets, terrestrial planets. उसके बाद gaseous planets है, हल्के वाले. उसके बाद छोटे छोटे gaseous fragments, icy fragments, okay, which could not form Jovian. Then इसको beyond क्या होगा? And beyond this Kuiper belt, you'll be having protons, neutrons, etc. Protons, electrons and neutrons drifting in the universe. And it is called as the plasma state. You can see how beautifully this universe has been created. Okay, then rocky. Then you have a belt, fragmented rocks called as asteroid belt. Then you have Jovian. Then you have the Kuiper belt. Then you have the plasma. So plasma mein you have the protons, electrons, neutrons drifting like that. And beyond this, you'll be having one more star also. Somewhere far away, you'll be having one more star. And the space between the stars is filled with this interstellar medium. Interstellar medium. जैसे इंटरनेशनल होता है, जैसे इंटरस्टार होता है, interstellar. So interstellar is basically made up of your plasma. So as in when you go towards the sun, okay, यहाँ पे क्या है? प्रोटॉन इलेक्ट्रॉन ड्रिफ्ट हो रहे हैं. यहाँ आने के बाद क्या होगा? प्रोटॉन इलेक्ट्रॉन जोड़ के हाइड्रोजन बनेगा, लेकिन हाइड्रोजन भी ड्रिफ्ट होता रहेगा. उसके बाद क्या होगा? ओके, वो प्लैनेट्स फॉर्म होंगे, गैसियस प्लैनेट्स. उसके बाद क्या होगा? रॉक्स फ्रैगमेंटेड and afterwards rocky planets. Okay, see, Ayush is asking what is plasma. Plasma is nothing but if the proton, electrons or neutrons are drifting apart, means यहाँ पे इतना भी ताकत नहीं है कि प्रोटॉन इलेक्ट्रॉन के संपर्क में आए, वो भी दूर दूर भाग रहे. एंड जब भी आप नजदीक आओगे वो सारी चीजें जुड़ जाएंगे, because the gravity is very heavy that they will collide with each other. So यहाँ पे क्या एस्ट्रॉइड में क्या हो रहा है? आपका पत्थर है, अलग अलग ड्रिफ्ट हो रहे हैं ना. पत्थर जोड़ने का शक्ति नहीं है, उतना नहीं, पावर नहीं है यहाँ पे. सो क्यूपर में क्या हो रहा है? गैसेस को जोड़ने का शक्ति नहीं है. उसके बियॉन्ड भी जाओगे आप, प्रोटॉन इलेक्ट्रॉन जोड़ने का शक्ति नहीं है. अंडरस्टूड? So Kalyan is asking, how did planets achieve definite path and why don't they collide with each other? See, इसका बहुत सारा theories है. That is called as the string theory. See, आपने okay, for example, if you study the quantum physics, आपने quantum physics में पढ़ा होगा या chemistry में भी आपने पढ़ा होगा. See, electrons जो होते हैं ना, electrons, see, this is proton, neutron, nucleus. Now, are these electrons randomly arranged anywhere? No, na. There are certain orbits. This is also called as quantization, and this is one of the fundamental principles of the quantum physics. In the same fashion, okay, somebody is saying what is ether. अभी उन सब चीजों में मत जाओ आप. ether क्या है, वो सब क्या है? Because ether मतलब there is a theory that ether बोल के एक medium है and उस medium में okay you have this universe. Again string theory again दूसरा बोलता है. तो string theory क्या बोलता है? String theory बोलता है कि universe is like the cloth, a stretched membrane in the universe. So ये वाला एक stretched membrane है, ये universe है. And उसमें ना ये सब पत्थर ये सब रखे गए, planets रखे गए, आपके stars रखे गए, वो एक theory है. So many theories here. So there is one question here. Stars have their own light, okay, emitting state, but planets don't. Then how are they part of stars or supernova stage? So let me get your question rightly. Stars have their own light because inside the stars you have nuclear fusion reaction. The stars are able to emit energy. Stars have nuclear fusion, they are able to emit energy. So inside the planets, they are not emitting energy. That's why the light is not emitted. Okay? And supernova, how a star becomes supernova and all, okay, you will study in science and technology. I will not be dealing that with right now. Okay? So there is one more question here. If a temperature is less than, how plasma state is possible, sir? Okay, Shanu is asking a beautiful question. See, in the plasma state, the temperature is, plasma state you have these protons, neutrons, electrons drifting away from each other. See, universe कैसे form हुआ था? The formation of the universe started from quark, gluon, plasma, and they have formed this. So after this you require some energy to combine all this together. To combine them together. Then they will be coming in contact with each other. अब ये प्रोटॉन न्यूट्रॉन साथ में आने के लिए या प्रोटॉन एंड प्रोटॉन साथ में आने के लिए they have to overcome this you have to overcome this electrostatic repulsive force, and the nuclear attractive force have to come in picture. Till the time the proton and proton does not come up with very high energy and they collide, they won't come near to each other. So this is how they have been formed. Okay, so in your mind, plasma state means high energy state. आपका प्लाज्मा मीन्स हाई एनर्जी, राइट. ये सब फॉर्म होने के बाद सी वंस द एटम्स हैव बीन फॉर्म्ड, अब इसको तोड़ना है ना, तोड़ने के लिए एनर्जी चाहिए. So plasma is ionized gas. What is ionization? Nothing but kicking off the electron. इलेक्ट्रॉन को किक ऑफ कर दिया, अभी एक प्रोटॉन यहाँ पे आ गया, एक इलेक्ट्रॉन यहाँ पे आ गया, इसको बोलेंगे प्लाज्मा स्टेट. सो इसके लिए एनर्जी चाहिए. सो आफ्टर अचीविंग दिस अगेन यू हैव टू गिव एनर्जी तोड़ने के लिए. मीन्स यूनिवर्स में जोड़ने के लिए भी एनर्जी चाहिए, तोड़ने के लिए भी एनर्जी चाहिए. So every process, okay, so every process is exothermic or endothermic. Okay, this way. Your doubt is clear, Shanu? Now let's get back to this. So this is how, okay, they have been formed. And one thing which is very important here is, now I have to use red color here. See, again, one thing is very standard in geography. सी ब्लू के लिए अभी तो ठीक है, लेकिन क्लाइमेटोलॉजी में आई विल बी यूजिंग ब्लू कलर टू ओके इंडिकेट कूल टेम्परेचर एंड रेड कलर हाई टेम्परेचर. नाउ आई एम यूजिंग रेड हियर, प्लीज एक्सक्यूज मी. सी according to the nebular accretion theory and planetesimal theory, so these are the planetesimals, and these planetesimals, because of gravity they have come together, and then because of high energy these are the rocks are molten in stage. Rocks are molten here, and then this has achieved rotation, because all the collisions will not be head on. Okay. So I'll turn it to whiteboard. So because of the oblique collisions, okay, it will achieve the rotation on its axis, and then this red ball will become spherical in shape. Now once it has become spherical in shape, it will start losing the heat. So when it will be losing the heat, so gradually it will become cooler. The outer layers become cool over a period of time, and inside the earth, deep inside the earth, you still have a lot of heat trapped. And this heat which is trapped inside is called as the residual heat. Residue means bacha hua. Yes, you are right. Adhiraj, okay, recently China has achieved, okay, the plasma state. No, China, okay, tokamak is a Russian technology, but China is using, okay, entirely different technology. So China is able to achieve even before what, okay, the sun was able to do. That is a different thing altogether. See, the heat which is trapped inside, it is called as the residual heat. And it is this residual heat which is responsible for various geological phenomena. Means a heat को बाहर निकलना है, ये heat कैसे बाहर निकलेगा? The heat बाहर निकलेगा volcanism से, right? So when the volcanism happens, the plate tectonics also happen. So the volcanism, the earthquakes, the plate tectonics, all this happen because of this residual heat. जब तक ये heat earth के inside है, all the geological processes keep happening. And the job of the geographer is not to study the processes inside the earth. Means जितने processes surface को affect करता है, man environment relationship को affect करता है, only those processes the geographer has to study. That's why a geographer also becomes geologist to certain extent. So they'll be studying the processes only to certain extent which affects the surface. So that's why in geography we'll be studying the processes such as volcanism, earthquakes, okay, the plate tectonics, etc. Or else geographers should not be studying. Rather geomorphologist padega unko, or rather geologist padega. Okay, understood? So only one thing which is important in this entire chapter as far as pure geography is concerned is this term called as residual heat. Now this heat which is trapped, okay, are you guys following me? Any doubt please ask me. Abhi tak koi doubts hai? Are you able to follow? Now the heat which is trapped inside the earth. So whiteboard is fine as compared to the blackboard. So these are all the cooler layers. So inside you still have a lot of heat trapped, and this is all the residual heat. And somehow the heat has to be dissipated. The heat has to be emitted outside. And what are the various ways of heat transfer? There are three ways of heat transfer. One is the conduction, convection, and radiation. See, conduction means layer by layer the heat will be emitted out. Okay, layer by layer the heat will be emitted out. This is conduction. Now, conduction is, so blackboard is more legible. People are saying blackboard is better. I'll shift to blackboard again. You guys are playing with me. Huh? Sure. Now, but here the problem is rock is a very bad conductor of heat. Rock is a bad conductor of heat. That's why the conduction as a process to emit the heat outside is not that effective. Next, what is the other process? Radiation. So radiation भी एक process है, but again the radiation is not that effective. Why? If radiation has to happen, things has to be transparent. अगर earth glass के जैसा होता, transparent होता, then radiation would have been effective. अभी earth transparent है क्या? No, it is opaque. That's why radiation is also not that effective. Now what is the most effective way of heat transfer? Convection. In convection what happens? The molten rock has to move, means the particles will be moving to dissipate the heat. That's why whatever molten rock which is there inside, a पिघला हुआ पत्थर जो भी अंदर है, वो खुद बाहर आके हीट को emit करेगा. And जब भी ये बाहर आता है, उसको बोलते हैं volcanism और ज्वालामुखी. And whenever this volcanism happens, इससे सारे process शुरू होते हैं. Say these are the layers. So this is say upper layer lithosphere. And from inside, this volcanism is coming. This molten rock called as the magma is coming. So it will be rupturing this, puncturing this, and then it will be coming out. लेकिन सारा ही material बाहर नहीं निकल पाएगा. Some material will start flowing under it, underneath. तो जितना भी आएगा बाहर flow नहीं कर पाएगा, थोड़ा बहुत नीचे से flow करने लगेगा. And when this flows sideways से इधर से जब खिसकेगा, so it will start dragging this plate apart. So it will start dragging this apart. So they will be moving away from each other. And when they move away from each other, इसको बोलते हैं plate tectonics. Plate tectonics means the movement of the plates. And the movements of the plates, okay, is also called as this continental drift. Later on, okay, continental drift theory has come. Now, हर समय the movement of the plates is not smooth. There will be friction, there will be tension, and जब भी ये tension release होती है, you will be having earthquakes. So, for earthquakes, for plate tectonics, for continental drift, what is responsible? The magma which is there inside, the heat which is trapped inside, or the residual heat is responsible. Now I am asking you a question. Acha, what is asking me? Convection I have missed. So in convection, again, see, you can see, I'll be wasting everyone else's time. See, these are the three ways of heat transfer. Okay, conduction, convection, and radiation. Rock is a very bad conductor of heat. That's why conduction is not an effective way of releasing the heat outside. And radiation, because the earth is opaque, it's not transparent. And convection is the very effective way of heat transfer. The convection means the molten rocks which are there inside, they'll be coming out in the form of volcanism. So, a planet is said to be alive only when it has a residual heat inside. Okay? So, what is a dead planet then? Dead planet is not about life. Dead planet matlab that planet which does not have plate tectonics, which does not have the volcanism, which does not have the earthquakes. And a lot of research, okay, related to this is happening, okay, on the this Mars, and also Moon. Some experiments are happening around 4.6 billion years ago. This was around 4.6 billion years ago. So at that time, the Earth was red hot. It's all molten. So over a period of time, it started cooling, and this is the present phase. And these are the interiors of the Earth. So inside the Earth, you still have a lot of heat trapped, and this is heat is called as the residual heat. The outer layers have been cooled. Okay. Now let's see, okay, some of the features of these planets, some of the major features of this planet. Okay. So till now, any doubt here? So what all things you have to remember here? The things which you have to remember here is residual heat, very important. So residual heat is responsible for all the geomorphic processes. If the residual heat is there, you'll be having magnetic field. If the residual heat is there inside, the plant is alive, or else it is dead. Okay. Again, this is basic. Okay, they will not be asking this in the examination. No need. And from here, okay, planetesimal theory, as far as prelims is concerned, they will not be asking this. But you should know what is responsible for this residual heat? The collision of these planetesimals. And why the planetesimals have collided with each other? Because of gravity. And plasma, etc. These are all, science and technology point of view. Geography point of view, only one thing which is important is this. Now again, sometimes they might ask, what are some of the important features of various planets? Okay. So we'll see some of the important features of the planet. Now the first planet is Mercury here. Now one thing which is very important with respect to Mercury is see, Mercury is the nearest planet, but Mercury is not hottest. It is not the hottest planet. The hottest planet is rather Venus. Now, the Mercury hardly has any atmosphere. Why? Because more about this you will understand in the interiors of the earth. We'll be doing a chapter called as interiors of the earth. We'll be doing magnetism. There you will understand this. So here the solar radiation is so intense that it has stripped away whatever little atmosphere it had. Means the rays which are coming from the sun, they are so intense, means पूरा strip कर दिया, पूरा यहाँ से gases पूरा निकाल दिया. That is one reason. Second reason is Mercury is so tiny that it has very less gravity, and this gravity was not able to hold the gases together. Okay. And thirdly, Mercury hardly has any magnetic field. See, जब तक magnetic field है, the gases will be intact. But why the Mercury will be hardly having any magnetic field? The size of the Mercury is so small, therefore the residual heat which is supposed to be there inside, it has been dissipated out. So that's why you will not be having a molten core. So the Mercury does not have any molten core. If the core is not molten, then magnetic field will not be there. So magnetic field is almost absent. And it does not have a molten core, if does not have a residual heat, the planet is considered to be dead. So it will not be having much of this activity such as volcanism, etc. Again, if in the examination, if they are saying that recently the volcano has been observed on the surface of the Mercury, etc. See, I am telling you one trick here. See, any point which has a future scope of discovery, if a UPSC is giving, mark it right. If you know this trick, you will be able to answer at least 10 questions. See, science has a lot of possibility and future discoveries have happened. So through various topics, I will be telling you what all points can be asked. And one more point, it is heavily cratered. Why it is cratered? Because being near to the sun, it has very high gravity. So because of the gravity, lot of planetesimals have collided with Mercury. So itna वहाँ पे collisions हुआ. Very near to the sun, a lot of collisions have taken place. That's why it is heavily cratered. And of course, it will be having extreme temperature. Daytime, nighttime temperature is very extreme. So Venus is the hottest planet because it has, its atmosphere is around 96% CO2. The CO2 will be trapping a lot of heat, and the Venus is also called as Earth's twin because the size of the Venus is almost similar to Earth. That means the Venus should be having a lot of residual heat inside. The heat must be trapped inside because the heat which is trapped inside depends upon the size. अगर कोई planet का size कम है, छोटा है, तो heat जल्दी भाग जाएगा अंदर से. अगर कोई planet बड़ा है size में, a lot of heat will be trapped inside. So since the Venus is called as Earth's twin, inside the Venus there is lot of residual heat. Then extremely weak magnetic field, and Venus has high temperature. In fact, it is the hottest planet because 96% of Venus is CO2. And third thing which is important about Venus, since it has very slow speed of rotation, it will be having extreme diurnal range of temperature. That means daytime it will be extremely hot and the night time it will be low. And Venus is also called as evening star. Why? Note all these points. Venus is also called as evening star. Why? So Venus has high albedo. Of course, it will be shining a lot. That's why it is called as evening star, and it's because of albedo. Why high albedo? Because of SO2. Remember this. So this is not just useful for the Venus; it is also useful for the Earth. कहाँ ये काम आएगा? Where all you can use this? See, whenever you have this SO2 in the atmosphere, it will be having high reflectivity. Venus has high SO2 reflectivity, that's why it shines, appear to be shining, that's why it is called as evening star. Now for example, okay, you want to reduce the temperature on the surface of the earth, means sun का heat जितना भी आ रहा है उसको reflect करवाना है. So there is some process called as cirrus cloud thinning. Cirrus cloud thinning. So in this process, you will be spraying a lot of SO2 in the upper clouds. Okay, in the stratosphere also you can spray. So the earth will also increase its reflective capacity and earth can become little bit cooler. Okay, this process is called as cirrus cloud thinning, and it is also called as geoengineering. So geoengineering is a term which is used when there are large scale changes on the surface of the earth. It is called as geoengineering. For example, you are installing solar power panels on the entire Sahara, geoengineering. If you are doing a very large scale afforestation, geoengineering. If you are painting a very large surface area on the earth white in color so that the albedo of the surface increases, geoengineering. If you are using jute, in the edges of the Sahara desert so that the sand will not spread further, geoengineering. So any large scale changes on the surface of the earth is called as geoengineering. This is called as cirrus cloud thinning, and it happens when there is SO2 in the atmosphere. Remember this. And these are the points which are important with respect to the Venus. And next point which is important, I am telling you the most important points which can be asked in the examination. Next is moon. So very important points about the moon. So the moon is more about this, you will be studying in science and technology. Moon is tidally locked, that means you will be able to see only one side of the moon. And secondly, the moon has extremes of temperature. Extremes of temperature. So this is also the reason why the scientific equipment, for example Chandrayaan-2 or Chandrayaan-3, when you are sending them, they have to work at extremes of temperature. During the daytime, the temperature will reach to 150 degrees centigrade, and at night time they will go to minus 120 degrees centigrade. So they have to sustain a range of around 200 to 250 degrees centigrade temperature. So in this range, it will become very difficult for the equipment to wake up again. This reason. And the moon equator is comparatively warm, and the poles of the moon have water. So this is also the reason why we are launching our missions. तो जब भी आप Chandrayaan-2, Chandrayaan-3 लॉन्च करते हैं, अब मून के साउथ पोल में जाके लॉन्च करते हैं. क्यों? Water availability होती है. So when you have the water availability, so in the future you can establish a station over there, because for humans the water is very important. And how the moon has been formed? The moon has been formed out of the earth around 4 billion years ago. How? So the earth was there, a very big asteroid has come and hit the earth, and the particles which have come out of the earth have collided with each other and they have formed moon. So this surface composition, or the elemental composition of the moon is very much similar to the earth. So these are some of the important points with respect to moon. So next one is Mars. So next one is Mars. So Mars has an average temperature of around minus 67 degrees centigrade. It is cooler. And Elon Musk wanted to establish a colony on Mars by 2022, but it could not happen because of COVID and various reasons. And Mars has a lot of winds, heavy winds. That's why landing on the Mars is very difficult because of these winds. And Mars is called as red planet because of lot of iron content. Again, remember this. So wherever you have heavy iron content, it will be red in color. Remember this. Iron, specifically iron oxide, FeO. So again, the Mars has a volcano which is around 27 kilometers tall. And it is extremely huge, and it is the largest volcano on the solar system. called as Olympus. So Mars has that largest volcano in the entire solar system. That means once upon a time Mars was also tectonically active. But today Mars is not tectonically active. Why? You can tell, answer. Once upon a time it was tectonically active. Means Mars, okay, was as good as Earth around 2.5 billion years ago. But today it is not. Why? Mars had everything. It had rivers, it had oceans, it had rainfall, and probably it must have had life. But today, no. Very good, Ritika, excellent. Because the Mars is comparatively smaller in size as compared to Earth. That's why it must have lost all the residual heat. That's why whatever volcanoes have been made around 2.5 or 3 billion years ago, they still are there. And Mars has lot of fluvial landforms, lot of alluvial landforms. Okay, so whatever deltas which are there on the Earth, the U-shaped valleys, canyons, etc., which are there on the Earth, you'll find on Mars also, because once upon a time it was just like the Earth. But now the core has been cooled. Even when the core is cooled, when you don't have a liquid core, it will be having almost zero magnetic field. Okay, so these are some of the important points about the Mars. Now after Mars, okay, you'll be having a belt called as the asteroid belt. So all these points are important for the prelims. Note down all these points. So this is where you have the Mars, and here you have lot of fragments, rocky fragments. They could not be collided with each other because of very less mass. Mass is very less. And these are also called as time capsules. Why? So whenever this word comes, time capsule, because UPSC has this strange habit of asking questions. For example, they'll be framing 4 options like this: time capsule. It is a capsule, okay, created by Brian Johnson, which has become very popular in the school of reverse aging. First option. Okay, second option. Okay, time capsule, okay, is a drug which has been created with the help of Ozempic and Monjaro, okay, which has wonderful results, okay, in diabetes and hypertension. Okay, option C. Time capsule is such a planetesimals which can be used in studying the formation of the universe or the solar system. Option D, none of the above. So like that they'll be framing. Now these time capsules, see, if you study these planetesimals, very good, okay, so Rohit, you're good, frozen records we can say. See, these could have become planets. For example, imagine the size of the sun is larger, say size of the sun or mass of the sun is 2x as it is today. So in this asteroid belt also you could have had a new planet. Since the size of the sun is not that much, and because of the less size of the sun, the gravity is not that much that they could collide with each other, a new planet could have been formed. That means we can say these are the remnants of the earlier planets. Now nowadays we are showing a lot of interest to study this asteroid belt because one reason is commercial. Means here in this asteroid belt you have some asteroid which are completely made up of carbon, such as Bennu. पूरा कार्बन से बना हुआ है, and this is a primitive carbon, means the carbon which has existed around 5 billion years ago. अगर आप एक कार्बन को जाके पढ़ेंगे आपको पता चलेगा लाइफ कैसे evolve हुआ है, because life on the surface of the earth is predominantly hydrocarbons and carbon is very important. Okay, first is the commercial aspect. The second one is in this asteroid belt. Okay, so since this asteroid belt is nothing but fragmented planetesimals, there are some planetesimals here which are completely made up of iron, which are completely made up of rare earth, which are completely made up of gold, diamond, etc. Now, okay, we have sent some missions. NASA ने एक मिशन भेजा, बेनू पे गया, सैंपल उठा के लेके आया. Imagine in future a technology will come where एक रॉकेट टाइप इंस्ट्रूमेंट जाएगा यहाँ पे, वो पूरा ओके गोल्ड से बना हुआ या प्लैटिनम से बना हुआ या रेयर अर्थ मेटल से बना हुआ एस्ट्रॉइड को खींच के लेके आएगा अर्थ के ऊपर. So in the future mining can also be possible. This is the commercial aspect. And the scientific aspect is we can study the evolution of the universe or evolution of the solar system. So Adhiraj is asking a question, why Mars couldn't restrain atmosphere and inhibit water and rainfall patterns similar to Earth when they both, similar situation. See, Mars is comparatively smaller in size. The Mars has 1/3 of the mass as compared to the Earth, and residual heat बचा ही नहीं उसमें. When there is no residual heat, there will not be any magnetic field. Understood? The asteroid belt, millions of rocky remnants from the solar system, okay, role in planetary evolution. Okay, the Kirkwood gaps, okay, this point you can note. Again, such kind of questions can be asked. See, the objects in the asteroid belt, okay, are not uniformly arranged. Because say, okay, there is a big planet over here. So the big planet will be having certain gravitational pull. So it will be clearing certain gaps in the asteroid belt, and these are called as Kirkwood gaps. It's because of Jupiter's orbital resonances or Jupiter's gravitational field. And asteroids vary by size. There's called as Cirrus, 940 kilometers in diameter is the largest. Most of them are under 1 kilometer. You'll be having type C, means you'll be having completely carbonaceous. You'll be having S type means silicates, patthar, rock se bana hua hai. Okay. So of course in the inner belt you'll be having this. You'll be having X type also, metallic also you'll be having. Okay. Anyways, I've explained that. Okay. So inner ores are dry, outer holes hold water. Obviously, when you are near to the sun, okay, the water will evaporate. When you are away from the sun, okay, they can be present in the icy form. Origin क्या है? Failed planet. Okay. Next, Jupiter. Okay, very important points about Jupiter. Anyways, you have this information everywhere. Okay, I'm telling you some of the very important ones. Elon Musk is planning to nuke. Means he'll be sending a nuclear bomb on the poles of the Mars, and the heat will become so intense. So यहाँ पे जो ice है वो पूरा पिघल जाएगा, पानी आ जाएगा. So this is how Elon Musk is planning, and comparatively the planet will become comparatively warm. So you're asking how you'll be able to protect yourself from this solar wind, because if there is no magnetic field, क्या तब space suit पहन के घूमना पड़ेगा ना? There is no other way, because you cannot produce the residual heat inside. So the next important point about Jupiter. So Jupiter is the largest planet. So Jupiter is mostly made up of hydrogen, helium. And there is one more theory here regarding this Jupiter. For example, say you want two suns in the solar system. आपको 2 sun चाहिए because you are unable to work 24 hours a day. Because रात हो जाता है तो आप सो जाते हो. So since Jupiter is mostly made up of hydrogen, we have to go to the core, middle of the Jupiter, and nuke Jupiter. So slowly nuclear fusion reaction will be initiated and we'll be having one more sun. So when you have 2 suns, रात कभी नहीं होगा, अब 24 घंटे काम कर सकते हो. Okay. Giant red spot. So giant red spot is on the surface of the Jupiter, and it is of the size of the Earth. And here a cyclonic storm is running for millions of years. तो जनरली कभी भी कोई स्टॉर्म होती है ना, वो शुरू होता है ख़त्म हो जाता है. मतलब यहाँ पे स्टॉर्म को इतना एनर्जी कहाँ से मिल रहा है पता नहीं. मिलियंस ऑफ ईयर्स से स्टॉर्म चली रहा है. And the wind speeds inside this red giant spot are order of thousands of kilometers per hour. इतना तेजी से यहाँ पे winds blow करता रहता है. That's why it is very important. Giant storm और cyclone दिख रहा है, so that is important. So next important thing here is, okay, largest, and it is protecting us. Means asteroid belt जो है ना वो अर्थ के तरफ आ सकता है, but the Jupiter's gravity is holding this asteroid belt together. अगर जुपिटर नहीं होता अर्थ के ऊपर एस्ट्रॉइड्स आके गिर जाते हैं. Okay, so this is the role of the Jupiter. Okay, you can see important points over here. So the most important ones I have already told you. Anyways, you can go through this. Okay, and okay, these are also important. It has got 92 plus moons, and Europa is also very important. It has got icy ocean, and Ganymede, okay, it's the largest moon here. It also has magnetic field, and Callisto, it is heavily cratered. Now Europa is important here because it is extremely icy, and since the temperature here is very low, you will be having a solid surface. Now if you want to go and study the Jupiter, or if you want to go to the outer celestial objects, then you have to build a space station somewhere. You can't build a space station on the surface of the Jupiter because Jupiter is mostly made up of hydrogen. It is gaseous. You won't be having any solid surface. वहाँ जाके land नहीं कर सकते हो. इसलिए तो जुपिटर का जितने भी सैटेलाइट्स है उसके ऊपर जाके आपको लैंड करना पड़ेगा या स्पेस स्टेशन बनाना पड़ेगा. So that's why the satellites become very important here. So next is Saturn. Saturn is very famous for the moon, so okay, very famous for its rings here. So there are various theories, why the rings have been formed. Okay, one of the famous theory is when the Saturn was rotating, the centrifugal force was so high that it has formed this concentric rings. And these rings, okay, are frozen gases. Okay, some are having solid surfaces as well. And the Saturn is the second largest planet after Jupiter, and it has the lowest density among the planets. Okay, and of course, all the Jovian planets, they are mostly made up of hydrogen, and of course helium will also be there. Okay, and North Pole has unique hexagonal storm. The Jupiter has red giant spot. This has hexagonal storm, and the temperature of the core is around 11,700 degrees centigrade. Very important, this one. Means the entire planet is extremely cold, but the center of the storm is extremely hot. And liquid metallic hydrogen layer generates magnetic field. So whichever planet is large, again remember this blindly, अगर planet large है उसमें residual heat होगा बीच में, and because of the differential movement of various layers, a magnetic field will be generated. So even Saturn will be having magnetic field. So iconic rings are made up of ice, rock particles, etc. Now it has 145 plus moons, so highest number of moons. Again Titan is very important. It's the largest thick atmosphere. It has got lakes, etc. So these are some of the important points with respect to the Saturn. Again Uranus, Neptune, etc. not that important. So next one is the Kuiper belt. Already told you. So these are nothing but the fragmented gases which could not become Jovian planets, the planet that never could be formed. Okay, and the Pluto is part of this Kuiper belt, and beyond this Kuiper belt you have the interstellar space which is made up of plasma. Now this Kuiper belt, okay, again kitna dur hai etc. you need not remember, but Kuiper belt is 200 times heavy and 20 times larger. Means uska size bada hai, because generally you will be thinking that the asteroid belt is heavier and larger. No, it is the Kuiper belt which is heavier and larger, and it has billions of icy bodies and dwarf planets like Pluto. Again others you can ignore here, remember Pluto here. Okay, again it is mainly made up of frozen water, methane, ammonia, etc. Okay, and mass is also comparatively low here, around 0.1 earth masses. And very important point, the short period comets, they will be coming from the Kuiper belt, and these are also called as classicals, also called as cold classicals. Very important. And resonant, okay, Neptune is locked. So I'll tell you about this cold classicals here. Once it has been asked in UPSC. So you have this solar system. So you have sun in between. So this is the entire solar system. And beyond this you have Kuiper belt. Kuiper belt. And very far away from the sun, around 10,000 AU away. 10,000 AU. 1 AU is the distance between the sun and the earth. So here we have something called as Oort cloud. Now the objects in the Oort cloud are held by the gravity of the sun, and the objects in the Kuiper belt are also held by the gravity of sun. But sometimes the object can get misfired. So Kuiper belt से अगर कोई बिखर गया या रास्ता भूल गया, now they will start rotating around the sun. They become heliocentric, okay? And these highly elliptical objects, these are called as comets. And since they are coming from the Kuiper belt, the time period of revolution is comparatively low. Sometimes from the Oort cloud also the comets can come. And this will be having a very long period of revolution around the sun. So the source of the comets is the Kuiper belt and the Oort cloud. Now Oort cloud is considered to be the part of the solar system, and it is the maximum expanse of the solar system. So we are discussing, somebody is asking about Neptune planet. See, not that important. See, I am discussing geography here. So I am going beyond little bit of geography. So little bit of all these things I am discussing regarding the solar system and discussing the most important points. See, पहले ज़माने में पूछते थे plants के बारे में, आजकल नहीं पूछता है. So आजकल whatever questions they will be asking from this part, they will be asking about the missions, scientific missions of NASA or the ISRO. Or else they will be asking about dark energy, dark matter, all these things they will be asking, or standard model of physics. Okay, these kind of questions they will be asking. So Halley's comet, Aditya is saying Halley's comet 76 years. So it is coming from this, Kuiper belt. Okay, earthquakes आगे बहुत कुछ बचा है. Pluto is the part of the Kuiper belt, largest known. So Pluto has a thin nitrogen methane atmosphere, heart-shaped glacier. You can remember the name of the glacier here. And 5 moons led by Charon. You can remember this name Charon here. And Pluto's surface has mountains, plains and possible cryovolcanoes. Cryo means extremely low temperature. Obviously यहाँ पे भी volcano होगा. Volcano is what? Nothing but because of the differential in the heat, convection will be taking place. So when the convection takes place, the material will come out. On the surface of the earth, the material which is coming out is molten rock. And here, the gases which are there on the surface of the earth, means यहाँ पे hydrogen निकल के आएगा, पानी निकल के आएगा. So पानी का भी volcano हो सकता है, and these are called as cryovolcanoes. Cryo means if you are working at extremely low temperature, below minus 196 degrees centigrade, it is called as cryo. And these are some of the missions. New Horizons flyby in 2015 revealed Pluto's diverse geology, confirming its Kuiper belt origins. So again, very similar to your asteroid belt, the Kuiper belt will also act as a fossil record for the solar system, because these are the objects which could not become a planet. So that's why if you want the evidence of the solar system, then you can go and study them, because they haven't, because these are very far away from the sun, the radiation must not have been affected these, and there is not much of erosion. Means the rocks or the objects which are there 4.6 billion years ago, they are been maintained in the same state. यहाँ पे कुछ भी नहीं हुआ. So that's why they are called as the fossils, or also called as time capsules. So these are some of the important points about this solar system. Mars is considered part of Goldilocks zone, no, but it doesn't sustain life. Why it is called? See, Goldilocks zone is such a zone where the water is existing in the liquid state. And Goldilocks zone with respect to the solar system is Earth only. Means, universe mein, for example, you have a star, some star is there. And at a certain distance from that star, the water can be there in liquid state where life can sustain. Okay, that is the Goldilocks zone, and Mars is definitely not part of the Goldilocks zone because the humans cannot survive over there. Now, what is galaxy? Galaxy is nothing but a constellation of the stars. So, all the stars come together, they form a galaxy. And our galaxy is the Milky Way galaxy. Milky Way galaxy is a spiral galaxy. Now, the galaxies can be of various types. Now, what is the current affairs here? Okay. Now, there is something called as RELIC, Reannihilation Limited High Cloud or Cloud 9. So, the UPSC will be asking the Cloud 9 which is recently seen in the news is what, etc. They will be asking. So, whenever you study the current affairs, you will be having certain doubts. I will be clearing that doubt. Okay, I should be using the green one or red one, which is more visible to you. Please let me know. So, this red I should use or green I should use, which is more visible here. Red, okay, fine. Chalo. See, so this is when the role of dark matter will be coming. See, a group of stars will be forming a galaxy, and inside the galaxy you will be having dark energy, right? And because of the dark energy, the galaxy will be collapsing inside a central galactic nucleus, also called as black hole. मीन्स गैलेक्सी में पूरे स्टार्स है एंड आपकी डार्क एनर्जी भी है एंड ग्रेविटी है. बिकॉज ऑफ दिस वो पूरा बीच में आ जाएगा. सो देर आर ग्रेविटेशनल पुल विल बी टुवर्ड्स द सेंटर, एंड जब भी ग्रेविटेशनल पुल हैवी हो जाता है, इन्फिनाइट हो जाता है, इट विल बी फॉर्मिंग ए ब्लैक होल, एंड ब्लैक होल इज ऑल्सो कॉल्ड एज सेंट्रल गैलेक्टिक न्यूक्लियस. एंड अगर कहीं पे हाइड्रोजन गैस है, over a period of time this hydrogen gas or nebula should be converted into a galaxy, and galaxy over a period of time should become a black hole, and it should collapse. But यहाँ पे कहानी में twist है, which is called as relic. Because recently we have launched something called as James Webb Telescope. Okay, this is a new telescope which is 100 times more powerful than the Hubble telescope. And this James Webb Telescope has been observing the universe and it is making a lot of observations. So recently, relic which is seen in the news is associated with what, etc. ऐसा पूछेगा. तो यहाँ पे क्या हो रहा है? You have this हाइड्रोजन गैस. सो हाइड्रोजन गैस होगा तो क्या ग्रेजुअली क्या होना चाहिए? इट शुड बिकम ए गैलेक्सी, ब्लैक होल. ओके, द स्टोरी शुड हैपन. बट enveloping this gas hole, this hydrogen gas, you have dark matter. अभी क्या होगा? The dark matter will be holding this gas apart. Means hydrogen gas क्या कर, it will try to collapse towards the center, but this dark matter which is surrounding this will be holding it away. Means it is in such a balance that a galaxy is not formed, and that is called as a relic. Understood? Concept clear? You can go through this. Okay, see the magnum which is given to you, इसके बारे में पूरा information है. I am telling you in a very simple manner. Okay, so reionization limited high cloud, also called as cloud 9. Sometimes they can ask this also. Cloud 9, which is recently seen in the news, is associated with what? Okay, it's the cirrus cloud, okay, which has been formed over Canada, okay, which is responsible for ozone hole, like that. They will give one option. समझ में नहीं आया? Okay, so फिर से एक बार समझाता हूँ मैं. See, आपके पास कोई मास है, नेबुला है, हाइड्रोजन गैस है, वो कोलैप्स होना चाहिए, बिकॉज ग्रेविटी शुड बी पुलिंग इट टुगेदर. वो कोलैप्स होने के बाद बीच में इतना ज़्यादा फोर्स ग्रेविटी हो जाएगा कि वो यूनिवर्स को पंक्चर करेगा, एंड दैट इज कॉल्ड एज अ ब्लैक होल. एंड ग्रेजुअली a nebula should form a galaxy, black hole, and it should collapse. This is normal way. लेकिन बीच में गैलेक्सी है, लेकिन उसके बाहर आउटर कोटिंग, you have this dark matter. This dark matter is not allowing this hydrogen gas or nebula to collapse into each other. So उसको गैलेक्सी फॉर्म होने नहीं दे रहा है. So NASA's Hubble telescope confirms first ever failed starless galaxy. वहाँ पे हाइड्रोजन है, लेकिन वो हाइड्रोजन स्टार नहीं फॉर्म हो रहा है, वो हाइड्रोजन गैलेक्सी फॉर्म नहीं हो रहा है. इसके बियॉन्ड कुछ मत पढ़ना, इतना ही पढ़ो. Whatever is written here, that is sufficient enough. Okay, got it? So Pawan is asking, what is the dark matter, how to prove its presence? See, dark matter, if this dark matter in the universe will be having gravity. For example, okay, my weight say on the ground floor is say 100 kg, but when I am measuring my weight in the second floor, the weight is increasing to 200 kg. मतलब मेरे वेइंग मशीन के नीचे डार्क एनर्जी है, मेरा वेट बढ़ रहा है वहां पे, मीन्स इट इज पुलिंग मी टुवर्ड्स द वेइंग मशीन. ऐसे कहीं पे भी यूनिवर्स में वैसे ग्रेविटी आपके कैलकुलेशन के हिसाब से और भी ज्यादा है. दैट मीन्स यू हैव डार्क एनर्जी देयर. अंडरस्टूड पवन? Pawan, you know, whichever language you are comfortable in, I will explain in that language. Huh? Telugu means Telugu, Hindi means Hindi, okay? Malayalam means Malayalam, Tamil da pesurom, everything. So next one is this Alaknanda galaxy. So Alaknanda galaxy is also in the news. It is 1.5 billion years after the Big Bang, located 12 billion light years away. The challenges models predicting chaotic early galaxies, suggesting rapid disk settling, gas accretion, and spiral density waves operated far sooner than they thought. See, if you are having a galaxy, okay, which is very old, means right after the Big Bang this galaxy has been formed. Now, early galaxies should have been collapsed. मीन्स वो ब्लैक होल फॉर्म करके वो खत्म हो जानी चाहिए, लेकिन अभी तक भी वो जिंदा है. मीन्स टिल नाउ यू हैव दिस गैस पैरेलिंग ओवर दिस, इट इज स्टिल एक्टिव. सो दिस इज अगेन द मैटर ऑफ कंसर्न, एंड दैट्स व्हाई दिस गैलेक्सी, दिस अलकनंदा गैलेक्सी इन द न्यूज. सो सिंस वी आर टॉकिंग अबाउट गैलेक्सी, व्हाट इज द नियरेस्ट गैलेक्सी टू द मिल्की वे? मिल्की वे इज ऑल गैलेक्सी, Andromeda galaxy, and there is a saying that in future Andromeda galaxy and Milky Way galaxy will collide with each other. They will collide with each other. Say after 5 billion years, 4.5 to 5 billion years के बाद they will collide. Again, this is in conflict with what you have studied earlier. So this is Milky Way. So this is Andromeda. So between these two, there should be dark energy, and dark energy is responsible for the expansion of the universe. Like, you know, why they are getting attracted towards each other? It means दोनों के बीच में dark energy उतना नहीं है जितना होना चाहिए, and because of gravity they are getting attracted towards each other. Yeah. Next you have this extreme nuclear transients. See, I'll show you what is happening here. You can see the animation. See, not be played once again. See, actually, extreme nuclear transients means You have a black hole, and near a black hole you have a star. So the star will be sucked into the black hole because black hole will be having almost infinite gravity. So the mass of the star will be sucked inside. Means the star will be fueling this black hole. Meaning because the star will be having hydrogen. So जब भी ये hydrogen, okay, black hole के पास जाता है, वो घूमने लगता है. So a lot of friction will be there. So because of this black hole will be emitting a very large amount of energy. It will be dissipating very large amount of energy. And such energy generation will outshine the entire universe. Means इतना light निकलेगा, इतना बड़ा धमाका होगा कि पूरा मतलब सन भी छिप जाएगा, मीन्स सन भी नहीं दिखेगा. मीन्स अगर दिन में ये वाला इवेंट अगर हो रहा है, आप देख रहे हो, it will outshine the sun, and these are called as extreme nuclear transients. Okay, in a very simple way. So when you are too close to a supermassive black hole at galaxy centers, extreme tidal forces rip star apart, forming a debris stream that spirals into a black hole event horizon, releasing immense electromagnetic energy through radiation. This is a scientific language which is there everywhere. Again I am explaining you, okay, in a very simple language. You have a black hole, you have a star. Of course the star should be larger. Only when the star is larger, it will be having enough hydrogen, enough gas होगा, enough energy होगा. So this black hole will suck in the star, वो घूमेगा black hole के around घूम के, and जब भी वो घूम रहा है, and this घूमने के जो part होता है ना, is called as accretionary disk. And at that time it will emit a very large amount of energy which will outshine the universe, and these are called as extreme nuclear transient. So nuclear क्यों? Because obviously the energy which is released here is nuclear energy. Transient मतलब क्या है? So transient मतलब universe में, okay, any light source is dimming or getting brightened up. Means अगर उसका light intensity कम हो रहा है या बड़ा हो रहा है, it will be called as transient. So this is the full form of extreme nuclear transient. Okay, Kalyan, very thank you. Okay, I am very famous for that only. I will be making very complex things very simple. But इतना ध्यान रखना, extreme nuclear transients. सबको समझ में आ गया extreme nuclear transients? Everyone understood? Good. Excellent, excellent. बढ़िया. Okay. Next. Okay, again literature is written here. Extreme energy output will be up to 10 times brighter than the GRBs. Sorry. So one ENT can emit 100 times the sun's lifetime energy. So ये तो अभी तो समझ में आ गया होगा, हाँ? Brightness rises over 100 days, peaks then fades over 150 plus days. Radio emissions persist. No, ये सब information magnum में है. Okay, don't worry. Huh? So hundreds of times less frequent than supernova. Supernova is nothing but, okay, explosion of a star. So it is more brighter than the supernova, explosion of a star. So occurring in large galaxies in massive central black holes. Obviously, it will occur in large galaxies only, because larger the galaxy, bigger stars will be having and bigger energy will be released. Okay, very simple. You can go through. Magnum में पूरा information है. Next is tidal disruption events. Again, I will show you animation here. दिख रहा है आपको? So you have a heavier object here, and if a star is coming in contact with that object or a black hole, okay, it is tidally attracting it, and gradually it will be sucked into the black hole. Okay, so यही मतलब है इसका tidal disruption events. So don't get confused. Again, one more animation I'll show you. Okay. So understood? So these are the intense bursts of radiation that occur when a star is entirely torn apart by a black hole's gravity. So these are more common and involve smaller black holes. Means this will be happening, extreme nuclear transitions will be happening when you have a very big black hole. And this will be happening, TDEs will be happening in smaller black holes. Okay. Only this much you should know, nothing beyond this. Okay, in Magnum these things are there. Okay, in the in the beginning only. Okay, universe वाला chapter में है ये सब. See, many things may not be there in the Magnum. The thing is, in the Magnum only you have this extreme nuclear transients and going bit beyond. Means अगर वो पूछेगा, then they can ask TDs also. Then they can ask fast X-ray transients also. They can also ask for this. And little bit, expanding the horizon here. I can show you animation here. You can see this is the universe. So in the universe, okay, now these things which are happening, this can be a supernova, means explosion of a star. Also it can be the gamma ray burst. Now fast X-ray transients. See, whenever a black hole becomes very active, it will be emitting a lot of radiation outside. Because when a star is sucked in and when it is rotating in an accretionary disk, and because of the heavy friction, it will be emitting a lot of radiation. And this radiation which is coming out, emitted by a black hole, is called as gamma ray burst. Now generally, you must have learned that even the light cannot escape a black hole, right? Nothing is emitted out of a black hole. No, it's not true. Only when the things enter beyond the event horizon, means black hole के surrounding, जो black part हो जाता है, होता है, that is called as event horizon. Only when the things enter into the event horizon, they will not be returned back. The event horizon is also called as the point beyond which the things cannot come back, point of no return. But surrounding the event horizon, you have this accretionary disk. In this disk, when the things are rotating because of the friction, a very large amount of energy is radiated out in the form of the gamma ray burst. उसका थोड़ा lower form है this one. One second. Fast X-ray transients. So this fast X-ray transients very short bursts of X-ray observed when stellar explosions release too little energy to generate gamma ray bursts. Okay. So FXTs are weaker, short-lived X-rays only events, while ENTs shine brighter, longer, and multiple. Okay. So we can put it this way. ENTs then you have gamma ray bursts, then you have FXTs. So this is in terms of intensity and energy. So since you have studied about that, we will study about gamma ray bursts also. Just now I explained. So these are energetic cosmic explosions caused by collapsing stars or merging neutron stars, okay, emitting intense gamma radiation. So GRBs were earlier considered to be the brightest explosions, but ENTs usually emit greater energy and last longer. So this is the very recent discovery, ENT. In the Magnum you will be finding ENT, okay, only ENT is there. So expanded ENT into GRB and FXT for comparison basis. Because UPSC will never ask a question from the first layer, second and third layers से question पूछेगा, okay? So Pawan is asking, I changed my optional to geography. Can I contact you? You can give. Yes, sure, Pawan. Okay, you can take my contact number. You can contact me. Right. So I hope you have understood. Don't complicate the things here. I'm telling you in a very simple way. See, for example, these are two neutron stars. So when they will be colliding with each other, so they will revolve around each other and they will release humongous amount of energy. So this is the gamma ray burst. Okay, इससे भी अगर खतरनाक powerful explosion हो रहा है universe में, that is called as ENT. Solar system is done. Little bit about sun I want to talk about today. So I'll be talking very briefly because rest of the things related to the sun you'll be doing in the science and technology class. So this is called as the core of the sun. Core of the sun. So in the core of the sun, all the nuclear reactions will be taking place. Nuclear reactions. That is, the hydrogen with the help of nuclear fusion, it will become helium. So all the nuclear reactions are taking place here, and the temperature of the core is around 15 million degrees centigrade. So this is the hottest part of the sun. Next, you have the second layer. This is called as radiative zone. Radiative zone. So whatever energy which has been released here, that will be radiated out. Now you can ask, there are the various modes of heat transfer: conduction, convection, radiation. The sun is made up of gas, hydrogen gas. So gas is a bad conductor of heat. So what are the other ways of heat transfer here? Convection and radiation. And sun, despite it is being made up of gas, it is so dense here. It is so dense that convection will not happen. The matter will not flow. That's why the radiation will happen. Means here, for the energy to come from this point to this point, it is so dense, thick plasma that on an average it will be taking around 1 lakh years. Sometimes some photons or energy particles will be taking millions of years also, from here to here. Okay, and telling the most important aspects. So rest of the aspects you will get anywhere. Okay, what is important for the examination, that I am telling you. And anyways, in more detail you will be studying in science and technology. And the next layer here is convection zone. So here the density decreases a bit. That's why the convection is taking place here. So this is called as the convective zone. I think sometimes the convection can increase here. Of course, after this, there are 3 other layers which are very thin. So you have other layers also which are very thin here. Very thin. It doesn't matter. So sometimes the convection will increase because whenever there is more energy being emitted from inside, okay, the convection will increase. So because of which you will see a phenomena called as the solar flares. So it is nothing but it happens because of the convection. So whenever the solar flare comes, a very large amount of energy is emitted. Then what is the difference between the solar flare and CME? Okay, CME is coronal mass ejection. So that I will show in the next slide. Now, what happened, what is in the news is the NASA satellites recently detected a massive solar flare with superheated plasma erupting from the sun and spreading out in a dramatic wing-like shape. Now you must be understanding these points. Okay, so they are sudden. Obviously they will not be gradual. Okay, it's like आप आग लगा दिया कहीं पे, कभी-कभी okay आग अचानक से ऊपर भी आ जाता है. The same fashion, जैसे आग में फ्लेयर आती है. For example, आप गैस चला रहे हो, गैस के पाइप के कनेक्शन में कुछ गड़बड़ी हो गया, तब भी थोड़ा ज़्यादा गैस आ जाता है. Similarly, in the sun also गैस आ जाती है. Okay, so these are nothing but intense burst of electromagnetic radiation from the sun due to magnetic field lines realignment. Now, I'll be talking about one more layer here. So, apart from these layers, on the surface of the sun, you have these magnetic field lines. जैसे आप जूते के ऊपर शू लेसेस बांधते हो ना, वैसे ही मैग्नेटिक फील्ड लाइन्स दे आर रिलीज्ड एंड दे आर रीअलाइन्ड आल्सो. एंड अर्थ का एटमॉस्फेयर होता है, सो दिस इज अर्थ. So the Earth's atmosphere is made up of gas, right? Now this is sun. The sun itself is made up of gas. Therefore, the sun's so-called atmosphere, it is made up of the magnetic field lines. And this magnetic field lines, this layer is called as corona, solar corona. आपने कोरोना वायरस सुना है? कोरोना इज नथिंग बट क्राउन लाइक अपीयरेंस, मीन्स सन के ऊपर एक ताज की जैसा दिखता है. सो दैट्स व्हाई इट इज कॉल्ड एज कोरोना. सो दिस इज वेयर यू विल बी हैविंग मैग्नेटिक फील्ड्स एंड इट इज द सो कॉल्ड द एटमॉस्फेयर ऑफ द सन. एंड ऑब्वियसली, okay, whenever you have this solar flares, this magnetic field lines, they will break and they will be going towards the sun. Oh, sorry, going towards the earth. So they are directed towards the earth. And the intensity can vary here. Sometimes it will be more intense, sometimes it will be less intense. And depending upon, okay, the intensity, they are categorized into A, B, C, M and X. Okay, so X being the most powerful. This is very important, remember this. Now, what all kind of radiation it will release? Again, I guess in the last class I have told you, or in some of my previous lectures I have told you, so entire electromagnetic spectrum can be released. So wherever you have a source, entire electromagnetic spectrum can be released. So it can release cosmic radiation. So it can release the gamma, okay, X-rays, UV, then you have visible. So while you are moving towards this side, the energy is reducing. The energy is low. Now again, one more point I am telling you here. Now if you want to observe, say ENTs, yesterday we have discussed ENTs, or gamma ray bursts, or supernova explosion. So if you want to observe such kind of high intensity incidents in the universe, then we have to look in this radiation spectrum. For example, you have this astrosat. The astrosat will not be looking at supernova and the merging of the black holes or the merging of the neutron stars in the visible spectrum. It will be looking in X-ray and UV spectrum. So if you want to see higher energy incidence in the universe, you have to shift towards this. For example, if you want to observe the moon, so moon itself does not have its own light, source of light. So will you see the moon in UV spectrum or X-ray spectrum? No, right? So you have to see in infrared spectrum. Say if you want to see someone in the night time, if you want to see the location in the night time, will you see in the visible spectrum? Because night time there is no energy, there is no light, source of light. That's why you have to move towards the infrared spectrum. So if you get these basics right, you will answer most of the questions with logic. And beyond 30 questions, your logic will help you. रटा हुआ knowledge कुछ भी help नहीं करेगा. Okay. So they are associated with magnetic storms known as CMEs, coronal mass ejection. For example, कभी कभी okay, यहाँ पे energy बहुत ज़्यादा हो जाता है, intensity will become more. So part of the coronal mass, solar mass, will be directed towards you. So previously in the UPSC, what they have asked, Okay. Now, whenever such kind of solar flares will be increasing, or whenever such kind of CMEs are directed towards the earth, what will happen? See, you can blindly mark all the above here, all the above. भैया इससे क्या हो सकता है? This is now nothing but electromagnetic radiation. So when such kind of high intense electromagnetic radiation, X-rays or UV, when they are directed towards you, your radio communication will be disrupted. आप भी तो भैया यहाँ पे सैटेलाइट तक आप रेडियो वेव से यूज़ करते हैं ना, तो ये वाली तार जा रही है, ये वाली रेडिएशन जा रही है, मोबाइल से सैटेलाइट तक जा रही है. अभी सूरज फेंक रहा है बड़ा रेडिएशन, भैया ये वाला तार तो टूटेगा ना, आपका जो रेडियो वेव्स है वो तो वीक है, वो तो टूटेगा. So again, with this high intensity radiation, your electronic equipment which you are using, satellites वगैरह, वो भी खराब हो जाएंगे. And imagine, say part of the sun का एक टुकड़ा, okay, with the very heavy force, it is directed towards the earth. Don't you think it can cause tsunami also? Don't you think it can cause tides also? So anything can be caused. Now if you keep this in mind, okay, then you can answer at least 10 questions. भैया आपको पता नहीं है क्या क्या होता है. एक बार यूपीएससी ने क्वेश्चन दिया था, okay, what can happen, okay, if the CME is directed towards the earth. कुछ भी हो सकता है वहाँ पे. So blindly mark the above, all the above. Don't think much in such kind of scenario. Right? Okay, now they occur mostly during the solar maximum, peak of the solar cycle. Now, even the sun has solar cycles. Means on the sun, on the surface of the sun, you will be having sunspots. Now, every 11 years, the sunspots will peak. Okay, फिर कम हो जाता है. फिर after 22 years, again they will peak. Then after 33 years, again they will peak. So, sun का भी solar maxima, solar minima, solar maxima, solar minima. So, this is the solar cycle. So, whenever the solar cycle peaks, okay, such kind of incidents will be more. And this is after every 11 years. Okay. Next, what is CME? I guess the animation is visible here. You can see this magnetic field lines which are coming out of the sun. So, here some amount of mass of the sun will be ejected. So, we can say a CME जो है ना, solar flare का बाप है. Now differences, okay, I have mentioned here. Okay, you can go through. Anyways, you guys want the PPT, I will be sending the PPT. See, in my PPTs, okay, more of pictures are there because you might have read all these things somewhere or other, लेकिन आपने कभी देखा नहीं होगा, इसलिए मैंने visual presentations ज़्यादा दिखाया. So only difference, okay, you can note down here between CME and the solar flare is these are massive. ये 10x, 20x, 100x ज़्यादा होता है, बस इतना ही difference है. Now, what can be the implications of the CMEs? Just now I told you implications can be anything. So, Earth का magnetosphere, because Earth also has a magnetic field around it. So, Earth का magnetic field है. अभी भैया सन ने फेंका है, okay, बड़ा सा what गोला or okay mass, okay, which is coming from the corona. That's what is called as coronal mass ejection. Don't you think the magnetic field lines can be disrupted? Tsunamis can come, okay, and in fact, okay, if the CME is more, the orbit of the Earth can also be disrupted. That can also be the scenario. The tilt, the axis of the Earth can also be deflected. Anything can happen. Okay, keep this in mind. So implications, power grids failure can happen, pipelines can be disrupted, etc. Anything can be there. Okay, so it can enhance auroras also. The northern and southern lights, okay, which are found in the higher latitudes, they can be enhanced. Okay, and when it becomes more and more, even in the lower latitudes, the auroras, this northern lights, southern lights, they can also appear. So anything can happen. So for example, in the examination, आपको ये समझ में नहीं आ रहा है. आपने पढ़ा है कि auroras, okay, will be there in the higher latitudes only. अभी lower latitudes में कैसे होता है इतना, okay, आप सोचो मत वहाँ पे. एक ही चीज़ याद रखना, फ्यूचर में पॉसिबिलिटी होगा. एंड टू मोर थिंग्स यू हैव टू रिमेंबर. क्या आपने जितने भी सोलर फ्लेयर्स रिलीज हुए और CMEs रिलीज हुआ है, सारी चीज़ों को आपने पढ़ाया क्या? नहीं पढ़ाया, राइट? आफ्टर ऑल, व्हाट इज द
स्पैन ऑफ ह्यूमन लाइफ ऑन द सरफेस ऑफ द अर्थ, अपनी हिस्ट्री कितनी है एंड उसमें साइंटिफिक हिस्ट्री कितनी है, at max 50-60 years. Since around 50-60 years, we have been studying all this phenomena scientifically, right? उसमें आपने सारी चीज़ें ऑब्जर्व कर लिया गया. फॉर एग्जाम्पल सन को आपने पूरा पढ़ लिया. क्या आपने पूरा यूनिवर्स को पढ़ा है क्या? वहाँ पे भी स्टार्स है, वहाँ पे भी कुछ भी हो सकता है, राइट? सो अगर ये चीज़ ओके आपके मन में है, देन यू विल बी एबल टू सॉल्व मेनी क्वेश्चंस. भाई CME फिर से बताऊँ क्या? ओके, बिकॉज यू हैव आस्क्ड दिस, क्लियर हो गया होगा अब तक. ओके, सो इतना ही है डिफरेंस. जो अब कितना भी ऐसा कंटेंट पढ़ो आपके दिमाग में नहीं घुसेगा, लेकिन एक बार आपने अगर पिक्चर देख लिया आपको समझ में आ जाएगा. ओके, दिस इज CME. अंडरस्टूड? रियलमी पैड कौन है? सो implications, solar flare implications. So again we have discussed this. So GPS signals can be disrupted, minor satellite glitches can happen, right? Of course the X class is more extreme. So X28 flare has happened in 2003. Okay, it is the strongest recorded till now, etc. एक बार तो what Canada में पूरा blackout हो गया था. Power grid failure has happened because of this CME and entire पावर ब्लैकआउट हैज़ हैपेंड. मतलब पूरी तरह बिजली चला गया था. ब्लैकआउट मतलब बिजली चला जाना हर जगह. इंडिया में भी हुआ था, बट इट इज़ नॉट बिकॉज ऑफ द सोलर फ्लेयर, बट इट इज़ बिकॉज ऑफ सम चाइनीज कॉन्स्पिरेसी. नाउ यू सी, ओके, नेक्स्ट टॉपिक इज द कॉमेट. सो yesterday we have discussed about two types of comets. One is the short distance one, other is the long distance one. The short distance one will be coming from the Kuiper belt and the long distance one will be coming from the Oort cloud. Now what is this comet made up of? So comet में क्या होता है? See, solar system का जो भी पार्ट है उसी से comet भी बनता है. लेकिन प्रॉब्लम क्या है? ये क्या है? Comet, okay, see, every object in the solar system has got certain orbit. So comet has a orbit, but again it has a very long orbit, an elliptical orbit, and it will be revolving around the sun. So जो भी पार्टिकल सोलर सिस्टम में है उसी से कॉमेट बना हुआ होता है. सो कॉमेट में पत्थर भी होंगे, गैसेस भी होंगे, बट द गैसेस विल बी मोर इन द कॉमेट. सो सिर्फ गैसेस होगा तो गैसेस तो इवोपरेट होगा, कॉमेट खत्म हो जानी चाहिए. सो इसमें पत्थर भी होगा. So it will be having some rocks, some metals and some gases. But whenever this comet is approaching towards the sun, so the gases which are volatile, okay, they'll be releasing a tail. That's why the comets have a visible tail. Okay. So it's also called as icy snowball. Okay, ice, rock, dust. Okay. So it can range between 1 to 10 kilometers. So whenever it comes near the sun, okay, the ice evaporate, okay, and the coma or the tail is visible. Sometimes it can also have two tails. Origin, Oort cloud, Kuiper belt, okay. Orbits are highly elliptical in nature, okay. Okay, so of course, whenever they are approaching towards the sun, they'll be losing certain mass, because don't you think the gases are getting evaporated? When the gases gets evaporated, it will be losing certain mass also. So more than this, the UPSC won't be asking anything. If at all, they are asking about comet. Okay. Now that comet is different and this is different, right? Now this can be differentiated into three. So these are the objects in the solar system which are directed towards the earth. So when it is beyond the Earth's atmosphere, it is called as meteoroid. It is nothing but a rock which is directed towards the Earth. And as soon as it enters the atmosphere, this is the atmosphere. So since it is coming at hypersonic speed, so it will generate a lot of friction, and because of the friction, it will burn with the help of oxygen. So it becomes meteor. See, sometimes, the most of the times, so whatever objects are directed towards the earth, they will burn out completely. But sometimes what happens, they will not burn out completely. A part of it can come and hit the earth. And this is called as meteorite. Okay. So spelling ध्यान रखना यहाँ पे. Okay. What is a normal view you are talking about? Switch back to the normal view. I am not understanding. So these are the meteors. Okay, if it is burning meteors, if some part is remaining, it is called as meteorite. Now, oldest meteorite impact crater. Okay, so this is there in Australia. So this is estimated to be around 3.5 million years old. It predates all known craters by over billions of years. Means अगर इतना पुराना meteorite okay form हुआ, by now it should have been totally denuded, okay, or eroded, but it is still remaining. Okay. Now, where is the location here? Okay, Pilbara region of Western Australia. So it is dome-shaped geological formation near the Antarctic Creek member. Now this Antarctic Creek member, okay, is not there in Antarctica, but it is located in Western Australia. Okay. So Antarctic Creek member is a distinct rock layer containing sedimentary rocks and impact spherules, okay, most molten droplets from the meteorite impacts. So what is the scientific importance of this? So it supports the theory of continental formation, means उस ज़माने में rocks कैसे होते थे अपन को पता चलेगा. And one more important thing about this meteorite is we will get to know what are the interiors of the earth, which we will discuss later. Okay. So it backs a theory that early meteorite impacts contributed to the formation of the earth's first continents by providing external energy to melt and modify the crust. See, you have the earth, and inside the earth you have a lot of residual heat, right? Now this residual heat has to come out. Only when the residual heat comes out, you'll be having the processes such as volcanism, earthquakes, mountain building, etc. Now for it to come out, either the force from inside has to be very high, बहुत जोर से वो अंदर से बाहर आना है, नहीं तो बाहर से अगर कोई पंक्चर भी कर दिया फिर भी ठीक है. So some of the geological processes on the surface of the earth, okay, which has done the job of sculpting and shaping the earth, has been done by these meteorites. जोर से आके इसको धक्का लगाया, so धरती को फोड़ दिया पूरी तरह, तब जाके अंदर का जो मैग्मा है, लावा है, वो बाहर निकला. Understood? So that is the meaning of this sentence. Understood? Okay. So comparison with other theories. Previously it was believed that the early continents were formed due to internal heat driven processes like mantle plumes or plate tectonics, which we will be discussing later. Means, see, अंदर का heat dissipate करने के लिए you have this mantle plumes also. So earlier people believed that, okay, they have shaped and sculpted the earth. But again, external objects like meteorites can also help in shaping the earth. What is the shape of the earth? The shape of the earth is also called as the geoid. Geoid means the earth-like. So is it a perfect sphere? No, it's not a perfect sphere. Now, if you look at the equatorial diameter and the polar diameter, the polar diameter is comparatively less. So it is 12,714 kilometers and the equatorial diameter is 12,756 kilometers. Now, why the equatorial diameter is more? Because when the earth is rotating on its axis, so because of this centrifugal force, you have an equatorial bulge. So earlier they used to ask questions like, what is the gravitational force over the equator as compared to the poles? The answer is very simple. So the formula of gravitational force is F is equal to G m1 m2 by r square. So more is the radius, lesser will be the gravity. So even today, over the poles, the force of gravity will be comparatively more as compared to the equator. Means your weight will be more over the poles as compared to the equator. So UPSC has asked these questions in the 90s, long time back. Now they won't be asking this question. Okay. So this is the only relevance of this. Again, Earth's circumference is around 40,000 kilometers, which is not of that relevance. Okay. Now, what is the elemental composition of the Earth? Sorry, this is elemental composition of the crust. So what is the crust made up of? So I'll not be just helping you in mugging up. I'll tell you with the logic here. Now why the oxygen is in highest quantity? See, if you look at the interiors of the Earth, what is the core made up of? The core is mostly made up of iron, right? And the volume of the core is comparatively very less. Around 63% of the volume of the Earth is made up of mantle. Okay, and then you have the crust. The crust is a very thin layer. Now, this mantle and crust both are made up of silicates. What is silicate? Silicate is SiO2. So your answer is here. So the mantle is made up of ferro-magnesium silicates and the crust is made up of even lighter silicates. So the concentration of oxygen should be more. Now if you look at the concentration of oxygen and the concentration of silicon, almost double, because the formula is SiO2. So SiO2 is in the form of chains like this. So it is in this form, never ending chain. And the chains are broken by the metals. Means यहाँ पे iron भी लगा सकते हो. Okay, whatever you want to keep, potassium, sodium, iron, magnesium, etc. So these are attached by these metals. And you have this mnemonic also for this, you can remember anyways, okay, osaic. If you want to remember, you can remember this way, osaic. Okay. So iron, you have to remember the concentration, iron is around 5%. So remember only these, okay, rest you can ignore. Now don't get confused between the composition of the crust and composition of the entire planet. So this is the composition of entire planet. Now here, when you take the composition of the entire planet, the concentration of the iron is highest over here. Because most of the iron, 95% of the core is made up of iron. Now, why not other elements but iron? अगर कोई बता देगा, कोई भी, मैं मान लूंगा कि इस बार आप IAS बन ही जाओगे. So इसके लिए आपको दूसरे डायमेंशन में जाना पड़ेगा. There is something called as nuclear binding force. So this is nuclear binding force, and these are the elements: hydrogen, helium, lithium, beryllium, etc. This is iron. So the nuclear binding force will keep on increasing, and at the iron it will become maximum. This is Fe26. At 26 atomic number, the nuclear binding force will be highest, and iron is the most stable nucleus. I am not talking about atom here. Most stable nucleus in the universe. इसीलिए आपको अर्थ के कोर में आयरन मिलता है, जुपिटर की कोर में आयरन मिलता है, सैटर्न के कोर में आयरन मिलता है. Even though they are gaseous planets, in their core you will be having iron, because it is the most stable nucleus in the entire universe. And not only Earth, if some asteroid is coming and hitting you, it becomes a meteorite, and 70 to 80% of the meteorite has iron. It has got metallic texture. So in the evidences of the earth interiors, we'll study this. And rest you can ignore. Of course, oxygen hoga to silicon bhi hoga. And afterwards you have magnesium, sulfur, nickel, etc. You can ignore this, but this is the logic. आपको रटना है तो रट सकते हो, मैं logic बता दिया आपको. At the definition stage is, a mineral has a set formula. So whatever I am saying, you will get it anywhere in any textbook or any notebook or any notes, you will get everywhere. So mineral has a set formula, and this formula repeats by itself. So that's why it will be having a set of melting point, and this will be having a range of melting point. Now, what are the various types of minerals? Minerals can be oxides, sulfides, carbonates, etc. You will be having various types of minerals. But as far as geography is concerned, we are not concerned about all these minerals. So we are concerned about silicates. So these minerals are very important. Why silicates? Because your crust on which you are living and your mantle, which is responsible for most of the geological processes, both are made up of silicates. Now let's see what are these various types of silicates. Silicate types. See, silicates mein what is common? The common thing in silicate is SiO2 minus 2. Okay. So this SiO2 minus 2 can be paired up with sodium, potassium. It can be paired up with calcium. It can be paired up with iron, magnesium. Right? So, if it is paired up with sodium potassium, means it should be having more of sodium and potassium. And of course, calcium, iron and magnesium can also be there. If you want, I will give a chemical formula here. Say something is made up of Na something X, K Y, Ca Z, okay, Fea, Mgb, okay, and SiO2. But the quantity of this is more. And these are called as lighter silicates. Lighter silicates. And these lighter silicates are mostly present in the crust. Then it can be paired up with calcium also. So the content of the calcium is more, it is called as intermediate. Now this can be paired up with the iron and magnesium also, ferromagnesium silicates, and these are called as heavier silicates. So these are the three classes of the silicates. And here we have seen this chaotic diagram. So these are various types of minerals which are present inside the earth. Orthoclase, quartz, plagioclase, pyroxene, olivine, etc. So this is the depth. So as the depth is increasing, you'll be getting more and more of olivine. And on the surface of the earth, you'll be finding more and more quartz or orthoclase. Means sodium, potassium will be more in the upper layers of the earth. So iron and magnesium will be more in the inner layers of the earth, deep inside the earth. Now these properties are very important. So later on, it will be helpful to you in judging earthquakes, volcanoes, and plate tectonics also. So while you're going deep inside the earth, the silicates will become heavier. Silicates become heavier. Okay, so I'll write it the order also. Sodium, potassium, it will be moving towards iron and magnesium. And while you're moving towards the interiors of the earth, the silica content reduces. Silica content reduces because the silica is light. सिलिका मतलब क्या है? मिट्टी है, लाइट है और तैर के ऊपर आ जाती है. बिकॉज आफ्टर द फॉर्मेशन ऑफ द अर्थ यू हैव दिस कन्वेक्शन टेकिंग प्लेस. सो दिस चर्निंग इज टेकिंग प्लेस इनसाइड. जब एक कन्वेक्शन हो रहा था, सो लाइटर एलिमेंट्स हैव बीन सरफेस्ड आउट and the heavier elements they were sinking inside. So that is how the earth has been concentrically arranged. हल्के वाले बाहर आ गए, भारी वाले अंदर चले गए. And silica मिट्टी होती है, लाइट होती है, और बाहर की तरफ आ गया, and जितने भी metals है वो अंदर की तरफ चले गए. तो silica content reduces as the depth increases. And next one, obviously while you are moving into the interiors of the earth, the melting point also increases because lower melting point वाला silicate अंदर exist ही नहीं कर पाएगा और melt होके बाहर की तरफ आ जाएगा. Okay, so the melting point increases. And talking about the silicates, on the surface of the earth you'll be having more of felsic content. The felsic means this is derived from the word feldspar. So feldspar is nothing but a lighter silicate. The felsic content will be more. Okay. Then while you are going in the interiors, it will become intermediate. Then the content will become more mafic and ultramafic. Mafic and ultramafic. Okay, if you know these terms, good and great. If you don't know, then also it's fine. Again, while you move inside the interiors of the earth, the viscosity, reduces. Means, while you are moving inside the earth, the things will become more mobile. अगर हिंदी में बोले तो towards the surface of the earth, the magma or the molten rock will be more viscous. ये बहुत गाढ़ा होता है. अंदर की तरफ बहुत fluid जैसा होता है. ये पानी की तरह होता है. Now, what is the relationship between? I'll tell you some logic here. I'll not be, मैं ऐसे रटोफाई नहीं करवाऊंगा. What is the relationship between this viscosity and silicate? So there is a relationship between these two. So what is the relationship here? See, silica जो है, it is in the form of chain. A chain है. And this chain, this monotony of this chain, it is broken by the metals such as anything, sodium, potassium, magnesium, iron, etc. Now silica हल्की है, so silica content will be more near the surface of the earth. While you are going deep inside the earth, the silica content reduces. ये सिलिका एक चेन जैसा है. जब तक ये चेन जितना लंबा होगा, जितना ज़्यादा क्वांटिटी में होगा, okay, उतना मोबिलिटी नहीं होगा. Mobility will be less. Imagine, okay, you guys are holding hands with each other. Everyone is holding hands with each other. Okay, and then if I'm asking you to move out of the room, I'm pushing you out of the room, you guys will be able to move out of the door easily? नहीं ना. मैं आपको बोलता हूँ हाथ छोड़ दो. Then if you guys are moving individually, so आप दरवाजे से आराम से बाहर निकल जाओगे, right? So in the same fashion, okay, the silica content reduces while you're going deep inside, okay. So the length of the chain is less, that's why it will become easily mobile, it will become more fluidic, okay. And towards the surface, the silica content is more, that's why it becomes more viscous. Is this point clear to everyone? And there is one more point here which is important, acidity. And acidity is directly proportional to the silica content. More is the silica, more acidic it is. Less is the silica, less acidic it is. Now what is the relevance? Of course, okay, आपने पूरा ये chemistry पढ़ लिया. But what is the relevance? Because geography studies the man and environment relationship. तो geographers को क्या पढ़ना है? Surface phenomena तो पढ़ना है ना. तो आप मुझे पूछोगे सर ये मुझे समझ में नहीं आ रहा है, अंदर जो चल रहा है हमारे जोग्राफर से क्या मतलब है, जोग्राफर तो रहता है यहाँ पे. सो मतलब यहाँ पे, नाउ ऑन द सरफेस यू विल बी हैविंग दिस वोल्केनिक फिनोमिना. से अंदर से वोल्केनो आया, एक वोल्केनो आया यहाँ से ए, एक वोल्केनो आया यहाँ से बी. So among these two volcanoes A and B, tell me which one is explosive? कौन सा वोल्केनो विस्फोट होके बाहर निकलेगा? कौन सा वोल्केनो ज्यादा तबाही मचाएगा? B is wrong. A. तो यही पे तो यूपीएससी क्वेश्चन पूछता है ना, यही पे लॉजिक की जरूरत पड़ती है. सी द थिंग विच इज कमिंग फ्रॉम इनसाइड, वो डीप से आ रहा है, उसको बाहर विस्फोट करने के लिए फॉर इट टू बिकम एक्सप्लोसिव it should come up with very high energy. And when it is coming from 2900 kilometers, do you think that energy will be sustained? उतना दूर तक ट्रैवल करने के बाद भी उसका पास एनर्जी रहेगा? नहीं भैया, that energy will be faded out. एटलीस्ट ये वाला लॉजिक लगाओ. दूसरा लॉजिक ये है, the thing which is coming from deep inside the earth is highly fluidic. वो आराम से बाहर निकलेगा. सो उसको छोटी सी छेद मिल गई, वो पानी जैसा बाहर बह जाएगा. बट द मैग्मा विच इज सोर्स फ्रॉम द अपर लेयर्स ऑफ द अर्थ, इट इज हाईली विस्कस, बहुत गाढ़ा है. छोटी छेद अगर दोगे उससे बाहर नहीं निकलेगा वो, ओके. उसको चाहिए बड़ा एरिया. सो वेन एवर इट ऊजेस आउट, वेन एवर इट कम्स आउट, वो पूरा एक साथ आने की कोशिश करेगा, तो पूरा फोड़ के बाहर आएगा. So these are highly explosive because they have more silica content. So that's why I have explained you all this. Now, see, if you understand my class na, in this way, you'll be able to answer any question, and this class is very, very important, and this will be laying foundation for your volcano topic, earthquake topic, and plate tectonics topic also. This is very important. Now let's discuss about rocks here. Now you must have studied what are the various types of rocks. Okay, igneous type of rock, okay, sedimentary type of rocks, and you have this metamorphic rocks. Metamorphic, you have studied all this. But today I will take you in different dimension. Okay, so you must have studied igneous types of the rocks, which are formed by the molten lava or magma. Okay, they are of various types, blah blah blah. Okay, but okay, once in the mains examination they have asked a 10 marker on igneous rocks. Bhaiya kya likhoge? If you are writing just NCERT knowledge, you will not be getting any marks. So you will be diving deeper. So it is not just the intention of writing a good answer in the mains examination, but also you will understand the entire dynamics. You will be able to understand the geomorphology in a very comprehensive way. Okay, thank you Adhiraj. Okay, a wish puri ho jaye. So first let's talk about the igneous rocks. See, say this is the crust. and somewhere here below you have the core. See, core से कुछ नहीं बाहर निकलेगा, which is the core. Nothing comes out of the core. What is the proof? अगर core से कुछ बाहर आता, imagine something coming out of the core, then भैया आयरन के खंबे होते ना, instead of rocks on the surface of the earth, because 95% of the core is made up of iron. कहीं आपको दिखते हैं क्या आयरन के खंबे? नहीं. So nothing will come out of the core. Whatever comes out, it comes out from the mantle. Now, when the things are oozing out of the mantle, because inside this there is a lot of heat, this heat has to be dissipated out. So, the rock will melt in the form of this mantle plume. The molten rocks will be oozing out. So when they ooze out, this rock, so this magma can be solidified here, and this magma can also come out on the surface and it can solidify here. So when this molten rock is inside the earth, it is called as magma. So when this molten rock, when it comes out on the surface expression of magma is called as lava. So this is the difference. Now, if this magma is solidified here, it will form the intrusive igneous rocks. Intrusive igneous rock. Now, if this magma has an expression of lava, it will be forming extrusive igneous rock. Extrusive and intrusive. Now, what is the major difference between these two? So, when it is solidified inside the crust, the rate of cooling is very low. Rate of cooling is low. Means ये जो पत्थर है बहुत ही धीमे cool होगा. Sometimes, it will be taking millions of years also to cool down, because the heat has to be dissipated out, and earth के अंदर जब होता है heat इतना dissipate नहीं होता है. So rate of cooling is slow, and here the rate of cooling is fast. Rate of cooling is fast here. So this is where the real difference will happen. Now these all things you can write in the igneous rocks or the topic of primary rocks. Now for example, okay, say you guys are sitting in a class. मैं आपको बोलूँगा, okay, आप एक दूसरे से के साथ जुड़ जाओ, दोस्ती बनाओ, and you guys form a group. Okay, you have 1 hour time. क्या आप एक दूसरे से एक घंटे में दोस्त बन पाओगे? नहीं. Say I'm giving you like 6 months or 1 year. अभी 6 महीने के बाद, 1 साल के बाद, okay, even if I don't tell you, you guys will make friends with each other. You will be forming bonds and groups in the class, right? So more time you take, more bonds you will create. Lesser time you won't be able to create those many bonds, right? So here extrusive igneous rocks, the rate of cooling is very fast. Therefore, here you will be having very small crystals or no crystals or invisible crystals. Here in intrusive igneous rocks, you will be having visible crystals. So this is a difference, major difference between intrusive igneous rock and the extrusive igneous rock. Now I'll be showing you various crystals here. So there's a diagram over here of intrusive and extrusive, which I've explained. You see here, granite, okay, this is rhyolite. So the granite is intrusive igneous rock, it has got visible crystals. Now the chemical formula of these two is the same, but the place where it has been formed makes all the difference. Okay. So granite, rhyolite. Okay. So then you have andesite, diorite. So andesite is extrusive, this is intrusive. Okay. Then you have basalt, gabbro. Now see this next thing which I'll be doing, you will not be finding it anywhere. But again, you note down this because it will be useful to you. I'll give you a table of igneous rocks because this thing you can use anywhere in the topic of volcanism, earthquakes, etc. थोड़ा difficult है लेकिन अब याद रख लो बहुत ही easy हो जाएगा. ये वाला टेबल रट लेना आप, हाँ? It will be very helpful to you. See, towards this direction, the depth is increasing. Okay. So what will happen to the silica content? Silica content will reduce. So what will happen to the melting point? Melting point will increase. What will happen to the acidity? Acidity will reduce. Okay. So these are the rocks which are present in the upper layers of the earth. Okay, and these rocks are called as felsic rocks. Now while you are going a little bit deeper, you will find the intermediate, so then you will find the rocks which are mafic and these are ultramafic. Okay. So here in this felsic rocks, the silica content is more than 70%. So 70% is related to silica content. So this is around 55 to 65% of silica, and this is 45 to 55, and this is less than 40%. Now this is the chemical formula of the chemical composition of the rock. Now while it is coming from inside, it can be solidified here also, means in the deep interiors of the earth, it can be solidified outside also. So the magma can be solidified, plus also the lava can be solidified. Now if it is solidified in the form of lava, it will become extrusive igneous rock. If it is solidified inside, it becomes intrusive igneous rock. अगर कोई चीज अंदर सॉलिडिफाई हो रही है with more than 70% of silica content, which is highly acidic, this is called as granite. Now, if it is solidifying inside with 55 to 65% of silica content, it is called as diorite. 45 to 55, it is called as gabbro, and this is called as peridotite. But if the peridotite is solidified, it can be solidified outside also, but the chances are very unlikely. So I will not be confusing with you that. If the gabbro is solidifying outside, if it comes out, it becomes basalt. Okay. If it is solidified outside, it is called as andesite, and this is called as rhyolite. And this is called as comatite. Now, if it is becoming difficult for you to mug up all these things, so at least mug up granite, okay, andesite, basalt, okay, only these things you mug up. So rest you can ignore. So granite, okay, why it is very important? Because see, it has very high silica content, बहुत गाढ़ा है, क्या ये बाहर निकल पाएगा? नहीं निकल पाएगा. So mostly it will be solidified inside the earth only. So the chances of formation of this granite is very high. In the same fashion, the chances of formation of the peridotite is very less. Why? Because it is ultramafic, it is highly fluidic, the chances of it coming out is very very high. Okay? लेकिन इतना अंदर से बाहर निकलना थोड़ा मुश्किल होता है. Okay? So the rocks which are formed in most probability is granite, andesite and basalt. Okay? So in the later classes we'll discuss, okay, where exactly these are formed. But again, if I have to tell you, I'll tell you, okay, in a very simple way. So basalt, the Deccan lava plateau is mostly made up of basalt. Andesite, andesite is mostly found in the mountains. That's why Andes in South America, it is andesite. So next you have the granite. So granite will be forming the basement rocks. So since it is solidified inside, okay, you'll be having this big rock on which the mountains are there, continents are there. So it will be forming the basement rocks. And most of the batholiths, batholith is nothing but the basement rock. So it is made up of granite. You please, mark up this table, it will be very useful later on. Okay, for example, okay, I'll tell you the applications of this. Now, say you come across a volcano which is highly explosive in nature. Then, which kind of rock it will be having mostly? Rhyolite. Means you can use such kind of terms in the value addition also. Okay, in the mains answer writing. Because when your answer will be compared with others, your answer should be having some extra value addition. कुछ तो अलग दिखना चाहिए. तब ये वाले terms use कर सकते हो. For example, if a volcano is silent, right, it does not cause much destruction. It is highly fluidic in nature. So which kind of rocks you will find in all probability? Basaltic rocks. Okay, so this is the application of this. And andesite is mostly found in the mountain. Okay, Andes, etc. So this is all about the primary rocks. So once a question, okay, has been asked in the mains about primary rocks. So until and unless you don't write these kind of things, you'll not be getting much marks. Okay. So next topic. So this is all about primary rocks. Okay, you have good content of around 200 words. So for a good 10 marker, it will be sufficient enough. Now what kind of question can be asked there? Okay, say extra 10-20 seconds लगेगा आपका मेंस का क्वेश्चंस भी मैं बता दूंगा. Okay, because आपका a foundation course ढंग से नहीं हुआ है, so that's why I'll tell you. If you can note down, you note down also. Of course, the focus is more on prelims only here. But again, if you understand in a comprehensive way, because the questions जो geography से आते हैं, वो factual questions नहीं पूछता है, depth वाले questions पूछता है, highly conceptual in nature. Okay, the mapping based questions you will be able to do, but the concept based questions आपको करने के लिए geography में आपको बहुत ही ज़्यादा depth चाहिए. जब तक आप ये सब चीज़ समझोगे नहीं, वो answers कर नहीं पाओगे. Now, what kind of questions can be asked? What are primary rocks? Or they can ask, what are igneous rocks and characteristics? Or what is the economic significance of various igneous rocks? So these three kinds of questions can be asked. Now the next topic here is sedimentary rocks. So this is a surface. So this is a water body or ocean. So on the surface, you have igneous rock. In all probability, the igneous rock is formed because of volcanic eruption. So this is igneous rock. Now, this igneous rock will undergo weathering or denudation. Means the rocks will be broken. Rocks are broken because of weathering, because the rocks are exposed to the air, water, etc. And these small particles, these rocks will be falling down. And here we'll be having the agent of erosion. So this is the agent of erosion. So most probability this agent of erosion can be a river. Agent of erosion can be anything. It can be air also, it can be animal also, anything. So river. So these sediments, these are called as sediments now. Now the sediments are carried by the agent of erosion, and finally these sediments will be deposited in the low-lying areas, most probably ocean. And in between these sediments, the clasting material, clasting or plastering material can enter, and under compression, under compactness, these sediments will be attached with each other, and finally it will become sedimentary rock. So something of this sort. ये देखा? So this is a sedimentary rock. So what it is made up of? It is made up of sediments, and the sediments are plastered by a clasting material. In most probability, this plastic material is CaCO3, calcium carbonate or tuna. And the color of the rock depends on the clasting material. So look at the color here, it is a little bit reddish in color. It is reddish in color. Why? Iron content is there. If it is white in color, more calcium carbonate will be there. Okay. Now, over a period of time, you can have the layer over layer like this. So you can see various layers over, and for this one layer to form, it has taken millions of years. And because of the pressure from above, so these sediments have been compacted and they have formed sedimentary layers. Now you see the color differences also here. Now you see a layer here which is more reddish in color. It is because during those times, somewhere in the geological past, maybe millions of years ago, maybe the oxygen content was high, the rainfall might be also high, and the oxidation of iron has taken immensely, and more iron oxide has been deposited here. So that's why you have this rock reddish in color. Say here, say, see, the rock is white in color. Now why this is white in color? Because maybe during those times, millions of years ago, in the ocean, the marine activity is very high. A lot of marine organisms such as foraminifera or your zooplanktons, they are more in number, and when they die, okay, they'll be depositing a very large amount of calcium carbonate. So that's why, okay, the rock becomes white in color. Now, these sedimentary rocks will be telling you the history of the past, means what might have happened earlier. Let's come back here. Say here different layers of the rocks will be formed. So they will tell you the history of the past, and these layers which have been deposited in the oceans over a period of time, finally they'll be lifted up. So this is how these sedimentary rocks are formed. Now, if you take this igneous rock and sedimentary rock, among these two, which is more stronger? The igneous rock will be more stronger, right? For example, I have a cup here. I don't have a cup. I have a cup. Now, if I am breaking this cup and then attaching it, do you think the broken cup will be more stronger, or this will be more strong, or the igneous rock will be more stronger? The igneous rock will be more stronger. And thus, wherever you have these sedimentary rocks or sedimentary rock layers, these are fragile, these are mobile, so these are easily prone to the earthquakes. If these layers are present on the surface of the earth and नीचे का पत्थर थोड़ा हिल गया, earthquake आया, ऊपर का rock और भी आसानी से हिल जाएगा. So that's why they are highly prone to the earthquakes. Now, over a period of time, these sedimentary rocks which are present inside say various layers of sedimentary rocks have been formed. Now, such kind of very large depression on the surface of the earth is called as geosyncline. And because of various forces, this geosyncline is compressed. These layers of rocks will be compressed. And when this geosyncline is compressed, so it will become smaller and smaller, and these rocks will be uplifted. Rocks will be uplifted. And they'll be forming fold mountains of today, like this, somewhat of this sort. I have the forces from both the sides. So this is how the fold mountains are formed. Now say, deep inside the earth, deep inside the ocean, if in between these rocks, say the marine animals will be falling. Say here, you have some kind of fish or something, or marine life. So when the marine life will be falling in between these sedimentary rocks, because of the compression and heat, all the volatiles will be expelled out and the carbon will be remaining back. So if the marine life is fossilified, marine life, if it is fossilified, so it will form the petroleum. And if the plant life or the terrestrial life, if it is fossilified, it will be forming coal. That's why the sedimentary rock of fossiliferous, okay, means they will be having fossils, whereas the igneous rocks will not be having fossils. So somebody is asking me to use light color pens. See, for differentiation, मुझे भी difficult है. Okay, different color pen choose करके सब draw करना. It will be very easy for me to use white color. But for differentiation, I am using, because okay, आपको अच्छा दिखेगा, शायद आपको दिख नहीं रहा है. Okay, I'll go black and white. My strain will be reduced. So let's see the differences between the igneous rock and the sedimentary rock. So igneous on one side, sedimentary on the other side. So the igneous rocks are also called as primary rocks, and sedimentary rocks are secondary rocks, because the sedimentary rocks are formed out of igneous rocks. Next.
The igneous rocks are strong, more stable, whereas sedimentary rocks are unstable, mobile, dynamic, and they form the most earthquake prone regions of the world. Igneous rocks will not be having any fossils, no fossils,
because they are formed after the direct solidification of the magma or lava. तो मोल्टन पत्थर में ओके कोई एनिमल या प्लांट रिमेन होने का चांसेस कम है. Now you guys might be telling me, sir, if the lava is coming out, okay, there was an animal over there, okay, lava आके एनिमल को लपेट लिया, okay, तो igneous rock के बीच में भी, okay, you can have an animal or plant remain. भैया, if a molten rock is coming up with a temperature of 1200 to 1500 degrees centigrade, do you think, okay, the organic matter which is there, it will remain over there? वो पूरी तरह जल जाएगा. And the fossils are formed after a lot of compression and heat, and this process has to be slow. The heat has to be supplied for millions of years. So then only from that organic matters all the volatiles will be expelled out and the carbon concentration will increase, forming fossils. Okay, so it will not have fossils at all and it will be fossiliferous. Next difference. Now the igneous rocks are
not layered, and they have layers.
And each layer will be telling you story of the geological past. So these are some of the differences between the igneous rocks and the sedimentary rocks. Next
is the metamorphic rock. Metamorphic rock. See, metamorphosis means change.
Something is undergoing change. For example, okay, you have an igneous rock or a sedimentary rock. For example, you have this sedimentary rock. Now, if I am applying a lot of heat and pressure, do you think the mineral and structural composition of this rock will remain the same? No, it will not remain the same. It will undergo change. This change is metamorphosis. So therefore, any igneous rock or the sedimentary rock can undergo change
and it can become metamorphic rock. So, any igneous or metamorphic. So, if a heat and pressure is applied, either heat or immense pressure is applied, then it becomes metamorphic rock.
Now, you'll have various types of metamorphism, which is not important for the GS, but again, nothing wrong in knowing one or two terms. So, if it is formed more because of the pressure from all the sides, it is called as dynamic metamorphism. Now, if it is formed, okay, because of heat, it is called as thermal metamorphism. Again, under this, you will be having various types, so don't get into all this. So, a Kharga is asking me, layered intrusive igneous rocks, silts and dikes will be doing in the topic of volcanism, not here. So, I am just building you the basics here. So, we have taken the topic of rocks and minerals, very simple topic, okay. So, metamorphic rocks. Now, in examination, what they can ask,
okay. So, for example, you have sandstone. So, sandstone is a sedimentary rock.
So, when a sandstone undergoes compression and heat, it will become quartz.
It will become quartz.
So, you have limestone.
When the limestone undergoes metamorphosis, it will become marble. Okay, these two are the sedimentary rocks. If you have granite, now igneous rock can also undergo metamorphosis.
So granite is one of the oldest rocks because the granite forms the basements of the continents. The granite will be giving stability to the mountains and the continents. So these are some of the oldest rocks which have been formed. इतना old है and नीचे दबा हुआ है, obviously उसके ऊपर pressure लगेगा, heat लगेगा, and it will undergo metamorphosis and it becomes gneiss. And sometimes you can also have very fine sediments. Okay, if you are having very fine sediments of the rock, it is called as clay. Now clay can also undergo metamorphosis. So depending upon different conditions, it can either form slate, phyllite or schist. So the schist form होने के लिए it require high temperature and high pressure. That's why the schist is formed mostly in the deep interiors of the oceans. So offering the schist, you'll be finding a lot of shark bones, shark teeth, okay, or the animals which are there on pelagic floor, etc. वो मिलेगा schist में. So these are some of the examples of the metamorphic rocks. So beyond this, they won't be asking. So what all questions can be asked, right? And next one is, they can also ask a question, what is rock cycle? Rock cycle. See, igneous rock can become a sedimentary rock. And igneous rock can also become metamorphic rock. And sedimentary rock can also become metamorphic rock, right? Say a sedimentary rock goes deep into the earth interiors. वो कहीं ट्रेंच में गिर गया, mantle के अंदर घुस गया. So inside the mantle, the temperature is very high. The sedimentary rock can melt and again it can become igneous rock. Similarly, a metamorphic rock can also enter into the mantle through the trenches. Then also it can become an igneous rock. The metamorphic rock, okay, also can undergo denudation, weathering, deposition. Again it can become sedimentary rock. And this is called as rock cycle. And the definition is, rock cycle is a descriptive conceptualization of how an igneous rock is converted into sedimentary, sedimentary is converted into metamorphic, and metamorphic is converted into igneous again. So this is a very simple definition. So you ratify these definitions, okay, because it will become very easy in the examination. Okay, don't write definition. Okay, phyllite क्या है, you are पूछ रहे हो ना? Phyllite कश्मीर में बहुत यूज होता है. Most of the houses in the Kashmir are made up of phyllite because the Kashmir is located in the Himalayan region, and Himalayas are sedimentary rock, and sedimentary rocks over a period of time can be metamorphosed. So clay, if you are having high pressure and intermediate temperature, phyllite will be formed, right? Kashmir में जो भी घर है, okay, sometimes earlier in the earlier times, the roofs of the houses in Kashmir, okay, उसके ऊपर phyllite रखते थे. Phyllite एक light पत्थर है, but comparatively strong है, okay, and जब ये पत्थर एक घर के ऊपर use करते थे, earthquake भी आ गया, तो उतना नुकसान नहीं होता था. So imagine you have the entire slab falling down, and you have, okay, like thin पत्थर, okay, slabs falling down. So slabs से ज़्यादा नुकसान होता है. So that's why we have to take this traditional knowledge also into account while you plan for the houses in the seismic zones. Understood? And next question which they can ask is economic importance of various rocks. Economic importance. Properties तो हो गया,
Now, why we are studying these rocks? What is the interest?
Geography is man environment relationship. ये पत्थर है लेकिन अपने लिए यूज क्या है? So in your houses you'll be using granite. Granite का flooring use करते हो. क्यों use करते हो? Granite is a basement rock. The granite has a capacity to stabilize the mountains. It has a capacity to stabilize the continents. It is very strong. That's why it is used in the flooring of the houses also, because of its strength. And also the granite has got beautiful texture here. Here you can see texture of granite. It has got beautiful texture. That's why also it is used. And granite has a lot of cooling properties. That's why also it is used. Okay. So you can take some of the igneous rocks and benefits. You can take some of the sedimentary rocks and their benefits. The sedimentary rocks, for example, now petroleum, coal, it's a sedimentary rock. Okay. Fuel का काम आता है. Sandstone, red sandstone, white sandstone, sedimentary rocks, again used in the construction purposes. Now what is the difference between a red sandstone and a white sandstone? See, the color of the rock depends on the clasting material in between. In a white sandstone, you have a lot of calcium carbonate, that's why it is white in color. And red sandstone, you have a lot of FeO, iron oxide, that's why it is red in color. In history also, you will come across this Gandhara School of Art and Madhura School of Art. Madhura School of Art मधुरा में है, इंडिया में है. तो जितने भी बुद्धा के स्टैच्यूज ओके मधुरा स्कूल ऑफ आर्ट से बनते हैं, दे आर रेडिश इन कलर. एंड जितने भी रॉक्स, जितने भी बुद्धा के स्टैच्यूज, ओके दिस गांधारा इज नथिंग बट कांदाहार विच इज देयर इन अफगानिस्तान, दैट इज वाइट इन कलर. सो वाइट सैंडस्टोन इज यूज्ड. एंड मोस्ट ऑफ द इंपॉर्टेंट मॉन्यूमेंट्स इन इंडिया सच एज फतेहपुर सीकरी ले लेना आप, ओके रेड फोर्ट ले लेना. सो मोस्ट ऑफ देम आर मेड अप ऑफ रेड सैंडस्टोन. सो हिस्ट्री में भी ये वाला चीज़ आपको काम आएगा. एंड मेटामॉर्फिक रॉक, एंड जस्ट नाउ आई एक्सप्लेन, okay, slate, okay, can be used as used for writing purposes. Phyllite, it can be used for the construction purposes, right? Okay, and schist, okay, it is not used anywhere. So these are some of the examples of metamorphic rock and their importance. And limestone, okay, it is used in industries. It's a metamorphic rocks. And most of the minerals, okay, which you get, they are also rocks. Okay, they also have got economic importance. So I'll be finishing this topic. These are the sedimentary rocks. So each layer will be telling you one story here. You can find this beautiful patterns. Okay, once upon a time they have been formed in the ocean, and because of the compression, so since they will be soft when they are inside the ocean, they'll undergo bending, folding, etc. So this is nothing but, so earlier you had a plant life. This plant life will be undergoing compression, and more you compress, better and better form of the coal you will be getting. You can see coal over here. This is a rock, and above this also you have a rock. So the plant remains have been fossilified and they have become coal. Okay, and the life in the oceans will become petroleum. So this is about the topic rocks and minerals. If you have any doubt with respect to the rocks and minerals, you can please ask. We kholo. So you'll be having various versions. For example, if I am opening on internet, so you'll be having various versions. For example, you take this. देखो इसमें कितना सारा ages, eons, etc. कितना सारा है. Do you think you'll be able to remember all this? And in the recent past, they have asked 2-3 questions on geological time scale. Devonosian time period, Mesozoic, 2 बार क्वेश्चन पूछा है. So बहुत सारा आपको इसमें versions मिलेगा, कुछ बड़े, कुछ छोटे, etc. I'll tell you in a very simple way, which will be useful for the examination. That is what I'll be doing in this class. Okay, आपको पर चीज़ें समझा रहा हूँ. When you guys will be making notes, please use colors. अगर मेरे क्लासरूम में स्टूडेंट्स होते हैं ना, okay, they use colors and over a period of time, the presentation skills will be improved drastically. See, prelims की बात अलग है, लेकिन मेंस में ना presentation matters a lot. सेम टाइप ऑफ कंटेंट दोनों बंदे लिख रहे हैं, लेकिन जिसका प्रेजेंटेशन बहुत ही अच्छा होता है उसको अच्छे मार्क्स मिलते हैं. एंड प्रेजेंटेशन अच्छा होने के लिए आपको सिंपल ट्रिक्स यूज करने पड़ेंगे, विच आई विल नॉट बी डिस्कसिंग नाउ. मे बी इन द फाउंडेशन कोर्स आई विल डिस्कस. नाउ नेक्स्ट टॉपिक इज जियोलॉजिकल टाइम स्केल. I'll be telling you things in a very simple way, and things which can be asked in the examination, which you can use in the examination for enriching your answers. Okay, दोनों चीज बताऊंगा. Okay, Kalyan is asking, okay, if possible, okay, please, okay, previous student notes. Okay, previous students का notes ना, okay, मुझे आप message करो, मैं आपको दूंगा. On this PMF platform I cannot, okay, because again उसमें लोग क्रिप करेंगे. सर ये ढंग से नहीं है, ये मुझे राइटिंग समझ में नहीं आ रहा है, सर यहाँ पे क्या है, वहाँ पे क्या है. बिकॉज कोई भी क्लास का नोट्स लिखेगा अपने हिसाब से लिखेगा ना. सो दैट्स वाई इफ आई अपलोड ऑन द प्लेटफॉर्म, लोगों को कुछ दो ना, फिर भी वहाँ पे तकलीफ होती है. ओके, सो वे बैक से 4.6 billion years ago, when the earth has been just formed. So when the earth has been just formed, it was a molten rock. Pura a red, hot, molten rock in which chaotic convections have been taking place. Means the churning process is happening. Right? And the earth is being bombarded with lot of asteroids also. Because at the time there was no oxygen, was not there. Right? And the geological time scale, जो भी आप time scale यहाँ पे देख रहे हो, for a time scale to change, some geological phenomena must have happened. For example, आप देख रहे हो यहाँ पे, okay, Hadean, Archean, Proterozoic, Paleozoic, Mesozoic, etc. Based on what kind of life forms have taken over the earth or ruling the earth, they will sculpt and change the landscape. तभी geological time scale बदलेगा. Now पहले life ही नहीं था, around 4.6 billion years ago. So this was the condition of the earth during that time. Now during this time, do you think any kind of life is possible? So life is not possible. Means आप life नहीं होती है तो आप यमराज बोलते हो ना. So the Greek god of death is Hades. So that's why 4.6 to 4 billion years ago, you had this Hadean phase. So no life has existed, no life. Now, after Hadean, 4 billion years to 2.5 billion years, you have this Archean. Archaeological बोलते हैं ना, पुराना, Archean. Now, why there is a differentiation now? Because just now, okay, we are discussing in Western Australia, oldest crater, which is around 3.5 billion years old, has been found, right? Now, what is the importance of that? Because when these asteroids, okay, when these extraterrestrial objects, when they are hitting the earth, they'll be puncturing the earth. When they puncture, you'll be having these volcanic eruptions. And when the volcanic eruptions happen, one of the important gases which is being released, okay, is CO2 and water vapor. A large amount of vapor is released and CO2 is released. Okay, The CO2 is providing the earth with the required heat because it's a gas, okay, which has global warming properties, and vapor है, CO2 है. So क्या हुआ, अर्थ के ऊपर ओशंस फॉर्म हुआ. So when the oceans will be formed, now let's see what happens during the Archean time. Okay, I'll be explaining you this in bit detail. So Hadean का features देख लो. Okay, the surface has cooled little bit. Okay, heavy meteoritic bombardment is happening, etc. Okay, all these things not that relevant. Now I'll tell you what is happening during this Archean time period. And this is very important. Okay, this will also lay a foundation for your climatology later on. You'll understand how the climate, various climates have been created. So during this Archean time period, see, from the volcanic eruptions, some of the important gases will be released. So this phenomena is also called as volcanic degassing. See, please adjust with this diagram because I could not get a better diagram than this. I could have written on the blackboard also, but writing here will make more sense because you will also get an essence. See, the humans, okay, our brain is not designed to, okay, पढ़ाई लिखाई में डिज़ाइन नहीं है, पढ़ के समझने में, okay, अपना ब्रेन डिज़ाइन नहीं हुआ है. ओके, फॉर एग्जाम्पल आप बुक पढ़ रहे हो, पिक्चर देख रहे हो, मूवी देख रहे हो, कौन सा चीज़ याद रहती है आपको? मूवी देखना. दैट्स व्हाई आई बिलीव मोर इन, ओके, मूवी तो मैं नहीं दिखा सकता हूँ, ओके, कांट मेक एनिमेशन ऑफ ऑल दिस थिंग्स, बट ओके एटलीस्ट आई कैन यूज डायग्राम्स. सो आपको थोड़ा बहुत, ओके, पिक्चराइजेशन होगा. सो वोल्केनिक डीगैसिंग. सो फ्रॉम हियर important gases such as CO2 and H2O will be released. Okay, and this H2O has formed the oceans which you can see here, and CO2, okay, has formed the warming. It is able to maintain the temperature. अगर CO2 नहीं होता अर्थ के सरफेस पे, you would have had extremes of temperature. Day time में you would have had very high temperature because sun's direct heat, and night time it would have become very cold, and in extremes of temperature the organisms will not survive. And if you have gases, they'll be able to stabilize the temperature. And in this H2O, and because of this volcanic degassing, you have these elements such as phosphorus, nitrogen, okay, oxygen, hydrogen. And of course carbon. So these are the 5 basic elements of life. Please ये ध्यान रखना, 5 basic elements of life. And these 5 basic elements, a sugar compound will be formed. So here you will be having a nitrogenous base, which you will be studying in science and technology, and here you will be having a phosphate group. See, over millions of years, because you have a time of around, okay, 1.5 billion years here. So various permutations and combinations have taken place, and finally such kind of a structure has been formed. Means एक pentagon type form हुआ, pentose sugar, and एक, okay, carbon पे आ गया nitrogenous base, एक carbon पे आ गया phosphorus group, and this has gained consciousness. Okay, and this is how the life has been evolved. So like this, all these nucleotides, they are able to join with each other, and it has formed something called as DNA. And the DNA is a basic form of life. Now किसको बोलते हैं of life? If it is able to propagate further, अगर इसकी copies ये खुद produce कर सकता है, and it is able to survive करके propagate कर सकता है, उसी को तो life बोलते हैं. So this is how the life has been evolved, and gradually the DNA, okay, has become chromatin. The chromatin has become, okay, has created an envelope around itself. Nucleus form हो गया, and gradually organelles have been developed, and finally it was able to form a cell. Okay,
And this primitive life which has been formed, this is called as the cyanobacteria. The cyanobacteria is nothing but blue-green algae. And this algae is able to undergo photosynthesis. Because जब earlier life form जो था, it did not complain. Oxygen नहीं है, okay, the volcano आ रहा है, okay, toxic gases आ रहे हैं, I will not survive, it did not complain. The UPSC students also should not complain much, मेरे पास AC नहीं है, okay, मैं सर्दी बहुत लग रही है, okay, ढंग का खाना नहीं मिल रहा है. जब तक ऐसे complain करोगे, then आप survive नहीं कर पाओगे. So the cyanobacteria did not complain. Okay, so whatever resources were available during that time, it was able to propagate further. It was able to survive itself. Then what was available during that time? सूरज available था, oxygen तो नहीं था, CO2 था. So with the help of CO2 and sunlight, it was able to undergo photosynthesis, and the byproduct, the waste product of this has become oxygen. So this is how the first oxygen has been created on the surface of the earth. And this was happening during the Archean time period. Now, whenever a new organism is evolving, it will sculpt the earth. पूरा algae form हो गया. So earth का जो shape है, means okay, the surface जो है, उसमें change आ गया. So that is why the time period will also change. You can see the important points over here during Archean period. First stable continental nuclei, cratons. Craton means the oldest rocks have been formed. Ancient mountain belts, such as this Aravallis, Eastern Ghats, have been formed during this time period. Means the plate tectonics were taking place. And early life such as prokaryotes, okay, and free oxygen, okay, has emitted, but still it is very low. So this is what happened during the Archean time period. So somewhat, okay, from such kind of a landscape, okay, it has become this one, something of this sort. So algae was everywhere. So that's why it is called as the Archean time period. Understood? So after Archean, now during this time, the single-celled organisms have been formed. Single-celled. Obviously, the single-cell organisms will become multicellular. So protozoa वगैरह, and beyond that, life forms have been formed. So this becomes proterozoic. Means bigger life forms have been formed. And for this evolution to take place, from 2.5 billion years, it has taken around 550 million years. And after this, further life forms have been created, and this would be called as Phanerozoic. Phanero means visible. Means visible life forms have been formed. So anything which is below this 550 million years, so this is all called as Precambrian. इसको पूरा बोलेंगे Precambrian. So this Phanerozoic is further divided into three. So this is all Phanerozoic. So Phanerozoic is further divided into three. Paleo means Purana. Paleozoic. Ceno means नया. Cenozoic. And जो बीच में है वो मीसो होता है. Mesozoic. So Paleozoic, Mesozoic and Cenozoic. Now, of course, the evolution of the life forms will be taking place here. So, till the Paleozoic, that is around till 250 million years, the life was mostly restricted to the oceans. So this is where somewhere here the plants have evolved, and somewhere here the entire oceans, they were ruled by fish. And इसमें further Cambrian, Devonian, Silurian, okay, Cretaceous etc. है, but वो सब याद रखने की ज़रूरत नहीं है आपको. So gradually the life forms have been evolving. इसके पहले क्या था? इसके पहले mostly cellular, single cellular or at max jellyfish have been evolved during the Precambrian time period. This is all Precambrian. Then gradually the fish has been evolved. Okay, अभी fish evolve हुआ, plants evolve हुआ. उसके बाद somewhere at the end of this Paleozoic, we have this amphibians. Amphibians have evolved, right? Means the animals which can live in the water as well as on the land. Okay, the amphibians will gradually give rise to the reptiles. So when the reptiles have evolved, okay, it becomes Mesozoic. Okay, then in Cenozoic, most of the reptiles which were present, they all perished and mammals have evolved here. So जब भी एक नया organism evolve होता है, it will sculpt and change the landscape. So that is how the geological time scale also changes. So during the Mesozoic, it was ruled by the reptiles. So you have these three time periods over here. Again, you may not remember, okay, need not remember, not required. Okay, Triassic, Jurassic, Cretaceous, etc. Okay, means basically, okay, you had this dinosaurs. So dinosaurs were ruling the earth. So when the dinosaurs were ruling the earth, do you think the mammals will be able to survive? If there is a competition between a dinosaur and a mammal for food, for hunting कर रहे हैं, भाई खाना किसको मिलेगा? Dinosaur को मिलेगा. That's why during this time, the mammals were very small. Mammals were small, means rats, rodents, okay, insignificant. But once the Cretaceous eruption has taken place, so Cretaceous eruption has taken place around 65 million years ago. At that time, all the dinosaurs have perished and mammals क्या छोटे थे. So rats, rodents, they were able to go inside the earth and they were able to survive the high energy radiations and big fires and swarm of earthquakes which have been formed. वो survive कर गए and थोड़ा temperature down होने के बाद वो बाहर आके evolve हो गया. So that is how the mammals have evolved during the Cenozoic time period. So this is what you can remember. 2-3 incidents which are important in the Paleozoic, I'll tell you. So during the Paleozoic, around 350 million years ago, 350 million years ago. See, the plants have become so intense. Means the earth was completely infested with the plants. क्योंकि तब animals नहीं थे ना. Animals होगा तो पूरा plant को खा जाएगा. So the plants have become very rampant during the Paleozoic because in Paleozoic most of the life was restricted to the oceans. And when the plant concentration increases, they will undergo photosynthesis, they will be sucking out all the CO2 and the ice age has arrived. So it has become so cold. And during the same time, lot of tectonic movements were taking place, lot of rifting has been created. And in this rift, all the plant life has fallen, it has fossilified, and during the Carboniferous time period, the coal has been formed. The best of the coal has been formed. So Carboniferous coal is best coal, and Indian coal is not Carboniferous coal. Okay, the Indian coal has been formed around 250 million years ago. This is called as the Permian coal. Indian coal is bit less mature, 100 million years less mature. That's why the carbon concentration in the Indian coal is not that great. Okay. And during the Paleozoic time period, okay, two important mountain forming incidents have taken place. So around 450 million years ago, you had this old fold mountains formed called as Caledonian. And around 350 million years ago, Hercynian. So these are two important mountain forming incidents which has happened during Paleozoic. Because as far as geography is concerned, we are concerned about the mountain formation, right? And of course, okay, why the time period is changing? Because of the evolution of life, right? Now during the Mesozoic, okay, the earth was infested with dinosaurs. It was ruled by reptiles, okay. So between these two, okay, not much of mountain formation has taken place because the mountain formation activity is not random. There are certain geological time periods during which the mountain forming will be forming. Now during the tertiary, okay, during this Cenozoic, the Cenozoic is further divided into two. So this is divided into two. One is tertiary, other is the quaternary. And the time period between these two is, okay, differentiation is around 2 million years. So during the tertiary time period, your mountains such as these Alps, these Himalayas, your Andes, Rockies have been formed. These young fold mountains have been formed during the tertiary time period. So that's why these are also called as the tertiary mountains. Again, 2 million years, quaternary. So this is where the earliest human life forms, have been evolved during the quaternary period, right? So these are the various incidents which have taken place. And northeast में जो coal मिलता है, that is the tertiary coal, which is not older than 65 million years. Now this quaternary is again divided into, do we have time? Okay, we can go for some more time. Now quaternary is further divided. Again you can go through the PPT here. So what has happened during the Proterozoic? So great oxidation event has happened, okay, large scale continental collisions, etc. I can go through all this, I have explained all this. So Permian, so every time period is marked with the extinction, a great dying will be there. All these things I have explained. Now, the quaternary time period is further divided into three, called as Greenlandian, North Grippian and Meghalayan. So this is during the quaternary time period, the Ice Age also started. Ice Age. Okay. So the quaternary is further divided into two. One is Pleistocene, Holocene. Right. So Pleistocene, okay, most of the Pleistocene is Ice Age. The Holocene is the period of warming. It is a period of warming. Now during the Pleistocene time period, again most of the life has perished. Because जब भी ice होता है, okay, वो perish होता है. Because the life won't be able to survive. During this time period, around 2/3 of the earth was completely covered with ice. So the period of warming has started around 11,800 years ago, but I'm rounding this off to 11,200 years. So a couple of million years here and there, does not matter. So this is Holocene is further divided into three. Okay. Again, why I'm rounding it off to 11,200 years, because I will make it 8,200 and I'll make it 4,200. Okay. So it is further divided into three: Greenlandian, North Grippian and Meghalayan. So this is 11,700. तो यहाँ पे 8,200 है, यहाँ पे 4,200 है. So मैं इसको भी 11,200 बना दिया. Okay. So the Greenlandian, North Gripian and Meghalayan. Now, this is the time period during which the warming is taking place here. This is a period of warming. So, आपने movie देखी होगी Ice Age. So, during this time period, the humans gradually started their migrations. Human migrations have started. Ice से बाहर निकलने लगे. And after this human migrations, around 8,000 years ago, settled. The humans have settled, and they also started agriculture. So this is where the civilizations such as your Mayan civilization, your Inca civilization, your Kiledi civilization, excavation over recently in Tamil Nadu. And the Kiledi excavations are said to be the older than Indus Valley civilizations, because Indus Valley civilizations records we have from around 3,000 years. So this is still 4,200 years. So Kiledi excavation civilization is much older than this. So we can also add. Officially it has not been added. Central government में पूरा fund रोक दिया. अगर कोई बोलेगा कि भैया नॉर्थ इंडिया में सिविलाइजेशन नहीं हुआ, तमिलनाडु में सिविलाइजेशन हो गया, so फिर उसको प्रॉब्लम आ जाएगी. Okay, so I will also add Kiledi. So, but 4,200 years ago, we can also add this, Egyptian civilization, the great, what is that? Pyramids of Giza, etc. Egyptian. So 4,200 years ago, there was a drought, extreme drought. And because of the drought, the civilizations have perished. And that is where we have entered into Meghalaya. It's also called as the period of great dying. Now the question is, should we add a new time period called as Anthropocene? Because throughout the geological time scale, we have been seeing that whenever some extinction has happened, whenever new life forms have taken over, started ruling the earth, the time period, the names have changed. Now, starting from, let's say, 1750s or 1850s, the timeline has not been decided. The industrial revolution has started, and the human population has increased enormously. The humans started ruling the earth, and humans have sculpted and changed the earth. Now, in the mains, they can ask questions. Do you agree that a new time scale or a new time period called as Anthropocene should be added to the existing geological time scale? Now, in order to support this, you should be coming up with various statements, so which can also be used in the pre. Now, क्या किया humans ने? So at the 1750s, 1850s, at the start of industrial revolution, the carbon dioxide was around 250 ppm or 285 ppm. From 250 to 280, now it has been increased to 450 ppm. So carbon dioxide has been increased. Sea level has risen. So the yearly sea level rise is around 4 mm per year. Sea level rise is increasing. Deforestation, very large scale deforestation has taken place. Per annum around the world, 10 to 12 million hectares of deforestation is taking place. The rate of sedimentation has increased because the humans are scourging the earth. The humans are doing mining. The humans are causing large scale dryness on the surface of the earth. So because of this, the sedimentation is increasing. More land erosion is taking place. The rate of desertification has increased. Deserts are becoming larger and larger. The moist deciduous forests are becoming dry deciduous forests. Population, in the 1300s was around 300 million. Now it has come 8 billion. In the beginning of this century, okay, means 20th century के beginning में 1900s में, the population was around 1 billion. That has become 8 billion. Means within last 100 years, our population has become 8 times. भाई किसी भी organism का population इतना नहीं है, okay, जितना humans का है. So such kind of, and temperatures have increased. So from the past industrial revolution, if you see, 1.5 to 2 degrees centigrade temperature has been increased. So the humans have caused large scale changes. So there is plastic everywhere, which is caused because of the humans. Okay, on the surface of the earth, you will see a lot of what do you call them? Nuclear materials, radioactive metals are spread everywhere. It is because of the humans. There's plastic in the ocean, microplastic in the ocean. It is because of the humans. This ozone layer, okay, ozone layer has been depleted, ozone holes have been formed because of the humans. There's a lot of SOx, NOx and anthropogenic gases which have been released. It is because of the humans. The humans have shaped the earth. पहले जो earth था, वैसा humans ने नहीं रखा. So that's why there is a need to change the time period, okay, from Meghalayan to Anthropocene. So whatever numbers I have told, okay, please remember. I remember all these numbers, that's why I'm telling you. Okay, anyways, if you guys want, I'll be sending you the notes also. Please go through the notes. In these notes, all these things are written. Okay, when I take the foundation class, okay, give the questions. I ask the students to write all this. So you can also find, okay, 15 to 20 evidences why we should be renaming, okay, why we should be giving a new name called as Anthropocene. Okay. Okay, I hope you have understood the geological time period. I'll be sending you the PPT also, you can go through it. So this is North Grippian, okay, starts with the abrupt cooling event, okay, this is when hunting gathering was taking place. Okay, then you have Meghalayan, okay, this is Anthropocene. So these are all the pictures only. I hope all the doubts are clear. Any doubts you have? All good? Are you guys there? Facts are overloading. Yeah. अभी तो ये वाला मैग्नम शुड बी रेड साइमल्टेनियसली, या रीड करो, बट इतना सारा इंफॉर्मेशन आपके मैग्नम में या कोई भी बुक में नहीं है. ऐसा लास्ट टॉपिक कुछ समझ में नहीं आया. ओके, सी फिर से आप आपको रिकॉर्डेड क्लास मिल जाएगी थोड़ी देर में, कुछ घंटों में. फिर से आप क्लास को देखना. एंड इतना ज़रूरत नहीं है. मोर अगेन सी यूपीएससी के लिए लॉजिक चाहिए, right? It's not about overloading of information, and whatever I tell you here, it based on logic only. सब चीज़ों के लिए मैं लॉजिक बताऊंगा. एंड आप एक डीपर अंडरस्टैंडिंग जब डेवलप करोगे ना, आप प्रीलिम्स का कोई भी आंसर सॉल्व कर लोगे. सो सिंस यू हैवंट कम अक्रॉस ऑल दिस थिंग्स बिफोर, एंड ये फास्ट पेस पे चल रहा है, सो इसलिए आपके कॉम्प्रहेंशन में थोड़ा दिक्कत होगा. बट you relook the class once again and then write your own notes. You'll be able to pick up, okay? And I am trying to simplify this in a very, मैंने तो ये वाला जियोलॉजिकल टाइम स्केल नहीं बताया ना. मैंने आपको कुछ ही चीज़ें बताया. हेडियन क्या होता है, कुछ लाइफ नहीं है. आर्कियन क्या होता है, तब ऑक्सीजन एवॉल्व हुआ था. प्रोटोजोइक क्या है, सेल्स एवॉल्व होने लगे. ओके, देन देन पैलियोजोइक में फिश हुआ, प्लांट्स हुआ. मीसोजोइक में डायनासोर आया. ओके, सीनोजोइक में ह्यूमंस आ गए, सॉरी मैमल्स आ गए. देन प्लीस्टोसिन में ह्यूमंस एवॉल्व हो गया, राइट. देन ओके, इन द क्वाटरनरी टाइम पीरियड यू हैव, सॉरी कौन सा, हैलोसिन में ह्यूमंस कंप्लीटली एवॉल्व होके बाहर निकलने लगे. तो धीरे धीरे आप पे देखो, चीज़ों को समझो. ओके, ये थोड़ा कॉम्प्लिकेट होगा. सी आपको अगर आंसर्स एनरिच करना है, सी मैं मेंस के पर्सपेक्टिव से भी बता रहा हूँ. सी टुमारो यू वांट टू राइट ए आंसर इन मेंस. अभी यू कैन नॉट जस्ट ओके से इन ए लेमैनिश वे ना,
that during the Mesozoic, around long time ago, when my forefathers were there, during that time this Caledonian mountains or such as the Great Appalachians have been formed. वो पूरा गंदा लगेगा. So you can say during the Mesozoic time, during the Paleozoic time period, the Caledonian mountain building was prominent, and one of the examples is the Great Appalachians in North America. So जितना पैसा लिखोगे उतने अच्छे मार्क्स मिलेंगे. Okay, and it's up to your choice also. आप long time ago the mountains in North America have been formed. ऐसे भी लिख सकते हो, वैसे भी लिख सकते हो. It's up to you, right? If you want to become a जिला कलेक्टर, okay, IAS बनना है तो आपको थोड़ा अच्छी तरह प्रेजेंट करना पड़ेगा आंसर्स को. If you are happy with IRTS, railway service है, नहीं तो कोई भी सर्विस है उससे भी satisfied हो, then you can write answers in the layman's way. See, mountains can be divided into various types. They can be divided into types based on when they are formed, or you can say age. So they can be divided into a type based on whether they are coastal mountains or they are inland mountains in between the continents, etc. But we'll be looking for, as far as geography is concerned, the most important one is the genetic types. Genetic type means based on the formation, how they are formed. So on this basis we'll be dividing the mountains. So on this basis you have 4 types of mountains. If you guys know what are these 4 types, you can type it over there. So the 4 types here are fold mountains, residual mountains, volcanic mountains, and block mountains. Of all the mountains, the fold mountains are only the true mountains, and the true mountains, these are also called as the orogens. So orogens are the true mountains. Now regarding the formation, see, the fold mountains are formed because of the deposition of the sediments in a geosyncline, and the geosyncline will be compressed because of various reasons. So these sediments will be uplifted to form fold mountains. So when the fold mountains become quite old, like we have seen the Caledonian mountains, Hercynian mountains, or Archean mountains, when they become quite old, they will undergo denudation, and after undergoing denudation, they become residual mountains. So these are also called as the mountains of denudation. The volcanic mountains are because of the volcanic process. That's why they are also called as the mountains of accumulation. So these are the other names of the mountains. Now, since the fold mountains are the true mountains, we'll discuss little bit about fold mountains. The fold mountains are not formed randomly. There have been distinct geological time periods during which the fold mountains have been formed. For example, so distinct geological time period means, so in the pre-Cambrian times, 550 million years ago. So it is said to be, again some people say that there have been 4 instances, some people say that there have been 5 instances, some also say 6 instances. So I'll go by the middle part. So during the pre-Cambrian times, pre-Cambrian, this word you should be knowing. So during the pre-Cambrian times, there have been 6 instances of fold mountain formation. And if you talk about the examples here, 2 examples, classic examples, we'll take from India here. The one is the Aravalli. So Aravalli is said to have formed around 2.1 billion years ago.
And Eastern Ghats, it is said to be formed around 1.7 billion years ago. So a couple of millions of years, here and there, doesn't matter. So this is the most accepted. So in some textbooks you might be seeing, okay, if you open Savindra Singh, they will say 2.5 billion years. Eastern Ghats 2 billion years. It doesn't matter because exactly किसी को कुछ नहीं पता है. Okay, so you are taking the approximates. Okay, that's why if you're saying Precambrian, it's fine. Whatever you say below it becomes fine. And during Paleozoic, this term you should know, Paleozoic, right? So 550 to 250. 250 also you have to remember because after 250 the Pangea formation will be taking place. So, okay, if you become familiar with these terms, it becomes very heavy because we'll be using these terms very repeatedly. So, again here you have the Caledonian and Hercynian. Okay. So, you may not remember these terms, okay, but okay, you have to know what kind of mountains are these. Now, again, if you look at various textbooks, you will see Caledonian, Hercynian mixed up. So we'll be putting certain mountains here, such as, for example, Appalachians. The Appalachians have been formed in the Caledonian and then they continue till Hercynian also. So I'll not be differentiating here as far as the GS is concerned. So I'll be writing certain mountains over here. So you can write the Appalachian GDR, Great Dividing Range. This is in Australia. And then you have the Pennines, okay, Pennines in UK, Urals in Russia. So these are some of the examples, okay. And we can also say that all these mountains have become quite old and today we can categorize them as residual mountains. Now the fold mountains or the young fold mountains will be having sharp peaks, okay. They will be having higher heights, whereas these mountains are rounded off and they will be having lower heights. Now again, not much has happened during the Mesozoic times and during the Cenozoic times, that is during the Tertiary time period, you have this young fold mountains form. Young fold mountains. So these young fold mountains are also called as tertiary mountains, and also they are called as, this is a phase of alpine mountain building. Now what are the various mountains here in the alpine mountain building? So here you have the Himalayas. Now what is the time period here again? 65 million years. Okay. So geological time scale is not that useful to you. Okay. The questions haven't been asked directly, but again at many places you can use the geological time scale. So we'll have a clarity. So that's why I've spent a little bit of time. I have explained that, but again, okay, it will enrich, okay, your understanding in a much better way. So Himalayas, Alps, the Rockies and the Andes. Andes, you remember? I talked about andesite rock. So that is from where this Andes name has come. Because, and most of these mountains also have andesite. Now they all belong to one class of mountains. These are also young fold mountains. They'll be having a height, okay, very good height. If you take the Himalayas, great Himalayas will be having 6,000, Rockies around 4,000, Andes around 5,000. So now why this phase is called as alpine mountain building, not Himalayan mountain building? Because most of the research has been done in the Alps, so that's why they have given these names, okay, alpine mountain building. So 6 instances, 7, 8 and 9 instances. So till now there have been 9 instances of mountain building. Now how these fold mountains are formed? See, there are various theories which explain the formation of the fold mountains. So different people have come up with different theories. Now there was a guy, okay,
called as okay, CDT guy, you know, you must be knowing, okay, Wegener. If you ask him, he will be saying that when the continents are moving over the oceans, then along the sides of the continent, the marine sediments have been deposited, and that has given rise to fold mountains. And if you ask the thermal contractionist, so they have given very weird explanation. So they have told that when the earth was cooling, the wrinkles have formed on the surface of the earth. Okay, when you cool the milk, you have a creamy layer. The creamy layer also forms the wrinkles. So in that fashion, when the earth's outer layer, when it was cooling, the wrinkles have formed, and these wrinkles are nothing but fold mountains. So different people have different explanations. Okay, but a very simple way of explaining this fold mountains is the geosynclining theory. Of course, in plate tectonics theory, we'll discuss in detail how these fold mountains are formed. So according to geosynclinal theory, so this is a syncline, geosyncline because it's a earth scale, means it is a very large depression. So in this large depression, the sediments will be formed. Sediments. The sediments will be deposited. The sediments will be undergoing compression. And because of the forces which are acting on both the sides, so this layer will become, this geosyncline will become smaller and smaller, and over this you have this fold mountain formation like this. So this is a very simplistic explanation. So these layers of the sedimentary rocks which have been formed in the geosyncline, they get folded, they are overturned, and finally the fold mountains are formed. Now, so this theory, you know, very simplistic. Now it is able to explain many things over here. Like most of the fold mountains, most of it is formed by the sedimentary rocks of marine origin. These terms you have to remember. Sedimentary rocks. Sedimentary rocks of marine origin. So it satisfies this theory. And the fold mountains can be formed in between the continents also, because the ocean will be finished, and in between the continents also you can have. Say, for example, only this part of the mountain is moving and that part is not moving. Then you can have these fold mountains on the edges of the continents as well. So this theory, okay, explains many aspects. So that's why it is considered, okay, one of the simplest theories to explain the formation of the fold mountains. Next. Now plate tectonics theory we will be discussing later. Now regarding these fold mountains, let's see what are the various features of these fold mountains. Features. Now whenever these mountains get folded, if the forces are equal on both the sides, okay, then you will be having a symmetrical fold. But if the force is more on one side, for example, I will show you this way. Now the forces, okay, I should be using Hindi also, okay. Say if the forces are equal on both the sides, then you will be having symmetry. Say एक तरफ से force ज़्यादा है, then you will be having this kind of fold, right? Now then it becomes an asymmetrical fold. Say force on this side is more, then you have this asymmetrical fold like this. Say और भी ज़्यादा force हो गया इस तरफ से, okay? ज़्यादा force है तो दो arrow use करूँगा. इस तरफ से और भी ज़्यादा force है, then it becomes like this. Force और ज़्यादा हो गया, it becomes like this. Then force और ज़्यादा हो गया, then it becomes entire mountain will fall down. It becomes like this. Force और ज़्यादा हो गया, then finally a fault or a crack will be created. A fault या crack create होगा. Okay, so I will not be going beyond this. I will explain till here only, because इसका application है. So I am going to that extent only where you will be having a lot of application and from where the questions can be asked. Now these are all asymmetrical folds.
asymmetrical folds. Now if the angle is equal on both the sides, this is called as isoclinal. You don't have to remember all these names, आपको ये सब नाम याद रखने की जरूरत नहीं है. Okay? Now if it is overturned little bit, it is called as overturned. And if the limbs of the mountain, means if the slopes of the mountain become parallel to the floor, it is called as recumbent fold. Now after falling down, because see यहाँ तक तो फोल्ड हो रहा है, क्यों फोल्ड हो रहा है भैया? ये सारे जितना भी ये रॉक्स है समंदर के अंदर थे, पानी में सोक किए गए, तो इनिशियली दे विल अंडरगो फोल्डिंग, मीन्स वो गुना हुआ आटे की तरह है, इसलिए फोल्ड होता है. लेकिन भैया अगर ये अर्थ सरफेस के ऊपर आने के बाद ओके सिर्फ 40-50 मिलियन ईयर्स हो गया, उसके बाद भी आप दबाए जा रहे हो, क्या वो फोल्ड होगा? नो. उसके बाद क्या होगा? वो फॉल्ट होने लगेगा. सो दिस इज कॉल्ड एज फॉल्टिंग. एंड द फॉल्टिंग विल बी टू सच एन एक्सटेंट दैट एक टाइम आएगा बी इधर चला जाएगा, ए उधर चला जाएगा. एंड दिस आर कॉल्ड एज द nappy structures. The nappies are also of various types, exotic nappies, autochthonous nappies, various types. I'll not be getting there. Now you might be asking, sir आपने तो ये सब ड्रॉ कर दिया, क्या ये रियल लाइफ में एग्जिस्ट करते हैं? सैन एंड्रियास फॉल्ट इज डिफरेंट, नूरप्रीत. क्या रियल लाइफ में एग्जिस्ट करते हैं? शो करता हूँ. सी ज्योग्राफी सच ए ब्यूटीफुल सब्जेक्ट. आपको किसी को ज्योग्राफी ऑप्शनल लेना है ना, आप ले लो, मैं आपको ज्योग्राफी बहुत ही आसान करवा दूंगा. सी लुक एट हियर. नाउ यू गैस टेल मी, कौन सा टाइप का फोल्ड है? क्या लग रहा है आपको? ऑफ कोर्स एग्जैक्टली नहीं होगा. लुक्स लाइक व्हाट? लुक्स लाइक द isoclinal fold. This looks like symmetrical fold. देखो, you see the limbs of the mountain are parallel. This is recumbent fold. Okay, so these are the various types of fold. Okay, लेकिन okay, you might be asking me, sir ये सब चीजें क्यों पढ़ रहे हैं? इसका application क्या है? The application is this. Application is. So application भी आप लिखते रहे ना, whatever I am saying. See thing ना, see आपने already एक बार कोर्स किया है, so आपको बहुत सारी चीजें पता होगा. So आप अगर कोई नॉर्मल टेक्स्ट बुक में देखेंगे, एप्लीकेशन सीधा यहीं पे लिखा नहीं रहेगा, वो कहीं और लिखा रहेगा. लेकिन मैं सीधा एप्लीकेशन यहीं पे लिख देता हूँ क्योंकि आपको थोड़ा बहुत अंडरस्टैंडिंग है सब्जेक्ट का. Now if you take the Himalayas, if you take the structure of the Himalayas, so this is great, around 6,000 meters. See why I am drawing all these things myself, because बहुत सारी जगह ऐसे चीज़ें नहीं है एंड मुझे एनिमेशन करके बनाना बोले तो बहुत मुश्किल हो जाएगा. ओके, सो दिस इज मिडिल. आई होप दिस इज वर्किंग विथ यू. एंड अल्टीमेटली आपको एग्जाम में क्या हाथ से ड्रॉ करना है ना, आप वहाँ पे कंप्यूटर ए लेके जेमिनी प्लीज गो बनाना क्रिएट इमेज नहीं बोलोगे, राइट? सो दिस विल ऑल्सो बी प्रैक्टिस फॉर यू. सो मिडिल is around 4,000 meters. This is Shivaliks. So this is around 1,200 meters. Average elevation. Now you tell me, so this kind of fold is also called as orthoclinal fold. Orthoclinal. If it is making a 90-degree here, it is called as orthoclinal. This is also called as the hogback structure. Hogback structure. Now tell me, among great, middle and Shivaliks, which is highly unstable, which is highly prone to earthquakes? So Realme is asking before nappy, that is allochthonous nappies. Again, इतना complicate मत करो subject को, जरूरत नहीं, application सीधा याद रखना. Middle, yes.
The middle Himalayas are highly unstable. Kyun? Because middle Himalayas, okay, has all the types of asymmetrical folds. As compared to these two, it will be having exotic nappies, allochthonous nappies, it will be having recumbent folds, highly overturned folds, सारे तरीका का है. And that's why it is also highly what? It is earthquake prone, landslide prone, is highly fragile. So whenever you are doing any construction, whenever you are doing any settlements, you need to be very, very careful, because say if you are cutting across the slopes in the middle Himalayas, what will happen? Entire slope will become unstable. And moreover, all these, most of them are made up of the sedimentary rocks, and sedimentary rocks are fragile, mobile and dynamic. Okay? So this is the application of this. So this is about the fold mountains in short. Later on, plate tectonics will be discussing more about the fold mountains. So residual mountains, okay, I have just discussed. These are nothing but the mountains of denudation. These have become quite old. The examples from India are Aravalis. Okay, Aravalis is recently in the news. Okay, a lot. We'll discuss about this. Okay, in the Indian geography. Eastern Ghats. Okay, and also the Urals, the Great Dividing Range in Australia. Okay, the Appalachian Mountains. You can keep this example in mind. Okay. Yes, if you are having see it's all about stability. Real me. Okay, ये ज़्यादा stable है, ये कम stable है. As simple as that. Huh? So residual mountains. And regarding the volcanic mountains, anyways, we'll be doing a topic called as volcanism. Now let's discuss about the block mountains. The block mountains are formed as a result of rifting. Okay. Now, rifting or faulting, you can say, both are all the same. Faulting. Now, there are three types of faults. Three types of faults. Okay. Now you have the crustal block here. Okay. This crustal block can break apart, and it can move away from each other. Okay. And this fault is normal fault. Normal fault. So generally you will be seeing the normal fault at the divergent plate boundaries. Divergent plate boundaries. Now again, you have a crustal block. Now this crustal block, this can move towards each other also. So when it will be moving towards each other, you will have a reverse fault. Now tell me, in the Himalayas, you will be finding a normal fault or a reverse fault? Reverse fault. So in the middle Himalayas, you will have numerous reverse faults. So what can UPSC give a statement? So UPSC can say that the middle Himalayas are extremely prone to the earthquakes because of the presence of reverse faults. This is a right statement. If it is saying that normal fault, wrong statement. And third type. Now here the plates, they are neither moving towards each other or they are moving away from each other. They just slip past each other. Slide past each other, and this is called as the slip fault. Slip fault. Now, what are the various features formed because of the faulting? Now they take the crustal block here, and you have the compression, compressive forces are there.
Compressive forces. Now when you have a compressive force, the fault will be appearing in this fashion, this way and this way. So when you are applying the force on this side, when applying the force from that side, imagine you have what you call brick in a hand, and you are compressing the brick. So this will slide over. Let's say this block is A, this block is B. So ultimately what will happen? This will become A, this will become B. Right? So these are the forces which are being applied. Now the region in between, this is all called as the graben. This is also called as the rift valley. Graben or the rift valley. Okay. Example of the slip fault. Okay, I will come to example of the slip fault. Okay. So Hemant Khatri. Okay, I didn't understand your question. So graben in German means grave. Means a grave ka daisha dikhega. Now, most of the rift valleys are associated with coal deposits. How? Because say, okay, you have the plant remains, plants on this side, you have the plants on this side, and the faulting has been created. And because of the erosion, the plant remains, plant का जो भी okay remaining things है, they will fall in the graben. उनके साथ मिट्टी भी करेगा. So मिट्टी okay biological matter. Okay. So because of which there will be excessive compression. So वहाँ पे heat generate होगा, compression generate होगा. जितने भी volatiles है उसमें वो सब गायब हो जाएंगे. बाद में क्या बचेगा? Carbon बचेगा. So that's why the rift valleys are associated with coal deposits. Now application क्या है? Application of this. So India में coal कहाँ मिलता है? Coal you find in Damodar Valley, Son Valley, your Mahanadi and its tributaries, your okay Godavari and its tributaries, but you will not find coal in the Ganga Valley. Indus Valley में आपको coal नहीं मिलेगा. Peninsular rivers में coal मिलेगा. Why? Because of peninsular rivers are found in the rifts and cracks. Means the entire peninsular India. The entire peninsular India. So this is all made up of hard granitic gneissic rocks. These are hard granitic gneissic rocks. Now granite तो बहुत ही hard पत्थर है. Do you think the rivers in the peninsular plateau will be able to carve their own path? Means खुद का मतलब पत्थर को काट के अपना रास्ता बना के जाएगा क्या? ना. So whatever faults, whatever rift valleys are present, okay, in that only the rivers will be flowing. Means जहाँ पे भी fault है, okay, उसी में flow करने लगेगा. Okay, so that's why in the peninsular plateau, the rivers which you find, okay, so they'll be having mostly this kind of pattern. ये वाला pattern रहता है. Whereas if you look in the northern India, you take Gangetic river, you'll be having this dendritic pattern. You'll have this dendritic pattern. Because here the rivers carve their own path. That's why, okay, if at all they are asking a question, say आपको चारों okay जगह का नाम दिया, rivers का नाम दिया, and they'll be asking you, okay, where the coal will be found. So you can blindly go for the rivers of the peninsular plateau. So wherever rivers are there, in most probability, okay, you'll be having coal deposits over there. So this is the application part of this. Now what are the examples of the slip faults? Okay, we'll discuss that later, a little bit later. Okay. Now let's see what are the various features which have been formed because of the rifting. This such kind of feature is formed here. So this is called as the graben, and this is called as the block mountain, The block mountain is also called as Horst. Horst is a German word again. And this is also called as escarpment. And पहले ये वाला चीज अंदर था, अब ये टूट के बाहर आ गया. That's why this face is also called as scarp face. So these are the various terms associated with the block mountains. And also you have two more terms called as throw and heave. Okay, I'll not be getting into that. Again, Gen Zs, it will become complicated. So these are the three types of faults, and this is about the faulting. I'll show you some pictures. So this is how the block mountains will be looking like. So the region in between is called as Rift Valley. So this uplifted portion, because for someone who is inside this valley, in this Rift Valley, and they look up, it will be looking like a mountain. That's why they'll be calling it as mountain. But is it a true mountain? It's not a true mountain. How it has been formed? Because of the crustal rifting. Means the crust में चीजें थोड़ा ऊपर नीचे हो गए थे टूट के. So that's why this has been formed. Okay. And this phase which you see, ये पहले तो अंदर था ना ये वाला, ये ऊपर उठ के बाहर आ गया. इसको बोलते हैं scarp phase. इसको बोलेंगे escarpment host, whatever you can call it. Now we'll see the examples of this. You see this? So this is how the Rift Valley looks like, and since they look like block in real, they are called as block mountains. I'll tell you some examples here. So this example within India itself, I'll draw the entire picture over here. So this is the Great Himalaya, Middle Himalaya, Lesser Himalaya. Then you have a depression over here, and these become the Great Northern Indian Plains. And here you will be having okay. So if you are cutting India, in this fashion, and if you take a side view, so this is how India will look like a little bit. Now I want to focus on this part over here. So this is part of your Deccan Plateau, or it is also called as Maharashtra Plateau. Maharashtra Plateau or Deccan Plateau. Okay. So this is your Vindhyas, and this is Satpuras. So in between the Vindhyas and Satpuras, rift valleys have been created. So which river is flowing here? Narmada river is flowing here, and here the Tapi river is flowing. And this is also the reason why. So in the peninsular plateau is sloping towards east. The slope is towards east. But despite having the slope towards east, they are flowing towards west. These are west flowing rivers. Why? Because they flow in a rift valley. Of course, most of the rivers in India are flowing in a rift valley. So this is one example from India. And such kind of diagrams, if you know, you'll have a good understanding of how India's topography is. For recently, for example, okay, you must have seen many videos. Delhi is getting extremely polluted. Why? So this is where Delhi is. So Delhi is in depression, not psychological, but physical depression. Okay, of course there are many various over reasons, but as far as the physiography is concerned, okay, this is the reason over here. Now other examples of block mountains. So if you go to Germany, again you have two blocks over here. So this is the Rhine Valley. The Rhine Valley is also associated with the coal deposits. So this is the French side. So this is German side. On the German side, you have Black Forest, and on the France side, you have the Vosges. So these two are the block mountains, and Rhine Valley is a rifting over here. Now one more example. So if you take USA, in USA you have the Rockies. Rockies is a very large mountain over there. Now beside the Rockies, you also have the coastal mountains. So these are the fold mountains. The Rockies are comparatively larger. So in between the fold mountains also you can have block mountains. So this is the extension of the coastal mountains called as the Cascade Range. This Cascade Range is in California. So recently they know every year, and there have been a lot of forest fires in California. So that's why also it can be asked. And this is the Sierra Nevada. Sierra Nevada. The Sierra Nevada is a block mountain, and these are Rockies. Okay. And also, okay, in the South Africa, you have a mountain called as Drakensberg. So Drakensberg is also a block mountain. So these are some of the examples of the block mountains. Okay. So let's get into next topic here. So types of mountain is over. Okay. So I'll tell you, okay, a few more points here, few more basics. Order of landforms. Order of landforms. So you have the first order landform, second order landform, and third order landform. The first order landform is the continental crust and the oceanic crust. So this is the CC and this is the OC. Because the oceanic crust is the primary crust. It has been formed in the beginning itself. Like around 4 billion years ago, 3.5 billion, 5 billion years ago, it has been formed. So since it has been formed initially, okay, it is the pioneer, it is called as the first order landform. And second order landform is because of endogenic forces, means the forces which are acting from inside. So these can be the fold mountains, block mountains, rift valleys, etc. So these are formed because of the endogenic forces. The third order landforms are formed because of exogenic forces, the forces which are acting from outside. Means these are also the forces of denudation. Forces of denudation, like rainfall, wind, animals, etc. And this can be a river valley, sand dune, delta, etc. So this is the various order of the landforms. So next, one more basic over here is, see, anything which is parallel is called as longitudinal. So anything which is perpendicular is called as transverse. Okay. I'll show you various examples here. For example, you have a piece of land. Say this is the direction of the wind. This is the wind direction. Now you can plow your field in two fashions, fashion A and fashion B. So this is B and this is A. Tell me in which this soil erosion will be more, A or B? In B, the soil erosion will be more because B is in the direction of the wind. In fact, this kind of plowing is actually creating a path और रास्ता दे रहा है, इसलिए यहाँ पे erosion ज़्यादा होगा. And since it is parallel to the direction of the wind, this is called as longitudinal plowing. So nowadays they are asking a lot of questions from agriculture part. And this is called as transverse plowing. Transverse plowing. Say they are giving a statement saying that the transverse plowing, will cause less soil erosion and is more eco-friendly as compared to longitudinal plowing. So don't get confused by the words over here, transverse, longitudinal. I'll tell you one more example of this transverse and longitudinal. Say you have a hill slope here. This is a slope. Now, again you have two types of plowing. One type of plowing is like into the plane, like this. Other type of plowing is this, along the plane. Now the rainfall is occurring here, where you will have more erosion, A or B? B में ज़्यादा erosion होगा, A में कम होगा. Again, this is also called as transverse plowing. Now let's talk about landforms. Examples of the landforms. This is the coast, and you have numerous valleys over here. You see valleys, and these valleys are called as fjords. F-J-O-R-D-S, fjords, and these are transverse valleys. And this fjords are so beautiful. You can see this, most Instagrammable picture like this. Right? These are called as fjords. These are there in Norway. Of course, they are there in other countries also. But again, in Norway, they are very famous. The cruise shipping happens here. These are so beautiful. Now, once, if I tell you the word mains, again, you will be saying, sir, हमको mains नहीं पढ़ा रहे, हमको what, something like that you will say. कुछ बताना भी पाप है. छोड़ो. Again, I am telling you one more thing. See, it's about psychology. See, the person who is making the paper, he has certain mentality, right? So he has certain topics which are favorite to him, which are close to him. Now, the UPSC must not be taking people by you come, you prepare, you will be preparing for mains only the questions. You come, you will be preparing the questions for prelims only. ऐसा नहीं होगा ना. UPSC must be contacting the same set of professors for preparing questions in prelims, as well as mains. Now, most of you, see, you for preparing for prelims, you only look at the PYQs of the prelims. एक बार mains के questions भी देख लो ना. Last year कुछ पूछा है, and often it has happened that the questions जो prelims में पूछा है, वो mains में appear होते हैं कभी-कभी. And the mains में जो questions पूछा है, prelims में भी appear होते हैं. So fjords, which has been recently asked in the mains, and till now there is no question on fjords in the prelims. So there's a probability that they can ask questions in the prelims. मैं mains नहीं पढ़ा रहा हूँ, prelims ही पढ़ा रहा हूँ. आप लोग को आधी अधूरी नॉलेज से आप जज करके. So this is called as a transverse valley. Now, what is the importance of these transverse valleys? Now, this will be helping in the fishing industry, because fishes will not be staying in this open waters, because open waters are very turbulent. The fishes will come inside, they will do nesting, they will do hatching, they will do mating. So it will act as a refuge for the fish. And also the ships can enter. See, आपके पास अगर इतनी बड़ी वैली है, आप कहाँ तक शिपिंग कर सकते हो? And if you are doing shipping, the cost of the transportation is also very less. And these are picturesque, very beautiful. You can also promote a lot of tourism. And also you can have, see यहाँ पे fishing बहुत ज़्यादा होती है, ships अंदर तक आती है, so they can have a lot of export processing zones, okay, fishing में. So these are the various advantages of these fjords. Now next question is, Noorpreet, thank you so much for acknowledging. Okay. Now how these fjords have been formed? See, fjords, are they just formed in Norway? No, they're formed in Iceland, okay, Scotland, upper part of Scotland, okay, this is USA. USA है क्या ये? Which country? USA? Greenland? See? The islands of Canada? So everywhere you have this fjords. So how come they have been formed here only? Because during the Ice Age, almost the Pleistocene Ice Age, which has been formed 2 million years ago. Again the word Pleistocene comes. The Pleistocene can also be asked in the examination. मैं सिर्फ फालतू में नहीं पढ़ाया आपको geological time scale. So during the Pleistocene Ice Age, almost 2/3 of the earth has been covered by 2-3 kilometer thick ice. So here till now you have ice over here in Greenland. Now this ice will be melting, you can see here. You still have the glaciers here. So this glacier will be having a thick mass of ice. So when this ice will be sliding down, it will be doing vertical cutting. वो कट करेगा नीचे जमीन को. So कट करने के बाद ऐसे वैली फॉर्म होगा. So there is a famous saying, present is the key to the past. आपको पास्ट में क्या हुआ आपको पता नहीं है, क्योंकि यहाँ पे नॉर्वे में आपको ज़्यादा कुछ ऐसे माउंटेन्स नहीं दिख रहे, ग्लेशियर्स नहीं दिख रहे. बट इफ़ यू वांट टू गेस व्हाट मस्ट हैव हैपेंड इन द पास्ट, थोड़ा ऊपर चले जाओ, आपको दिख रहा है यहाँ पे ग्लेशियर्स. So these glaciers have been cutting the land over here. These are glacial cut valleys, and after the melting of the ice, the sea level rise will happen, and after the sea level rise, these glacial valleys are submerged. So the submerged glacial valleys are called as fjords. Remember this. Okay. Next, that is transverse valley. Let's take the example of the longitudinal valley. How many fans of Game of Thrones here? So most of the Game of Thrones has been shot here in Croatia. Now look at this. Look at these valleys. Are they perpendicular to the coast or they parallel to the coast? Parallel to the coast. So once upon a time these were mountains. Okay, यहाँ पे पानी नहीं था पहले, लेकिन बाद में after Pleistocene Ice Age there was a sea level rise, means around 140 fathoms, means 200-300 meter, 40 around 100 meters का rise हुआ यहाँ पे water. So when the water level has risen, so जितने भी mountains थे और mountain valleys में पूरा पानी घुस गया. Now these features, they look parallel to the floor, and this coast of the coast of Croatia, there is a country called as Croatia here, and this is called as Dalmatian coast. And the Dalmatian coast is an example of the longitudinal valley. Okay, so remember these words, longitudinal and transverse. Again, UPSC will be asking the questions over here, because earlier you had this Yugoslavia. So many countries have broken up from Yugoslavia, and now recently, this Montenegro, this Albania, is negotiating with the NATO, for its membership and all. So that's why it's in the news. So they might be asking you which of the following countries have a coast with Adriatic. So right now I'm not discussing map. Mapping के लिए separate session लिया है. This is why I can't post it directly in this group. Okay, somebody needs detailed mapping every month का 40 minutes. आपका एक भी क्वेश्चन मिस नहीं होगा, वो देख लेना आप. हाँ. So they might be asking questions from here also. Which all countries will be having the coast from the Adriatic Sea over here? Huh? So you have a crust, mantle, core. So this is the wrong diagram. In fact, the core mantle is comparatively very large and the crust is the outermost thin layer. This is the crust. And in the crust you will be having continental crust and you will be having oceanic crust. Then you will have the continental crust. And this is the core. This is the core. The core is metallic and the crust and the mantle, it is made up of silicates. So I have discussed heavier silicates, lighter silicates, etc. Okay. So first we will discuss about the crust. Crust. See, the crust is of two types, CC and OC. This is oceanic crust and this is the continental crust. Now CC is made up of lighter silicates, and OC is made up of heavier silicates. Now what are these lighter silicates? You have sodium, potassium, mostly it will be having sodium and potassium. And these are made up of ferromagnesium silicates. Ferromagnesium silicates. So lighter silicates, ये मिट्टी का कलर है. So मिट्टी का कलर है तो इसमें क्या होगा? It will be light gray in color. Light gray. So this will be dark in color. Now density, okay, it will be having around 2.2 gram per centimeter cube. It will be lighter. So this will be comparatively denser, 2.9 to 3 gram per centimeter cube. So this will be comparatively denser. Now most important thing, okay, ये सब चीज़ तो कहीं पे भी मिल जाएगा. Now the continental crust being lighter, it will never undergo subduction. Never undergo subduction. कभी अंदर जाएगा ही नहीं. It is buoyant, हल्का है, अंदर डूबेगा नहीं. Because below the continental crust, you have again the mantle. Below this again you have the mantle. And mantle here will be having a density of 3 gram per centimeter cube. And ऊपर वाला 2.2 gram है. It's like a wooden block floating over the water. कितना भी आप डुबाओ फिर से ऊपर ही आ जाएगा. So it will never undergo subduction. So therefore it is older crust as compared to the oceanic crust. Older. So if you look at the textbooks, the oldest rock on the surface of the earth is found in northwestern territory of Canada. ये दिखेगा. So which is around 3.5 billion years old. ये सबसे पुराना रॉक है बोलते हैं. But recent scientific studies they say that the सिंघभूम plateau, अपना जो बिहार है, सिंघभूम plateau is the oldest. Means इससे भी oldest rocks have been found in Singhbhum cratonic region. Why? Why will be having older rocks? Because this continental crust once formed is formed forever. Is formed forever. Whereas the oceanic crust is heavier and it will undergo subduction. Means अगर ये oceanic crust किसी और crust से टकराएगा वो heavy होगा, तो इसलिए अंदर slide हो जाएगा, so it will undergo subduction. That's why this oceanic crust is not older than Mesozoic times. Now ये वाला word use आया, Mesozoic times, not older than. So this can be asked. So that's why I taught you the geological time scale. So this is around like 250 million years. Not older than this. Of course, there can be exceptions here and there. For example, in examination, they'll be saying that, okay, the oceanic crust, at some places the oceanic crust is found older, okay, than 400 million years. Accept it, okay, because अगर examiner एक statement दे रहा है, वो बंदा कहीं ना कहीं ये पढ़ा होगा, किसी न किसी इंटरनेशनल जर्नल में ये वाला आर्टिकल छपा होगा, तभी तो उठा के दे रहा है ना। आपने क्लास में ये वाला एग्जाम्पल पढ़ा है कि ओके इट इज़ नॉट ओल्डर देन Mesozoic टाइम्स, सो डोंट मार्क इट रॉन्ग. Okay, so such kind of statements will always be true. Again, remember this. See, we haven't explored the entire earth, we haven't explored the entire universe. Anything can happen, and we haven't explored everything which happened in the past, and anything can happen in the future. अगर ये चीज़ें आप याद रखोगे, आपको 10 क्वेश्चंस ऐसे ही मिल जाएंगे without having any knowledge. Remember this. So it is not older than Mesozoic times. One more difference between these two. Now, CC is broader, whereas OC is thin. Why? The thickness of the CC is around 70 kilometers. Because the CC is lighter, it is less dense. Therefore, it can afford to have more thickness. For example, okay, the CC will be having a thickness of, a density of say 5 gram per centimeter cube. So, इतना भारी भरकम चीज़, do you think it will be able to stay stable? No, वो डूब जाएगा अंदर, अंदर खिसक जाएगा. ये लाइट है, फुर्तीला है, इसलिए फ्लोट कर रहा है, right? That's why it can afford to have more thickness, whereas OC, which is denser, cannot afford to have more thickness. Now, mantle, okay, this is around 400 kilometers, 700 kilometers. So it will be having a depth of 2900 kilometers. So this is the upper mantle, this is the intermediate, and this is the deep mantle. Now, one thing about upper mantle is very important. The upper mantle will be having a mineral called as olivine. Remember this mineral, olivine. The olivine has semi-molten plastic properties. See, plastic का क्या होता है? So plastic will be looking solid. So on the face, the plastic will look solid. But मैं क्या plastic को खींच सकता हूँ? Yes. So when Ekagra Singh is asking, if Singhbhum is the oldest, then why the coal found around it is bituminous? See, वहाँ का पत्थर old है. See, it has been formed around 3.8 billion years ago. See how the coal is formed. Coal is formed because of the formation of the faulting ना. Fault उतना पुराना नहीं है. Fault has been formed around 250 million years ago. Fault नया वाला है. इसीलिए. Okay, because of the formation of the fault will be giving rise to the coal. So it will be having olivine which has semi-molten plastic properties. That means if you are applying stress, then it will behave like liquid. It will start flowing. It will behave like liquid. And this layer of the upper mantle, okay, which has this olivine, is called as asthenosphere. अगर asthenosphere में olivine नहीं होता, then we wouldn't have had plate tectonics. Plate movement wouldn't have happened, because this is acting like a Vaseline. It is acting like a greasy layer. Okay, it is acting like a lubricant, which will allow this CC and OC float. Okay, slide over this. So this is the property. Okay, so intermediate does not have much of the properties. Now let's go to the deep mantle here. So this is the CC, OC, or this you will be having oceans. So deep inside, you have the core here. So I told you nothing comes out of the core. So near from the core, because core is extremely hot, the core is metallic. So from near the core, the magma is generated. Magma. So the rocks will be melting here. This is nothing but the molten rock. ये जो molten rock है, okay, whenever the rock melts, it will become हल्का. ये हल्का हो जाएगा. हल्का होके ऊपर राइज करेगा. So it will rise. राइज होने के बाद ये आके टकराता है क्रस्ट से. अभी क्रस्ट से टकराने के बाद डू यू थिंक इट विल बी एबल टू कम आउट वेरी इजीली? बिकॉज क्रस्ट में होता है ग्रेनाइट रॉक. ग्रेनाइट इज कंपैरेटिवली हार्ड. सो ऊपर आने के बाद इसके पास उतना भी एनर्जी नहीं रहता. सो इट स्टार्ट्स फ्लोइंग ओवर हियर, स्प्रेड होता है. ओके, so this kind of a thing is called as the mantle plume. So imagine a similar mantle plume is coming here. Now here also it will spread. So after spreading, because जब वो अंदर था, it is compressed, heavy pressure था. So that's why the melting point increases. So whenever you apply more pressure, the melting point increases. Now while it is coming towards the surface, the pressure reduces. That means decompression is happening. And this phenomena is called as decompressional melting. Decompressional melting. So melting point reduces and it starts oozing out, lava outside. And such kind of regions where you will be having centralized magnetic activity, this is called as the hot spots. तो आपने अटलस में देखा होगा, नॉर्मल वोल्केनिक eruption को भी हॉट स्पॉट्स बोल देंगे, बट हॉट स्पॉट्स आर सेंट्रलाइज्ड मैग्नेटिक एक्टिविटी. मीन्स वो एक ही जगह से निकलेगा. सी ऊपर वो सीसी एंड ओसी है, वो कहीं पे भी फ्लोट कर सकता है, वो कहीं पे भी जा सकता है, लेकिन ये निकलेगा यहीं से. So that is the hot spots. Now tell me, the volcanoes which has been formed as a byproduct of the hot spots, will they be explosive in nature? Will they be silent or violent? Silent ring basic. They are highly fluidic. हाईली फ्लूइडिक मीन्स वो पानी जैसा पतला है. मीन्स जब भी ऐसे वॉल्केनोस निकलते हैं ऐसा पानी जैसा बाहर बहता रहता है. सो दे विल नॉट बी एक्सप्लोसिव इन नेचर, दे विल बी बेसिक इन नेचर. टेल मी विच काइंड ऑफ रॉक दे विल बी हैविंग. कौन सा रॉक निकलेगा यहां से? आई कैन रिमेंबर द फर्स्ट क्लास. basalt. Very good. So they will be forming basaltic provinces. So that's why I have built the basics first. Okay, igneous rocks होगा but no basalt होगा. You guys are answering in a very excellent way. Nice, very good. तो ये वाला concept आप पकड़ लिए ना, अब कोई भी आंसर सॉल्व कर सकते हो. Now let's see some of the examples of these hotspots. So I'll come from here. You see an island over here called as Kerguelen Island. See, once upon a time, okay, India was located here, near Antarctica. So India has come somewhere, okay, somewhere from here. So it started moving in another direction, somewhat like this. It moved till here. So this is how the continental drift has taken place. So this is the Kerguelen hotspot. Kerguelen. Now what is the importance of this? So when India has come near this Kerguelen hotspot, the Kerguelen hotspot has vomited lava over India. As a result, we have Rajmahal Hills. कितने लोग हैं यहाँ पे? झारखंड से, वेस्ट बंगाल से. So it is mostly located in the border of this your Jharkhand and okay. Nothing in blackboard. Are you not able to see this? It's not visible? Okay, fine. So I'll not be using this. So Kerguelen hotspot is there. So near Madagascar, you have an island called as Reunion Island. So this is also a hotspot. So in the Indian Ocean, you have this two hotspots, and also some people say that Diego Garcia is also hotspot, but can you ignore that? And off the coast of Ecuador, here you have Galapagos Island. So this is where the Charles Darwin has done much of his experiments. So Galapagos is one of the examples here. And in USA, you have Yellowstone National Park. You have this rifting called as Great African Rifting. You all are rifting here. And this region is called as Triple Junction. Triple Junction. And in this Triple Junction, you have Afar, a region called as Afar. Why it is called as Triple Junction? Because one of the rift is going towards Gulf of Aden, one of the rift is moving towards Red Sea, and one of the rift is moving towards Africa. And Africa is very much tectonically active, and this rift is also running into Gulf of Aqaba, and then it is running into River Jordan, and then it is running into, why it is behaving like this? It's also running into West Bank, Israel, Sea of Galilee, okay, your Golan Heights, etc. And this region, okay, has been in the news. This might be also the reason why they can ask you this. That's why keep this in mind. Now we have done about the hotspots. Okay, so let's get into the core here. Core. So you have the outer core and you have the inner core. This is the inner core and you have the outer core. I forgot 2-3 points over here. See the discontinuity between the crust and the mantle. So this discontinuity is called as the Mohs discontinuity. Mohs. And the discontinuity between the mantle and the core, this is called as the Gutenberg discontinuity. So these two discontinuities you can remember, others I have, okay, you can go through. Now you can tell me why it is called as discontinuity. Why this is called as discontinuity? So you'll be understanding this change in the temperature and pressure. No, you can post your comments over there, but I'll be discussing this when I'll be discussing the evidences of the Earth's interiors. Okay. Meanwhile, you can think over it. Now, most of the core is made up of iron. 95% of the core is iron. Around 4% is nickel and rest. So rest can be anything. Okay. So whichever element is given in the examination, you mark it right. So change in temperature, pressure, change in the state of matter and density, structural changes, change in the state of matter, no. These are not the reasons, I'll tell you later. Till then you can think. Now, outer core is liquid and inner core is solid. See, there are various schools of thought here. See, while you are going towards the interiors of the earth, while you go deeper and deeper, so this is at the depth of around 2,900 kilometers. So beyond this depth, the temperature increases. The temperature at the center of the earth is around 6,000 degrees centigrade in the inner core. So here in the outer core, it is around 5,100 degrees centigrade. Now if you take the melting point of the iron is around 1500. So this is around 1500 degrees centigrade. So iron should melt at both the temperatures. So the inner core also should be liquid, but it is solid. Now various schools of thought is there. So it is solid because of the confined pressure. You are applying pressure from all the sides, that's why it is solid. Why it is liquid? Because of high temperature. Now it is liquid not just because of high temperature, it is because of the presence of impurities. Okay, impurities such as silicon, oxygen, sulfur and etc., whatever is given, because of these impurities. Now why in the iron, why in the core there are impurities? Because when the earth was churning, means at the time of formation, the mantle convecting cells or the convecting cells were very active. Means in that process, the lighter elements were being surfaced out and the heavier elements were sinking in, right? So some of the silica, some of the oxygen, that is silicates, and some of the elements such as sulfur, they have been trapped here. So when you have an impurity, because the inner core has a perfect crystalline iron lattice structure, means वहाँ पे एक type of structure बना हुआ है, and some of the recent studies also say that the inner core is acting like a single crystal, means वहाँ पे different structure of iron form हुआ है, right? लेकिन उस structure में अगर बीच में impurity आ जाता है और bond break हो जाता है, वो attachment हो नहीं पाता है. So that's why the presence of the impurities will be making it liquid. Again, this is one school of thought. In the examination, okay, if any reason is given, okay, you agree for that. Don't disagree. Understood? He is saying that the seismic waves from the earthquakes from 91 to 2003 found that the inner core's rotation has slowed down and related to the Earth's surface. Now, what kind of causes this deceleration will cause? So, rotational speed change is very subtle; it is not noticeable, and okay, little bit of changes can be found in the day and night. Now, how come this what magnetic field of the Earth is created? So you have the inner core which is solid, outer core which is liquid. So in the outer core you will be having a lot of iron, and this iron has a lot of free electrons, because whenever the temperature increases, the electron will not be staying in the orbit, so you will be having free electrons. So it will be acting like a solenoid. So the inner core, which is acting like an iron bar. Now if you are placing an iron bar and around that you have the current passing through, that is electrons revolving, and because the Earth also has rotating on its axis, so such kind of gyres are formed in the outer core, and this will be causing the magnetic field of the Earth. And this magnetic field of the Earth is oriented in this direction. So in the southern hemisphere you will be having the north pole, in the northern hemisphere you will be having the south pole of the magnet. And what is the source of heat inside? The source of heat inside the Earth is the radioactive elements, because whenever you have these radioactive elements, they will be undergoing nuclear fission reaction. When they undergo bombardment, when they break, they will be releasing lot of heat. And the second source of heat is whenever these heavier metals, when they will be sinking down, the potential energy is converted into kinetic energy, and when they will be moving down, because of the friction, the heat is generated, and this heat is the source of internal heat. And also along with this heat, you have the residual heat. So the Earth magnetic field line is created by molten iron swelling in the core due to the heat. Now, what is the job of, what is the role of this magnetic field? See, the magnetic field of the Earth will be acting like a protective layer, and it will be protecting the Earth from the solar radiation. We have studied about the solar winds. The solar winds are highly energetic in nature, and the magnetic field of the Earth will be protecting the Earth from the solar radiation. Now, you have certain terms over here called as magnetic declination or magnetic variation. See, when you are on the surface of the Earth, you take a compass. The compass is causes. So you have the inner core, and you have the outer core. See, inner core has iron and outer core has iron. Both have iron.
iron here, iron here. Okay. So this iron is solid and this is liquid, right? And Earth is rotating on its axis. Now because of this, you will get a feel like solid iron bar, and in this you have free electrons because it has a temperature of 1500 degrees centigrade. So at this high temperature, the electrons are mobile. The Earth is rotating on its axis. So because of this, we get a feeling that around this solid iron, you have these electrons revolving. So it gives the impression that it is a solenoid. So this is how the Earth's magnetic field is created. So this was very old version. Now, what is the new version of it? So in this field, the things keep on changing. The new version is, this is the inner core, and here you have outer core. So outer core is liquid, and Earth, same as it is rotating on its axis. So when the rotation happens, so here in this liquid, such kind of gyres are created, such kind of spirals are created, like this. So around the solid iron core, you have the electrons which are revolving, and because of this the magnetic field is created. And at present it appears that a magnetic bar is placed inside the Earth, whose north is located in the southern hemisphere and south is located in the northern hemisphere. And the magnetic field lines always emerge from the north and end in the south. Okay. So this is how the magnetic field is created. Now the thing is, so let's understand this first term. So understand these things in this way only. So don't get confused here and there. So the first, let's understand this term, a magnetic declination or magnetic variation. Okay. So magnetic declination or magnetic variation. See, this is a geographic north. Here you have geographic north. Here you have geographic south. So geographic north and geographic south, these are antipodal. Antipodal means if you are drawing a line, it will pass from the center of the earth. Now, today, if you look in your textbooks, the magnetic north is located somewhere in your Canada. And magnetic south is located somewhere here. Okay, it's in Antarctica. This is the magnetic south. So this is in Antarctica. Now, if I am drawing a line between these two, it is not passing through the center. Therefore, the magnetic poles are not antipodal. Not this point, this first point you have to remember. Now, for example, if I have a compass, say, okay, you are in Hyderabad, okay, Delhi, whatever. If I am holding a compass. Now, there will be an angle between the magnetic north and geographical north. Okay, so that is nothing but this phenomena, your magnetic declination or magnetic variation. Remember this. There is an angle between true north and magnetic north. This will vary from place to place. For example, okay, in Hyderabad it is this much, okay, 0.51. If you take Dubai, it is around 2.24 degrees. New York it is 3.46. Okay, understand in this way only, because from place to place it will vary. So there will be little bit of variation. But now what is happening here? Does this magnetic declination, does it change? Yes, it will change, because this magnetic north is moving over a period of time. Now it has come somewhere here, and this phenomena is called as pole wandering. See here, pole wandering. So the magnetic north was somewhere in Canada. So 1632, 1700, 1600, somewhere here. Okay. Now this is 2010, 2015, 2020, and this is the North Pole, geographical North Pole. And again in 2025, okay, it has moved. So this movement of the magnetic north or magnetic south, this is called as pole wandering. Remember all these terms, because nowadays a lot of things are happening with respect to this magnetic north and south. So that's why I'll be taking a bit time here. This is called as pole wandering. Now the movement of this magnetic north, this movement is around 55 kilometer per year. And the movement of this is around 10 to 15 kilometer per year. So this is moving very fast. Okay, this is also moving fast. And such kind of drastic movements will happen whenever the magnetic field inside the earth is changing. Okay. Now, one more point here. So, the magnetic field over a period of time will change. So, this is the present position, this is the north, and this is the south. Now, over a period of time, it can also become like this, north, south, and it can also become like this, south, north. So, the movement between these two, this is called as magnetic reversal. The poles are getting reversed, and the frequency of this, the magnetic reversal, is around 2 to 3 lakh years. So 2 से 3 लाख years में एक बार a reversal होता है. And what are the effects of the reversal? So before it get reversed, before reversal, the magnetic field of the earth will also become zero. Means while it is changing, it will keep on becoming weak. Keep on becoming weak. At a point it becomes zero and it undergoes reversal. And whenever it goes, it happens zero, it is associated with mass scale extinctions on the surface of the earth. Because when you don't have the magnetic field around the earth, the solar radiation will become very intense. The solar winds will be coming towards the earth like this, when this protective layer is not there. So a lot of UV radiation, alpha radiation, gamma radiation will be hitting the earth, and life on the earth will perish. Now the problem here is, so every 2 to 3 lakh years it should change. it should undergo reversal, but from the past 7,80,000 years, there is no change. Means the change is long overdue, right? And now the changes are happening very fast. That means, okay, in the recent time period, in the next, okay, a few, okay, millions of years or thousands of years, so there is going to be a drastic change in the Earth's magnetic field, and it might also lead to zero, okay, in the magnetic field strength. So these things are important. And there is one more term called as magnetic excursion. Excursion मतलब आपको पता है? When you are in the school, you guys used to go to excursions also. So you have the geographical north here, and the magnetic north. Magnetic north can be here, can be here, can be here, can be here, like this. No, it can move. So it will be moving around this geographical north. And this is called as magnetic excursion. Okay, I hope you have understood all this. Then you can read the literature over here. So magnetic declination is the angle between the magnetic north, that is true geographic north, okay, particular location surface of the earth. Now there is one more term called as magnetic dip. So you have this magnetic north somewhere here and magnetic south, right? Now if I am taking a compass, say this is the compass. Now while I am moving towards the north pole, the south pole of this compass will get attracted. It will bend like this. And when I am moving towards the southern hemisphere, again it will become like this. Okay. So on the equator, means magnetic equator, it will be horizontal. But while it is moving towards the poles, it will become 90 degree. So here you have to remember only one thing over here. That is, at poles, it is 90 degree. At the magnetic equator, it will be 0 degrees. So beyond this, nothing else is required. Anyways, you will be getting the PPT, you go through it, look at the class once again. Now there is one more term here, magnetic field changes and secular variation. So secular variation refers to the slow change in the strength and direction of the magnetic field over the years or centuries. Usually it is over the centuries. Now why this is happening? Why this all changes are happening? Because the speed of rotation is changing inside the interiors of the earth. So when the earth will be rotating on its axis, there will be a friction between inner core, outer core. There will be friction between the core and mantle. So because of this friction, it might slow down, and the earth's magnetic field also has induction effect. Means the magnetic field will make the inner layers of the earth revolve once again. So this is called as induction effect. So because of these variations, there will be changes in the speed. Okay, and because of the friction, they might slow down, and because of the induction, again the speed will pick up over a period of time. So this is where the changes will be happening. And as far as the examination is concerned, whatever comes in the examination, you agree to it. Okay, because this field is still evolving. These are very recent scientific findings. So again next year, again new things can come up. A lot of research is happening in this. So whatever comes in the examination, okay, if you find it little bit logical, if you find that there is a possibility for this, okay, you agree to it. Okay. Now Ekagra is asking, can scientists predict about when Earth is going to undergo reversal? So when Earth is going to undergo reversal, predict तो नहीं कर सकते, लेकिन based on the data which we have, they have found that 2 से 3 लाख के ईयर्स के बीच में रिवर्सल होता है। एंड दे ऑल्सो फाउंड दैट रिवर्सल होने से पहले मास स्केल एक्सटेंशन होता है। अभी साइंटिस्ट को कैसे पता कि रिवर्सल से पहले मास स्केल एक्सटेंशन हो रहा है? बिकॉज during those times, every 2 to 3 lakh years, they will find lot of fossil evidences. Okay, a mass scale extinction, मरा हुआ जानवर, plants बहुत मिलेगा fossils में, और they find a set of frequency. Now, how do we get to know that the magnetic field is changing? Because whenever the lava oozes out, right? So in the lava you will be having magnetic field materials, right? Magnetic properties will be there. So they will, okay, and lava is in the liquid state. So these magnetic field materials, they'll get aligned, ferromagnetic substances will get aligned according to the magnetic field. For example, during this time period, okay, a ferromagnetic substance has been released in the lava. So उसका direction कैसे होगा? ऐसे होगा. Now it has been released during this time, volcanic eruption अब हुआ. Say this is around like say 3 lakh years ago, this is 2 lakhs years ago. And यहाँ पे 2 lakh years ago there was a volcanic eruption. So the magnetic field orientation will be like this. And the present times में say volcanic eruption हुआ. So the orientation will be like this, right? And they will freeze, right? Okay, after it gets solidified, it will freeze. So any doubts here in any of these terms? You can ask. Again, I'll be sending you this PPT, how the, okay, reversal happens, etc. It can be anything, the field will weaken, okay, multiple temporary poles will also appear, chaotic phases, etc. Restabilization, duration, etc. Duration can be anything. Now, one more important thing, okay, I want you to see the video here for this. So this is about auroras. So I was talking about, in the last class I was talking about the auroras. Last class I was talking about the solar corona. In the solar corona, you will be having this magnetic field lines. This is not working. So this is the sun. So from the sun, you have this magnetic field lines coming out. So magnetic field lines. So the place from where these magnetic field lines come out, it will be comparatively darker. And this is called as sunspot. You see here? Here, the place from where the magnetic field lines emerge is called a sunspot. So depending upon how many magnetic field lines come, I guess it is working. So depending upon how many magnetic field lines come, you will be having those number of sunspot. So more the number of sunspots means more magnetic field lines are emerging, and ये बाहर निकलेगा, टूटेगा, and they will be coming towards the earth. So more sunspots means more temperatures on the surface of the earth. And after every 11 years, the intensity will be more. Means after every 11 years, we'll be having higher temperatures on the surface of the earth. So Kishore is asking secular variation. The secular is the opposite of regular. Okay? Regularly nahi hota hai. Okay? Because there is no guarantee over here that after 2-3 lakh years it is happening. It is chaotic. Or maybe we haven't understood it properly. So the opposite of the words regular is secular. Now Fatima is asking magnetic excursion समझ में नहीं आया. Magnetic excursion यही है. Excursion मतलब क्या? आप स्कूल में आप excursion जाते हो ना, घूम के आते हो ना. सो द मैग्नेटिक नॉर्थ जो है ना एक जगह नहीं रहता है, वो घूमता रहता है. ओके, कभी कनाडा में रहता है. ओके, मीन्स आप अटलस खोलोगे तो कनाडा में दिखेगा, लेकिन आप कोई इंटरनेट खोलोगे तो अभी साइबेरिया में दिखेगा वो. ओके, सो इन द लास्ट 100 years from 1900 to this 2025, the last 125 years, it has moved from Canadian part of Arctic to the Siberian part of Arctic. इतना मूवमेंट हो गया उसका. ओके, सो ये घूमता रहता है यहाँ पे. एक घूमने का चीज को अपन बोलते हैं एक्सकर्शन. ओके, अंडरस्टूड? ऑल डाउट्स क्लियर? So you have these magnetic field lines. So this magnetic field lines will be coming out of the sun. Okay, and what are these winds called as now? What are these called as? So they become solar winds, and this is called as solar flare. Okay, if their intensity increases even more and more, if some part of the sun, some mass of the sun is coming in this, okay, if mass is also included, means solar winds plus mass, this becomes CME, coronal mass ejections. So when they will be directed towards the earth, now earth will be having its own magnetic field, now दोनों के बीच में लड़ाई हो रही है, एंड ये आके क्या करेगा, इसको तोड़ेगा, इट विल ब्रेक देम. सो व्हेन दिस इज ब्रोकन, आई एम नॉट ड्रॉइंग मेनी लाइन्स हियर, ओनली फ्यू लाइन्स आई एम ड्रॉइंग. सो द फर्स्ट लाइन इज ब्रोकन, ये ब्रेक होके ये पीछे चले जाएगा, ऐसे पीछे चले जाके कहीं जाके मिलेगा, एंड इट वोंट बी एबल टू ब्रेक ऑल, इट विल बी एबल टू ब्रेक ओनली फ्यू, एंड सामने का फिर भी रहेगा, एंड पीछे के ये रहेंगे. ओके, एज इट इज. Okay, that's why the face of the earth which is facing the sun will be having less magnetic fields, and the other side, other face of the earth, means night time, say this is daytime, it will be facing the sun. So daytime it will be having less magnetic field lines, and night time it will be having more magnetic field lines. Means the strength of the magnetic field during the daytime will be less, and the strength of the magnetic field during the night time will be more. Okay, so Ayush is asking, if polar water moves towards equator, it will have any effect on the earth's axis tilt? Okay, it will be having very minute difference, very small difference will be there. Obviously when the water will be coming, it will be generating friction. Say it is moving, okay, opposite to the direction of the rotation of the earth, of course it will be having, okay, some difference. Even, okay, because of the change in the speed of inner core, outer core, or the mantle, will be having very small variation in the day and night timings, because the rotation of the earth will also be affected, right? Okay, so changes होगा, effect होगा, कितना होगा, बहुत ही कम होगा. Will you be able to notice that? Humans, will you be able to notice that? No. Normal clocks which you are using in your home, will they be able to notice the change? No. For that you have to use precise clocks such as atomic clocks. ऐसे कुछ चीजें यूज करना पड़ेगा, तभी जाके आपको पता चलेगा. Okay? So these are the various terms associated with magnetism. I hope you have understood this, right? Now let's see, okay, how these auroras are formed. Auroras. So there will be interaction between the solar wind and magnetic field lines. Okay. So whenever the magnetic field line, when it is broken, it will be leaving a lot of material, lot of charged particles on the poles of the earth, because from the poles the magnetic field lines are emerging. जब ये टूटेगा,
तो जब ये मैग्नेटिक फील्ड लाइंस टूट रहा है, टूटने के बाद में यहाँ जाके इट विल डिपॉजिट a lot of charged particles. Such as protons, electrons, etc.
And these charged particles, when they interact with the solar radiation, again they will shine, and this will be giving rise to the auroras. In the northern hemisphere, it is called as aurora borealis. In the southern hemisphere, it is called as aurora australis. Why in southern hemisphere it is called as australis? Because in southern hemisphere, you don't have many continents. You have Australia. Australia se dikh raha hai. So उन्होंने बोला aurora australis. So in why in northern hemisphere it is called as aurora borealis? Anybody can answer. Why it is called as aurora borealis in the northern hemisphere? Anyone? Because in the northern hemisphere, especially Norway and all, for example here, you'll be having a lot of boreal forest. Here it's not visible, I guess. You have a lot of boreal forest. Yes. So boreal forest के पीछे दिखेगा background. So boreal forest का screen saver जैसा दिखेगा पीछे. So that's why it is called as borealis. Very good, Fatima. Ekagra, very good. Now there is one more term called as Van Allen radiation zone. So I'll explain on the board again. See, whenever these charged particles, whenever the magnetic field line, when it breaks or snaps, lot of charged particles are released. Now sometimes these charged particles can be trapped in between the magnetic field lines. Okay, बीच में trap हो जाएगा. Okay, and the zones in which this magnetic field lines are trapped, they are called as Van Allen radiation zones. Now these zones, okay, you have two zones. These zones are in between the magnetic field lines. Means इसके बीच में the magnetic field lines निकल रहा है. So these zones are highly charged. So they'll be having highly charged atmosphere. And these zones are made up of protons and electrons, highly charged atmosphere. So whenever our astronauts or whenever our spaceships or whenever our rockets, when they want to go into the universe or when they want to go into the outer space, they have to avoid these two. Because अगर कोई एस्ट्रोनॉट ओके स्पेसशिप में बैठा है, इसके अंदर चला जाएगा, इतना चार्ज एटमॉस्फेयर में उनका तंदूरी हो जाता है. Because the radiation is very heavy over here. Means पूरे electrons है with very high density. And over a period of time, okay, the strength of the Van Allen radiation zone, okay, is increasing. See, the outer radiation belt, okay, is at a distance of around 50,000, 60,000 kilometers. Okay, the inner one, okay, will be starting from 600, 700 kilometers. So 600-700 kilometers के दूर में ये है, वो around 54,000, okay, 50,000 kilometers दूर में second radiation belt है. Now what is happening here? See, इन दोनों के बीच में gap है यहाँ पे. There's a gap here. So it should be starting from 600 kilometers. लेकिन क्या हो गया यहाँ पे? ये जो चीज जो है ना, this belt, okay, we'll draw on the board.
Are you guys familiar with all this? So this is the inner radiation belt. This is usual one. ऐसा होना चाहिए. And the distance between these two should be around 640 kilometers. लेकिन ये क्या हो गया? ये पुष्पा नहीं है, सो झुक गया ऐसे झुक गया. It has come very near now. Now it has come the 640 kilometers has been reduced to around 200 kilometers.
And बहुत नजदीक आ गया. अब और भी झुकेगा, ये आके अर्थ को टच हो जाएगा.
Now, if you go to the southern part of Atlantic,
और भी नजदीक आ जाएगा ना, आप जाके छू सकते हो.
So that's why this is called as Southern Atlantic Anomaly. Anomaly means what?
Means इट इज ऑपोजिट टू व्हाट यू एक्सपेक्ट. आप सोचा एक चीज था, दूसरा चीज हो रहा है वहां पे. अब सोच रहे हो कि वो 640 किलोमीटर दूर है, लेकिन वो नजदीक आ गया. ओके, सो इट इज ओके व्हाट ऑपोजिट टू व्हाट यू एक्सपेक्ट, एंड दैट इज कॉल्ड एज anomaly. Okay, so Ekagra is asking, talked a lot about it during ISRO launches. Okay, good Ekagra. So Ayush, क्या नहीं है, मतलब I didn't get your question properly. So this is called as southern Atlantic anomaly. Now अगर ये नजदीक आने से क्या हो रहा है, सी भाई इतना चार्ज एटमॉस्फेयर आपके पास आ रहा है, आपके वहाँ पे सैटेलाइट्स होते हैं, सैटेलाइट्स घूमते रहते हैं. अगर सैटेलाइट्स इसके अंदर आ गया, देन तो सैटेलाइट्स में जो इलेक्ट्रॉनिक कंपोनेंट्स होंगे, सो उनका वेयर एंड टेयर ज़्यादा हो जाएगा, वो ख़राब भी हो सकते हैं. एंड एस्ट्रोनॉट्स ओके जब बाहर जाएंगे, सो इंडिया का भी ये होता है ना, गगनयान होने वाला है. ओके, सो व्हेन दे विल बी गोइंग आउट, इफ दे एक्सीडेंटली एंटर इनटू दिस एंड इफ दे हैपन टू स्टे इन दिस फॉर लॉन्ग पीरियड ऑफ टाइम, मर जाएंगे. ओके, यू हैव टू बी वेरी केयरफुल. Okay, understood? So all clear? All your doubts are clear? So this is where the southern Atlantic anomaly is there. Okay, so this is where this is where the Van Allen radiation belt inner zone is bending. Understood? So Kishore is asking, does it change the satellite orbit? See, delta change कर सकता है, थोड़ा बहुत change कर सकता है. हम नहीं बोल सकते हैं कि चेंज नहीं करेगा. ओके, बट अगेन इट इज नॉट नोटिसेबल. सो बेसिकली दिस आर द चार्जेस, राइट? सी इट्स लाइक, सी योर सैटेलाइट इज रिवॉल्विंग अराउंड द अर्थ, एंड बीच में बहुत सारा पार्टिकल्स आ गया. ऑब्वियसली दे विल बी कॉजिंग फ्रिक्शन, एंड क्या पता वो पूरा सैटेलाइट को जला भी देगा, इलेक्ट्रॉनिक कंपोनेंट्स को खराब भी कर देगा. खराब नहीं कर रहा है, एटलीस्ट फ्रिक्शन तो क्रॉस करेगा ना, वो पार्टिकल्स है. सो बिकॉज ऑफ द फ्रिक्शन, the speed of the satellite can be reduced. It might also change the direction. So because the charged particles will be creating some polarity, उससे क्या होता है, डायरेक्शन भी चेंज हो सकता है. So Noorpreet is asking, what is the concept of the Bermuda Triangle? Bermuda Triangle कुछ नहीं है भाई. Okay, लोग unnecessarily confuse होते हैं. People say that near the Bermuda Triangle magnetic field कुछ होता है, ऐसा कुछ नहीं है. See, have you guys heard of this MH370? MH370 सुना है? Around 10 years ago, एक प्लेन, मलेशियन प्लेन which was going to China गायब हो गया था. यहाँ पे गायब हो गया था. Means अभी भी even in 21st century the planes vanish. Now पहले like in the 1900s and all, what happens? So the major trade was taking place between North America and Europe. दोनों के बीच में ट्रेड होता था. So Bermuda Triangle is located somewhere here. Now during those times the ships were not also that powerful. Okay, and in near Bermuda Triangle, okay, यहाँ पे ना एक जायर फॉर्म होता है. So here one ocean gyre is formed. This is called ocean gyre, which you'll be studying in oceanography. Now, अगर कोई शिप जा रहा है यहाँ से और बीच में फंस जाता है, and especially near Bermuda Island, you have a lot of weed called as sargassum grass. So अगर शिप का टर्बाइन जो है ग्रास में फंस गया, तो शिप फेल हो गया, right? Therefore, the company or the sailors will be blaming it on Bermuda Triangle. अभी लोगों को साइंटिफिक रीजन समझा नहीं सकते. शिप आ रहा है, वहाँ पे ओशन ज़ायर फॉर्म हो गया, देयर इज लॉट ऑफ सरगासम ग्रास बिकॉज द वाटर इज स्टेबल ओवर देयर, द ग्रास ग्रोथ इज मोर बिकॉज इफ ट्रॉपिकल रीजन. ओके, सनलाइट ज़्यादा होता है तो एल्गे भी वहाँ पे ग्रो होता है, तो टर्बाइन के बीच में फंस गया था, इसलिए शिप फेल हो गया. लोग समझे क्या इतना नहीं. ईजी क्या है, वहाँ पे कुछ अद्भुत शक्तियाँ हैं, तो वहाँ पे कुछ खतरनाक चीज़ें हैं, भेताल रहता है, शैतान रहता है. ओके, वहाँ पे जाओगे ना, आपका शिप फंस ही जाएगा. सो लोगों को लॉजिक ज़्यादा मैजिक ज़्यादा समझ में आता है इंस्टेड ऑफ लॉजिक. सो इसलिए बर्मुडा ट्रायंगल बदनाम है. ओके, शिप्स ऐसे फंस जाते हैं. ओके, नाउ व्हाट अबाउट प्लेन्स? प्लेन्स तो अभी भी व्हाट गायब हो जाते हैं ना. So this is तो like 1900s and all, 1800 या 1900s. So during that time अगर एक दो प्लेन भी वहाँ पे गायब हो गया, so लोगों को ऑलरेडी पता है बर्मुडा ट्रायंगल है, वहाँ पे कुछ अद्भुत शक्तियाँ है, कुछ तो होता है, तो वो लोग प्लेन वाले तो नहीं बोलेंगे ना, सी हमारे कंपनी का प्रॉब्लम है. अभी भी रिसेंटली ओके अपना अपना एयर इंडिया प्लेन भी क्रैश हो गया था. सो एट दैट टाइम ओके कोर इन्वेस्टिगेशन करेगा, बोइंग इन्वेस्टिगेशन करेगा. ओके अभी भी पता है क्या आपको एग्जैक्टली क्या हुआ? डू यू नो द रीजन व्हाट एग्जैक्टली हैपेंड? नोबडी नोस, बिकॉज the people who are in power or the companies, corporations doesn't want people to know what exactly is happening there. So, and this is 1900s. So what is easy? So they'll be saying that Bermuda Triangle है, okay, वहाँ पे अद्भुत शक्ति आके पूरा प्लेन को खींच लिया, खत्म हो गया. So that is the easiest way.
So Edward Suez. So, and the earlier geomorphologists, according to them, you had the semantic oceans. Over this, you have Sial floating. Sial. And because of this, various geological phenomena is happening. अगर इनको पूछ रहे हो, एडवर्ड सुएज जैसे बंदे को पूछ रहे हो कि माउंटेन्स कैसे फॉर्म हो रहा है, तो दे विल बी सेइंग दैट भाई जब ये सियाल फ्लोट होता है, ड्रिफ्ट होता है, तो यहाँ पे बहुत सारा मटेरियल जमा हो जाएगा एंड इट विल बी फॉर्मिंग ए माउंटेन कॉल्ड एज फोल माउंटेन. सो दिस इज देयर एक्सप्लेनेशन. बट अकॉर्डिंग टू द मॉडर्न एक्सप्लेनेशन, it is not just a Sial and Sima. So Sial is nothing but your continental crust, Sima is nothing but the oceanic crust. So it is not this way. In reality, you have the CC and you have the OC, CC, OC. So both are drifting over asthenosphere. Asthenosphere.
And why they are drifting over asthenosphere? In the asthenosphere, you have something called as olivine. So olivine make it slippery. It will be creating a lubricant effect. It is semi-molten plastic layer. So both together will be drifting. Okay. Now around the earth,
you have the CCOC, CCOC, CCOC. Okay. Do you think, okay, we'll be having one earth, one crust रहेगा क्या? जरूरी रहेगी ना?
So this is like a eclair's chocolate.
So below the crust, you have this asthenosphere. So in this you have the asthenosphere.
आपने eclairs का चॉकलेट खाया होगा ना, अंदर लिक्विड होती है, ऊपर सॉलिड होती है. So the solid which is above can break because of the liquid which is present below.
So that's why this layer is not a single unit, but it is broken into parts. And these broken parts of the crust is called as the plates.
And these are called as lithospheric plates. Why they are called as lithospheric plates?
Because the crust along with the upper part of the upper mantle, okay, so this will behave like a single unit. मीन्स थोड़ा बहुत जो क्रस्ट जो है ना नीचे के पार्ट से चिपका हुआ है.
इमेजिन दिस एज ओके, ऊपर आपकी रोटी है, नीचे आपकी सब्जी है. ओके, रोटी सब्जी के ऊपर रखे हुए हैं. ओके, थोड़ा बहुत सब्जी तो रोटी के साथ चिपकेगा ना, बिकॉज ये लिक्विड है, जेली काइंड ऑफ ए थिंग है. थोड़ा सा जेल जो है ऊपर का आपका ब्रेड जो है उसके साथ चिपक के रहेगा, राइट.
एंड दिस पार्ट, दिस इज कॉल्ड एज lithosphere.
So lithosphere is nothing but crust plus upper part of the upper mantle.
And the thickness of the lithosphere is around 100 kilometers.
And it is this lithosphere which is floating over the asthenosphere. So that's why these broken parts
are called as lithospheric plates.
Now these lithospheric plates, they can be small, they can be big. So they can be of any size. So in this fashion. Now in this you have the major plates, minor plates and micro plates. You have three types. So the major plates are North American, South American, Pacific, African plate, Eurasian plate, Indo-Austral plate is one. So these are the major plates. Then you have the minor plates, Cocos, Caribbean, Nazca, Somali, Arabian, okay, etc. You have these minor plates. Apart from this, you also have these micro plates, means extremely small, such as John de Fuca plate is here. Okay, so यहाँ पे इंडिया के पास है, यहाँ पे छोटा सा बर्मीज प्लेट है, तिमोर प्लेट है. Okay, so like this you have, okay, Timor plate है, okay, and you have this, bird's leg plate hai. Just you have numerous plates over here. So these are some of the major plates. Now if you look at the Pacific plate, it is mostly oceanic. We can say it is completely oceanic. If we take the Eurasian plate, it is mostly continental in nature. So they can be a mix of continental plus oceanic. Ayush, very thank you. So Ekagre is asking, the switch was turned off. I forgot its name. The fuel control switches were turned off. Yeah, okay, they have been telling that, the fuel control switch in the Air India flight, they have been turned off because वहाँ पे fuel अचानक से बहुत flow हो रहा था. Because वो पूरा fuel किया flight को and पता नहीं क्या हुआ कि fuel ज़्यादा बहने लगा. So वो अचानक से fuel off कर दिए थे. लेकिन वो क्यों बहने लगा किसको नहीं पता. अभी तक कोई minor plates, remember these names? Okay, so these are the microplates. These are extremely tectonically active, often temporary or evolving. So as far as India is concerned, you remember this plate, Burmese plate, because of the interaction between the Burmese plate and the Indian plate, Andaman and Nicobar group of islands are formed. Okay, remember this. Okay, so this is the Burmese plate, this is the Indian plate. So on this arc, you have this Andaman and Nicobar group of islands. Okay, so this is about the Earth and its interiors chapter. Okay, any doubts here? In magnetism, Earth and its interiors. We'll go to the next topic now. Evidences of the Earth's interiors. Good. I'll show you this later. So, evidences of Earth's interiors. Now you have some direct evidences, some indirect evidences. Direct, indirect. So direct evidences like mining. See, what will be the depth of a mine? See, for example, coal is there, or most of the minerals, okay, iron ore ka, okay, mine hai. So you'll be going 100 meters, 200 meters, 300 meters, that's it. Meters में ही जाओगे. Until and unless you're finding something very precious, you'll be going deeper. That's why the diamond mines, gold mines are deeper. So in South Africa, you have a mine which is around 3.9 kilometers. Now, the radius of the earth, the depth of the earth is 6,400 kilometers. अभी 6,400 में 3.9 is just barely scratching the surface, nothing. You won't get to know anything. You're not even going beyond the crust there. So, this is hardly any evidence. So Adhiraj is asking, okay, Delamination वो आएगा, next topic आएगा वो. Mining can be one of the evidence. Abhi, okay, you don't have the capacity to mine, okay, to very deep, but because of the volcanism, the constituents which are there inside, they are coming out. So volcanic rocks जो अंदर है वो बाहर आएगा. So उससे आपको पता चलेगा कि अर्थ का इंटीरियर्स कैसा है. लेकिन क्या आप एग्जैक्टली बता सकते हो कि ये वाला वॉल्केनिक रॉक कहाँ से आया है इंटीरियर्स ऑफ द अर्थ से? नो, यू कांट डू. यू वोंट गेट टू नो. थोड़ा बहुत प्रॉपर्टीज पता चलेगा. बसाल्ट आ रहा है, यू विल बी एबल टू गेस दैट इट इज कमिंग समवेयर फ्रॉम 2000 किलोमीटर्स, okay, or 1500 kilometers. So if it is highly andesitic in nature, okay, or acidic rocks hai, then you will be saying that it has come somewhere from 100 kilometers, 200 kilometers, 400 kilometers. आप guess कर सकते हो, but exactly कहाँ से आ रहा है you won't get to know. So the volcanic rocks are also not the conclusive evidences. You get some idea, but exactly not. Okay, then you tell me what are the other evidences of the earth's interiors. Now deep inside the earth you have trenches. Mariana Trench suna hai, which is around 11.8 kilometers deep. Now, James Cameron is making a movie on the Mariana Trench. So he himself, okay, went inside this trench. Okay, he saw all these creatures, and 95% of the oceans are not yet explored. We exactly don't know what is there inside. And when you're going inside the water, the pressure increases enormously. So itna high pressure hota hai, so you won't be able to do any kind of experiments. And सारे सरकारें इतना पैसा नहीं देखती है, नहीं फूकती है, okay, experiments के लिए, until and unless there is some commercial output. तो वहाँ पे कुछ सोना मिल रहा है, चांदी मिल रहा है, या कुछ rare earth metals मिल रहा है. जब तक आपकी कुछ बिजनेस एंगल नहीं रहता है, उतना मनी कोई इन्वेस्ट नहीं करता है, एक्सपेरिमेंट्स के लिए कोई नहीं करता है. So that's why the trenches are also hardly explored. That's why and moreover, okay, अगर चले भी जाओगे वहाँ पे, कितना किलोमीटर पता चलेगा? इतना ही पता चलेगा. Okay, and at some places you have this swollen mantle. Swollen mantle means mantle थोड़ा swell होके बाहर आ गया. आप mantle के पास तो नहीं जा सकते हो, लेकिन mantle थोड़ा swelling हो गया. लेकिन this is only there at one place near the Scotia plate. तो साउथ सैंडविच ट्रेंच है, ओके, साउथ अमेरिका के पास है, एक ही जगह पे है. सो दीस आर नॉट कंक्लूसिव एविडेंसेस, नॉट कंक्लूसिव. यू कांट conclude anything. Now you have some indirect evidences. So what are these indirect? So indirect evidence is, say for example, this meteorite rocks. See, we can't go inside the earth, right? We can't go inside and do experiments. What is there inside? Lekin we have the rocks which are coming from the outside space. ये rocks earth के तरफ आ रहे. And do you believe that? Okay, because all the celestial processes, behind all the celestial processes, there is only one reason. The process by which this meteorite rock has been made and the process by which the earth has been made is the same process. उसको आप process बोलो, भगवान बोलो, okay, आपकी मर्जी है. Means जिस भगवान ने meteorite rock बनाया, वही भगवान ने धरती को भी बनाया, वही भगवान ने सूरज को भी बनाया, ऐसा भी बोल सकते हो. Okay? So इसमें जो constituents है, same होना चाहिए, right? So therefore, when these meteorite rocks are coming towards the earth, and surprisingly they have found that this has around 70 to 80% of iron metals. Okay, and this class of minerals are called as tectites. I'll show you the rock also. It has lot of metal texture. ये देखो, ये वाला meteorite rock है. So कहीं से भी ये आपको silicate दिख रहा है क्या? पत्थर दिख रहा है, रॉक दिख रहा है क्या? नो, मेटल है. नाउ द सरफेस ऑफ द अर्थ मीन्स द क्रस्ट ऑफ द अर्थ. द क्रस्ट हैज ओनली
5% iron.
That means the rest of the iron must be hidden somewhere inside. So this is the indirect inference.
So next one. Now take two types of the earth. One is the chaotic arrangement, बीच में hollow spaces है, खाली है, खोखला है. And other one is concentric spheres. Layer by layer, like an onion, it is arranged. Now both are spinning on its axis.
So an earth for most of its geological history has been spinning smoothly on its axis. So until and unless you don't have the concentric sphere arrangement, you don't have smooth spinning of the earth. ऐसा chaotically arrange होगा, then earth smooth spinning नहीं करेगा और wobble करने लगेगा. Okay? So this is one more indirect evidence.
Next one. But again, here by these two evidences, you can only get indirect inferences, but you won't get direct inferences. And these are also inconclusive. Till now, whatever you have studied, direct or indirect, they are inconclusive. We can't exactly say. Okay. So one of the conclusive evidences is the seismic wave analysis. Seismic wave analysis.
Now let's see what are these seismic waves.
The seismic waves means the earthquake waves.
Now what kind of questions can be asked here, right? The seismic waves, okay, this is nothing but, okay, the release of energy. So whenever the energy is released, it can be manifested in any form.
So whenever the earthquake occurs,
earthquake is what? Nothing but it is a shaking in the crust.
Means somewhere the energy is released. So यहाँ पे कहीं energy release हुआ है. Energy is released. And the place where the energy is released, this is called as focus.
Now I am asking you a question. Okay. The earthquake, so which of the following waves are released during the earthquakes?
Okay, note down the question. Which of the following waves are released during the earthquake? Okay. Sound waves, electromagnetic waves, longitudinal waves, transverse waves. Okay. Modi waves, anything. आंसर क्या है यहाँ पे?
The answer is
all the above.
All the above. I have included Modi wave also. I'll tell you, I have got explanation for that. See, earthquake is what? Energy. जब भी energy release होती है, it can be manifested in any form. So it can be propagated in the form of electromagnetic wave. वो light के form में भी जा सकता है. अगर वो energy बहुत ज़्यादा है, X-ray के form में भी जा सकता है, और भी ज़्यादा है, gamma ray के form में भी जा सकता है, right? Earthquake happens because of the friction between two rocks. So when there is friction between two rocks, fire भी आ सकता है, okay, infrared radiation, sound भी आ सकता है. Of course, you know, ये तो आपने पढ़ा है, longitudinal wave, transverse waves, ये तो आपने पढ़ा है. Now, why Modi wave? Means exam में जो भी चीज़ आए, okay, कितना भी weird हो, आप mark कर देना. Why Modi wave? For example, कोई है, okay, say राजकुमार गौतम मोदी मेरा नाम है. So say tomorrow I discover okay, some new kind of a wave which is coming from the earthquake. Of course, मेरा नाम ही दूंगा ना, right? So any kind of wave can be released, okay? But what you will be studying here, we will not be studying, okay, all of this. We will be studying the mechanical waves. Mechanical waves which are released from the earthquake. Now let's classify this. And you know this, right? Focus hai. And the place which is on the surface of the earth, this is called as epicenter. Epi means ऊपर. So focus के ऊपर जो place है, it is called as epicenter. Now why? What is the importance of the epicenter? Say the earthquake is happening somewhere 20 kilometers below. मीन्स कोई ओके पॉलिटिशियन आके आपको पूछ रहा है, आप सेक्रेटरी इन द गवर्नमेंट ऑफ इंडिया हो, भाई earthquake कहाँ पे हुआ था? आप बोलोगे सर ओके इट इज एट 82.5 longitude ओके एंड 24 latitude ओके एट अ डिस्टेंस ऑफ 20 kilometers below these two intersection. ओके पॉलिटिशियन क्या बोलेगा? अब बोलना क्या चाहते हो? आप क्या बोलोगे? सर पटना के नीचे हुआ है, ऐसा बोलोगे ना? So you have to take a reference on the surface of the earth. ऊपर earth के ऊपर एक reference लेना पड़ेगा, and that is called as epicenter. Okay, so these two are the terms. So earthquake or seismic waves. So what are the various types of seismic waves? So here we are talking about the mechanical waves only. Mechanical waves. Now when the earthquake happens at a focus, from the focus the waves are released and these are traveling inside the body. Therefore they are called as body waves. Now, when the body waves, when they reach the surface, and the body waves, when they reach the surface, so they'll be disturbing the surface also. So, the body waves will be giving rise to the surface waves. The surface waves will be more near the focus, more near epicenter. अभी दूर क्यों नहीं रहेगा? Because by the time, okay, they will be traveling here. Don't you think they will be losing the energy? इतना दूर जाने के बाद क्या ये क्रस्ट को हिला पाएगा? नहीं. जब ये नजदीक है तभी ये क्रस्ट को हिला पाएगा. Okay, that's why the body waves will be giving rise to the surface waves, and they can be felt more near the epicenter. And while you are moving away from the epicenter, you will be feeling them less. Okay, I am coming to that, Nurpreet. Coming. Exactly follow my pattern only, you'll understand everything. Now, what are the various types of body waves? Now, the body waves are of two types. One is the longitudinal wave, other one is the transverse wave. So in the longitudinal wave, you have the compressions, rarefactions. Compression, rarefactions. Means it's like a spring. आपने push किया, okay, spring get compressed. Again the spring will be undergoing rarefaction. And जब spring will expand, on the other side again there will be compression. Okay, the spring का एक तरफ आप खींच दो, वो जाके push करेगा. That is how the energy is propagated. So here the energy travels in the direction, and the longitudinal wave, okay, it travels in all the mediums. All the mediums means solid, liquid, gas. इस सब में ट्रैवल करेगा. Whereas the transverse waves are these waves. It's like you're holding a rope and moving the rope up and down. Okay, this kind of a wave. So here the particles are traveling up and down, means perpendicular to the direction. Here the particles are traveling in the direction of the wave. The particles are traveling up and down. Now tell me, कौन जल्दी जाएगा? Which one will be faster? So the longitudinal waves are faster. Okay. Since they are faster, they are recorded first on the seismograph. That's why they are also called as primary waves. सबसे पहले आपको पता चलेगा because ये fast भाग के आएगा, इसलिए primary. ये second आएगा seismograph में. That's why they are called as secondary waves. Now these transverse waves, they won't travel in liquids. Liquid में travel नहीं करेगा. So I'll give you an analogy of this, why they don't travel in the liquid. See, okay, so I'll tell you the difference between solid and liquid, right? Solid means you are holding hands with each other, okay? If I'm pushing one person on this side, okay, he'll be pushing everyone, okay? ये solid है, सब हाथ पकड़ के हुए solid है. अब हाथ छोड़ दो, फिर मैं push कर रहा हूँ, फिर मैं बाकी लोगों को push करूँगा. The energy will be traveling forward. Now let's take this wave, transverse wave. Okay, हाथ पकड़ के रखो सब. जब आप हाथ सब पकड़ के रखे हो, solid है. Okay, अगर मैं जंप करूँगा ऊपर, because these are moving up and down. अगर मैं जंप करूँगा, मेरे साथ दूसरा जो है उसको भी खींच के ऊपर लेके जाऊँगा. जब मैं नीचे जाऊँगा, मैं दूसरे को भी नीचे लेके जाऊँगा. तो जब मैं नीचे ऊपर होता रहूँगा, मेरे बाजू वाला को भी ऊपर नीचे खींचता रहूँगा. Solid. हाथ छोड़ दो. You have become liquid. So in the liquid, okay, if I keep jumping, only I will keep jumping. I will not be affecting the other person who is beside me, liquid में. Similarly, जब तक rigidity है, okay, it will be traveling. Say the liquid is coming here. So if it is moving up and down, do you think it will be affecting the liquid? No, it will not affect the liquid. Therefore, the transverse waves, they require rigidity and they won't be able to travel in the liquid. Means they won't be able to travel in the outer core because outer core is liquid. So outer core mein they won't travel. Understood? Is it clear? Primary, secondary? Okay, Adhiraj, okay, I'll explain that. This one is clear to you, everyone? ये बहुत important है. Next. See, when the body waves will be hitting the crust, so they'll be coming towards the surface. So when they come towards the surface, you can have this kind of movement, to and fro movement. You can also have up and down movement. Up and down. So this to and fro movement, this is called as love waves. This up and down movement is called as relic waves. Relic. Right? And the direction, the speed of these waves, in सबसे पहले तो of course P wave आएगा, right? उसके बाद S waves आएगा, उसके बाद L आएगा, उसके बाद R आएगा. So the speed of the waves is PSLR. You can remember this way. आपको DSLR पता है, कोई आप रील्स वील्स बनाते तो आपको पता है DSLR कैमरा होता है. So PSLR, right? Now among these, which is most destructive? Okay, see, Adhiraj is saying the relic waves are more dangerous. See, actually यहाँ पे ना उतना simple नहीं है. This is horizontal and this is vertical. मैंने भी कई बार चेक किया. The booklet in which you have read, okay, relic waves are more dangerous because relic waves also have a rolling kind of movement. Little bit of rolling and little bit of side by side movement will be there. Okay, but I also have checked at many sources. Okay, नासा का वेबसाइट में देखा, ओके, लव वेव्स, ओके, आर मोस्ट डिस्ट्रक्टिव. आई नो विच, ओके, मटेरियल यू रेफर्ड टू, ओके, उसमें रेलिग है. सो गूगल में वही दिख रहा है. आई नो व्हाट यू आर सेइंग. मैं नासा में देखा, आई बिलीव इन नासा. So if you want to see the pictures, you can see. So this is the focus, this is the epicenter. Okay. And then these are S wave, P wave. So in the primary wave, okay, you'll be having contractions, rarefactions. In the S wave, you'll be having, okay, this wave kind of movement. So UPSC में क्या मार्क करना है, okay? तो UPSC में अगर पूछेगा तो स्पीड पूछेगा, and still, okay, there is, okay, lot of conflict between, okay, because कुछ sources relic maintain करते हैं, कुछ sources love करते हैं. So I don't think, you know, UPSC will ask here, and आपके NCERT में भी clear cut mention नहीं है ये वाला चीज़. So अगर पूछेगा तो love mark करना. So you can see the relic, okay, relic waves and love waves. So see, both look almost the same. Both are wave kind of a thing. Okay. So relic is rolling. Okay. Love is, okay, side by side and little bit of rolling. So Kishore is asking sources में both mentioned है. I didn't exactly understand sources में both mentioned है. एक बार chat GPT को पूछो ना क्या बता रहा है. And this is how the waves are coming. Okay. The P waves, S waves, the P waves, S waves and surface waves. Now let's discuss this a bit. See these P waves, okay, S waves, these are, okay, so Adiraj is saying both waves can cause significant damage but the building's infrastructure, but relief waves are generally more destructive due to larger amplitude and longer wavelength. Love waves and relic waves are two types of surface waves and generate, okay, generally more, okay. Source क्या है इसका Adiraj? GPT. चैट जीपीटी लव बोल रहा है एकाग्रा. मैं तो नासा में बिलीव करता हूँ भाई. फॉर मी नासा इज अल्टीमेट. ओके. एनीवेज, यू नो, लेट्स टेक दिस, यू नो, टॉपिक असाइड. यूपीएससी में आ रहा है, ओके, आप वहाँ पे, यू नो, टॉस कर लेना. अभी, यू नो, डिफरेंट सोर्सेस डिफरेंट चीज़ें बोल रहा है. लिव इट. So you have this P waves, okay, you have this S waves. Now you look at the time period over here. So generally, okay, the time period between the body waves and surface waves is around, like, you know, 3 to 4 minutes or sometimes 6 to 7 minutes. So depending upon from where it is coming, okay. And seismograph में सबसे पहले आपको P and S wave दिखेगा. Now, if you're talking about early warning in the earthquakes, so earlier the Chinese have come up with some early warning system. So the Chinese have found that because the animals have more senses, you know, as compared to the humans. So animals behave in a certain way when the earthquake is going to come or some, okay, disaster is going to come. उनको पहले पता चलता है. So China ने एक मेथड निकाला कि, okay, जब भी animals, you know, when they are running up ground, कहीं और भाग रहे हैं, okay, safety की जगह, then, okay, they started declaring that the earthquake is going to come. एक बार वर्क कर गया चाइना के लिए. लेकिन दूसरी बार भी पता नहीं एनिमल्स को क्या हुआ, खाना वाना दे रहे थे शायद, पता नहीं, कोई बास आ गई, एनिमल्स भाग ही रहे थे. तब भी, यू नो, चाइना ने डिक्लेयर किया कि earthquake आ रहा है, लेकिन उस बार नहीं हुआ था. So there is no foolproof, okay, early warning for the earthquakes. So we will get to know that the earthquake has come only 3 to 4 minutes or 6 to 7 minutes before. So जब भी P and S waves आएगा, they are not a destructive. ओके, फॉर एग्जाम्पल, ओके, टेबल के ऊपर बॉटल पड़ा हुआ है, बॉटल गिरेगा जब पी एन एस वेव्स आएगा. और, यू नो, किचन में कुछ सामान रखा हुआ है, कबर्ड वबर्ड नहीं है, ओके, ऐसे सेल्फ में रखा है, वो गिरेगा. और फ्रिज के ऊपर का कुछ चीज़ है, वो गिरेगा. दैट इज पी एन एस वेव्स. एंड दिस आर कॉल्ड एज इनिशियल ट्रेमर्स. इनिशियल ट्रेमर्स. एंड दिस इनिशियल ट्रेमर्स विल बी एक्टिंग एज द अर्ली वार्निंग.
So whenever the initial tremors come, you have to evacuate the building. Okay? तो जब भी पहला शेक होता है ना, आपके पास बस 3 से 4 मिनट का विंडो रहता है. उस टाइम पीरियड में आपको बिल्डिंग से बाहर भागना है. उसके लिए आपको ड्रिल्स होना चाहिए. इफ यू आर अनेबल टू गेट आउट, देन यू हैव टू गो फॉर ए सेफ लोकेशन. ओके, जहाँ पे पिलर और बीम दोनों मिलती है, वहां जाके आपको रेफ्यूज लेना है. लाइक यू हैव टू टक इन एंड देन यू हैव टू गो अंडर द टेबल. So these should be done as a part of your early, drilling exercise. Okay, में ये सब करना चाहिए. बट इंडिया में क्या करते हैं, लोगों को पता ही नहीं है. ओके, ड्रिल कैसे होता है, हाउ यू हैव टू गेट आउट ऑफ द बिल्डिंग, एंड वी हैव वेरी नैरो डोर्स. ओके, नैरो स्टेयरकेसेस, स्पेशली इन द बिल्डिंग्स वेयर यू विल बी हैविंग थाउजेंड्स ऑफ पीपल. आपका कोचिंग सेंटर देख लो कहीं पे. ओके, सो बहुत सारे लोग होते हैं जो लोग बाहर निकल नहीं पाते हैं. सो ओके, दे विल बी गोइंग एंड ब्लॉकिंग द डोर. जो आराम से निकलेगा ना आदमी, वो भी ब्लॉक हो जाएगा वहाँ पे. तो लोग क्या करते हैं, इधर से घूमते रहते हैं. ओके, एंड जो अर्थक्वेक नहीं गिराएगा बिल्डिंग को, लेकिन बिकॉज ऑफ द मूवमेंट ऑफ द पीपल ना, द बिल्डिंग गिर जाएगा. सो द ड्रिल्स आर वेरी इंपॉर्टेंट. नाउ नेक्स्ट कम्स द सरफेस वेव्स. सो दिस इज द सरफेस वेव्स. ओके, इन दिस यू विल बी हैविंग L and R, love and relic waves. So these are more destructive, the amplitude is more. Now इसके बाद भी थोड़ा बहुत शेक हो रहा है ना, राइट. दिस आर कॉल्ड एज आफ्टर ट्रेमर्स. मीन्स एक बार ओके सरफेस वेव आने के बाद क्रस्ट पूरा हिल जाएगा. ओके, एंड उसके बाद क्रस्ट जो है ना सेटल होता है. ओके, यहाँ पे से सरफेस वेव्स में क्रस्ट कहीं ब्रेक हो गया. ब्रेक होने के बाद वो सेटल होता है धीरे धीरे. फिर वो सेटल होना, दिस आर कॉल्ड एज आफ्टर ट्रेमर्स. दिस आफ्टर ट्रेमर्स विल ऑल्सो कॉज ए लॉट ऑफ डिस्ट्रक्शन. स्पेशली इफ योर बिल्डिंग्स आर इन हाईली डिलैपिडेटेड कंडीशंस. आपके पुराने बिल्डिंग है, उसमें स्ट्रक्चर्स ढंग से नहीं है, बिल्डिंग में सही से रेनफोर्समेंट नहीं हुआ है, पिलर्स नहीं यूज किया, देन उसके बाद आफ्टर ट्रिमर्स में भी ओके गिर सकता है. ओके, गुड. ओके, दिस इज अबाउट द सीस्मिक वेव एनालिसिस. So the earth and the interiors, this topic is over. Evidences of the earth's and interiors topic is over. So let's see how the P and S waves move. Body waves movement. So first let's imagine you have one earth, one density. Means you have uniform density. Right? So this is the core. And you have the waves released over here. So body waves are released. Body waves. So this is a P wave. So the P wave will be traveling irrespective of the medium. Because the outer core is liquid, from liquid also it will travel. Irrespective of the medium, it will be traveling. Then you have the S waves, and this is the outer core. Now the S waves won't travel from the liquid medium. It won't travel. So this region becomes the S shadow region. But do you think the earth has one earth, one density? Okay, Adiraj, okay, whatever you have said is right. Love waves cause greater destruction. What is Nurpreet saying? No. Okay, let's not get into the debate. Okay, which one is more? मेरा सुनो आप. Okay, मैंने काफी रिसर्च किया है इसके बारे में. But the earth does not have single density. So this is the core. So this is the P waves. So you must have studied the laws of refraction, right? So this has a density 1, this has a density 2. So whenever you travel from one medium to other medium, the refraction will be taking place, right? So in case of electromagnetic waves, means light, this wave will be moving towards the normal, towards move karega. For example, you have this light wave, it will be moving like this, inward move karega. So for mechanical waves, it will be moving outwards. वो बाहर की तरफ रिफ्रैक्ट करेगा. So this is how they will be traveling. So they will be diffracting outside. Why? Because of the density differences. So this is how the P waves will be moving. But the P waves can also move through the core, because the P waves can also travel through the liquids. So the P waves will be traveling like this. And this region becomes the P shadow. P shadow. This is also P shadow. And this angle over here, so this angle is 103 or 105. Okay, different sources have different angles over here. And this angle over here, this is 145 degrees. So the region between 103 and 145, okay, 105 or 145. So this becomes the P shadow region. That means वहाँ पे आपको P waves नहीं दिखेगा. And the S shadow region will be the same. So this is a core. Anyways, they won't be able to travel, okay, from the liquids. So this entire region becomes the S shadow region. So this is the proof that, because from this beyond this 103 degrees, you will not have any S waves. So this is the proof that the inner core is liquid. Inner core is liquid. Right? So Adhiraj is asking, mantle is solid or liquid? See, mantle is all solid, but at some places the mantle becomes liquid. Because of the processes which are happening inside, the mantle will melt from inside, and when it melts inside, it will be releasing these magnetic eruptions. So अंदर से बाहर आने लगेगा. You can see in the picture over here. See, कहीं कहीं वो लिक्विड होता है. क्यों? मे बी वहाँ पे एनर्जी बहुत ज़्यादा है, हीट ज़्यादा है, तो वहाँ का पत्थर पिघलेगा. पिघलने के बाद वो लाइट हो जाता है, लाइट होके बाहर निकलने लगता है. Okay, so there are only few places where the mantle is liquid or else it is solid. Okay, yes, solid है, rigid है. Okay, fine, understood. Now, talking about the evidences of the Earth's interiors, so the shadow regions will confirm that inner core is liquid. Now, how do you know that the density is changing? The density is changing, the proof is the diffraction. अगर density same होता, they would have come straight. You won't have this P shadow region. The P shadow region is a proof that density is varying. S shadow angle, okay, beyond 103 degrees, it's all S shadow. ये पूरा S shadow है. Then one more point which they can ask is this. So P shadow confirms that the density is varying. But how do you know which material is found where? Which rock is found at what depth? ये आपको कैसे पता? See, the speed of the waves will vary. The speed of the waves will vary. So if you are taking the crust, granitic rocks, crust में mostly granitic rocks होता है. So in the granitic rocks, the speed of the waves is around 4 to 5 kilometer per second.
While you are going deeper,
Okay, it will become 6 to 7 kilometer per second.
so if you are testing the speed of the seismic wave in the granite on the surface of the earth, it is found to be 4 to 5.
Now, जब ये wave इधर ही travel कर रहा है, when it is traveling in the
Upper layers only. So you know the distance between these two, you know the time. So when the earthquake has been triggered and when the earthquake is received here, you know the time. So distance by time, you will get to know the speed. So by speed, you can indirectly infer which kind of rock is there. So here,
say granite is there, okay,
more of felsic content is there.
while you are going deeper, okay, intermediate content is there,
Because the speed of the earthquake waves is becoming 6 to 7 kilometer per hour.
then while you are going even deeper,
The speed is increasing 7.5 to 8 kilometer per second. Then you can infer that mafic material is present. So this is how you can infer which material is found at what depth. So therefore, the earthquake waves will be acting, seismic waves will be giving the conclusive evidences of the Earth's interiors. Okay, understood? Is it clear? Next. So we'll be entering into new topic called as continental drift theory.
now remember this timeline. Now, earlier, before 1912, there were thermal contractionists. Thermal contractionist. So one of the major propagator, इनका सबका boss guru था, someone called as Harold Jeffrey. Okay.
Jeffrey, okay, मुझे ये नाम कैसा है? Game of Thrones में most hated person is Joffrey है ना person, वो जो बच्चा था. So Harold Jeffrey. So according to them, they believed in the permanency of oceans and continents. Permanency of oceans and continents means they believe that oceans and continents are permanent, they are not mobile. Now why they have to believe that? Means बहुत सारे लोगों को thought आया, see why they will be permanent, why they cannot drift. Okay, so scientific experiments तो होते रहते हैं, लेकिन ये जितने भी ये thoughts आते हैं वो religious ideas की वजह से दबा दिया गया. Because they have been told that their place of worship is at the center of the earth. उनको बोला गया है कि जेरूसलम center of the earth है. अगर continents drift होंगे, the continents and oceans are moving, the Jerusalem will not be the center of the earth anymore. Okay, then they'll be saying that you guys are talking or blasphemous things. Okay, we'll kill you like that. Okay, डर के मारे वो लोग बाहर नहीं बोलते थे, लेकिन कुछ लोग बाहर बोल देते थे. But again, the experiments were not taking place for long period of time because of this this religious pressure. Now finally, in the year 1912, then came the guy called as Alfred Wegener. So Alfred Wegener is a climatologist. Basically, he was a meteorologist. Means ये बंदा rainfall पढ़ता था, एक climate पढ़ता था. At max we can qualify him as a climatologist. For the first time, the Alfred Wegener has told that continental drift is happening. He has come up with various evidences of this. Means ये खुद evidences find नहीं किया, he has collected all these evidences. Basically, he was doing the job of a lawyer. Lawyer क्या करता है कोर्ट में? वो खुद evidences collect करता है क्या? नहीं ना, पुलिस collect करती है evidence. He was presenting all these evidences because from a very long period of time, the people have come up with lot of evidences. So he has presented all these evidences, and finally he has concluded that the continents and oceans, there is no permanency, they are drifting. Then इसको लोगों ने बहुत गाली दिया, ऐसे कैसे बोल सकता है? Okay, how come our place of worship
is not at the center of the earth. Okay, so go to France. Okay, go to Poland. Okay, because he was a German. लोगों ने बहुत गाली दिया इसको. So finally he has come up with various evidences. We'll study the evidences. First we'll see the timeline. Then Wegener has laid a foundation. Finally, over a period of time, the Wegener was able to establish that the continents and oceans were drifting. But the Wegener was not able to give the reasons properly. Because reason find करने के लिए you have to search in the interiors of the earth. अभी इंटीरियर्स ऑफ द अर्थ कौन पढ़ता है? जियोलॉजिस्ट पढ़ता है. बेचारा जियोलॉजिस्ट था क्या? ना, मेट्रोलॉजिस्ट या एटमैक्स क्लाइमेटोलॉजिस्ट था. एंड बेचारा पूरा वर्ल्ड घूमा. ही वेंट टू ग्रीनलैंड, ही वेंट टू अंटार्कटिका. फाइनली हिज डेथ हैपेंड इन द ग्रीनलैंड. स्नो में मर गया बेचारा. उसका बॉडी को भी किसी ने नहीं उठाया. ओके, सो ही वॉज ए क्लाइमेटोलॉजिस्ट and he has given some weird reasons. Okay, and those reasons are so weird that people did not accept Alfred Wegener. But some people, okay, went into searching what could be the reasons. Then in the year 1930, Arthur Holmes, he has come up with something called as mantle convection cell theory. Mantle convection cell theory. Basically, he has laid the foundation. Okay, कुछ तो reasons बताया इसने. Then, over a period of time, again the scientific experiments have taken place. In the 1960s, after the World War II, because these people, okay, Americans, okay, they were in the search of oil. Okay, because these Americans, they have seen that in the Persian Gulf, if you can find 50% of the world oil, अगर इतने छोटे पर्शियन गल्फ में इतना सारा तेल है तो हमारे पास तो बहुत बड़ा अटलांटिक महासमुंदर है. उसमें कितना ऑयल मिलेगा बोल के ग्रीडी हो गए. एंड दे हैव कंडक्टेड एन एक्सपेरिमेंट कॉल्ड एज ग्लोमर एक्सपीडिशन. ग्लोमर. सो इसमें ओके, टू पीपल आर वेरी इंपॉर्टेंट कॉल्ड एज हैरी हेस एंड डीट्स. बेसिकली दिस पीपल वेर मैरीन इंजीनियर्स. तो सेकेंड वर्ल्ड वॉर टाइम पीरियड पे नेवी पीपल थे. इनको एक शिप दे दिया, बोला कि भाई खोज के आओ. सो दे हैव डन लॉट ऑफ एक्सपेरिमेंट्स एज अ पार्ट ऑफ सी फ्लोर स्प्रेडिंग हाइपोथेसिस. Sea floor spreading. Basically, they have studied the Atlantic Ocean. So they have found a lot of things in Atlantic Oceans. Okay, they have found trenches, they have found central axial rift valley, they have found a ridge, they have found different types of mountains. So they have found that when actually before this, people used to believe that the ocean floor is uniform. वो सोचते थे कि ओशन फ्लोर में कोई वेरिएशंस नहीं होंगे. बिकॉज इसके पहले इन लोगों ने लेक के नीचे गया, तो जब लेक पे चलते हो तो यूनिफॉर्म सरफेस होता है. सो दे थॉट ओके द ओशन इज नथिंग बट द मैग्निफिकेशन ऑफ द लेक इटसेल्फ. लेकिन जब इन लोगों ने बताया भैया ऐसा नहीं है, अंदर तो ओके हिमालय से भी बड़े बड़े पहाड़ है. हिमालय कितना है? ओके, लेंथ इफ यू टेक 3000-4000 किलोमीटर्स. लेकिन भैया अंदर तो 70,000 किलोमीटर का माउंटेन है. सो अर्थ के ऊपर कोई भी प्लेस लोगे, डेप्थ कितना रहेगा? ओके, लाइक ना 340 मीटर्स, 350 मीटर्स, इतना डेप्थ रहेगा. अंदर तो ट्रेंचेस है, ओके, 11-12 किलोमीटर है. सो दे फाउंड दैट द फ्लोर ऑफ द अटलांटिक, ओके, और ओशंस इज मोर डाइवर्स, मोर लार्जर एज कंपेयर टू द surface of the land. Then this has further given rise to the plate tectonics theory in 1968-69. And further, okay, right now what is going on is the microplate tectonics theory. So this is the timeline. Okay, now let's do Alfred Wegener. So Wegener भैया ने क्या बोला देखते हैं. So Wegener's continental drift theory. Because I am telling you the story because the story से आपको ना चीज़ें अच्छी तरह याद रहती है instead of giving all the facts. Okay? आपने पहले ये वाला स्टोरी सुना है या पहली बार सुन रहे हो? अभी चीज़ें अच्छी तरह याद है? टाइमलाइन अच्छी तरह याद है? बताओ.
Good. Thank you. अभी वेगनर भैया ने क्या बोला देखते हैं. So Alfred Wegener, a German, a metallurgist, right? He has come up with various evidences. So what are these various evidences? Let's see. So this is one of the Wegener's pictures. असली picture है क्या पता नहीं है. So Wegener has found that even today, South America and Africa seem to be fitting into each other like a puzzle, jigsaw fit. Now, लोग बोलने लगे भैया it can be coincidence, कोस्ट लाइन तो मैच हो सकती है. देन उसने बोला, उसने खोदा, कोस्ट में जाके खोदा, कोस्ट के पास जो रॉक्स होते हैं ना, these are called as bedding plains. You have these various sedimentary rocks, these are called as bedding plains. And these bedding plains in South America and in Africa they are same. So यहाँ का जो continuity है वहाँ पे दिखता है. Then he has given the second evidence. This is called as structural evidence. Now what are the various evidences of Wegener? Okay, I will put it one place and then I will explain. Evidences of Wegener. The first one is jigsaw fit. The second evidence is structural evidences. Structural. So structural में क्या आता है? First is bedding plains. Bedding plains. The next evidence is faulting lines also. Faulting lines means this. So when the Africa and South America, when they were together, you must have had a fault. Even today, there is a continuation of this fault. अभी continents अलग हो गए, लेकिन fault यहाँ भी दिखता है, वहाँ भी दिखता है. The second evidence is the faulting zones, fault lines. Third evidence is age of rocks. So the age of the rocks in South America and the age of the rocks in Africa, three are same, right? So these are some of the structural evidences. Third one is paleoclimatic evidences. Paleoclimatic evidences. Means paleo means purana, old. Means old climatic evidences. Now what evidence he has found? Earlier, see, North America and Europe were together, but today they have been separated. They were together. So during this time period, the coal was formed. Okay. Now, generally people will not go and find the age of the rocks, but coal का कुछ commercial value है, economic value है, इसलिए coal कौन सा type का coal है, okay, what कौन सा age का coal है, ये तो find out करते experiments तो करेंगे इसके ऊपर, पैसा मिलता है उससे. So he found out that the coal which is found in Appalachians, North America, the coal which is found in Newfoundland, okay, this is near Canada, the coal which is found in Greenland, the coal which is found in Pennines, England, okay, ये सारा type का coal same है, okay. This is paleoclimatic evidence, means purana climate evidence है, okay. And one more evidence of paleoclimate is, now if you see the coal, okay, distribution in the world, now how is coal formed? The coal is formed because the plant life, rich plant life, has been fossilified. Means rich plant life होने के लिए you need to have a marshy land, marsh, and this can be found in tropicals only, because tropical regions will be having more sunlight, more photosynthesis, more cellulose, more lignin. Okay, so that's why you'll be having rich plant life. And only when this rich plant life is fossilified, you'll be getting this anthracite grade coal. Means अच्छा grade का coal मिलेगा. But today if you see where the coal is found, the best of the coal is not found here in tropical regions. The best of the coal is found in the best of the coal resource you found here in Utah, Wyoming region, British Columbia in Canada, Appalachians in North America, okay, Natal region in South Africa, right, Concepcion here in Argentina, okay, and Chile, Pinan coal in England, Ruhr Valley coal, okay, in Germany and France, Pechora Basin, Moscow Basin in Russia, Lena Basin again in Russia, Donbas Basin on the border of this Ukraine and Russia, Kuznets region again in Russia, Manchuria in China, right? And Australian coal here. So the best of the coal today you will not find in the tropics. इंडिया भी तो इंपोर्ट करता है ना बहुत सारा कोल, तो ट्रॉपिक्स में नहीं मिलता है. बट लॉजिकली द ट्रॉपिकल रीजन्स हैव द ग्रेटर चांसेस ऑफ फॉर्मेशन ऑफ द गुड कोल. इसका मतलब क्या है? सो वंस अपॉन ए टाइम दीज रीजन्स, ओके, सो कॉल्ड टुडेज टेम्परेट रीजन्स और द पोलर रीजन्स मस्ट हैव बीन लोकेटेड नियर द इक्वेटर. एंड जब यह रीजन्स इक्वेटर के ऊपर था, वहाँ पे बड़े बड़े मार्शस थे, बहुत सारा प्लांट लाइफ था. एंड आफ्टर दिस रिच प्लांट लाइफ द फॉल्टिंग हैज टेकन प्लेस. उस फॉल्ट में पूरा प्लांट्स गिर गया, उसके ऊपर मिट्टी गिर गया, हीट, प्रेशर. बिकॉज ऑफ दिस द प्लांट लाइफ हैज बीन कन्वर्टेड इनटू कोल, एंथ्रासाइट ग्रेड कोल. अंडरस्टूड? एंड ये भी पुराना क्लाइमेट का एविडेंस है. ओके, अंडरस्टूड? क्लियर? You can see here, okay, once upon a time they were also in the tropical regions. So one more evidence is the fossil evidences. Now today you see these animals like, Cynognathus, Listrosaurus, Mesosaurus. They are found across all these continents. Now if you see these animals, okay, this is a freshwater reptile. Freshwater में रहता है, समुद्र में नहीं रहता है. So these fossils are found, okay, here in South America and Africa. Now there can be two reasons, right? So one reason is this animal could have evolved in Africa, swim करके इधर चला गया. लेकिन swim कर सकता है क्या? नहीं. That is ruled out. What is the second possibility? Once upon a time they must have been together. Let's take this Cynognathus. Same. ये समुद्र में चल के जा सकता है क्या? नहीं. ये तो reptiles है, ये तो चल के भी नहीं जाएगा. So Wegener has concluded that once upon a time South America, Africa, Antarctica, India, Australia all were together. And examination में इतना deep में नहीं पूछेगा, okay, कि okay, which animal is found in which continents, ऐसा नहीं पूछेगा. But remember one thing, Glossopteris is a fern, it's a type of a plant. Its fossils are found everywhere, across, right? So remember one thing, you can remember a generic statements. The fossils of Listrosaurus, Cynognathus, Mesosaurus and Glossopteris are found across Gondwana. This is also called as the Gondwana land. You can remember this generic statement. If you want to remember specifically, you can remember, okay, or else you can ignore. So Noorpreet is asking, read about it earlier, Madagascar plate and Indian plate are also zygophyte. Yes. Okay, we'll discuss this in Indian geography, Madagascar and India. Okay, good, Gurpreet. Sorry, Noorpreet. Okay, so this is about Wegener and its evidences. Now, so Wegener ने इतने सारे evidences दे दिया, okay, then do you think the people who have been believing that the continents and oceans don't drift, okay, the people who have believed in the permanency of oceans and continents, do you think they'll be happy? No, they won't be happy. Then Wegener को क्वेश्चन करने लगे, ओके भैया तूने एविडेंसेस तो दे दिया, अब बता ये सब कैसे होता है. बेचारा वेगनर ओके क्लाइमेटोलॉजिस्ट था, मीटोलॉजिस्ट था, उसको क्या पता ओके अर्थ के अंदर क्या होता है. तो अंदर ये सब हो रहा है उसको क्या पता बेचारा, वो सरफेस को भी नहीं पढ़ सकता है. ही इज नॉट इवन जियोमॉर्फोलॉजिस्ट. उसको बस क्लाइमेट इसके ऊपर जो हवा होती है उसके बारे में पता है. ओके देन उसको टॉर्चर किया लोगों ने. देन वेगनर हैज कम अप विद सम वियर्ड एक्सप्लेनेशंस. सो वेगनर ने बोला ओके सो ऐसे ही लोग उसको टॉर्चर करने लगे. हाँ, वेगनर बेचारा एक दिन शायद ओके ऐसे ही बाल्टी में ऐसे घुमा रहा था. अभी बकेट, अभी आपके पास वॉशिंग मशीन ही है, आपको कपड़े धोना है, क्या करते हो, बकेट में सर्फ डालते हो, सर्फ डालने के बाद कपड़े डाल के ऐसे घुमाते हो ना. बेचारा वो भी ऐसे घुमा रहा था शायद. जब वो घुमा रहा था उसने देखा कि पूरा झाग जो है, फ्रॉथ जो है, वो बीच में आ रहा है. आइडिया आ गया उसको. उसने बोला कि सी earlier the Pangaea, the very big continent called as Pangaea, was located in the southern hemisphere. The earth was rotating on its axis, so when the rotation happens, the Pangaea will be moving in the middle, because whenever something rotates, okay, there is pole fleeing force, means pole से भाग के center में आ जाएगा. So he called it as pole fleeing force. But according to this logic, all the continents should have been accumulated on the equator of the earth. Is it so? No. In fact, most of the continents today you find in the northern hemisphere. The northern hemisphere is also called as land hemisphere. The southern hemisphere is also called as ocean hemisphere. Wrong है. देन लोगों ने पूछा ओके ये सब दिमाग बाद में लगाया. एट दैट टाइम उनको इतना दिमाग नहीं था. ओके देन उनको पूछा भाई ओके फाइन, ओके आपने बता दिया कि पोल से दूर भाग रहा है, इक्वेटर की तरफ भाग रहा है. ओके फाइन. देन लोगों ने उसको पूछा कि भैया ये बताओ, द कॉन्टिनेंट्स आर नॉट जस्ट ड्रिफ्टिंग टुवर्ड्स द सेंटर, द कॉन्टिनेंट्स ऑल्सो आर ड्रिफ्टिंग वेस्टवर्ड्स, especially North America and South America. They're also drifting westward. So, Wegener ने बोला कि why they are drifting westward, because इस तरफ आपका सन है, सन जो है खींच रहा है इस कॉन्टिनेंट्स को. Because at that time the understanding was you have the Oceanic continents and Semantic oceans. So they considered it as a wooden block floating over the water. And tidal force तो सबको पता है, right? Tides होती है because of the gravitational pull of sun and moon. So he told that because of the gravitational pull of the sun, these continents are like wooden blocks on the water. Therefore, they will drift. बोल दिया था, okay? So उसकी जो knowledge है उसके हिसाब से उन्होंने बोल दिया था. But both are wrong. अगर टाइडल फोर्सेस से कॉन्टिनेंट्स खिंच जाएगा, then the friction between this Sial and Sima, these continents and oceans, would be so strong that it will stop the rotation of the earth. And moreover, the gravitational pull of sun and moon, okay, in fact moon का ज़्यादा powerful होता है as compared to sun. They can pull the level of the water to couple of meters. So water को खींच सकता है. So continents को खींचने का शक्ति नहीं होगा, okay, इस tidal pull में. So later we got to know. So these are some weird explanations, okay, which have been given by Wegener. But why Wegener is considered? See, Wegener ने खुद ने तो evidences collect नहीं किया, and the reason which has been given by the Wegener is also lame. But still Wegener is considered to be like a pioneer. Why? Because see कभी-कभी ना फाउंडेशन स्टोन ले करना ये बहुत बड़ा काम होता है.
मीन्स उन सबके बीच में जो बिलीव कर रहे थे कि पोर्शंस एंड कॉन्टेंट्स आर परमानेंट, उनके बीच में जाके बोला कि भैया ऐसा नहीं होता, यू आर ऑल रॉन्ग। तो जो बंदा खड़ा होके बोल रहा है तुम सब गलत हो, ओके मेरा सही है, ओके दैट बंदा, ओके दे विल ले अ फाउंडेशन फॉर द न्यू टेक्नोलॉजी, ओके और ओके न्यू आइडिया. So he had laid a foundation seed for the further evolution of the plate tectonics. So that's why the Wegener is considered to be one of the pioneers. Now the Arthur Holmes has come. The Arthur Holmes is a geologist. He studied the processes in the interiors of the earth. Okay. Then he has come up with this mantle convection theory. So he told that, see, deep inside the earth, the core is very hot. This heat has to be dissipated out. There are three ways of heat transfer: conduction, convection, and radiation. So radiation is not possible because earth is not opaque, earth is not transparent, and conduction is not possible because rock is a very bad conductor of heat. So what is the only way of heat transfer? Convection is a way of heat transfer. So when the convection will be happening, okay, you have this rising limb and you have this diverging limb. So these diverging limbs will be pulling the plates apart. So this has been told by Arthur Holmes. Finally, he laid the foundation for the mantle convection theory. So next, in this order, you have Harry Hess and Deeds seafloor spreading hypothesis. Seafloor spreading. So these people have conducted a lot of experiments in the Atlantic. So according to this, you have the crust, and below the crust, you have this mantle convecting cells. So this is a rising limb, and this is diverging limb. So when this magma is oozing out, it will become cool. Again, after becoming cool, it will lose the energy, it will sink back. So this is called as the sinking limb. Now over a period of time, the crust will become thinner. A crust thin हो जाएगा. It will break apart. It will break apart. And finally, this lava will come out. And lava will come out, it will be forming various features on the ocean. So whenever the content breaks, the oceans will be formed. And finally, the region in between will be filled up with the water. It will become the ocean. So this will happen in 3 steps here. So initially you will be having continental rifting phase. So you have this rifting. That is, part of the crust will be broken and the spaces here will be filled up with the water and you will be forming rift valley lakes. And these rift valley lakes are there in Africa. I will show them. Then when it becomes even larger, it will become ocean. So when it becomes an ocean, it will form a nascent ocean or new ocean. And further it will become larger, it will form a mature ocean. Okay. Now let's talk about the rift valleys here. You see this Africa. You have the rifting over here. So this is called as Great African Rifting. Last time I told you, here in Ethiopia, you have Afar triple junction. So one arm is moving into Gulf of Aden and one arm is moving into Red Sea. So here the continent is broken into 2 parts and these regions have been filled up with the water. And as examination they can ask the order of these lakes. So you have this Malawi country, this is called as Malawi Lake. Okay. You have one more lake over here. You have this Tanganyika.
Then you have Lake Kivu here. Kivu, city called as Goma here, Lake Kivu. Lake Kivu is, remember, okay, because it is located between DRC and Rwanda. Two countries are there, Rwanda and DRC. And there is a rebel group called as M23, okay, which has become very violent in DRC. Okay, it's a terrorist group called as M23, okay, near Lake Kivu. Here you have a city called as Goma, also remember this, because Goma recently had this volcanic eruption, and the group which is active, M23, has taken over this city called as Goma. Goma ko le liya. The western part of this DRC, now it is completely under the control of this M23, and there's so many terrorist groups over here. Now, why there are so many terrorist groups, okay, along the Great African Rifting region? Because I told you, whenever you have a rift, that region will become rich in minerals, and this region, okay, is very rich in minerals. Western part of DRC along the rifting is very rich in minerals. Especially you get a lot of copper over here. Copper milta hai yahan pe. You get a lot of coltan, COLTAN, coltan milta hai. So coltan, okay, is used for making the mobile phones and all. And also you get diamonds, okay, and other minerals. So minerals are there, okay. So if there is a stable government, okay, the Western powers won't be able to mine this minerals. वो लोग क्या करते हैं, कुछ terrorist group को fund करते हैं यहाँ पे. वो लोग आकर अटैक करते हैं, वो लोग कब्जा कर लेते हैं. M23 कब्जा कर लिया लेक क्यू के आसपास. तो M23 के पास तो ओके टेक्नोलॉजी नहीं होगा. वो लोग क्या करेंगे, बुलाएंगे अमेरिकन को या किसी को. वो लोग आके यहाँ पे माइनिंग करके चले जाएंगे. ओके, सो if you are mineral rich and if you are mineral rich, gradually instability will be created and foreign powers will come and take over. अभी recently क्या हुआ वेनेजुला में, इतनी बड़ी कंट्री है, मुद्रो ओके वो रूल कर रहा था. अमेरिका ने क्या बोला, मुद्रो ओके यू हैव बीन trafficking drugs into USA, will come and arrest you, we will take over. What is this, huh? If okay रशिया ने अगर किया ओके यूक्रेन में तो पाप है, यूएसए ने किया तो ठीक है. सो हमारा प्यार प्यार है ऐसा बोलते हैं ना, ओके वैसा ही चीज़ है. देन व्हाट सद्दाम हुसैन, ओके गद्दाफी, ओके लिबिया, अरब स्प्रिंग, व्हाई ऑल दिस थिंग्स हैव हैपेंड? बिकॉज दे आर वेरी रिच इन रिसोर्सेस, ऑयल. अगर तेल नहीं होता मिडिल ईस्ट में, क्या टेररिज्म होता वहाँ पे? राइट. FAFO, okay, is also important group. Good. Now, remember the order of the lakes. Okay, Lake Malawi, okay, is also called as Lake Nyasa, Lake Tanganyika. Okay, no मैपिंग करना सेपरेट आपको मैं भेज दूंगा. कुछ लोगों को भेजा है, मुझे मैसेज कर दो, मैं मैपिंग का लिंक आपको भेज दूंगा मैं. ओके, लेक कीवू, ओके, लेक एडवर्ड, लेक आल्बर्ट, दिस इज लेक आल्बर्ट बिटवीन उगांडा एंड दिस. लेक आल्बर्ट, this is Lake Edward. Now Victoria Lake is not a Rift Valley lake. It is not located in the Rift Valley. Now these Rift Valley lakes, okay, are very rich in minerals. Why? Because when the rifting will be taking place, so this is of the land cracks. So when the rifting will be taking place, it will be releasing a lot of minerals. इसमें अगर पानी घुस गया, वो minerals को dissolve करेगा. So when the lake will be formed, okay, they will be, sometimes they can become highly alkaline also, but they will be very rich in minerals. And when you have more minerals, more phytoplankton growth will be there, more phytoplankton, more fishes. That's why these lakes are very rich in fisheries. बड़े बड़े fish होते हैं, and fishing is one of the important source of livelihood here. And this is also called as Somali plate. So this Somali plate is getting separated. So in the future it will get separated like this, and gradually this Somali plate will be moving towards India. And जहाँ पे Western Ghats है, so Western Ghats की जगह new Himalayas kind of new fold mountains will be formed in the future. Maybe after 40-50 million years, new fold mountains will be formed. Okay, and उनको बोलेंगे future में Somalayas. Like Himalaya, Somalia. Why? Because Somalia is moving towards India. And gradually, the Rift Valley will become nascent ocean. So this is a nascent ocean, new ocean. And the nascent ocean will become large ocean. So this picture has been shown here. Okay? You can see the picture here also. Now, what are the various features which are formed? Okay, when the sea floor spreading takes place. So, after the sea floor spreading, the Harry, Hess and Dietz, they have told the world that, so there are very large features. You can see a very big crack over here starting from Iceland, starting from Arctic, you see this? So, earlier North America and Europe were together, South America and Africa were together. So, this is where the rifting has taken place. You see a crack over here? So, this crack is called as Central Axial Rift Valley. And see a elevated portion over here? So, this elevated portion is called as ridge. Sometimes it is called as central ridge. And you see numerous mountains over here. Sometimes these mountains will be coming over the land. Okay? When the mountains come over the land, when the seamounts come over the land, they are called as islands. Okay? When they are inside the water, they are called as seamounts. Sometimes what happens, the seamounts can also become flat. Say a seamount water के बाहर आया, okay, and waves होते हैं sea waves. Sea waves क्या करता है? Top का जो conical surface है उसको flat करता है because of the wave action. This is called as aerial and subaerial erosion. So because of this aerial and subaerial erosion, the top will become flat, and this top which has become flat, it is called as gyot. And छोटा सा seamount होता है ना, उसको बोलते हैं knoll. So these are all the various features of the ocean. And this ridge which is there in the Atlantic, which is running from the Arctic to Antarctic, so this is around 16,000 kilometers. And this ridge is interconnected. You can see this ridge interconnected. And interconnection always happens at the triple junction. Now see, this ridge is again running into your Indian Ocean. See, again it is running into Southern Ocean, is running into Australia, is running towards this Gulf of Aden. So this is nothing but mountain chain system. It is all over the globe. The length of this mountain chain system is around 70,000 kilometers. Noorpreet is asking, cropping system will change. ये होगा like, in the next 40-50 million years. Okay, I'll show you the picture here. So these are the various features. So this is the ocean floor bottom. See, flat top है तो gyot हो गया, उससे थोड़ा बड़ा होगा तो sea mount हो गया, बाहर आ गया volcanic island. So this elevated portion which you see in between, इसको बोलेंगे ridge. Okay, the place where actual rifting is taking place. तो जहां से लिथोस्फेरिक प्लेट फट गया, इसको बोलेंगे, बीच वाले को बोलेंगे सेंट्रल एक्सियल रिफ्ट वैली. ओके, अगर सी माउंट से भी छोटा माउंटेन कहीं है, ऐसा छोटा माउंटेन, द छोटा माउंटेन इज कॉल्ड एज नॉल. ओके, and this is shelf, etc. Okay, this is the trench. Okay, this will study in oceanography later on. Okay, understood? So these are the various features of the ocean. Okay, and two more things which have come out in the sea floor spreading hypothesis is, so while you are moving from the ridge towards the continents, from the central axial rift valley towards the continents, the age of the rock increases. Obviously, so volcanic eruptions तो हो रहा है यहाँ पे ना, यहाँ पे हो रहा है. So obviously the age of the rocks near the ridge will be less. The age of the rocks away from the central axial rift valley will be more. And next, the sediments will be more near the continents, and the sediments will reduce while you are traveling towards the center. Obviously, sediments कहाँ से आएंगे? मिट्टी कहाँ से आएगा? So content से ही आएगा. तो जितने भी contents है, because of the rivers, because of the wind, मिट्टी आता रहेगा. You can see all the sediments over here falling down. See, the sediments will be more near the continents, and the sediments will reduce. Okay,
while you are going towards the center. That's why here it is comparatively smooth. आपने देखा smooth है, क्यों? See, इसके पहले okay, यहाँ पे भी ऐसा rough surface था, but a rough surface जो है sediments के कारण ढक गया, because sediments have overlaid all these seamounts, knolls, gyots, whatever are there, but they won't be able to travel that far. So that's why you'll be seeing a lot of rough surface, and while you go towards the center it will become even rougher. What is this portion here? Why this is elevated? This elevated portion is called as ridge. So that is from where actually this volcanic eruption is taking place. You have this diverging limb over there, rising limb. So when you have a limb like this, वो थोड़ा वहाँ पे सूझेगा. So this portion in between, okay, it will be called as the central axial rift valley, and there you will be having a lot of ridges. Understood? Any doubts? So this is about seafloor spreading hypothesis. Okay, next comes the plate tectonics theory. So समझ में आ रहा है, मजा आ रहा है? Good. Because I feel that I'm teaching only trivial things. Is it adding any value? जितने भी आपके concepts में कुछ gaps थे, वो fill हो रहे क्या? Or you feel that I'm wasting your time? Because some of you may feel that okay, हमको सारी चीजें पता है, sir unnecessarily repeat कर रहे हैं. Okay, good, adding value, good. So see UPSC में see especially recent pattern देखो आप. See एक तो मैपिंग पे क्वेश्चंस पूछेंगे. See मैपिंग बहुत लंबा है, मैं आपको वीडियोस भेज दूंगा. Okay. See बाकी क्वेश्चन जो है ना कॉन्सेप्चुअल क्वेश्चंस है. जब तक आप कॉन्सेप्ट नहीं पढ़ोगे, okay, डीपर अंडरस्टैंडिंग नहीं रहेगी ना, यू वोंट बी एबल टू सॉल्व. दैट्स व्हाई आई एम फोकसिंग ए लॉट ऑन कॉन्सेप्ट्स. तो कंटेंट तो आपको हर जगह मिल जाएगा, ओके, लेकिन इनको दिमाग में कैसे घुसाना है, ओके, मुझे अच्छी तरह पता है. सो दैट्स व्हाई ओके आई एम पेइंग मोर अटेंशन ऑन दिस. Okay, good. Next is plate tectonics theory. Okay, now before plate tectonics, okay, you had this Arthur Holmes mantle convecting cell theory. Okay, so then okay, the Harry Hess and Dietz, they have done seafloor setting hypothesis. उन्होंने पता लगाया कि someone's below the oceans there are very large plains, there are very large mountains, your fjords, seamounts, volcanic islands. So I told a lot of things. So finally the plate tectonics theory has come in the year 1968-69. So some of the pioneers of this are Morgan, Wilson, etc. So many people have contributed, many people have contributed. These are some of the important ones. Many people have contributed. Some of the important ones are Morgan and Wilson. Now, according to the plate tectonic theory interpretation, see what was the earlier understanding? Earlier understanding was you have the Sialic continents floating over seamatic oceans, but it is not as simple as it seems. So it is the Sial along with Sima, Sial along with Sima plus little bit of upper part of the upper mantle, both combined together, and this is called as lithosphere, which is around 100 kilometers thick, and this lithosphere, this is floating over the asthenosphere. So this is around 400 kilometers thick. And you have these lithospheric plates, that these lithospheric plates are drifting over the asthenosphere. Okay. Now, these plates, these lithospheric plates, these plates can have three types of movement. Three types of movement. A, the plates can move towards each other, right? Next, the plates can move away from each other, away from each other. Now see, the plates can just slide past each other, slide past each other. So here the plates are moving towards each other. The plates are moving away from each other. The plates are just sliding past each other, rubbing against each other, right? थैंक यू JPS. अच्छा टीचर तो हूँ, लेकिन अच्छे टीचरों की इज्जत ही नहीं है मार्केट में. See, when the plates are moving towards each other, okay, example, okay, दो ईंट है, एक दूसरे की तरफ मूव कर रहे हैं, दो पत्थर है एक दूसरे की तरफ मूव कर रहे हैं, तो क्या होगा? तो बीच का जो पत्थर जो है ना वो टूटेगा, टूटेगा, डिस्ट्रक्शन होगा यहाँ पे, destruction. So that's why this is also called as destructive plate boundary. Destructive plate boundary. कुछ नहीं आया आयुष. ओके तो आप लोग को तो करते हो, लेकिन इन लोगों को पता नहीं ना, बिकॉज नाउ डेज यू नो, ओके, वो जो कहावत है ना, ओके, जो दिखता है बिकता है, वो सबसे ज़्यादा दिखता है वही बिकता है. ओके मैं दिखा नहीं हूँ कहीं लोगों को ज़्यादा. ओके दैट्स व्हाई पीपल डोंट नो मी मच. सो हियर प्लेट्स आर मूविंग अवे फ्रॉम ईच अदर. जो जस्ट नाउ यू आर सीन, so the plates are moving away from each other. Say this is single plate, now it has moved apart, it has moved away from each other, so new ocean floor has been formed. New ocean floor अभी भी देखा है आपने. So here construction is taking place, that's what is called as constructive plate boundary. सो लास्ट क्लास में एक बंदा क्या बोल के गया है, आई डोंट नो हिज नेम, कमेंट में करके दिया. सो ही सेइंग दैट सर मुझे कुछ समझ में नहीं आ रहा है, पैसा दिया पूरा वेस्ट है ये. अभी कोर्स शुरू हुआ है, थोड़ा बहुत डाइव करो, एफर्ट मारो, हाँ, चीज़ों को समझने की कोशिश करो. बिना ट्राई किए आप बोल रहे हो कि मुझे कुछ समझ, मतलब स्टार्टिंग के स्टेज में गिव अप नहीं मारना है. ओके इट्स द वर्ल्ड्स मोस्ट टफेस्ट एग्जामिनेशन. Now, the plates are sliding past each other. See here destruction is taking place, here construction is taking place, and here nothing is taking place. कुछ नहीं हो रहा है. That's why it is called as conservative plate boundary. Conservative plate boundary. Conservative मतलब कुछ नहीं हो रहा है, no changes. Like आपने सुना होगा ना, वो लोग बहुत conservative है. Okay, for example, someone comes and proposes you. Okay, what you'll be saying? No, my parents are very conservative. Okay, that means they don't want any change to happen. That is conservative. Conservation बोलते हैं ना, right? Now move towards each other. आपको कैसे याद रखना है? I will tell you a trick here. Okay, so when you guys are moving towards each other, say आप प्यार में गिर रहे हो, okay, आपका मेकअप हो रहा है. So with respect to your career, कंस्ट्रक्शन होगा डिस्ट्रक्शन होगा, व्हाट विल हैपन टू योर कैरियर? भाई आप कोई रिलेशनशिप में पड़े हो, कंस्ट्रक्शन होगा डिस्ट्रक्शन होगा? डिस्ट्रक्शन. सो व्हेन यू गाइस मूव टुवर्ड्स ईच अदर, डिस्ट्रक्शन, तबाही, ब्रेकअप हो गया आपका. व्हेन यू गाइस आर मूविंग अवे फ्रॉम ईच अदर, आपका ब्रेकअप हो गया, देन यू विल फील दैट मैं तो ओके, आई विल शो व्हाट आई एम, आई विल शो टू द अदर पर्सन. मैं कलेक्टर बना के दिखाऊंगी या कलेक्टर बन के ही दिखूंगा. ओके लाइक दैट. सो एज फार एज योर करियर इज कंसर्न, सम काइंड ऑफ कंस्ट्रक्शन इज टेकिंग प्लेस. Okay, so it is called as constructive plate boundary. यहाँ पे स्लाइडिंग पास्ट ईच अदर, आपको कोई पसंद है, आप बस ऐसे उसके पास ऐसे जाके जा रहे हो, जस्ट यू आर स्लाइडिंग पास्ट ईच अदर, आप बोलते भी नहीं हो, स्माइल करके चले जाते हो, कुछ हो रहा है ना, ब्रेकअप हो रहा है ना मेकअप हो रहा है, क्या होता है, कंजर्वेटिव. नाउ दिस कंस्ट्रक्शन, डिस्ट्रक्शन और कंजर्वेटिव इज विथ रिस्पेक्ट टू द ओशियानिक प्लेट. सो यहाँ पे जो ओशन प्लेट जो है, अगर बीच में ओशन प्लेट है, दोनों कॉन्टिनेंटल क्रस्ट आके एक दूसरे से भिड़ेगा, बीच में जो ओशन क्रस्ट है वो अंडरगोज डिस्ट्रक्शन, खत्म हो जाएगा, दैट्स व्हाई डिस्ट्रक्टिव. यहाँ पे न्यू ओशन प्लेट इज अंडरगोइंग कंस्ट्रक्शन, दैट्स व्हाट इज कंस्ट्रक्टिव प्लेट बाउंड्री. हियर नथिंग इज हैपनिंग, conservative plate boundary. Understood? So the construction, destruction or conservative, all with respect to oceans. Understood? So this is what has been told in the plate tectonics theory. Now, so let's take different plates over here. So let's take the destructive plate boundary. Sorry, let's take the constructive plate boundary or divergent plate boundary. Divergent plate boundary or constructive plate boundary. आयुष पूछ रहा है, मेरे साथ ऐसा कुछ हुआ था क्या? भैया मेरे हाथ में से बहुत सारे IAS IPS निकले थे. मैंने 3 इंटरव्यू दिया है, लेकिन somehow couldn't clear because of various reasons. So let's see the divergent plate boundary. So the divergent plate boundary, okay, you have this crust. This crust will be breaking apart. So initially what will be formed? A rift valley will be formed. So this is a rift valley, just now I explained you. And this rift valley will further, it will give rise to the ocean floor. This will again further move apart. So बीच में क्या आ जाएगा? So बीच में ocean floor will come. Means basalt will come. Means नीचे का जो magma है ऊपर आना चाहिए. So this will become basalt. So this is a nascent ocean or new ocean. Like Red Sea. Red Sea is the example here. And when they move apart, again larger ocean will be formed. A mature ocean will be formed. Right? So this is a divergent plate boundary or destructive plate boundary. Okay? And the example of this, okay, divergent plate boundary or the destructive plate boundary is Great African Rifting. Great African Rifting. Now this Great African Rifting is further extending into Red Sea. You can see a crack here in the Red Sea. दिख रहा है आपको? Crack? Red Sea. And this is also extending into Gulf of Aden. And बीच में क्या है? Afar triple junction है. Okay. And Africa में, okay, some places, okay, wherever this volcanic eruption is taking place, they look very alien. मतलब वहाँ पे इतने सारे chemicals आ जाते हैं अंदर से. They look very alien. For example, I'll show you. I don't have the picture. So in Ethiopia, there is a place called as So Ethiopia, there is a place called as the Danakil Depression. I'll show you the place. Don't know what is happening. So divergent plate boundaries is a constructive plate boundary. Okay, I said destruction. Okay, sorry. Okay. So I'll stop the class here today. Again in the evening we have a class. We'll continue with the constructive. Okay, sorry. Okay, convergent plate boundaries. So Adhiraj is asking, why is Somalia looks like a desert? See, Somalia looks like a desert because so I love to explain things very practically. So this is the equator. This is the equator, right? And this is the tropical region, right? Now you have these winds coming. Trade winds are very prominent in this region. A trade winds are. Only when the trade winds are onshore, you will be getting rainfall. Means यहाँ पे आपको कितना gap है? Winds आएगा. Do you think these winds will be able to pick up moisture from the ocean and give rainfall? No, they won't be able to give rainfall. That's why Somalia remains dry. And moreover, even if the wind is coming with moisture, you should be having some mountain होना चाहिए. Then only, okay, this air will rise up, moisture laden winds will be rising up, and they will be forming a cloud and give rainfall. Now you see this Ethiopia. Ethiopia is comparatively green. Ethiopia is comparatively green because if you look at the topography of Ethiopia, it is all hills. It is all hills. So, whatever little moisture comes, if it is climbing over the hill, it will be forming clouds and giving rainfall. That's why Ethiopia is comparatively green. And look at Ethiopia, it is on the either side of the Great African Rifting. So Ethiopia is an example of the basaltic eruptions. So when the crack has taken place, on the either side, a lot of basalt has poured out and a basaltic plateau has been formed. Just like you have this, okay, Deccan Plateau in India, it is very similar to that. Okay, that's why the average height of this Ethiopian highlands is around like 1500, 2000, 3000. And Ethiopia में बहुत सारे लड़ाइयाँ होती है, lot of conflicts take place because you see the entire Ethiopia, okay, it has lot of undulations, means ऊपर नीचे hilly region है. So whenever you have a hilly region, the people's contact will be less. When you have a plain region, for example India है, India में क्या है, पूरा plain है. That's why the religion has spread to vast region. And the culture is also intermingling. ऐसा नहीं कि strict divide है. Whereas in Ethiopia, the people won't be able to meet each other. They won't be able to exchange the cultures because of the undulating topography, because of the hilly region. So you have various ethnic groups over here. So because of the difference in ethnicity, and you have been ruled under one banner. Ethiopia kingdom form हुआ, okay, it is ruled under one banner. Obviously the differences will be there. If any political party wants to, okay, exploit these differences, they can easily do that. They can, okay, create this difference, us versus them, others versus we. Differences create कर सकता है, and a war can be created. That's why you have the regions called as Amara region है, okay. Amara region is here, okay. Lot of conflicts have taken place. So these things we'll be discussing in map pointing, not now. So when I will examples also we have discussed. Examples, the Great African Rifting. So this Great African Rifting, note down all these locations. All these locations are important. Later in the mapping we'll do this in detail. So this Great African Rifting through this Afar junction is entering into the Red Sea. From Red Sea, it is entering into Aqaba, Gulf of Aqaba. So you see a port called as Aqaba. This question has been already previously asked. Aqaba is the only port of Jordan. यहाँ पे country है Jordan. See, once upon a time, all these lands, including Sinai Peninsula, used to belong to Jordan. सबको Jordan को belong करते थे. लेकिन बाकी सब लोग आके ऑक्युपाई कर लिया आज जॉर्डन को बस एक छोटी सी जगह मिला, okay, near Aqaba, and from here only Jordan is okay doing trade, and Jordan is very important for phosphate deposits. So India को supply करता है Jordan, and it is very important for India's agriculture because India we use NPK fertilizers, right? Very important, and this is further okay. And in the last year pre they have rifting part है, see आपको rift दिख रहा है यहाँ पे, ये पूरा rift है. River Jordan is important, Dead Sea is important. Dead Sea, okay, the world's lowest point on the land. At the same time, this lake has a salinity of around 380, means 1 लीटर के पानी में 380 ग्राम नमक होता है इसमें. Then again River Jordan, you have Sea of Galilee here. Sea of Galilee is very auspicious and very important, and it is the source of River Jordan. And थोड़ा ऊपर जाओगे यहाँ पे Golan Heights है. So Golan Heights, it belongs to Syria but has been occupied by Israel. So all these are very important. So this is an example of divergent plate boundary. So Great African Rifting, Red Sea and Dead Sea Rifting. You can also call it as Jordan Rifting. Now next example is the Atlantic rifting or mid-Atlantic ridge. So in between the Atlantic Ocean, you have a very big ridge. You see this ridge over here? So this is also an example of divergent plate boundary, whose divergence has started around 150 million years ago and ये अभी तक चल रहा है. Now wherever you have a divergent plate boundary, along the divergent plate boundary, you see the cuts over here? Cuts like a spinal cord, right? This is also called a spine because it looks like a spinal cord. Now can anyone tell me what are these cuts? A cuts क्या है? Along the divergent plate boundary. Because they can ask a question. For example, a underground tunnel is being built from London to New York, right? The technological feasibility is possible, commercial feasibility is also possible, but the only problem is with earthquakes. And the earthquakes in the MOAR region, means mid-oceanic Atlantic ridge, is because of which of the following plate boundaries? Divergent plate boundary, conservative plate boundary, convergent plate boundary, none of the above. Answer क्या है? So these are the conservative plate boundaries, because this ridge, okay, starting from Arctic to Antarctic, this is around 16,000 kilometers in length. Do you think the entire North American plate and the entire Eurasian plate or the African plate, do you think they'll be having single movement? No. We will not be having one plate, one movement. So here part of the plate will be splitting. Means कभी कभी ना ये वाला part slide करेगा, कभी ये वाला part slide करेगा, कभी ये वाला part slide करेगा. So the differential movement between the plates gives rise to transform plate boundaries along the divergent plate boundaries. See, the divergent plate boundaries per se are not that dangerous. So as far as the earthquakes is concerned, okay, not much along the divergent plate boundary. क्यों? Because in a divergent plate boundary, the magma is highly fluidic. It is sourced from around 2,900 kilometers, almost from near core mantle boundary. So since it is highly fluidic and it is basaltic, it is not acidic, so it won't cause much disturbances. So अंदर से आएगा, आराम से बाहर निकल के फैल जाएगा. And along the divergent plate boundary, you will be having numerous hotspots. In fact, the series of the hotspots will be giving rise to a divergent plate boundary. So hotspots से जो magma निकलती है highly fluidic है, वो कोई disturbance cause नहीं करता है. So since it is highly fluidic, आराम से बाहर निकलेगा. जब वो बाहर निकलेगा, वो crust को कुछ हिलाएगा ही नहीं. So that's why the earthquakes along the divergent plate boundaries are not that dangerous. They are generally silent. But the conservative boundaries, okay, conservative means neither they are creating any oceanic floor, nor they are destroying any oceanic floor. So this conservative, okay, plate boundaries or the slip faults along the MOAR. So they will be causing the earthquakes here. Okay. And what about volcanism? So that's why I have laid the foundation in the first class itself regarding this. So volcanism will be highly silent, it will be highly basaltic. So sometimes if the volcanism comes more from this divergent plate boundary or a hotspot, it can also create large basaltic provinces. So यहाँ पे क्रैक है, अभी भी आइसलैंड में ना आपको क्रैक दिखेगा. सो क्रैक के दोनों तरफ बसाल्ट फैल गया. बसाल्ट फैल के ये पूरा ओके आइलैंड फॉर्म हुआ यहाँ पे. सो दिस इज ऑल्सो एग्जाम्पल ऑफ basaltic province. Okay, this is all about the divergent plate boundary. So next let's talk about the transform plate boundary also, because convergent is bigger, we'll deal it at once. So next is transform plate boundary. So transform plate boundary is nothing but a slip fault. Here the plates are sliding past each other. Okay, so they are avolcanic, means no volcanism, but in terms of earthquakes they are highly destructive. So one of the famous examples is the San Andreas fault. So where is this located? So you have this North America. So आप diagram draw करना भी सीख लेना यहाँ पे. Okay, very simple to draw diagrams. So this is the North American plate, and in California, just beside this North American plate, you have this plate called as John D. Fuca plate. Okay, and these plates are sliding past each other, rub कर रहे हैं. And दोनों के बीच में San Andreas fault हो गया, and this fault is in California, and this is very infamous for causing earthquakes in California. And California में wildfires भी होती है, California में, okay, you'll be having this earthquakes also. So this is one example. Second example, of course, you have numerous faults along MOAR. So this is the MOAR in the S shape. Along the MOAR, you have numerous slip faults. Can anyone tell me what is the commercial importance of the slip faults? If you're talking about, I'll give you a hint also. What is the commercial significance of these slip faults? For example, if you're talking here in the central Indian Ocean basin, or if you're talking about this fault, which is running between Hawaii, below Hawaii, and entering into Mexico here, this fault. This is also slip fault. What is the commercial importance of this? So this we'll be discussing in oceanography, but I'm telling you now, along this, okay, slip faults, you'll be finding a lot of not oil, not minerals. आपने सुना है, okay, this polymetallic nodules मिलेगा. This we'll discuss in oceanography. Remember this. So this is the importance. And the third example here is Anatolian fault. Anatolia means Turkey. So here I don't have a picture of Anatolia. I'll show you. I forgot to include the picture. So why this is important? Because so recently there has been an earthquake in Turkey and Syria. There was an earthquake.
You have this North Anatolian fault, East Anatolian fault, Dead Sea fault, Dead Sea transform. See, this East Anatolian fault, North Anatolian fault, they are compressional plus slip. This is divergence plus slip. Means the faults will not be purely convergent, purely divergent, or purely slip. The slip will be combined with either divergence or convergence. Now, East Anatolian fault is compression plus slip. So, the recent earthquake, which has destroyed a lot of buildings across the border of this Turkey and Syria, has happened along East Anatolian fault. Okay, so such kind of faults are also called as transpressional faults. Means transverse plus compression. Transpressional. Okay, note down this word. Transpressional, you note down. So this is all about the slip faults. So next is convergent plate boundary. So convergent plate boundary, the interaction can be of three types. One is the interaction between the OC and OC. One is the interaction between the OC and CC. Third one is the interaction between the CC and CC. CC means continental crust. OC means oceanic crust. Okay. I will show you where they exist. Now take this. See, you have this strip. This strip is what? OC, and this is CC, continental crust. On this side, again you have OC, and this is CC. So here the interaction is taking place between OC and OC. Oceanic crust and oceanic crust are undergoing, they are interacting with each other. Okay, understood? Now I will draw this. What all will be created, I will be drawing. Pay attention here, very important. So this is the most important thing. If you follow this, your doubts regarding the earthquakes, volcanism, mountain building, all will be cleared. I'll give you numerous examples here. First, let's see the process. See, I'm drawing it very carefully. On this side, you have CC. So this is the OC, oceanic crust, and this is the older and heavier oceanic crust. This is the CC. Now they are moving towards each other. They are interacting towards each other. Now, when you will be having ocean floor, you will be having sediments. The sediments I'll be representing by green color. So these are the sediments. Now, one of the plates will be moving forward. So this is moving forward. So this has come here. CC has moved here. And this OC. Now among these two OCs, oceanic crust, one will be older and heavier. So in this case, the Pacific Ocean is older. Okay, so it has been compressed because of the sedimentation. It has been compressed. It has become denser. So it has become heavier. So the one which is denser and heavier will undergo subduction. It will undergo subduction like this. And this will be staying as it is, wherever it is. Right? So this is one more OC. Now, whatever sediments were there here, sediments, when it will be bruising, okay, when it will undergo abrasion and going inside, don't you think part of the sediments will be plastered here? So these are the marine sediments which are plastered, and this is called as the accretionary wedge or accretionary prism. Okay, so accretionary wedge or accretionary prism. Now when this will be undergoing subduction,
when it will be going into deep mantle, it will undergo melting. After it undergoes melting, it will give rise to volcanic eruption. So here it will be forming volcanic island arcs, also called as volcanic archipelagos. It will be forming. Now when it will be forming volcanic island arcs, so see earlier this was a single ocean, ये पूरा एक ही ओशन था पहले, लेकिन अभी बीच में क्या आ गया, बीच में एक आइलैंड आ गया. सो आइलैंड के पीछे वाला जो सी है, दिस सी विल बी कॉल्ड एज बैक आर्क. बैक आर्क मीन्स बैक साइड ऑफ दिस आर्किपेलाजियो. समटाइम्स इट इज ऑल्सो कॉल्ड एज marginal sea. Marginal sea because it is in the margins of the continents, right? And the place where this subduction is taking place, the zone of subduction, this is called as the trench, and this is called as accretionary wedge or accretionary prism. Sometimes these accretionary prisms can also come out of the surface of the water and they can become islands. I'll give you an example of that. So here if you see, so this is the Indian plate. I'll show you once again. Indian plate, and this entire thing is the Eurasian plate. When the Indian plate is undergoing subduction, you see numerous islands formed over here off the coast of Indonesia. So recently the Sumatran island also had numerous floods, severe floods. You see numerous islands over here. So this is nothing but the accretionary wedge. Okay, so वहाँ पे इतना deposit हो जाएगा कि पानी के ऊपर आ जाएगा. Whereas actual volcanoes are formed in this. So that also I'll show you. If you look at the terrain map, you'll see ये पूरा volcanic mountains है, ये पूरा volcanoes है. So volcanoes यहाँ पे form हुआ. This is the accretionary wedge. The similar one we'll also see in the Pacific Ocean. So in the Pacific, you see here, see, so this is the volcanic island arc which has been formed. Arc जैसे form हुआ है. These are all volcanic in nature. Now see here, this is also volcanic island arc. इसके सामने जो है ना, this portion, so this is that accretionary wedge. So Japan also has been formed like that, right? So the example of this, I will draw it here. So this is called as the Aleutian Trench. And Aleutian Trench के पीछे Aleutian Islands है. And behind this you have a marginal sea. This sea is called as the Bering Sea. And this peninsula which you see, this is called as Kamchatka Peninsula. So recently the Kamchatka Peninsula also has been in the news because of volcanic eruptions. Numerous volcanic eruptions are happening here. And this is called as the Kuril Trench. Kuril के पीछे Kuril Islands है. Okay. And these Kuril Islands, okay, these are disputed also. Disputed between the Japan and Russia. क्यों? Because these volcanic islands formed very recently. So they won't be having a very long history of occupation. So बहुत सारे, from a very long time, the people will not be settled here. So as in when a country becomes powerful, it will start asserting its power. तो कंट्री आके बोलेगा कहीं पुराने ज़माने में जब हमारे पूर्वज बहुत शक्तिशाली हुआ करते थे, वो वहाँ तक राज करते थे, हमारा राजा तो वहाँ तक जाके पूरा ओके वो सब करके आया था, ओके बोल के. सो ये प्रूफ कहाँ है? राजा का पर्सनल डायरी में लिखा था. सो ऐसा कुछ कहानी बता के दे विल कीप ऑन फाइटिंग विथ ईच अदर. नाउ अलोंग द जापान यू हैव दिस जापानीज ट्रेंच. You have Izu Bonin Trench. Izu Bonin. This is the Mariana Trench, Mariana, the deepest one. So these are the various trenches. And on this side, you have the California Trench. California side. So this is the Middle American Trench. Middle American. And you have the marginal seas here. See this sea you see here, this is called as Sea of Okhotsk. जापान के पीछे Sea of Japan. And here you have East China Sea. China Sea. And here you have South China Sea. Sometimes they can ask you the order also. They will be giving you these seas names and they will be asking you to arrange from north to south. Okay? And remember, okay, these trenches also. But one trench which is very important, which has been in the news very recently, is little bit south. So off the coast of Australia, you see here a place called as Tonga along the New Zealand. So this is called as the Tonga Kermadec Trench. So in the year 2022, the explosion was so huge that the explosion has caused a separate island. First point. Secondly, the explosion was so huge that from this space you are able to see this plume. में जब volcano explode हुआ, तो यहाँ पे जो plume निकलता है, is mushroom type thing which is okay जो निकलता है, वो stratosphere तक चला गया था. And it will be having a lot of particles, lot of dust particles will be there, lot of SOx will be there, SO2 will be there, and they have also caused ozone depletion. Okay, that's why it is very important. So for three reasons it is important. First reason, it has formed a separate island. Second reason, the plume has reached the stratosphere. Third reason, it also caused a numerous tsunami, and you have an island called as Fiji here. In Fiji, it has caused numerous tsunamis, and Fiji has a lot of Indian population. So पहले बिहारी यहाँ पे गन्ना काटने गए थे, अभी यहीं पे settle हो गए हैं. So that's why, okay, for Indian diaspora, it is important. So Adhiraj is asking a question: convergence between ocean and continent led to trenches. Why it is mainly on the Pacific arc and less on the other parts leading to the accretionary wedge? No, it's not like that. Trenches are there everywhere, but most of the trenches you'll be finding in the Pacific, because Pacific Ocean is a remnant of Panthalassa. सबसे पहले जो पुराना ओशन था ना, Pangaea, Panthalassa. So Pacific is like 200-250 million years old. सबसे पुराना है. अब पुराना है तो इसका टाइम खत्म हो गया, तो सबडक्शन होना चाहिए, खत्म होना चाहिए. सो हर तरफ से खत्म हो रहा है. सो यहाँ पे देखो चिली ट्रेंच है, यहाँ से खत्म हो रहा है. टोंगा कर्माडैक ट्रेंच है, यहाँ पे न्यू हेब्रिडिस ट्रेंच है, न्यू ब्रिटेन ट्रेंच है, मरियाना ट्रेंच है, इजुबोनिन, ओकिनावा ट्रेंच है, फिलीपींस ट्रेंच है, बहुत सारे ट्रेंचेस है. So along every trench it is undergoing subduction. As compared to Pacific, the Atlantic Ocean is new ocean, nascent ocean. So new ocean में आपको ज़्यादा trenches नहीं दिखेंगे, because नया नया फॉर्म हुआ है. अभी नया फॉर्म होके ये बड़ा होके उसके बाद बूढ़ा होगा, तब जाके मरेगा. It's like a life cycle. Okay, जन्म होता है, मरता है. It's like that. That's why, okay, in Atlantic you have only 3 trenches over here. Okay. So you have this Cuba over here, Cayman Island, okay, Cayman Trench है. You see a country called as Puerto Rico, Despacito, कहाँ पे है? Puerto Rico, या Puerto Rico Trench here. 2 trenches here in Caribbean, and you have one more trench. Okay, in the evidences of the Earth interiors, we are talking about South Sandwich Trench. देखो यहाँ पे देखो, कितना खुल गया यहाँ पे. So this is where you have this fallen mantle. Mantle swell होके बाहर आया. So this is called as Scotia Plate. ये पूरा Scotia Plate है, and this is a South Sandwich Trench. Okay, and this entire region is called as the Pacific Ring of Fire. So this is This is all the ring of fire. Some people extend this till here also, ring of fire. And the ring of fire has 70% of earthquakes and more than 80% of volcanoes. Since it looks like a ring, it is called as ring of fire. So Adiraj is asking how the oceans are newly formed when it's just breakdown of lands while Panthalassa remain the same all over the world. I didn't quite get your question. How the oceans are newly formed when it's just breakdown of the lands while Panthalassa remain the same. See, जब Pangea break हो रहा था, I will show you. I don't know whether I got your question correctly, but I will try to explain. See, according to Wegener, I am telling you according to Wegener. See, according to Wegener, so this is Pangea, and this is Panthalassa. Now, say Pangea is broken. It is broken from here, say, broken to two parts. Now, what will happen? ये वाला part जो है, ये वाला थोड़ा ऊपर खिसकेगा. Okay. Now part of the Panthalassa, ये तो खत्म हो गया ना. अब ये इधर खिसक रहा है. Part of Panthalassa will undergo subduction, and यहाँ पे you will be having some kind of mountain formation, and this is a new ocean which is formed. Ocean, and gradually either it will keep on going here, and gradually new ocean will be formed here. That is how gradually the Panthalassa will be finished. Say this is Pacific Ocean. And this is Atlantic. Understood? Okay. Okay. Understood? So Ayush is asking, इनके नाम याद रखना है क्या? See, नाम आप allusion का याद रखो, because बाद में भी काम आएगा. जापान तो आपको याद रहेगा. कुरिल आपको याद रखना है, because कुरिल आइलैंड से under dispute. Okay, मरियाना तो आपको याद रखना पड़ेगा, because Mariana में Challenges Deep है, which is the lowest point on the surface of the earth. Okay, next Tonga Kermadec is in the news because इतना बड़ा धमाका हुआ वहाँ पे, वो तो याद करना पड़ेगा. These things you have to remember, and remember names of the marginal seas which are frequently asked. They will ask you to arrange, and the islands which are in conflict. Okay, so one more island which is in conflict, is here, somewhere here. So यहाँ पे Taiwan है, Taiwan के ऊपर है. You have an island called as Senakaku or Diagu Island, and which has been already asked in the examination. So they will not be asking this. So South China Sea mein again you have islands. You see a group of islands called as Paracel Islands here, Spratly Islands. So Paracel, Spratly. Now China wants this entire South China Sea. 1, 2, 3, 4, 5, 6, 7, 8, 9. So earlier China has drawn a 9 dash line. जैसे लक्ष्मण रेखा ड्रॉ करते हैं ना, तो चाइना ने यहाँ पे 9 डैश ड्रॉ किया, बोला कि ये पूरा मेरा इलाका है. कैसे तुम्हारा इलाका होगा? बिकॉज चाइना ने बोला पैरासेल आइलैंड्स मेरा है, स्पार्टली आइलैंड्स मेरा है, राइट. सो 9 डैश लाइन ड्रॉ किया. देन when the Russia has attacked Ukraine, so there was a speculation that the China will also attack Taiwan. Then China ने attack नहीं किया, but after this 9th dash, the China has drawn 10th dash. This is the 10th dash. So the Taiwan also has come under the ambit of China now. अभी 10 dash line draw किया, and according to China, entire South China Sea belongs to China. Why South China Sea is important? Because US का 2 air bases है यहाँ पे इस region में. Philippines is a very good friend of USA, and most of the countries over here are good friends of USA. So USA has air bases here, and here South China Sea is also famous for oil. In fact, India is mining a lot of oil and gas here. India का जो ONGC Videsh Limited है ना, it is mining over here.
So it is important for that, and this is also important sea lanes of communication, because earlier the power was in Atlantic Ocean. So all the trade used to happen between the Europe and USA. So the power was centered here. अभी यूरोप का dominance कम हो गया and the China has risen to power. So power has shifted from the Atlantic to the Pacific Ocean. So most of the trade is happening here in between these two. That's why if you are having the monopoly over the seas, if you control the trade routes, you will be able to have hegemony. आपका power रहेगा, दबदबा रहेगा. So that's why it has occupied this. Okay. So this is about the OCOC. So one more example of OCOC is, see, this is all Indian plate. जहाँ पे भी हिमालयस है, ये पूरा Indian plate है, और we can call it as Indo-Austral plate. तो यहाँ से आपको बाउंड्री दिख रहा है, ये बाउंड्री, यहाँ से बाउंड्री दिख रहा है. So कितने अच्छी तरह मार्क किया हुआ है बाउंड्रीज. The beauty of geography is whatever you say, you can see it here actually. The polity में जितने भी चीज़ें पढ़ते हो, और कॉन्स्टिट्यूशन, ओके, सेक्युलरिज्म, फेडरलिज्म पढ़ते हो, कैन रियल लाइफ में दिखता है क्या? नो, राइट. लेकिन ज्योग्राफी में सब कुछ दिखता है. Whatever you see, okay, whatever you read, you can see that. I'll take up the question. So can they also ask which pair correct? Yeah, they can also ask which pair is correct. So Lenovo is asking which plate will undergo subduction. Old one, yes, old one will be undergoing subduction. So one more example here is, so this is the Indian plate, and on this side you have the Burmese plate. This is the Burmese plate. The Burmese is a microplate. So both are undergoing subduction. So because of this subduction, you have this Andaman and Nicobar group of islands. So when you have this Andaman and Nicobar, when you have this subduction, you'll also have volcano, right? You have this OC on this side, OC on this side. You have this volcano also. So in Andaman and Nicobar, you have an active volcano called as Barren Island here. So Barren Island is the active volcano, only active volcano of India. So this is Narcondam. So this must be Barren. You can see the recent volcanic eruption. हरियाली नहीं है, बहुत सारा ऐश है, बहुत सारा मिट्टी है. तो रिसेंट वोल्केनिक eruption हुआ. एंड वन मोर थिंग, अगर आप पुराने एटलस में देखोगे ना, द बैरन आइलैंड ओके विल बी गिवन एज एक्सटिंक्ट वोल्केनो और डॉर्मेंट वोल्केनो. मीन्स लोगों ने सोचा कि फटेगा नहीं. मीन्स 2017 में आप गूगल मैप्स का पिक्चर देखोगे तो पूरा ग्रीन रहेगा. लेकिन इन 2017 सडनली इट हैज erupted एंड पीपल वर सरप्राइज्ड. Then they have declared it as active volcano. Okay. So one such example. Okay. Will you move to next? So any doubts in OC and OC? OC convergence? No, right? Which plate example you mentioned? Where? Indian plate and Burmese plate. Next, I will continue from the same here. So this is the OC, and on this side you have CC, and this is the older oceanic plate, which is undergoing subduction. On this side you have this CC. So you have this volcanic island arc. Now over a period of time, what will happen? The CC will finally come here. The CC will come here. And finally what you have? Finally you'll be having this OC. On this side you have CC. And you'll be having this volcanic island arc. This volcanic island will be there. And you'll be having accretionary prism. ये जो यहाँ पे चिपक के था ना, वो यहाँ पे आ जाएगा, थोड़ा लार्ज हो जाएगा. This will be happening.
So the OC will finally become OCCC. Now the oceanic crust will be interacting with the continental crust. Okay. अब जब भी क्वेश्चन पूछते हो थोड़ा डिटेलली पूछो, because I want to understand the context. Now when they will be interacting with each other, now this CC will move forward. ये CC आगे जाएगा and this OC will start undergoing subduction, because among these two the OC is heavier. That's why the oceanic crust will be undergoing subduction. Now what will happen? This accretionary prism which will be there, it will be plastered here, and these islands, the volcanic island arcs which have been formed, they will also be plastered here. Which color use kiya maine? Okay, so they will be plastered here. Okay. Now this will undergo subduction, and here one more volcano will be formed. Volcano will be formed. So basically usually you'll be having three islands, three mountain chains over here. So one chain is formed by the ocean sediments, accretionary prism. One will be formed by the island arcs, which is now plastered here, and one is the volcano because of the oceanic plate subduction. Okay, so now it becomes OCCC subduction. Now the example of this is here. Now you have a Nazca plate here. The Nazca plate is undergoing subduction along the Peru-Chile trench, and on the margins of the continents you have these mountains formed. Okay. So this is nothing but the uplifted old volcanic island arcs plus the accretionary prism. So that is how the mountains like the Andes and the mountains like the Rockies are formed. Right. Now here the volcanism will be highly explosive in nature. Why it will be explosive? Because see, along the trench a lot of water is also going inside. The water goes inside and the water boils a lot. When the water boils, along these vents, along these volcanoes, a lot of water vapor will also come. Okay, a hot steam niklega, a high pressure steam niklega, and that's why it will be making this volcanic eruptions highly explosive in nature. So यहाँ से जो पानी है, ये पानी ऐसा समंदर है पूरा, ये पानी अंदर जाएगा, it will boil, and from here a lot of vapor will come. And one more thing I am telling you, okay, which you can absorb, matlab, if you're understanding it's okay, if you're not understanding then also fine. See, earlier I talked about the table, right? You remember? Basalt, andesite, granite, peridotite. Now this is also called as Bowen series of partial melting. Bowen series of partial melting. See, on this side you will be having highly fluidic magma. On this side you will be having viscous magma. और magma fluidic है, पानी जैसा है, वो आराम से बाहर निकलेगा, कोई explosion cause नहीं करेगा, जैसे I told you first day. And magma जब viscous होगा, गाढ़ा होगा, वो अंदर से आराम से नहीं निकलेगा, and जब भी वो बाहर आएगा, वो explode करके बाहर आएगा. Okay? अधिराज बताऊंगा, delaminestion आएगा. Okay? Don't worry. The purple ये वाला है ना, I see I'm very bad at the colors. Purple है क्या ये वाला? Purple है तो ये है. Same color I'm using, huh? Okay, I will do that, Noorpreet. So remember this. This is a very big concept, but it will be helpful to you. See, deep inside the earth, which rock you have? You have peridotite. And जब ये peridotite बाहर निकलेगा, the peridotite will undergo partial melting and peridotite will give rise to basalt. This is basalt. Now this ocean floor is made up of basalt. Ocean floor is made up of basalt. When basalt will be undergoing subduction, you will be getting andesite. This is called as Bowen series of partial melting. So GS के हिसाब से उतना ज़रूरत नहीं है. But if you want to understand why these volcanoes are highly explosive, if you want to understand when something is coming from deep interiors of the earth, why we don't exactly get peridotite, while we will be getting basalt. When the basalt is going inside, why we will be getting andesite. Okay, so this is explained by something called as Bowen series of partial melting. So basalt अंदर जाता है, andesite बाहर आता है. Okay, and andesite is viscous rock, acidic rock. Therefore, it is associated with highly explosive volcanoes. Therefore, in North America in Rockies, in South America in Andes, you have a lot of explosive volcanoes. कहीं पे भी समंदर है, okay, समंदर के पास कहीं volcano है, along the coast, they will be explosive in nature. आपको ये याद नहीं रहता है ना, andesite वगैरह याद नहीं रहता है. ये बस याद रखना, समंदर के पास में अगर कोई सबडक्शन हो रहा है, वहाँ पे कोई अगर वॉल्केनो है, अंदर पानी जाएगा, अंदर पानी जाके वो विस्फोट होके बाहर आएगा. So recently in Indonesia, you have a volcanic mountain called as Mount Sumeru. So Mount Sumeru also underwent very high explosion. Okay, remember this, Mount Sumeru, Indonesia. Ask me anything, okay, you can WhatsApp me, okay, on this number, I'll reply. See, now let's get back here again. Now let's get into Indian geography little bit. See, earlier you had this Eurasia. This was Eurasia. And this is the Indian Peninsular Plateau. Indian Peninsular Plateau. And between these two there existed a sea called as Tethys Sea. I'll show in the map also here. So India was not here. Please ध्यान रखना, the journey of India. So its journey has started somewhere from here. So India and Madagascar were together. So India has come near Kerguelen hotspot, I told you earlier. Then India went near Reunion hotspot. So India and Madagascar were together. So India wanted to move forward. And यहाँ पे क्या था? So here you have Reunion hotspot. So Reunion hotspot has punctured. It has created a crack. Okay. So that is how India got separated from Madagascar. Then India started moving in this direction. Somewhat like this. Okay. So this is how India has traveled. This map, okay, this is there in your NCERT also. Now between these two, there existed a sea called as Tethys Sea. Now how does it look like? So does it not look like the above diagram here? So this is CC, India. So this is the Indian plate. This is the Eurasian plate. And this is the Tethys Sea. Tethys Sea. So even before the formation of the Himalayas, so this is the Indian plate. This is the Tethys Sea, which was undergoing subduction. Tethys. And this is the Eurasian plate. So, because of the Tethys plate subduction, we will have volcanoes. Volcanoes. And because of the accretionary prism, you will be having a chain of islands formed. And because of Japan kind of islands, because of volcanic archipelagios, you will have one group of chain of islands. Now, again this ocean will be associated with the sediments. So, this will have again the sediments. Say this was around, say 100 million years ago. 100 million years ago. So, even before the formation of the Himalayas, the Eurasian plate is associated with mountains or fold mountains. And today, these mountains have been highly denuded. And today we call them as, so इसको बोलते हैं Karakoram today. Karakoram. This is called as the Ladakh range, and this is called as the Janskar range. So since they are beyond Himalayas, since they are older than Himalayas, since they have formed before the Himalayas, these three combined are also called as the Trans-Himalayas. Okay? So the Trans-Himalayas are a byproduct of OC-CC interaction, where the oceanic crust is a Tethys oceanic crust and the continental crust is the Eurasian. Okay? Okay, next. Abhi Adhiraj, okay, you will get satisfaction now, wait for some time. यहाँ तक सबको समझ में आ रहा है? Very important. Okay. Now, earlier, the Karakoram used to have volcanoes, active volcanism. But today we don't have active volcanism. Why? Because the oceanic plate subduction has been finished. So gradually what happened? So gradually this Indian plate will move forward. This Indian plate, it will be moving forward. It has come here finally. And this is where you have the Eurasian plate. And as it is, you will be having these three mountain ranges. I have to use a specific colors over here. Three mountain ranges. So this is Karakoram, this is Ladakh, sorry. This is Karakoram, this is Ladakh, and this is Janskar. And the Tethesian sediments, these are all Tethesian sediments. And these Tethesian sediments will become Himalayas. So this becomes the Great Himalayas and this becomes the Middle Himalayas. Middle Himalayas. The Shivaliks are not true fold mountains. The Great and Middle are true fold mountains. So this is how the OC-OC interaction, sorry, OC-CC interaction gets converted to CC-CC interaction. Now this is today you have Karakoram. Now why the Karakoram does not have any active volcanism? Because there is no oceanic plate subduction. But 100 million years ago, 70 million years ago, the Tethesian oceanic plate subduction was taking place. That's why the Karakoram had active volcanism. But today, still in Karakoram, you will find volcanic rocks. In Karakoram, you will find a lot of volcanic rocks. Where? In a range called as Rakaposhi range. Rakaposhi in Karakoram. So Ekagra is asking, can you repeat how Ladakh range is formed by the sediments? See, again I will go back here. Ladakh पूछ रहे हो ना? See, ऊपर जाओ. ये green क्या है? When this ocean plate is undergoing subduction, for example, आपने लगाया मुल्तानी मिट्टी यहाँ पे हाथ पे, and इस हाथ को ऐसा रगड़ रहे हो, तो क्या होगा? इस हाथ के ऊपर मिट्टी जमेगा ना? वो मिट्टी जमा है. Ocean sediments have been plastered here. Okay. Now this oceanic crust is finished. Now this oceanic sediments will be plastered against CC.
right? Now this is moving forward, this CC is moving forward. क्या होगा? These ocean sediments will be going here, and this volcanic island arcs, this andesitic rocks, they'll be plastered here. Okay, you have these three ranges. So Ladakh range will be having andesitic rocks plus ocean sediments. दोनों ही रहेगा उसमें. And one more point which I forgot here, यहाँ पे.
See, now the mountains have been formed. Don't you think these mountains have to be stabilized? So this, to stabilize these mountains, underneath the mountains, you will have big rocks which will be formed, and these rocks are called as batholiths. And how the batholiths will be formed? Because see, this pink one is andesite. Don't get confused here. आपको समझ में नहीं आ रहा तो ठीक है, no problem. So this is andesite. Don't you think this andesite will also go inside?
Because this will be eroded and the andesitic rock will be going inside. And according to the Bowen's series of partial melting, where is this? Here.
When the andesite undergoes subduction, you will be getting granite. Granite.
And granite is highly viscous. बहुत गाढ़ा है. And granite इतने आराम से बाहर नहीं निकलेगा. That's why the granite यहीं पे जम जाएगा. Actually, I told you in a very simplistic way. There is more scientific reason for this, but as far as GS is concerned, this much is sufficient.
So the batholith is made up of granite.
आपको अगर बोवेन सीरीज ऑफ पार्शियल मेल्टिंग समझ में आया, नो नहीं आया, नो प्रॉब्लम. सी इसमें से जब ये सारे रॉक्स अंडरगोइंग सबडक्शन मेल्टिंग, दे हैव टू कम आउट. थोड़ा बहुत ग्रेनाइट भी निकलेगा, एंड ग्रेनाइट ऊपर तक नहीं आ पाएगा क्योंकि वो बहुत गाढ़ा है. इसलिए ग्रेनाइट यहीं पे जम जाएगा, गिविंग राइज टू बैथोलिथ और बेसमेंट रॉक्स. अगर ये भी समझ में नहीं आ रहा है, भाई यहाँ पे इतना बड़ा पत्थर है, वहाँ के इतने बड़े पहाड़ है, वो पहाड़ के नीचे अगर कोई स्ट्रॉन्ग फाउंडेशन नहीं होगा, कोई स्ट्रॉन्ग रॉक नहीं होगा, don't you think these mountains will collapse? Okay, so that's why the batholiths will be created, and these batholiths not only provide stability to these mountains, but also they provide stability to the continents. That's why they are called as basement rocks. Understood? So Ayush is asking which plate is with respect to. भैया आप ना प्लीज मुझे स्पेलिंग मिस्टेक्स है, मैं कैसा समझूँ विथ रिस्पेक्ट टू इंडियन एंड इंग्लिश, समझ में नहीं आ रहा है, फिर से टाइप करो. नूरप्रीत इज आस्किंग आफ्टर नेपाल earthquake माउंट एवरेस्ट हाइट डिक्रीज्ड, इज इट ड्यू टू प्लेट टेक्टोनिक्स और एनी अदर रीजंस? डिक्रीज मतलब थोड़ा बहुत डिक्रीज हुआ होगा, मिलीमीटर में या माइक्रोमीटर में, उतना फर्क नहीं पड़ेगा. ओके, यस अधिराज यू आर राइट. ओके, वी आर कमिंग टू दैट. अधिराज ना सारे क्वेश्चंस पहले ही पूछ लेता है. ओके, थोड़ा सब्र करो. ओके, आ रहा हूं, मैं वहीं पे आ रहा हूं. Now come here. So normally
ऐसे होता है, ऐसा होना चाहिए, right? So whenever two CCs, okay, are interacting with each other, and below this you have mantle. इसके नीचे क्या है? Mantle है. What is the density of mantle? More than 3. What is the density of CC? 2.2.
अब कितना भी आप इसको नीचे डुबाओ, because the mantle is heavier, ऊपर ही बॉइंट होके ऊपर आ जाएगा. लाइक दिस आर लाइक लाकड़, व्हाट यू कॉल लकड़ी, वुड. दिस इज लाइक वाटर. कितना भी वुड को पानी के अंदर डुबाओ, बिकॉज इट इज लाइटर, बिकॉज इट इज बॉइंट, इट विल कम अप अगेन, राइट? लेकिन आपने सुना है इट हैपेंस ओनली इन इंडिया. वर्ल्ड में कहीं पे भी चीजें नहीं होती है, इंडिया में होती है. सेम केस, समथिंग डिफरेंट हैज हैपेंड हियर. ओके, I will tell you what the earlier understanding was. I will tell you what is the new understanding. So Nurpreet is asking, in Uttarakhand also Indian plate is subducting occurring to Tibet plate. Okay, we'll come to that. भाई, okay, एक मिनट रुको, मैं आ रहा हूँ.
Now what happened is that we'll not be calling it as subduction now. But what happened? So this was the earlier understanding. So earlier understanding was, so इंडिया का प्लेट ना थोड़ा इसके नीचे दब गया, यूरेशियन प्लेट के नीचे. Say this is Tibet and this is North Indian plains. North Indian plains. So Indian plate is acting as a lever. Indian plate went underneath the European plate, Eurasian plate, and then it is lifting at ऊपर like a lever. नीचे जाके उसको ऊपर उठा रहा है. Now why this is happening, nobody knows. Okay, because we haven't studied the interiors of the earth that objectively and that properly, and this has been happening. And because of this, the Eurasian plateau, okay, gets a lot of height, especially Tibet. Now, according to this scheme of things, the Tibet and the North Indian plains should be having same height, but Tibet has a height of around 4,000 meters, right? So 4 किलोमीटर ऊपर है, टेबल लैंड है. ऐसा टेबल लैंड कहीं पे भी नहीं है. Why? And this phenomena is called as double crusting. Double crusting. So because of this double crusting, the Tibet has got a good height, the Karakoram has got a good height, the Ladakh has got a good height, the Janskar has good height, and also the Himalayas have got this orthoclinal fold like this. And this is where the middle Himalayas is. This is middle and this is the great Himalayas. So nowhere in the world, see, the Rockies, Andes, Alps, Himalayas, all belong to same age. All are tertiary mountains. सबका age लगभग same है, around 60-65 million years. But of all, if you take Rockies, कितना है वहाँ पे height, average height, 4,000, 3,000, Andes, 5,000, 6,000, Alps, again 3,000, 4,000. But you take Great Himalayas, around 6,000 है, average height. So why the Great Himalayas are such lofty? Why? Because of the phenomena called as double crusting. So this hasn't happened anywhere, it happened only in India. So this was the earlier understanding. Now let's see what is the new understanding. Abhi recently scientific studies, see this is the Indian plate, again this is the Indian plate. बीच में क्या आ गया? Asthenosphere आ गया. So normally how it was, so Indian plate was beneath and this was Eurasian plate. Eurasian and Indian. Right? This is called as double crusting. लेकिन क्या हुआ? This Indian plate छिल गया बीच में से. Means Indian plate, okay, something of this sort. And बीच में ना asthenosphere घुस गया. Asthenosphere. जैसे आप पन्नी निकालते हैं ना, लैमिनेशन, डीलैमिनेशन. लैमिनेशन मतलब क्या? आपका फोन है, लैपटॉप है, उसके ऊपर लैमिनेट करते हो ना, गाड़ी है, गाड़ी के ऊपर लैमिनेट करते हो ना, वैसे डीलैमिनेशन हो गया. नाउ दिस इज द यूरेशियन प्लेट. Understood this part? If it is complex from here, okay, I have explained in a very simple way. And इसके बीच में ना mantle घुस गया. I don't have other color. Okay, so this is where you have this mantle, and this mantle is melting, and it is causing lot of disturbances here. And the scientists are of the opinion that the recent earthquake in Nepal and lot of tectonic disturbances in Tibet are because of this phenomena called as delamination. Understood this part? See, okay, this phenomena will not be calling it as subduction, will be calling it as under thrusting बोलेंगे इसको. Subduction मतलब, subduction is used for the oceanic plate. The oceanic plate has to go inside the mantle, it has to undergo destruction और पूरा melt होना चाहिए. इसको बोलेंगे under thrusting. Okay. So Adiraj is again asking if Indian plate would have been subducting. Subduction word is wrong, under thrusting. The Himalayas formation would be had. I think Himalayas symmetric fold and mountains form because of collision. भैया आपका डाउट मुझे समझ में नहीं आ रहा है. Okay, whatever you say, Adiraj, I agree to it. Okay.
सही है आपका, चलो. So understood? So just now we have seen the OCCC subduction. Now you have this Cascadia subduction zone. Off the coast of North America, you have this Cascade range. So Cascade range के side में Cascadia subduction zone है. So why this is in the news? It is in the news because the 600-mile fault line running from North California to Vancouver Island. It is a convergent plate boundary where the John D. Fuca place slides beneath the North American plate and accumulates tectonic stress over centuries, and sudden release triggers giant earthquakes and tsunamis. So previously also we have drawn this diagram, North America and John D. Fuca. So North America and John D. Fuca is not just slip fault. Just now I told you, the slip fault purely slip नहीं होते, कभी slip plus compression भी होते हैं. They are called as transpressional fault. So recently it has been found that the John D. Fuca, okay, is not just sliding, but also it is undergoing subduction, and because of which you have this convergence also. Okay, so this is in the news. So this is there in a Magnum also. So this is regarding the Indian plate. Okay, this is the process of delamination. Again, you can see one more news over here. So Indian plate tearing beneath the Himalayas. Tearing मतलब वो delamination हो रहा है, छील रहा है. Okay. So this is the diagram. And one more thing is also news, Kona Sangri Rift. The Kona Sangri Rift is this one. See, when the mantle is going inside, means it is going, say this is an Indian plate है. So mantle इसके अंदर घुस गया. So mantle melt हो रहा है, melt होके बाहर निकल रहा है. So बाहर निकल के जब वो निकलेगा, here you will be having divergence. So that is nothing but Kona Sangri Rift. So the Indian plate is again tearing apart. Means earlier there was a thinking that Indian plate was moving towards Eurasia, means a convergent plate boundary. But within the Indian plate, again divergence is happening. So why the divergence is happening? Because of delamination. Okay. So you can read all this. I will be sending this document to you. So what is a link to the Himalayan tectonics? The process provides new insights into how the Himalayas evolved vertically and laterally over millions of years. It indicates that mantle flow beneath Tibet plays a bigger role in the crustal deformation than previously thought. So this redefines the understanding of the mountain building process across the entire India-Eurasia collision, etc. You can go through it. So you have one more diagram for this, how the mantle is flowing. So this is the Indian plate, this brown one, Indian plate, a Eurasian plate. Okay. So delamination is also explained here, you can go through it. Understood? Any doubts here? So Kishore is asking, the Kona Sangri Rift also has a volcano. भैया अभी तक volcano नहीं आया. यहाँ पे देखो आप, so different diagrams है. See, mantle under flow हो रहा है. अब ये बाहर निकलने के लिए millions of years लग सकता है. See, the crust is still this thick. Indian plate यहाँ पे फिर भी है. यहाँ पे Himalayas का thickness है. Means actually mantle यहाँ पे होना चाहिए. So यहाँ पे mantle नीचे होना चाहिए. यहाँ पे होना चाहिए. Indian plate के नीचे. But mantle ऊपर आ गया. तो इसको और बाहर निकलने के लिए it can take more millions of years. Right? Understood? Any doubt still here? So this is the CCCC. Now you understood why the Great Himalayas have hogback structure or orthoclinal structure. And why the Middle Himalayas, they are overturned? Because lot of stress is being generated. That's why they are overturned. Now we क्या करेंगे, थोड़ा change करेंगे इसको. This was the earlier understanding. What is the new understanding? Now इसके बीच में पूरा mantle घुस गया. This is a part of asthenosphere or mantle.
So this is the new understanding. So if I am drawing the diagram again here, it will look somewhat like this. So this is the Indian plate. So this will be the Indian plate. So over this you have this Eurasian plate. So inside the Indian plate, you have this mantle which is flushing inside. And as it is, you will be having this various mountain ranges. This is Tibet, this is this various ranges, this is Great Himalayas, and this is Middle Himalayas. Now, how the Shivaliks have been formed? The Shivaliks are not true fold mountains, but whatever debris that has fell from here. So this is the Middle Himalayas. So from the Middle Himalayas, lots of debris have fell down. And this debris has been accumulated and it has got uplifted. So नीचे जो भी कचरा है uplift होके ऊपर उठ गया, and that is how the Shivaliks is formed. Shivaliks middle. So the Great Himalayas and Middle Himalayas will be having structural folds. So इसमें structural folds रहेगा. Means folding will be till deep. So इसमें क्या है, कचरा ही है, debris है. It will not be having structural folds. That's why the Shivaliks are not true Himalayas. Not true Himalayas. And these three are, these are trans Himalayas. Trans Himalayas. Because they are formed even before the formation of the Himalayas. Understood? Any doubt here, please ask. Called as microcontinent. You have seen microplates. So this is a phenomenon called as microcontinent. So it's like, for example, आपके पास प्लास्टिक की पन्नी है, कोई खींच रहे हो, अगर बीच में से टूट गया, we'll have two continents and in between the ocean will be formed. लेकिन वो बीच में से exactly नहीं कट रहा है, पतला होते ही जा रहा है, लेकिन बीच में ना एक thick plastic will be there. Imagine that way. So that is the microcontinent or failed continent. It should have formed a new continent, but it could not form a new continent. I will draw and show. So they'll be asking this, as a part of your mapping locations. as a concept नहीं पूछेगा, because these concepts are not that much evolved. पूरी तरह इनके theories कहीं नहीं है. आज सही है, कल को गलत हो सकता है. I said, don't worry much. Say, you have this crustal block. Usually what should happen? The rifting is taking place. Rifting. Then अगर ढंग से rift हो गया, ढंग से उनका breakup हो गया. So, two continents will be formed. Continent A, continent B. Say this is A, this is B. A, B दोनों अलग हो गए. So in between you will have ocean. But sometimes what happens, rifting is taking place. So this is B and this is A. And और भी अगर खींचोगे, more compressive forces you are applying here. Say A will be coming here and this will form a very thin layer over here. And in between, a lump will be left, a content kind of a thing will be left, and this will become B. ये वाला ढंग से separate हुआ नहीं. This has not been separated. It is very small. That's why we call them as failed continents. So since they are smaller in size, we call them as failed microcontinents. Microcontinents. So we'll see such examples. Everyone understood this part? Failed microcontinents? Any doubt here? Adhiraj, पहले आपने ये पढ़ा होगा. Okay, very good. See, I am explaining you in a very simplistic way. Okay, as laymanish as possible. Now I will show you. See, one such is Davis Strait. Okay, यहाँ पे दिख रहा है लेकिन मैं reality में कैसे होता है दिखाता हूँ. And mind the locations here. You can see this. So this is Greenland. So this is Baffin Island. बीच में ये वाला part दिख रहा है. So it is part of the continent only. Light blue color means continent. Dark blue means ocean floor. So wherever we be having continents, the depth will be less. So that will be denoted in light blue color. So they can ask. This is also called as Baffin Bay. Now Baffin Bay will be separating what? It will be separating the Labrador Sea, okay, with the Baffin Bay. ये दोनों को separate करेगा. And here you have Greenland and here you have Baffin Island. So such kind of questions can be asked in the map pointing. You can see here. And there is one more failed microcontinent here, okay, here near the Iceland. You can see ये वाला दिख रहा है part between Iceland and Faroe Islands. You have one more example here. So you have three examples here. So similar microcontinent examples include, okay, J. Mayhem microcontinent, northeast of Iceland. Just now we have seen, remember this name, J. Mayhem microcontinent. You have one more, East Tasman Sea Rise near Tasmania. So Tasmania is near Australia. And you have this Gluden Drak. It is in Western Australia. Okay, I'll show you all this. You can read the definition also. You can see the pictures here. So it is submerged primitive microcontinent located beneath the Davis Strait. The Davis Strait is a bay-like marine passage of North Atlantic that separates Baffin Bay in north from the Labrador Sea in the south, lying between Baffin Island and Greenland. Okay, all this you remember. Baffin Island कहाँ है? Greenland कहाँ है? Because Greenland is in the news. Trump कभी पगला गया जाके ग्रीनलैंड को भी अटैक करेगा. So that's why it is important. The region consists of unusually thick continental crust, about 90 to 24 kilometers. आपने देखा है अभी. Formed during the tectonic plate separation along the Ungava fault zone and is bordered by relatively thinner. ये सब याद रखने की जरूरत नहीं है. So whatever I am underlining, okay, this also you no need to remember. Remember these two. These two remember. Remember Labrador Sea also where it is. Okay. Baffin तो वैसे ही आपको याद है. Geologically, the proto-microcontinent is interpreted as a partially detached fragment of the continental lithosphere that did not fully separate when the Greenland and North America drifted apart tens of. See, आप literature तो पढ़ोगे, जब तक आप kind of animation नहीं देखोगे, diagram नहीं देखोगे, आपको समझ में नहीं आएगा. अभी समझ में आएगा आपको microcontinent कैसे form हुआ. I drawn a diagram. Okay, remember that only. The Davis Strait itself extends roughly blah blah blah. Okay, you can go through it. Okay, this examples you can remember. I'll show you some examples here. In reality, where they exist, we'll see. So this one, this is one, and one more. So near the Western Australia, okay, you have something of this sort. यहाँ पे दिख रहा है आप, ये वाला. This is also very thin near Australia. And near Tasmania also you'll see ये वाला. This one also. And since we are talking about microcontinents, we can also talk about the forgotten continents. See, during the Pleistocene Ice Age, this entire region, okay, from New Caledonia to New Zealand, this entire region. So this was called as Zealandia. because during the Pleistocene Ice Age it was as good as a continent जैसा ही था. And if you compare the area, entire area, it is larger than Australia. So ये this entire region, this is larger than Australia, and this is called as Zealandia. Now why it is called as a continent, and there was a demand for it to recognize as 8th continent. How many continents you have? 7 continents. 8th continent. Why? Because it has all continental rocks. Continental rocks. That is, it has felsic rocks. That is, it has lighter silicates. Lighter silicates. That is, it is made up of mostly sodium, potassium and a little bit of calcium silicates. Whereas this ocean floor which you see, this is all ocean floor. Okay. So this is made up of ferromagnesium silicates. So ये दूसरा पत्थर से बना है, and ये Australia and Zealandia, they are made up of the same material. Now what is the advantage? Why we should be declaring it as a separate continent? उसका फायदा क्या होगा बताओ? Or what kind of impact it will create? Say you are a policy maker, आपके पास proposal आएगा. What will be the advantage? What are the merits? Any guesses? अगर ज़ीलैंडिया को डिक्लेयर करेंगे एज ए 8th कॉन्टिनेंट, इफ पॉसिबल यू कैन स्विच ऑन योर कैमरा ऑल्सो, बिकॉज आपका चेहरा दिखेगा, मुझे भी लाइव फील आएगा. We can have a live interaction. See, the advantage is, example, say स्कूल के बच्चों में, स्कूल के बच्चे हैं, उनके लिए कंटेंट मतलब क्या है? जो पानी के ऊपर है, राइट? पानी के नीचे जो है उनको कंटेंट नहीं बोलेंगे, ओशन बोलेंगे. मीन्स अभी तक आपको भी ओके ये अंडरस्टैंडिंग है. पानी के नीचे मतलब है ओशन फ्लोर है, पानी के ऊपर है दैट इज कॉन्टिनेंटल क्रस्ट. अगर स्कूल को बच्चों को ये पढ़ा दिया जाएगा कि पानी के नीचे भी कॉन्टिनेंटल क्रस्ट होता है, सो दैट विल ओपन ए न्यू हॉरिजॉन इन द किड्स. फर्स्ट एडवांटेज. Second advantage, tomorrow when the sea level rise happens, don't you think the coastal regions of Australia, the coastal regions of India, don't you think they will be submerged? Means once upon a time it was a continent, but because of the sea level rise, okay, now it has come under the ocean or sea. So it gives an warning against the sea level rise. So basically awareness spread karega. The children will also get to know from the beginning itself that okay, the sea level rise can happen. What if the entire Antarctica melts? Antarctica has an ice sheet of around 2 to 3 kilometers thickness. What if it entirely melts? The sea level rise will happen by 160 meters. मतलब more than half of the land will be all submerged. अभी वो समंदर के नीचे आएगा. Will it be? Do we call it as oceanic crust? No, right? It will be still continental crust which has been submerged. Understood? Adhiraj is saying exploration for resources. अगर कोई चीज़ डूब रहा है, अब कैसे एक्सप्लोर करोगे भाई? ओपन फॉर इकोनॉमिक डेवलपमेंट. इकोनॉमिक डेवलपमेंट के नाम पे आप सारी चीज़ तबाही कर दो, पूरा लूट लो मदर अर्थ को. डीप सी मिशन, समुद्रयान. ओके, चलो. ओके, सो दिस इज ऑल अबाउट द प्लेट टेक्टोनिक्स एंड द करंट अफेयर्स. तो सारे करंट अफेयर्स हो गया. So you have the map of Zealandia also. You don't have to remember this Campbell Plateau, Lord Howe, ये सब याद रखने की ज़रूरत नहीं है. बट न्यूजीलैंड है वहाँ पे, तो ये ध्यान रखो.
So this is all about the plate tectonics. So next topic which we'll be doing is earthquakes. Earthquakes. The first is, what are the various reasons for the earthquakes?
See, आपको मैं फिर से बता देता हूँ.
So not only you guys, even the mature students. So whenever I talk about the nature, oceans, continents, आपका मन में सबसे पहले ये आता है, how to explore, how to exploit the resources. मीन जब आप पेड़ देखोगे, आपको फर्नीचर की याद नहीं आना चाहिए. पेड़ देखोगे, ऑक्सीजन की याद आना चाहिए. Okay, the shade which it gives, the carbon sequestration which it does, the way in which it fertilizes the soil, the way in which it provides the habitat, these are all long term. एक पेड़ रहेगा तो 100-200 years के लिए it will provide all these services. आपने पेड़ को काटा, कोयला वाटर अंदर चूल्हे में डाल दिया, 2 मिनट में पूरा खत्म. So especially, okay, as far as my subject is concerned, geography हो, environment हो, you should be having little bit concern about the environment. And आप questions भी देखो, okay, environmental concern बहुत सारा रहता है. And when you become a policy maker, you should be having that concern. When you become a policy maker, you should take the side of the weak, right? So अंबानी अदानी के लिए तो बहुत सारे हेल्प करने वाले हैं, लेकिन बेचारे मैंग्रोव्स को, आइलैंड्स को, जंगल को कौन हेल्प करेगा? You should be taking the side of these. You should always take the side of the weak. अभी मेरे ही साथ वाले बहुत सारे, ओके, हमारा एक व्हाट्सएप ग्रुप है, वहाँ पे डिस्कशन होता रहता है. सो वो लोग इतना IAS IPS ये सब बने हैं, लेकिन एकदम गधे के गधे ही है. मीन्स उनका अंडरस्टैंडिंग इतना शैलो है चीज़ों में. मैं उनको लेक्चर देता रहता हूँ, भैया तुम बदलो, ओके. दे नेवर, ओके, दे ऑलवेज टो डाउन टू हुसएवर रूल्स. जो भी रूल पे आता है ना, उसका बूट लिकिंग में रहते हैं लोग. Okay, it is very sad. At least when you guys become the civil servant, follow the principles of the constitution. जो भी constitution में, जो भी power में है उसका और boot licking में मत रहना. Okay, very bad. Empathetic, you should be empathetic. Understood? Okay. So reasons for the earthquakes. Let's see this.
Now, the reason can be anything here. Because what is an earthquake? Earthquake is nothing but shaking of the crust, or we can say vibrations in the crust. Vibrations in the crust, right? Now, what can cause the vibration in the crust?
For example, I am jumping up and down. Vibration आ सकता है ना, right? Say a meteorite is attacking the earth. Vibration आ सकता है ना. For example, you have a sedimentary rock which is very weak. इसके ऊपर आपने विकास प्रो मैक्स कंस्ट्रक्ट कर दिया. Because अपने लिए विकास प्रो मैक्स मतलब यही है ना, बड़े बड़े बिल्डिंग दिखते हैं, शीश महल दिखते हैं, तो आप बोलते हैं कि वाह क्या डेवलपमेंट हो गया. अगर कहीं पे अच्छा व्हाट पॉन्ड दिखता है, जंगल होते हैं, फिर से नो बैकवर्ड है. कहीं पे व्हाट बड़ा मंजिल दिख गया, वह डेवलपमेंट है. सी गाँव, ओके, कोई अगर पहले किसी का घर था, अच्छा खासा गार्डन है, पेड़ है, छोटा सा हाउस है, अगर वो सब तोड़ के किसी ने बड़ा सा व्हाट शीशे का बिल्डिंग बना लिया, आप क्या बोलते हो? वाह उनका डेवलपमेंट हो गया रे, एकदम उसने बड़ा मंजिल कंस्ट्रक्ट किया, राइट? सो आवर आइडिया ऑफ डेवलपमेंट इज एंटायरली डिफरेंट. So we are into materialistic development, okay? That idea that thinking has to change. Say, okay, you have a sedimentary rock and you have constructed 10-floor buildings. फिर कश्मीर में, उत्तराखंड में, हिमाचल में आप ऐसे कंस्ट्रक्ट कर रहे हो, फ्लोर पे फ्लोर पे फ्लोर. एर्थक्वेक होगा तो क्या होगा? पूरा ये सब what it will all collapse, right?
earthquake छोड़ो, लैंडस्लाइड हो जाएगा, लैंडस्लाइड छोड़ो, बारिश हो जाएगा तो ये पूरा टूट जाएगा. इतना फ्रेजाइल है our idea of development. So if these sedimentary rocks, these layers, when they break, because they are not that strong as igneous rocks, what will happen? The building will collapse, right? So there will be shaking in the crust. Or you are doing mining. For example, this is the surface of the earth. Okay, अंदर है कोल. आपने पूरा कोल निकाल दिया. Because coal is a sedimentary rock. कोल निकाल लिया. Do you think this rock structure will be stable? This is all hollow now. अंदर कुछ नहीं, खोखला है. ये rock है ऊपर. Do you think it will be stable? It will again collapse. So it will give rise to the shaking in the crust. So it can also cause the earthquake, right? Now there is a system called as hydraulic fracking. Hydraulic fracking. See, generally, you get petroleum between the sedimentary rocks. So sedimentary rocks के ऊपर की layer में you will be getting the petroleum. So these sedimentary rocks have bigger pores. Pores are larger. Okay. But what if the petroleum is formed in the clay? This is the clay. See how the petroleum is formed. The petroleum is formed when the marine life undergoes fossilification. So you have two rock layers. In between these rock layers, the marine life has been fossilified. So आप यहाँ पे पाइप घुसाओ, सीधा निकल जाएगा पेट्रोलियम. Say, what if the marine life has been fossilified in the clay? ये clay के बीच में microorganisms have been fossilified. So you still have petroleum, but again it is difficult to extract. This is easy to extract. It's like sand के बीच में water है. अब sand में water pour किया, means रेती है. So रेती को बीच में खोदो, पानी बीच में आ जाएगा, आप आराम से पानी निकाल सकते हो. लेकिन अगर मुल्ठानी मिट्टी में क्ले के बीच में पानी आ गया, कितना भी गड्ढा करो बीच में, क्या पानी निकलेगा? नहीं. So for this you have a process called as hydraulic fracking. इसमें क्या करते हो? एक पाइप घुसाते हो. Then you will be inserting horizontal pipes, and through these pipes at high pressure you will send a lot of sand, chemicals, hot water, गवार फली होती है ना, गवार, adhesives, etc. So you'll be sending all of them at high pressure. So when you send all of them at high pressure, what will happen? The sedimentary rock will be broken. It will be broken, it will become fragile. Then when all these chemicals and hot water, when they get inside, the petroleum which is there inside, it will be dissolved. Then you'll be sucking out this liquid. A liquid को suck करके, and then you'll be extracting petroleum from that. So this process is called as hydraulic fracking. So this is the reason why USA, which was earlier importer of the oil, now USA has become exporter. In fact, USA is exporting oil to India also. पहले USA 2014 के पहले वर्ल्ड का लार्जेस्ट इंपोर्टर था ऑयल का. But आज USA has become the exporter also. It is because the US was able to exploit its shale gas reserves. This is called as shale gas or oil. Now India also has a lot of shale gas and oil. Do you think we should exploit these reserves? Do you think we should exploit? Again, geography, environment, okay, should also have a concern. I'll tell you. See, India में आपको rules का पता ही है, right? See, लोग बोलेंगे कि no, we'll be carefully extracting will not be destroying any groundwater aquifers. Do you think it will happen? Leakages can happen. It will destroy the groundwater aquifers. Even now, in the rural areas, 80% of the fresh water needs, पीने का पानी जो है ग्राउंड वाटर से आता है, उनके पास आरओ वगैरह नहीं होता है. अभी रिसेंटली इंडोर में देखा है ना, इंडोर में भाई फ्रेश वाटर के सप्लाई में नाले का पानी घुस गया, लोग पी के मर गए. ऑलरेडी मध्य प्रदेश हैड दिस डिजास्टर, भोपाल गैस ट्रेजेडी हो गया बिकॉज ऑफ द एयर पोल्यूशन, बिकॉज ऑफ द वाटर पीपल आर ड्राइंग. Now, do you think if we allow such kind of hydraulic fracking in India, जितना भी ग्राउंड वाटर है पूरा ही एक्सप्लॉइट हो जाएगा एंड लोगों के पास पीने का पानी नहीं रहेगा. ऑलरेडी द सरफेस वाटर हैज बीन टोटली पोल्यूटेड इन इंडिया, राइट? एंड वंस यू एक्सट्रैक्ट ऑल दिस, आप पेट्रोलियम निकाल लोगे वो केमिकल सोल्यूशन में से, बाकी का कहाँ फेंकोगे आप? यू विल थ्रो इन सम रिवर और लेक, राइट? इट विल ऑल्सो पोल्यूट द सरफेस वाटर. So in India, rules are not followed at all. Okay? And जब भी आप बाबू लोग बनो ना, at least environment को protect करना. Okay? So Adiraj is saying materialistic love indirectly links with technological advancement, no internet, peaceful world. Okay, good. Chalo. Okay? So the earthquakes can happen because of any reason. But the most common reason for the earthquake is plate tectonics. Now that is because of the movement of the plates you have the earthquakes. Now we will see the earthquakes along divergent plate boundary. We will see the earthquakes along transform plate boundary. And we will see the earthquakes along convergent plate boundary. Now already I have explained, along the divergent plate boundary, you hardly have any earthquakes. Why? Because then the magma which is coming from below, it is highly fluidic. So this is highly fluidic and it flows very easily. It flows very easily without causing any disturbance, without shaking the crust, वो चला जाएगा. So that's why it will not disturb the crust. You can hardly perceive any earthquakes. That's why along the MOAR, along the Great African Rifting. Now Great African Rifting is very much active. आपने pictures भी देखा है. अभी recently वहाँ पे crust टूट रहा है वहाँ पे. फिर भी earthquakes are hardly perceived. Recently in Goma, that is in DRC, eastern part of DRC, near Lake Kivu, volcanic eruption has happened. But still earthquakes are not there. Why? Because आराम से निकल के बाहर आएगा. Okay? Yes, नूरप्रीत, या आपके बटिंडा में, अपना सिरसा है ना, सिरसा के ऊपर जो भी आपका पंजाब का पार्ट है, श्री गंगानगर डिस्ट्रिक्ट एक्सेट्रा, which is in Rajasthan, but above that, in your Punjab, there is very high uranium contamination. So why it happens, I will tell you later. Now transform plate boundary. So around the transform plate boundary also, you will be having the earthquakes. Because the two plates are undergoing abrasion. There is a friction between these two. दोनों प्लेट मूव कर रहा है, कहीं पे एक प्लेट अटक गया, रॉक्स अटक गए. So lot of tension will be generated. And finally this tension will be released all of a sudden. Okay? For example, दोनों स्लाइड कर रहे हैं, कहीं पे अटक गया. अभी यो प्रेशर बना ही रहा है, the pressure बढ़ेगा, suddenly slip हो जाएगा. So that is how the energy is released suddenly in the form of the earthquakes. And here, जितना wide होगा ये दोनों के बीच में space, the earthquake is directly proportional to the square of the width. And how it becomes wider and wider? Say you are having a fault anywhere. Make sure that in that fault the water doesn't go. If the water goes into that fault, the fault will become wider and wider. And more the width increases, the intensity of the earthquake increases even more. Okay? Now where we can apply this? See, the Himalayas have numerous faults, and in the Himalayas, you are building lot of dams. Numerous dams you are building. For example, Uttarakhand है, right? ये पूरा Himalayas है, and especially middle Himalayas, a lot of asymmetrical faults, nappy structures, and a lot of reverse faults. And in between these, okay, you are building large dams. Say for example, this Tehri dam is there. You see, यहाँ पे नदी आ रही थी, नदी को आपने रोक दिया, and सारा पानी यहाँ पे इकट्ठा हो गया. ये पानी क्या करेगा? किसी न किसी क्रैक में तो घुसेगा ना ये वाला पानी. And these are all okay sediments which have been uplifted, and this water will soak these sediments. The sediments which have been hardened, because of the contact with the water, they'll become soft, and soil loose हो जाएगा, and it will result in the landslides, mudslides, weak rocks, collapse of the rocks, breaking of the rocks, earthquakes, etc. It will lead to a lot of problems. So that's why we should stop constructing a lot of dams in the fragile Himalayas. What if this breaks? What if this dam breaks? इतना सारा पानी आपने इकट्ठा करके रखा है. Okay? What if there is a cloud burst here? What if there is a heavy rainfall here? What will happen? This dam can break. So when the dam breaks, what will happen to the lower riparian parts? नीचे जितने भी गांव हैं, देखो यहाँ पे गांव, they all will be flushed out. It will become a very large disaster. And most of the dams in India are like 60-70 years old, बहुत पुराने हो चुके हैं. And the developed countries are destroying the dams. And India is into construction of the dams. क्यों construction? Because one dam will be costing you like lakhs of crores of rupees. Say I am a politician or I am a bureaucrat, so I am responsible for signing of the documents related to dams. अगर मुझे 1 लाख करोड़ में 1% भी कट मिलेगा, 1000 करोड़ मेरे हो गए, right? So there is lot of corruption everywhere. Yeah, Bhatinda cancer belt, true. Yeah, Nurpreet, you're right. Malana Dam has cracked recently. Okay. Chalo, this is about the transform faults. Now let's see about the convergent plate boundary. Okay, how it happens. Now when you have a convergent plate boundary, so it can be of two types. One is associated with the subducting oceanic plate. Ocean plate subduction. On this side you can have anything, OC or CC, whatever. This can be OC or CC. So this is the OC. So here you have water, the ocean. So here you can have mountains and all, etc. Right? Now here the earthquakes can be because of volcanic eruption. यहाँ पे volcano erupt हो रहा है, and these volcanic eruptions are andesitic. Andesitic plus they are associated with a very large amount of water vapor, steam आ रहा है इसमें से, steam. And this andesite is viscous, acidic है, because of which it won't be able to come out. And these volcanoes are explosive in nature. So because of this, because of their explosiveness, they can shake the crust of the earth, giving rise to earthquakes. That is one reason. The second reason is, now there can be friction between this crust and crust. Say this is the continental crust, this is the oceanic crust. When this crust is undergoing subduction, so कहीं पे rock फंस सकता है. फंसने के बाद वो tension generate करेगा. Then okay, the tension what accumulates over a period of time, and suddenly all the energy will be released at once. So because of the friction between this crust, friction, the earthquake can happen here also. Okay, so the earthquake can happen within the crust within 70 kilometers. So this is 70 kilometers. Then there can be friction between the subducting oceanic slab and the mantle. This oceanic slab is subducting into the mantle. मीन्स वो अंदर घुस रहा है, जब वो अंदर घुस रहा है तब भी फ्रिक्शन हो सकता है. दिस इज कॉल्ड एज mantle slab friction. Mantle slab friction. So because of this friction also there can be earthquakes, and this is up till 300 kilometers. 300 kilometers. And finally this oceanic slab will undergo melting. It will undergo melting and chemical changes. Chemical changes. And when it undergoes melting, it's like, say this ocean slab was under the water, and when it goes inside the mantle, वो बहुत गर्म है. जैसे ओके जब गर्म ऑयल में आप प्याज डालते हो, अगर जब कुकिंग करते हो ना, गरम गरम ऑयल में प्याज डालोगे, क्या होगा? एक्सप्लोजन होगा. या मिर्ची डालोगे, एक्सप्लोजन होगा. सेम, this ocean crust has soaked in the water for a very long time. Okay, the temperature is also low, it has a lot of water, and finally when it enters into the hot mantle, the water inside it evaporates. When it is undergoing destruction, lot of chemical changes will be taking place, and because of which there can be lot of disturbances here. So because of which there will be lot of explosions over here, and this can happen anywhere between 300 to 700 kilometers. Now you have got three zones over here. एक है 70 kilometers, एक है 300 kilometers, 700 kilometers. So within 70 kilometers, within the crust, it is called as shallow focus earthquakes. Means the energy is released from here. Between 70 to 300, it is called as intermediate focus earthquake, and this is called as a deep focus earthquakes. Means depending upon where the focus is, so depending upon from where the energy is being released, we can divide the earthquakes into three types. So now you guys tell me which earthquakes will be more felt on the surface of the earth. Shallow focus, intermediate focus, or deep focus? Shallow focus, very good. In fact, 80% of the earthquakes, more than 85% of the earthquakes are shallow focus earthquakes. अभी deep focus earthquakes उतना feel क्यों नहीं होते हैं surface के ऊपर? Because deep focus earthquakes has to come beyond 300 kilometers. अभी 400 किलोमीटर से अगर वो आ रहा है, उसको ट्रैवल करके आना है, तब तक ओके इट विल बी लूजिंग द एनर्जी, एंड इट माइट नॉट बी हैविंग एनी एनर्जी टू कॉज एनी डिस्टर्बेंस ऑन द क्रस्ट. फर्स्ट रीजन. Okay, and shallow focus earthquakes are very near. So their focus is generally at 5 kilometers, 10 kilometers, 15 kilometers, 20 kilometers. So they'll be having enough energy and they'll be able to reach the surface very fast. So because of which, okay, the shallow focus earthquakes are more in number. Okay, remember this. So shallow focus, intermediate focus, deep focus. Okay. So can deep focus cause tsunamis? See, cause करने को cause कर सकता है, लेकिन अभी तक जितने भी tsunamis अपन ने पढ़ा है, means which have been observed, so which have been documented, they are all because of shallow focus. अभी 400 किलोमीटर के अंदर से एनर्जी निकल के वो क्रस्ट को डिस्टर्ब करना चाहिए, एंड वो वाला क्रस्ट जो है इट हैज़ टू डिस्टर्ब द वाटर, दैट इज हाईली अनलाइकली. ओके, अंडरस्टूड? So this is about the earthquakes. Now, the zone which is there is a subduction zone. Means the earthquake can happen because of slab friction. The earthquake can happen because of mantle slab friction. The earthquake can happen because of destruction of the slab. So this is the destruction of the slab. This is mantle slab friction, and this is slab friction. And this entire zone from where the earthquake can come, from where the earthquake can originate, this is called as Benioff Vadati zone. And this angle is usually 45 degrees. 45 degrees angle. Means this oceanic slab will be undergoing subduction at 45 degree. And the maximum depth is 700 kilometers. So ये वाला हो गया 700 kilometer. Okay. Now tell me, how far from the trench? So this is the trench. How far from the trench on this continental crust you can have epicenter? Mathematics, CSAT. CSAT इग्नोर मत करना. मैं खुद IIT से हूँ, फिर भी एक बार CSAT में फेल हो गया because of ignorance. Okay, be very careful. Don't think. I know many IITs you have failed in CSAT. So how far from the trench on this CC you can have the epicenter? कितने किलोमीटर? नो आइडिया? भाई मैथ लगाओ ना. सी ये वाला एंगल कितना है? 45 है. ये वाला कितना है? 700 kilometers. What is tan 45? Tan 45 is 1. If this is 700, this also will be 700. So what is the practical application of this? So 700 kilometers. 700 kilometers from the trench. You need to be very careful. You can have the epicenter of the earthquake. Understood? Okay. So remember this Benioff Vadati zone. Okay. So next, the earthquakes along the continent, CCCC. CCCC. So above the CC, you'll be having this fold mountains. Now between these two continental crusts, there is head-on collision. So you have this head-on collision. So head-on collision hai, and between these two, a lot of stress can be generated, and that stress can be released over a period of time. So it will also generate the earthquakes. And above these two crusts, you have this fragile sedimentary rocks. These rocks are fragile sedimentary rocks. So नीचे के जब पत्थर जब हिलेगा, ऊपर के rocks भी हिलेंगे. And moreover, here there is head-on collision, means forces are towards each other. Therefore, along the CCCC, you'll be having more severe earthquakes. So here you'll have more severe earthquakes. So of all the regions, the CCCC earthquakes are very dangerous because they are associated with excessive compressive forces. Excessive compressive forces. Okay. So there are some more terms associated with this earthquakes. There's a term called as seismic gap. Seismic gap. See, you have this Indian plate, and on this side you have Eurasia, and this side you have Indian plate. So this is India. So this is where you have these Himalayas. So this is where you have the plate boundary. Is the plate boundary? Boundary between the Eurasian plate and Indian plate. See, the entire plate boundary, this is tectonically active. This is tectonically active. But what happens, the part of the plate boundary in some parts, so here the earthquake hasn't happened for a very long time. For example, you have this central Himalayan belt. Central Himalayan belt. So in this central Himalayan belt, from the past say 500 years, there is no major earthquake. There is no major earthquake. Means here the earthquake is long due. Long due. And this is called as seismic gap. It is like the stress is being built up over here. अभी बहुत दिनों से यहाँ पे earthquake नहीं आ रहा है, तो अच्छी बात है बुरी बात है, बताओ. It's a good thing or a bad thing? If you are having seismic gap, bad. Why it is bad? For example, जब आप यूपीएससी के लिए पढ़ाई करते हो, ओके, आपको बहुत फ्रस्ट्रेशन होता है. ओके, 8-10 घंटे आप बुक्स पे ही बैठे रहते हो, राइट? In between, you scroll the reels, etc., watching this YouTube and all, right? But the stress has to be busted somewhere. कभी कभी आप मूवी चले जाते हो, कभी कभी किसी से झगड़ा करके निकाल लेते हो. So weekly once, one day you take rest, do whatever you want. Or on daily basis you do some physical activity. जाओ जिम जाओ, रनिंग करो, योगा करो, कुछ तो करो. So whenever you are getting mentally strained, that has to be released. Okay? अगर आप रिलीज नहीं करोगे, 4 महीने कंटिन्यूसली पढ़ोगे, आपका दिमाग फट जाएगा. So here lot of stress is being accumulated. Okay, last 500 years, sometime, okay, in 1503, sometime back, so there was a huge earthquake. अभी इस region में जो भी earthquake आएगा ना, so it will be of the order of the 10 plus आएगा Richter scale में. Okay, so that's why we need to be mindful. So seismic gaps are very bad. 85% of the earthquakes are shallow focus earthquakes. Okay, around 12% of the earthquakes are intermediate focus earthquakes, and around 3 to 5% are deep focus earthquakes. If you want to note down, you can note down. But okay, just remember this. Now, so earthquake prone regions of the world. Now, if you want to learn, you can learn how to draw a world map in a very easy way. So I'll start with North America. I will draw a tree here, then do this, then this, and नीचे जाओ. Then I draw a triangle here, then draw a tree. Okay, हो गया North America, South America. Then draw the equator, reference line. Then skull of Africa, ये skull draw करना. Okay, then नीचे और एक triangle draw करना है ऐसा. This is Horn of Africa. Then join this. So this comes your Saudi Arabia, and this comes your Italy. This gives Iberian Peninsula. Then this becomes your Scandinavia. यहाँ पे एक डॉट डाल दो, इंग्लैंड आ गया. देन ये लाइन खींचो, ईरान हो गया. सो दिस कम्स, हियर कम्स योर इंडिया. ऑथेंटिसिटी के लिए इंडिया के नीचे छोटा सा ट्रायंगल, श्रीलंका आ गया. ये हो गया आपका म्यांमार. Okay, Lao, Cambodia, South China Sea, Kamchatka Peninsula. Okay, draw this way. Okay, now iske niche, okay, you have this Sumatra, Bali, okay, yeah, all these islands over here. You have Philippines over here, and यहाँ पे your Australia will come, whatever. Okay, you draw it this way. Okay, so यहाँ पे Madagascar हो गया आपका world map, right? Now, what are the earthquake prone regions of the world? So most of the earthquakes are happening along the Pacific Ring of the Fire. So this is the Ring of the Fire. So this entire region. So Pacific Ring of Fire has 70% of the earthquakes. And the Trans-Eurasian Himalayan Belt. Okay. This is called as Trans-Eurasian Himalayan Belt. This has 20% of the earthquakes. 20%. And you have this MOAR, Mid-Oceanic Atlantic Ridge. You have this Great African Rifting. You have some trenches in Caribbean over here. So rest will be having around 10% of earthquakes. Right? See, obviously, wherever you have the plate boundaries, that will be more prone to the earthquakes. Okay? So if you want to draw a map anywhere, okay, you can simply draw this way. For authenticity, draw Sri Lanka over here. So you can draw this way. And ऊपर का मिला देना. वैसे ही अखंड भारत है, तो फर्क नहीं पड़ेगा. हाँ, पूरा अपना ही है. Right? So obviously the Himalayan belt, okay, will be highly earthquake prone. So this entire Himalayan belt. And this is further extending along the Andaman Nicobar. So you'll also have Andaman Nicobar. Okay. So these are the regions which are generally prone to earthquakes, right? But if you look at the previous earthquakes which have happened in India, for example, you have this Bhuj earthquake. Bhuj earthquake कहाँ पे? यहाँ पे Bhuj 2001. You have Lathur earthquake in Maharashtra 1993. Now these earthquakes haven't happened along the plate boundaries, but they have happened inside the plate. Why? Okay. So that is why you need to understand the local faults in India. See, in the red part, obviously, okay, we'll be having earthquakes. For example, okay, I am the India plate. This board is Eurasian plate. If I go and hit, okay, obviously there will be shoulder pain, right? But what if I already have a fracture here in my leg or in my shoulder? If I'm going and hitting a wall, don't you think the impact will be carried here also? Obviously मैं यहाँ पे टकरा रहा हूँ, ए वाले शोल्डर पे टकरा रहा हूँ. जब मैं जोर से जाके ये वाले शोल्डर में टकराऊंगा, यहाँ पे भी मुझे पेन होगा ना. So that's why you need to understand the local faults also. So India has local faults, and these local faults are prone to earthquakes. I'll be drawing these local faults. See, here from Ahmedabad to Bhuj, you have a fault called as Allah Band fault. This Allah Band fault has been created in the year 1811. Now, why it is called as Allah Band fault? What happened here is, there was a crust, stable crust, but part of the crust has been uplifted. Part of the crust एक ऊपर उठ गया. So थोड़ा अगर ऊपर उठ गया crust, वो बांध जैसा दिखेगा, डैम जैसा दिखेगा, तब लोग उसको बोलने लगे बांध. Means when you don't know the scientific reason, you will attribute it to religion. So they thought अल्लाह ने फॉर्म किया, इसलिए अल्लाह बंद फॉल्ट हो गया. Next, from Ahmedabad into Gulf of Kambakht, you have one more fault here. This is called as Cambe Graben. These are the local faults. From Nashik to Kalagadi, it's in Karnataka. You have a fault. This is called as Koina fault. And from Nashik to Sholapur, you have one more fault called as Kurduvadi fault. And here you have Malda fault. Near Delhi, you have Sohna fault. So likewise, you have numerous local faults. Now 2001 में जो earthquake आया, that is near Allaband fault. This is where the Bhuj is. And 1993 Lathur earthquake जो आया, that is near this fault. This is where Lathur is. Okay. So the earthquakes in India do not just happen along the plate boundaries, but also they happen in the interiors because of the presence of local faults and figures. Now, if you take the seismic map of India, the seismic map of India will be having various versions. So, recently it has been revised also. So, you take the map here, सबसे simplest map ले लेते हैं यहाँ पे. Okay, I guess you guys have done, okay, if you guys have done disaster management, I have explained this already to you. ये वाला चीज़ ले लेते हैं. See this. Now in this, you have this region in red, zone 5 hai. Now this zone 5 is highly prone to earthquakes. Now what are these regions? So these are the regions of Middle Himalayas. Now why the Middle Himalayas are highly prone to earthquakes? Because already I told you, Middle Himalayas have numerous faults. Middle Himalayas have a lot of asymmetrical faults. They have recumbent faults. They have nappy structures. That's why they are highly prone. Why the entire northeast region? Because the Indian peninsular plateau was earlier traveling like this. So the western part has hit Eurasia first. And after hitting the western part first, it started rotating in the anti-clockwise direction. So anti-clockwise rotate हुआ. तो पहले ऐसा आ रहा था, अभी ऐसे, okay, the force is being applied. So most of the forces are being applied in the northeastern direction. That's why the entire northeast, okay, is under very heavy stress, and this is also called as the door hinge action, also called as anti-clockwise rotation of peninsular plateau, anti-clockwise rotation of peninsular plateau. So this is also the reason why the eastern Himalayas, they have an abrupt rise, where the western Himalayas have three distinct ranges. So पहले जब peninsular plateau west में hit किया था, okay, and then जब turn हो गया, so the Himalayas have formed three distinct ranges. ऐसे. So when it has turned in the anti-clockwise direction, whatever sediments are there, they fell and slump and fell. धीरे धीरे नीचे गिरा. नीचे गिर के इस तरफ three ranges form हो गया, and यहाँ पे it has formed a single range. So that's why they'll be having abrupt rise, and there is a lot of stress here. So that's why it is in zone 5. So then you have this region, entire Kutch region. Why this is in zone 5? Because Allaband fault has been created very recently. अभी for example, okay, आपका दिल टूट गया very recently. या आपका एक पुराना ब्रेकअप है, आपका नया ब्रेकअप है, ओके ओके, आपके सामने से दोनों गुजरेंगे, तो किससे आपको ज़्यादा दर्द होगा, नए वाले से या पुराने वाले से?
Okay, this is about zone 5.
Next, zone 4. Zone 4 is rest of the Himalayas, because the Himalayas are made up of the sedimentary rocks of marine origin. Of course, they are fragile. And the region which is surrounding this, okay, and this one is Koina fault region. And देखो यहाँ पे अपने क्या किया, so the place where both the faults are meeting na, there we have constructed a dam. I'll show you. So this is the greatness of India's planning. Again it got stuck, okay, fine, okay, no problem, okay, it is coming. See, you can see a fault line over here, big fault. So this is a Koina fault, and inside this fault, see, you have constructed a dam called as Koina Dam. कोयना रिवर दिख रहा है यहाँ पे, कोयना डैम कंस्ट्रक्ट किया. नाउ जब ये फॉल्ट में पानी घुसेगा, डोंट यू थिंक दिस फॉल्ट विल बिकम लार्जर एंड लार्जर? So when the fault becomes large, the intensity of the earthquake will be more and more, isn't it? Let's go back here. So zone 4 you understood? Now zone 3. So if you look at zone 3, so zone 3 is associated with the rivers here. See, यहाँ पे दामोदर रिवर है, दामोदर रिवर, महानदी रिवर, महानदी. दिस इज कृष्णा गोदावरी. यहाँ पे छोटे मोटे रिवर्स है, पेन्नेरी रिवर, पालार रिवर, पोन्नियार रिवर. एंड एंटायर वेस्टर्न घाट्स इज एन एस्कार्पमेंट, इज अ ब्लॉक माउंटेन, इज अ फॉल्ट. दिस इज नर्मदा तपी, माही, साबरमती, सोन रिवर. So already I told you, wherever you have these rivers flowing, the rivers in the peninsular plateau are already flowing in the cracks and joints. Means खुद से वो ग्रेंडिक रॉक को काट के अपना रास्ता नहीं बनाएगा. So अगर कहीं पे भी फॉल्ट है उसमें फ्लो करने लगेगा. So these cracks and joints, these faults are associated with zone 3 of the earthquakes. The rest in blue, okay, you have almost stable. Okay, you will not have much of earthquakes over there. So this is the earthquake zonation map of India. And ये वाला जो explanation है ना, why it is in zone 5, why it is in zone 4, you will not find it anywhere. Take any source, you will not find it. So आप इसी note से okay, जिस class से लिख लेना. Okay. Okay. So rest of the things we'll discuss in the next class. So in the next class we'll discuss rest of the earthquakes and earthquakes. Now you can measure the earthquake by measuring the amplitude. You can measure amplitude. Amplitude means shaking of the crust. Shaking, or you can say the vibrations in the crust. Vibrations in the crust. This is one method. And this method is objective method. Objective. Objective means तुम measure करो, मैं measure करो, same रहेगा. And this is done by seismograph. Seismograph. And this is called as Richter scale. And this scale is from 1 to 10. But beyond 8 on the scale, we'll use movement magnitude scale. We'll be using movement magnitude scale beyond 8, because beyond 8 this is not accurate. Now it measures the amplitude or the vibrations, but this is Richter scale is logarithmic scale. Means the magnitude is measured as log 10 amplitude.
So you'll be taking logarithmic scale because whenever you have numbers which you can't manage properly, then you'll be going for the logarithmic scale. That means, for example, okay, the shaking of the earth, so shaking of the crust is say 10 meters, so 10 meters, 10 hai. Then it will be considered as 1. If the shaking of the earth is say 100 meters, on scale it will come as 2. The shaking, I don't have space here, I can't draw like this, okay. The shaking is 1000 meters. So on the scale it will be 3, okay. That means for every subsequent change in the magnitude, the vibrations increase by 10 times. This is very important. For every change in magnitude, vibrations increase by 10 times. Means, for example, you take, on Richter scale, magnitude of 3. And magnitude 4 में आपकी बिल्डिंग 10 गुना ज़्यादा हिलेगा. ओके, इसका मतलब ये है. Next. Now the energy increases by 32 times. 32 times. That means on Richter scale 4, the energy is 32 times than on Richter scale 3. So this is about the energy. So remember these two terms. And very important thing about this is, it is objective in nature. Now comes the next scale, which is subjective. So this is subjective. And here you will be measuring the intensity. Whereas here you measure the amplitude. Okay, here you measure the intensity, or here magnitude, their intensity. So intensity, how will you measure? It depends upon the enumerator. So for example, you can take number of deaths. So how many people have died in an earthquake? And this scale ranges from 1 to 10. Why 10? Because till now, the largest earthquake on a Richter scale has been around 9.5 on the Richter scale. अभी तक 10 के beyond नहीं आया. इसलिए the scale is 1 to 10. अगर हिमालयस में फ्यूचर में beyond 10 आएगा, ये भी बढ़ सकता है. Now this is measured between 1 to 12. This is the difference. Okay. So you can measure number of the deaths here. You can also measure, for example, nowadays, okay, in our country we don't have any value for the death. लोग पानी पी के मर जाते हैं. So deaths अगर ignore करोगे आप, okay, then you can also measure the number of buildings collapsed. Or you can also measure economic loss. Means कितने कार खत्म हो गए, okay, कितने buildings खत्म हो गए, कितने लोग खत्म हो गए, okay, इन सब का जोड़ के you can calculate the economic loss. Okay, for example, if my students are ecologically very sensitive, they'll also calculate the damage caused to the environment. So not only economy, but also ecological loss, right? Now some people will be calculating just number of deaths. किसी का हाथ पाँव टूट गया, that also you can calculate. So physical disability also you can calculate, right? अगर उससे भी beyond कोई जाएगा, because as an administrator you have to be sensitive to all the needs, right? उससे भी beyond कहीं जाएगा, somebody can also calculate post traumatic stress disorder. ये भी calculate कर सकता है. So this can also be calculated under the loss. So there is no limit to it. Now it depends on the enumerator. For example, you are an administrator. Okay, आपको सरकार ने भेजा है, भैया देख के आओ कितना लॉस हुआ है. ओके, आप जाओ के देखोगे वहाँ पे पड़ा हुआ है बंदा, हाथ पैर पूरा ही टूटे हुए है. ओके, आप जाके नस पकड़ोगे, ओके, बोलोगे जिंदा ही है, चलो, नॉट काउंटेड, राइट. इट शुड नॉट बी दैट इनसेंसिटिव. ओके, आजकल मैं देख रहा हूँ, ओके, कितने इनसेंसिटिव है. ऐसा लगता है कि एडमिनिस्ट्रेशन में क्यों है लोग, सिर्फ लूटने के लिए गए लोग. So you can calculate all of this. So that's why it is highly subjective, and also depends on country to country. Depends on country to country. कैसे? For example, in Scandinavian countries, okay, even if there is traffic delay, means traffic signal में कहीं problem आ गया, आप late हो गए, so that also is considered as a disaster. The compensation will be paid. मैं सुना है ना, okay, जापान में को 1 second भी ट्रेन लेट नहीं होती है, right, like that. Recently in Brazil, right, Brazil is not such a developed country, India के आसपास ही है, okay. If you consider GDP is less than India. So वहाँ पे नया ट्रेन चल रहा था, okay. हमारे कंट्री में तो प्रधानमंत्री हर एक वंदे भारत को वो लॉन्च करते हैं, बट देयर वहाँ पे कोई पॉलिटिशियन आने वाला था, ओके, ट्रेन को इनॉग्रेट करने, तो टाइम पे नहीं आया, ट्रेन चली गई, राइट. नाउ डिपेंड्स अपॉन कंट्री टू कंट्री कितना सेंसिटिव है. सो दैट्स व्हाई इट इज हाईली सब्जेक्टिव. नाउ दिस वेरीज, द स्केल वेरीज बिटवीन 1 to 12, एंड दिस इज कॉल्ड एज, द नेम ऑफ द स्केल इज Mercalli scale. Mercalli scale. Now how this scale will differ? For example, you have a magnitude of 4, okay, you have in Delhi and you have in Rajasthan. So magnitude of 4 नहीं लेते, 6 लेते हैं, 6. So Delhi में you can have say around like lakhs of deaths, lakhs of people will die, because वहाँ पे building इतने पुराने हैं, वो गिर जाएंगे, they are in dilapidated conditions. So most of the buildings in Delhi do not even have pillars and beams, so they will die. But in Rajasthan desert, there can be 0 deaths. So on the Richter scale it is same, but on Mercalli scale it is different. So it depends on region also. Depends on region. Next, let's take again magnitude of say 8. So recently Japan में हुआ था, Japan 0 deaths again, no fatalities at all. Whereas if the same magnitude 8 happens in India or Delhi, आधी population साफ हो जाएगी दिल्ली में, crores of people will die, like 1 to 1.5 crore people will die. So within the country it will differ, okay, and across the countries also it will differ. So that's why it is highly subjective, region specific, country specific. Therefore, country like India applies Richter scale. So India will be applying this. India will go for this. But the countries like Japan will be going for Mercalli scale. Because the Japan, okay, the administration, the people want, okay, to pay for the losses. They are very sensitive to any of these things. So that's why they will be going for Mercalli scale. So in a country where you have uniform development, or sensitivity, so those countries will be going for Mercalli scale. So बाकी गए गुजरे countries, they will be going for a Richter scale. Understood? सो एकाग्राम, अभी वो वाला चीज़ अभी डिस्कस नहीं करेंगे, नायोडा टेकी के साथ क्या हुआ. So this is about the differences between the Richter scale and Mercalli scale. Any doubts here? Anyone? So as far as prelims is concerned, so they can ask any of these things. See, आप लोग ना ऐसे ही short notes बना सकते हो. So once you read the entire content, your entire geography can be compressed into 10 to 12 pages. पूरा 10 to 2 पन्नी में आ जाएगा. And अब सारे ही subjects का ऐसे ही short notes बना सकते हो. So 10-12 पेज ज्योग्राफी के हो गए, 10-15 पेज पॉलिटी के हो गए. सो आप एक स्पाइरल या एक नोटबुक में सारे शॉर्ट नोट्स बना लो. आप कहीं पे भी जा रहे हो, यू कैन टेक दैट नोटबुक, यू कैन रिवाइज. बस में जा रहे हो, ट्रेन में जा रहे हो, आप वो रिवाइज कर सकते हो अच्छी तरह. देन चीज़ें अगर पूरे एक ही जगह पे होंगे ना, तो इफ एवरीथिंग इज वन प्लेस, यू कैन हैव बर्ड्स आई व्यू, यू कैन हैव अ गुड कंपैरिजन. आपको चीज़ें भी अच्छी तरह याद रहेंगे. You can go for the pictorial representation. You can go for your own innovation, in making the notes. So before the prelims, you guys should be making the short notes. ये कोर्स खत्म होने के बाद डेली जब भी आपकी क्लास खत्म होती है, क्लास होने के बाद जब आप सुनते हो फिर से, उसके बाद अपना अपना शॉर्ट नोट्स बना लेना. So this is about the measurement of the earthquakes. So the topic of the earthquakes is over. So next topic will be the volcanism. Again, I'll be giving a bird's eye view. What all topics should be included under the volcanism? So in volcanism, what all questions can be asked? So one question which they can ask is about landforms. Mostly they'll be asking about the landforms only. Mechanism they will not ask. Anyways, you know the mechanism. Mechanism क्या है? आपने plate tectonics से पढ़ा है. You have read the features of the interiors of the earth also. अगर मैग्मा बहुत ही अंदर से आ रही है, that will be fluidic और silent volcano होगा. अगर जो भी मैग्मा बाहर की लेयर से आ रही है, so that will be highly violent. You can remember this way. कोई shallow thinking है, then वो बहुत violent होगा आदमी. Deep thinking है तो आदमी शांत होगा. ऐसे याद रख सकते हो आप. 10 मीटर, मैंने मीटर तो ऐसे बता दिया मैंने. हियर एम्पलीट्यूड वाइब्रेशन कितना हिल रहा है आपकी बिल्डिंग या क्रस्ट कितना हिल रहा है. दिस इज नॉट मीटर आई हैव जस्ट टेकन फॉर द रेफरेंस. अंडरस्टूड? सो हियर मोस्टली दे विल बी आस्किंग क्वेश्चंस ऑन लैंडफॉर्म्स. आपके यहाँ बहुत गर्मी हो रही होगी, सॉरी ठंड हो रही होगी. मेरे यहाँ एसी चलाना पड़ता है. So mechanism, they will not be asking. Landforms will be asking. So the landforms can be extrusive landforms which have been formed outside. The landforms can be intrusive which have been formed inside. Intrusive landforms. Right? So in intrusive landforms, the landforms can be formed deep inside the earth. Deep. The one which are formed deep inside, they are called as plutonic landforms. Now landforms can be formed just below the surface. Just below the surface. These are called as hypabyssal formations. Hypabyssal formation. So deep inside means, say this is a surface, a surface, and very deep below you have these landforms. And famous example of this is batholith. Because what is the need of batholith? Because above this you will be having various formations. इसके ऊपर माउंटेन फॉर्म हो सकता है, पहाड़ फॉर्म हो सकता है. इफ नॉट एनीथिंग दे विल गिव स्टेबिलिटी टू द कॉन्टिनेंट्स. सो बैथोलिथ है जो बेसमेंट रॉक है, ओके, बहुत नीचे होता है. सो दिस इज प्लूटोनिक लैंडफॉर्म्स. एंड व्हाट आर द फीचर्स ऑफ दिस लैंडफॉर्म्स? फीचर्स क्या है? सो क्रिस्टल साइज विल बी लार्ज. Crystal size is large. They're comparatively stronger. Okay, these are the properties. Now, let's talk about these batholiths. Now, batholiths, I'll go back there again. So, batholiths are there inside. So, over the batholiths, you'll be having mountain. Say after 3 billion years, 3 billion years. So this mountain will be eroded. Mountain will be eroded. So after the erosion of the mountain, so this will bounce back. It's like Earth is acting like a cushion. For example, a sofa है. So Earth का जो surface है sofa है. अब सोफे पे बैठे हो, Earth पूरा नीचे जाएगा. ओके, आप सोफा से उठ गए, माउंटेन पूरा एरोड हो गया. सोफा क्या होता है? सोफा थोड़ा बाउंस बैक होता है, राइट? सो दिस बैथोलिथ विल बाउंस बैक, and this bouncing back phenomena, this is called as isostatic rebound. Remember this word, isostatic rebound. So this batholith will gradually come towards the surface because of isostatic rebound. And these batholith rocks, they'll be exposed, they'll be eroded, and finally they will become mineral rich regions of the world. Mineral rich regions of the world. And these are called as shield regions. Remember this, very important. Shield regions. So in the last class, when I was differentiating the continental crust and oceanic crust, I told you that the Singhbhum plateau, which is there in Jharkhand, Odisha, okay, part of Bengal, I told you it is the oldest. So लगभग 3.5 billion years लगते हैं ये पूरा पहाड़ एरोड होने में, इसको बाउंस बैक होने में. So they become the mineral rich regions of the world, right? Now let's see which all are the mineral rich regions of the world. So I'm making everything at one place only. So these are called as shield regions. So don't get confused between these shield regions and shield volcano. Shield volcano is different from this. So what are all the mineral rich regions of the world? So India mein you have Singhbhum plateau, okay, and in Karnataka you have this Dharwad plateau, or you can also call it as Chota Nagpur plateau. And these regions will be rich in metalliferous minerals. Metalliferous means iron family related. Iron family. Say iron मिलेगा यहाँ पे, manganese मिलेगा, chromium मिलेगा, okay. But zinc, copper, lead, silver, gold, they will be in less quantity. So iron family के you will be getting in more quantity. So manganese मिलेगा, okay, chromium, okay, iron, right, okay, aluminium, okay, these things will be getting more. That's why India has a deficiency of this, okay, the other metals, that is lead की कमी है India में, what, zinc की कमी है, plata, plomo, okay, silver की कमी है, gold की कमी है. But in this, India is very much rich in. Now let's see the mineral rich regions of the world. Now somebody is asking you, right, where all, okay, in the world you have, where all in the world you have iron. आप सिंपली मिनरल रिच रीजन लिख सकते हो. फॉर एग्जाम्पल इंडिया में आपको किसी ने पूछा है, ओके, वेयर इन इंडिया यू गेट लॉट ऑफ आयरन ओर. सो इफ एट ऑल इन मिनरल्स दे विल बी आस्किंग एनीथिंग. सो क्या पूछेगा? आयरन पूछेगा, कोल पूछेगा, पेट्रोलियम पूछेगा. ये तीनों याद रखना, ओके. बाकी अनटिल एंड अनलेस इट्स इन द न्यूज़, ओके, ये तीनों तो स्टैंडर्ड है. सो इंडिया में अगर कोई आपको पूछ रहा है, ओके, सो इंडिया में आयरन कहाँ मिलता है? ब्लाइंडली यू कैन से, ओके, छोटा नागपुर रीजन, ओके, और धारवाड़ शील रीजन. क्रोमाइट कहाँ मिलता है? ब्लाइंडली यू कैन से दीज टू रीजन्स. और इनफैक्ट कोई भी मिनरल हो, ओके, कहाँ मिलता है? ब्लाइंडली यू कैन से दिस रीजन्स. अभी पूरे वर्ल्ड में कहाँ पे क्या मिलता है, यू कैन नॉट रिमेंबर, राइट? सो आई विल टेल यू सम ऑफ द शील रीजन्स ऑफ द वर्ल्ड, ओके. सो हियर इन USA you have Ozark Plateau. Which color should I use? Yellow should I use? Ozark Plateau. So in Brazil, here you have Brazilian Highlands. Brazilian Highlands. So near Venezuela, you have this Suriname, this country is there here. Here you have Guinea Highlands. Guinea Highlands. So this entire region, these are called as the Great Lakes of USA. So this entire region around Hudson Bay, this entire region, this is called as the Canadian Shield. Canadian Shield, right? So this is the Scandinavian Shield. Scandinavian Shield. Of course, in India, you have this Chota Nagpur Plateau, Dharwad Plateau. So here in Russia, you have this Siberian Shield. So entire Western Australia, it's very mineral rich. आपको अगर एग्जाम में कोई कंफ्यूजन हो रहा है, कोई भी मिनरल ले लो, ऑस्ट्रेलिया टॉप 5 में तो होगा ही होगा. फर्स्टली, ओके, इट्स साइज इज वेरी लार्ज, एंड मोर ओवर द वेस्टर्न साइड ऑफ ऑस्ट्रेलिया इज ऑल शील्ड रीजन. इट इज वेरी मिनरल रिच. And since Myanmar is also in the news, in Myanmar you have something called as Shan Plateau, and you have Lao, Cambodia, Vietnam. Here you have Korath Plateau. Okay, here you have Yunnan. In China, in this region, you have this Manchurian. Okay, so here DRC, Democratic Republic of Congo, Angola, Botswana, Zambia. So these are also very much mineral rich, extremely. So here you have Katanga. So these are some of the shield regions in the world, okay, which are mineral rich. You can write all these examples here. So यहाँ पे सारे examples लिख लेना, एक ही जगह पे रहेगा. So next you have hypabasal formations. So you guys must have read, okay, what are the sills, dikes, what, facholiths, lopoliths, okay. इन सब में confusion होता है. Yunnan is in China. So you guys must have come across this. So आज मैं confusion दूर कर दूंगा. So this is a surface, and deep below the surface, okay, here somewhere you have this batholith. ये पूरा batholith है, basement rock है. And below the surface, you will be having the primary rocks. These are called as primary rocks. Or you can also call them country rocks. into. These are the various layers of the rocks. It will not be having one rock, one earth, one layer nahi rahega, different layers rahega. Now, see, this batholith can also be magma chamber. Magma chamber. और that's magma plume. जब अर्थ के अंदर से जब मैग्मा निकलती है, प्लूम फॉर्म होता है ना, सब प्लूम से बाहर निकलता है, right? So when this magma chamber, when it gets solidified, it will be forming the batholith. So from here, you'll have these volcanic eruptions coming out. So from the central vent, from the vent they will come out, and on the surface they will be forming a volcano. Now while this is coming out, if there is a weak rock here, some of it can be solidified here and some of it can be solidified here also. Right? यहाँ से बाहर आके, so it will leak and some of the magma will be solidified here and here. Now this is a lens shaped rock. As far as exam is concerned, only remember this. This is lens shaped rock. So this lens shaped rock is called as phacolith. And these are formed on synclines and anticlines. So this is anticline and this is syncline. Now again this magma is oozing out. Now it can go and fill up this entire depression over here. So पूरा space को fill कर देगा. So यहाँ से magma leak होके saucer, it looks like a saucer. So this is a saucer shaped rock. The saucer shaped rock is called as lopolith. Lopolith. Now when this magma is oozing out, sometimes it will not have much force or energy, it can be solidified here only. Okay? This is undelivered volcano. Undelivered volcano. Any Telugu people here? Telugu guys? Or Kannada guys? I'll tell you a trick to remember these two. So this undelivered volcano is called as laccolith. You can remember this way. Something is lacking here. That's why it is unable to come out. Laccolith. So if anyone is Telugu, you can remember this way. So this is a depression. In Telugu, okay, lopala. Lopala means inside. So something is formed inside. Lopolith. Phaco means lens shaped. Now again this lava is oozing out. Now it can spread horizontally. So this horizontal rocks which will be formed, these are called as sills. Now you can also have vertical intrusion. कभी कभी ऐसे side में चला जाएगा, vertically चला जाएगा. This vertical intrusion is called as dike. Dike मतलब literal meaning is wall. Sill मतलब literal meaning is floor. Floor जैसा दिखेगा. Okay, I'll show you example of these. No, not all the rocks I have, but some examples I have here. We have a rock here. See, so these are the country rocks. So in between the country rocks, you have this vertical rock in between. So this is how the dike look like. Okay. Similarly, the sill will be horizontal rock. Okay. So these are hypabyssal formations. So these hypabyssal formations will be just below the surface. So if I am drawing it here, here. So somewhere in the deep you have this batholith. and here just below the surface you will be having this hyperbasal formations. Okay, and these are all intrusive rocks. So beyond this nothing is required. Next let's come to the extrusive rocks, which are formed on the surface. Now you can differentiate this into various types. Now this can be central vent type. Central vent. The central vent means through a conduit or through a pipe, so the magma will be coming, and then on the surface it will form. Okay, so from the central vent it will come. Okay. Now the magma can also come from the fissure. So this is the top view, and the earth can form a crack here. This is a crack or a rift, and from the rift or crack it will spread on either sides, and this will form extensive basaltic provinces. Extensive basaltic provinces. So can you tell me the examples of this extensive basaltic provinces? This is formed by a crack, or this is rather it is called as fissure type eruption. Can you tell me the examples of this? Iceland, very good. Iceland. Okay, along the MOR only you have this Iceland. What about Deccan Plateau? India's own Deccan Plateau. Siberian traps. Siberian traps or Siberian Plateau. Yesterday you have seen along the Great African Rifting, you have Ethiopian Highlands. Ethiopian Highlands, Great African Rifting. Now these are basaltic provinces. I'll show you the picture here of Ethiopian if you have forgotten. So this is where you have rifting, crack. On the either side of the crack you have these eruptions, Istaraf. Okay. Natal. Yeah, you're very good. Drakensberg. So Drakensberg in South Africa, this is also a escarpment और ब्लॉक माउंटेन. So इस तरफ ना जब अफ्रीका अंटार्कटिका से टूटा है, so when it broken from Gondwana land, so here a block mountain has been formed. On this side of the block mountain, okay, you have the basaltic provinces. Okay, you can say western side of Drakensberg. So इतना example sufficient है. And these basaltic provinces will be having black soil, and these are extremely fertile also. Now can anyone tell me why the black soil has lot of clay content? Black soil is not coarse, clay ज़्यादा होता है इसमें. Clay को हिंदी में क्या बोलते हैं? Why? First class, remember the first class. Because this is extrusive igneous rock, बाहर आके form हुआ है. Instant freezing होती है. When the instant freezing happens, the crystal formation will not be there. So that's why the black soil will be extremely fine. Remember this, this we'll discuss in Indian geography. Now this central vent can be of two types again. Central vent can be of two types. You can have acidic lava. Acidic lava means the magma is sourced from about say 400 kilometers.
You can also have basic lava. If the magma is sourced from about 2,900 kilometers, means deep. I am taking two extremes here. Now, when this, I am taking the same surface here. When this will be oozing out, when the acidic lava comes out, this acidic lava is highly viscous. So when it comes out, it will be forming conical formations, cones. Whereas when this comes out, this will form domes. Dome form hoga. Dome, a cone, remember this. Because this is highly fluidic. Since it is highly fluidic, it will spread. It will spread for hundreds of kilometers. Okay, you can see a picture also here. So I'll show you volcanoes. So we can have various pictures over here. See, tell me this. This is acidic or basic? Acidic or basic? Acidic है, conical formation है. Acidic. See this. यहाँ पे कौन फॉर्म हो रहा है क्या? देखो लावा कैसे फ्लो हो रहा है, पानी की तरह बह रहा है. This one is basic. Now this is acidic or basic? Explosiveness है, acidic है. Acidic है, conical formation. And ये वाले shots जो है ना, आप देखोगे, whenever you have a conical shape, you will be taking a photo or a video from very long distance. आप इसके पास नहीं जा सकते हो. Whereas, look at this shot. ये नज़दीक से लिया है shot. ये वाला दूर से लिया है. ये देखो. This is acidic. यहाँ पे भी कौन दिख रहा है? कौन दिख रहा है? Long shot है. Acidic है. See this. So this is basic. It is flowing. Right? So there is a video, okay, I don't know if I can play it or not. So वहाँ पे lava flow हो रहा है and वहाँ पे वो लोग volleyball खेल रहे हैं इसके पास में ही. Because they know that it will not explode. और पानी की तरह आराम से बह जाएगा. Okay? Iceland may I may be getting it. I don't know I'll be able to play a video or no. So this is in Iceland. I think these are the people over here camping. You see people over here? दिख रहे लोग? I guess यहाँ पे भी दिख रहे हैं. See. इतना पास कोई volcano जा सकता है क्या? So this happens in Iceland. Because Iceland is along MOAR. So they know that it is not explode. So वहाँ पे कुछ धारा बना हुआ है, उस धारे से वो लावा आराम से फ्लो हो जाएगा. So लोग यहाँ पे जाके कैंपिंग करते हैं. आइसलैंड में बहुत ठंड होती है. यहाँ जाके कैंपिंग करते हैं, खाना पीना खाते हैं, वॉलीबॉल खेलते हैं. हाँ, सी इतना नज़दीक से बंदा है, देखो शॉट ले रहा है. So this is highly fluidic. You can see people over here. Highly fluidic. So what I have typed? Volcanoes Iceland have typed. सीधा सीधा ये वाला पिक्चर आ गया. अब वोल्केनो जापान लोगे ना, ओके, आपको दूर के शॉट से दिखेंगे. Understood? So this is the difference between acidic lava and basic lava. One is the cone shape, other is the dome shape. Now, where these are found? Where is the important question. तो जैसे मैं बना रहा हूँ ना, वैसे भी आप भी बना लो. Are you guys making notes of whatever I'm saying? Because your generation ना has become very lazy. आपको सब कुछ एकदम बहुत रेडीमेड चाहिए. हाँ, जब तक आप खुद बैठ के सुन के नोट्स नहीं बनाओगे, आपके दिमाग में नहीं घुसेगा. भाई आपका कैमरा तो दिखा दो भाई एक बार. So I'll also have a feel because I love offline classes. अभी offline नहीं हो रही है. That's why I have to take online. So very good. बस मस्त ठंड में बैठे हो भाई, मजे में. है, You can send your screenshot of the notes also. किसी ने ढंग से अगर नोट्स बनाया ना, आप ग्रुप में स्क्रीनशॉट भी भेज सकते हो. हाँ, Now where these are found? Cones. So these are found along the subduction zones. Again remember your initial classes. Subduction zone में क्या होता है? Basalt is going inside. According to Bowen series of partial melting, what comes out? Andesite comes out. Basalt goes inside, andesite comes out. So dome कहाँ पे मिलेगा आपको? Hot spots पे मिलेगा. Again, you can write the examples of all the hot spots here. So what are the various hot spots? You guys tell me. You guys type over there. Hot spots के examples बताओ. So Indian Ocean में reunion, because of which our Deccan Plateau has been formed. Kerguelen, ये अंटार्कटिक के पास है, because of which Rajkumar Hills has been formed. Okay. If you go to the Atlantic, you have Azores, Assumption, Iceland, Tristan da Cunha, etc. Again, if you go to the Pacific, you have Galapagos, where Darwin has done so many experiments. Darwin पूरा अपना theory of evolution यहीं से निकाला था. Next, land के ऊपर Yellowstone National Park. So if you look at the Yellowstone National Park, so it's in USA. Now why it is named Yellowstone, you know? कोई guess कर सकता है? Anyone will guess? Why it is called as Yellowstone? See, Americans are very simple in naming. वहाँ पे yellow color है इसलिए Yellowstone नाम रख दिया. Right. Why it is yellow in color? Because wherever you have this volcanic eruption, there you will be getting lot of sulfur. Why you will get lot of sulfur? अगर आप crustal composition देखो, osaic है composition, OSAIS, sulfur. Sulfur is in high quantity. That's why you'll be getting lot of sulfur. So wherever you have this, new volcano, emerging volcano, okay, या पुराना volcano है, खत्म हो रहा है volcano, dead volcano almost. So वहाँ पे आपको बहुत सारा sulfur content दिखेगा आपको. Now this Yellowstone National Park is also called as Old Faith National Park, because here what happens is that in Yellowstone National Park, you will be getting this, okay, this one. So these are called as geysers. I mean, जब भी अंदर pressure build होता है ना, पानी बाहर आने लगता है. So this eruption comes out after every 90 or 92 minutes. जैसे कुकर की सीटी बजती है ना, after every interval. So यहाँ पे भी सीटी बजती है. So earlier when people did not know the scientific reason, okay, they attributed to religion. Okay, so that's why it is also called as Old Faith National Park. Yellowstone is also called as Old Faith National Park. So these are some of the examples. Now let's look at other features, other landforms. See, especially where you have the subduction zones, say this is a surface, this is a central vent, say already have a old volcano, say already volcano यहाँ पे है, a central vent है. So whenever a volcano comes, say initially, say यहाँ पे बहुत सारा ash आया, a lot of ash has come, because initially a lot of gases will come. Ash, okay, ash, let's say ash only. Then afterwards, lot of water will come, and this water will be mixed with the mud. The water will be mixed with the ash here, and this water plus mud, okay, this ash, this will become mud flow, and this mud flow is called as lahar. Remember all these terms? This is lahar. इसके बाद you will be getting a lot of burnt rocks.
मीन्स पत्थर, जला हुआ पत्थर बाहर आएगा. Says burnt rocks are called as pyroclast. Pyroclast. And these burnt rocks can be of various sizes. Various sizes. So it can be less than 2 mm. It can be between 2 to 64 mm. It can be greater than 64 mm. अगर 2 mm में छोटा है, जैसे अपना आप पार्टिकुलर मैटर बोलते हो ना, PM10, PM2.5. So this is called as volcanic ash. Volcanic ash. 2 to 64 mm. If it is a P-shaped rock, this is called as lapilli. मटर जैसा अगर पत्थर है, this is called as lapilli. These words you remember. Sometimes they'll be asking, okay, they'll be giving you these words, and they'll ask you to match the following. Okay, so it's a volcanic rock. Okay, say it is associated with earthquake. This rock is associated with earthquake. ऐसा पूछेगा. So they'll be giving the feature on one side. On the other side, they'll be giving the type of the rock. So greater than 64 mm, this is called as volcanic bomb. अब सारे questions भी practice करते रहो. Okay, because you know most of you are lacking. Okay, many of the basics here. I'm teaching all the basics, and every day you are getting the questions also based on the topic which you have done. Please सारे questions okay आप solve करो. Are you guys able to solve the questions based on the class? And after this, the lava will also come. So you'll also have this lava flows. So this is the lava. Now such kind of mountains, okay, these are associated with the subduction zones. These are called as composite volcanoes. Composite why? Because they are made up of various types of materials. Also called as stratovolcanoes. Strata means what? Strata means layer. So they are layered by various materials. That's why they are called as stratovolcanoes. Now, if a volcanic mountain is associated with a lot of volcanic ash, मीन्स वहाँ पे लावा वावा कुछ नहीं होगा, सिर्फ धूल मिट्टी होगी. ओके, सिर्फ ऐश होगा. फॉर एग्जाम्पल दिस सिर्फ ऐश है यहाँ पे. सो दिस इज कॉल्ड एज सिंडर कोन. सो सिंडर कोन इज, सिंडर मीन्स ऐश, मीन्स ऐश ऑन ए volcano. Okay, so these are the various types of volcanic landforms. And some more features. There's something called as crater and caldera. I'll show you a small video of crater and caldera. I don't know I'll be able to play or not. Let's try. If it is getting stuck, don't accuse me. I'm just trying. Very simple 1-minute video, you'll understand it better.
A magma chamber extrudes lava onto the surface.
So the magma will be oozing out. So these are the various layers.
As magma migrates up into the magma chamber from great depths,
so finally the volcanic eruption will be happening. This is stratovolcano. It is associated with oceanic plate subduction. And when the pressure is done, the magma withdraws. The magma जो withdraw हो गया, एक खोखला हो गया, strength नहीं रहेगा, it will collapse. एक caldera बन गया, right? So this is how crater to caldera is formed. Understood? You can watch this video later also. So I'll draw it here. So the top of the mountain it is called as the crater. Okay. So when the crater collapses or when the crater explodes, when the volcanic mountain explodes, so it will form, this is called as caldera. Okay. Now this crater can be filled with the water. This can be filled with water. This is called as crater lake. And if the caldera will be filled with the water, then also most of the time it is called as crater lake. We should be calling it as caldera lake. लेकिन लोगों में इतना शॉर्ट दिमाग नहीं होता है ना क्रेटर और कैल्डेरा में डिफ्रेंशिएट करें, बिकॉज दे आर लेमन. उनके लिए क्रेटर क्या है, कैल्डेरा क्या है, दोनों ही सेम है. वो लोग बड़ा क्रेटर को ओके, एक्चुअली फॉर देम कैल्डेरा इज बड़ा क्रेटर, दैट्स इट. ओके. नाउ लेट्स सी सम ऑफ द एग्जांपल्स ऑफ दिस वोल्केनोस इन द वर्ल्ड. सी माउंट डेनाली, मैं नाम नहीं लिखूंगा, माउंट वगैरह नहीं लिखूंगा. सो नियर सैन फ्रांसिस्को, रेनियर. Here one explosive one is Saint Helena, right? So here you have Cotopaxi and Chimborazo. Ojas del Salados. This is Mount Aconcagua. So Mount Aconcagua is the highest of South America. Highest of South America. Denali is highest of North America. So along the Great African Rifting, you have Ruwenzori. So recently in Indonesia, you had a huge explosion called as Mount Sumeru. And few years ago, you had a very huge explosion called as Mount Krakatau. Mount Krakatau. So Mount Krakatau is between Sumatra, there is an island called as Sumatra, and Java के बीच में, दोनों के बीच में. And of course in India, I've shown you yesterday, you have this barren island. Barren island. Right? Okay, when it comes to Europe, you have three mountains here. Mount Vesuvius, Mount Etna, and you have Stromboli. The Stromboli is also called as lighthouse of Europe because ये समंदर में है. So जब भी a mountain से वो light निकलता है, it will be giving them a direction. So when the sailors are in the sea, they will be able to see this mountain and get the sense of direction. And of course in Japan you have Mount Fujiyama. So these are some of the important ones. Okay, other than this, nothing is required. If at all anything is there, nothing has happened as such recently. And few more 2-3 terms associated with the volcanism. There's something called as mud volcano. So recently in India, okay, in Bharatang Island, you had a mud volcano. So very important features which you have to remember regarding this. So this is associated with subduction sedimentary basins.
Because the Indian plate is undergoing subduction. On this side you have Burmese plate. Burmese, this is Indian. So on the border of this two plates, you have this, okay, this Andaman and Nicobar group of islands have been formed. Andaman and Nicobar. So subduction sedimentary basins. So since it is a sedimentary basin, it will be associated with a lot of methane gas. Methane means CH4. So along with the methane, other gases will also be there. But methane is very important. So this mud volcanoes will not have lava, will not be there. Molten rock will not be there. But they will sometimes, they can have fire. Why fire? Because of methane. The methane can sometimes ignite. So mostly they are associated with the mud and water. Okay. So these are some of the important features. So you can see a picture of this mud volcano. You see the pictures. Mostly muddy रहेगा, lava कहीं नहीं दिखेगा. Okay. So some people also consider this to be therapeutic. मतलब क्या बोलते हैं therapeutic मतलब क्या? दवाई होता है इसमें, something like that sort. So इंडिया में अलो नहीं करते जाना वहाँ पे नज़दीक तक. So this is all okay about your volcanism. I think I covered. If I'm missing anything, can remind me. Any doubts in volcanism? I'll be moving to the next part now. Tsunami. All clear? Chalo, next topic. So next topic is tsunami. So tsunami in Japanese means harbor wave. Harbor wave. That's why you should not be calling it as tsunami wave. Because already tsunami mein harbor wave included. The tsunami name is a misnomer. So harbor wave. Now, what are the various causes of the tsunami? The causes can be anything. For example, there is a meteorite attack. There is a submarine landslide. Or there is a volcanic eruption. So anything can cause. And if a tsunami is occurring in a lake, it is called as siege. See, पानी कहीं पे भी हिल सकता है ना. फॉर एग्जाम्पल स्विमिंग पूल है, मैं जोर से आके स्विमिंग पूल में कूद गया, क्या होगा? स्विमिंग पूल का पूरा पानी ऐसे ऊपर नीचे हो जाएगा ना, राइट? सो स्विमिंग पूल में भी आ सकता है वेव, लेक में भी आ सकता है, राइट? रिवर में भी आ सकता है, कहीं पे भी आ सकता है. लेकिन अगर लेक में आ रहा है उसको बोलेंगे सीच. रिमेंबर दिस. एंड ओशन में ऐसा वेव कॉज करने के लिए आपको बड़ा फोर्स चाहिए. दिस बड़ा फोर्स इज मीटियोराइट, सबमरीन लैंडस्लाइड और वोल्केनिक eruption, राइट? बट द मोस्ट कॉमन रीजन for the tsunami is earthquake. Which earthquake? Submarine earthquake. Submarine earthquake. And this earthquake, submarine earthquake, should be mega thrust. mega thrust earthquake. So mega thrust earthquakes are those earthquakes where it is more than Richter scale 9, magnitude more than 9 होना चाहिए. Okay. Generally more than 8 is also sufficient, but generally more than magnitude 9. Now, again, earthquakes are of various types based on the origin, based on the focus. You have shallow focus, intermediate focus, and deep focus. And the deep focus will not cause, because for the deep focus earthquake, focus to come outside and cause this impact, it will not be having that much energy. Means 700 किलोमीटर के नीचे एनर्जी निकल के अर्थ के अंदर से बाहर आके उसके ऊपर का पानी को ऐसे करने के लिए बहुत सारी ताकत चाहिए, उतना ताकत नहीं होता है. सो अगेन सेकंड कंडीशन इज शैलो फोकस earthquakes. Now where they are formed. So as it is, you have this subducting oceanic plate. On this side again you have this oceanic crust, and this is the continental crust. So this is the CC and this is all OC. So this is the water. This is the water level. Now where the earthquake can happen? The earthquake can happen here because of the friction between these two, because of slab friction. The earthquake can be triggered. So here the earthquake can be triggered. And this is of course the shallow focus earthquake. So when there is, because of this friction, if there is the upliftment of the crust, so the level of the water will increase here. So यहाँ पे एक wave create होगा. Level of the water will increase. And this will be carried forward. So, while you are deep inside the sea, the amplitude is low. So, these points are very important. So, amplitude will be low, say around 3 feet. आपको पता भी नहीं चलेगा. जब आप सी के अंदर होंगे ना, अगर वहाँ पे सुनामी आए, अब जस्ट इसके ऊपर ही हो, you are just near the epicenter, you won't even get to know, because your ship will hardly get any upliftment. But the speed here is very high. The speed will be in the order of around 800 km per hour. Speed will be very high. Okay. But the wavelength, say I am taking rough figures over here. Wavelength is around 200 km. Wavelength. But while it is moving towards the coast, the amplitude increases. It can increase up to 100 feet also. Because as the sea becomes shallow and shallow, तो ये पानी कहीं ना कहीं तो रिफ्लेक्ट होना है ना. तो यहाँ पे तो बहुत सारा स्पेस है. Okay, the sea, the depth of the sea will be acting as a shock absorber. But while this energy is moving towards the coast becomes shallow. And ये land जो है ना, cushion की तरह act नहीं करेगा. Rather, it causes lot of friction. And जब ये wave जाके land से टकराएगा, टकराने के बाद वो आगे ऐसे topple होता है. So this forward motion happens. So because of this, you will be getting this wave called as tsunami wave. So that's why the amplitude increases enormously, to 100 feet. So while moving towards the coast, again the speed reduces. The speed becomes, say, 50 or 25 km per hour. Speed itna decrease ho jayega. And the wavelength, also reduces. This also reduces, say, to 10 kilometers. So you don't have to remember all these figures. These are all rough figures. Now they can ask, what happens to the amplitude as you are moving towards the coast? as you move towards the coast. Amplitude increases, speed reduces, wavelength reduces. You have to remember this. Where most of the people will be making a mistake is here, speed. If somebody is saying that the speed of the wave which is generated in the mid of the ocean increases while it comes towards the coast, अब मानोगे कि सच है लेकिन वो झूठ है. So remember these three. ये भी this is very high level of question. इतना deep नहीं पूछेगा. I guess all of you must have done foundation from somewhere or here. लेकिन आपने ये वाला डायग्राम must not have come across. आपने कोई पढ़ा है ये वाला पहले? Did anyone come across this? If you want to further read about it, there is a website called as NOAA. So NOAA में you have a very good explanation about these things. So I take the references from here only. So this is NOAA. So regarding climatology, if you want any kinds of facts and figures, or regarding oceanography also, if you want any kind of facts and figures, you can take from this website, NOAA. So you can see the depth, wavelength, speed. So speed देखो while coming towards the coast, 36 तक reduce हो गया. Wavelength देखो 10 तक reduce हो गया, right? So this is a very good website, you can refer to this. Or you can go for IPCC reports also. But this is the most trustworthy. Okay. Now let's see some of the other features regarding tsunami. So this is a very high level question. ये सबको समझ में आ गया? समझ में आ गया तो फाइन, नहीं भी समझ में आया नो प्रॉब्लम. लेकिन ये चीज ध्यान रखना, while coming towards the coast the speed increase नहीं होगा. Now some more terms associated with the tsunami. Now tell me, look at the diagram and tell me. So fisherman यहाँ पे कहीं है, कोस्ट के पास है. So this is where your fisherman is. Boat है, fisherman. Tsunami आ रही है. Then what would you suggest to fisherman before approaching tsunami? Will you ask them to go inside the sea or will you ask them to घर आ जा? क्या बोलेंगे आप? What will you suggest? You'll ask them to go inside. Because when they will be going inside, the amplitude keeps on decreasing, the height of the wave keeps on decreasing. So उनको पता भी नहीं चलेगा. Right? Now you might be getting a doubt that, see sir, यहाँ पे इतना speed है 800 km/h. But आप wavelength भी देखो ना, wavelength 200 km है. आपको पता भी नहीं चलेगा. Say after every 15 minutes you will get the 3 feet of wave. After every 15 minutes you will get a wave. But यहाँ पे the wavelength is less. So that's why this will be very frequent. But before a tsunami approaches, there will be withdrawal of the water in the sea. पानी पीछे चला जाएगा. So this is called as withdrawal. Withdrawal. So what happened here is, so in 2004 when the tsunami has come in Indonesia, so along one of the coasts, कोई बच्ची थी, छोटी सी बच्ची, शायद ज्योग्राफी में पढ़ा होगा उसने. So there was a withdrawal of the sea. So they immediately went, because at the time, hardly anyone knew about tsunami, because recent recorded history में कहीं tsunami नहीं आया था, लोगों को पता भी नहीं था. So she went and warned the coast guard. She says a withdrawal in the sea. I think the tsunami is going to come. Then उसने सबको alert करके बाहर लेके आया था. What happened in India? चेन्नई में क्या होता पता है? When the sea has withdrawn, sea का surface जब expose होता है, वहाँ पे shells मिलते हैं, coins मिलते हैं, अलग अलग तरह की चीजें मिलती है. Now out of curiosity, scientific curiosity, इंडिया में बहुत है ना scientific curiosity लोगों को, right? Because it has been enshrined in our directive principles of state policy also. We have to develop scientific temper. So लोग अपना scientific curiosity को satisfy करने के लिए they went into the sea.
okay, and then they died, they perished. That's why having a knowledge is also very important. So the withdrawal, remember this. And whenever a tsunami is approaching, so in case of India, in 2004 tsunami, so this is where the tsunami has originated. This is Sumatra Island and this is Java of Indonesia. They both belong to Indonesia. And somewhere here, you have this Andaman and Nicobar group of islands. Andaman and Nicobar. And this is somewhere you have the Sri Lanka. Now the wave which has emerged from here has travelled all over. So south of this, you have this island called as, this is called as Great Nicobar. The Great Nicobar was affected very badly, and the southern side of Great Nicobar, you had the southernmost point of India called as Indira Point. Indira Point. This Indira Point has been submerged. वो 4 मीटर नीचे चला गया because of the tsunami. And in this Great Nicobar, we are building a lot of projects यहाँ पे. We are building a transshipment terminal, बड़ा सा port build कर रहे हैं, airport भी build कर रहे हैं. We are going for palm oil cultivation also. We will be building a lot of resorts also. छोटा सा island है. And this is one of the only islands in India, or one of the few places in India where you have equatorial forest, very rich forest. You also have tribes such as Shompen types, Nicobarese tribe. These are primitive tribes, PGVTs. They're still into hunting and gathering. And we are going and destroying this entire island. Of course, you have the other viewpoint also. India की development होगा, यहाँ पे ट्रांसशिपमेंट टर्मिनल आ जाएगा, लेकिन ये लोग क्या करेंगे? कोलंबो पोर्ट है, हम्बनटोटा पोर्ट है, ट्रिकोनामल्ली पोर्ट है. सी पोर्ट्स कैसे काम करते हैं पता है? ऑलरेडी उनके जो लिंक्स है, एस्टैब्लिशमेंट्स है, ओके, एंड दे गिव अ लॉन्ग टर्म कंसेशन ऑल्सो. And for this port, for example, you are building a port here, and for this to become a Triconomaly port or a Colombo port, it will take next 50 to 60 years, very long period of time it will take. And destroying the pristine environment, okay, if you want to develop a port, you could have developed here somewhere near Chennai or somewhere, ना? तो यहाँ पे भी डेवलप कर सकते हो. ऑलरेडी आपने यहाँ पे एक डेवलप किया है, ओके, नियर त्रिवेंद्रम में भी आपने एक डेवलप किया है. Anyways, leave that apart. The thing is, if you're building, you are coming up with such kind of infrastructure, and this infrastructure is very near to the subduction zone. यहाँ पे Java Sunda Trench है. Java Sunda Trench है. And this region is prone to the tsunamis, and it can be badly affected. And whenever the waves will be coming, again remember these two terms which we have discussed. If the coastline is transverse, transverse means what? Perpendicular. It will be affected more. Means, see, island ऐसा है, tsunami ऐसे आ रहा है. It will be affected more. Now, अगर ऐसे आ रहा है, so this is a tsunami, and this is the island, and this is longitudinal. So this will be less affected. Okay. Again, remember these two terms, longitudinal, transverse. So they can ask, the longitudinal tsunami will be affecting the coast more. This is a wrong statement, right? So this is all associated with tsunami. This much is sufficient enough. And one of the recent tsunamis, very strong tsunamis, has also occurred in the Japan, where it has destroyed a nuclear power plant called as Fukushima Daiichi. Okay. Now, we have done everything in geomorphology with respect to endogenic. Now, what is left is exogenic. Exogenic is the landforms. Landforms. So, for the landforms, I'll be showing you a PDF document. the document that I'll be sending you, okay, the document will have a lot of pictures and one-liners. Again, this topic is very exhaustive also. So I'll be covering what is there in the NCERT plus recently what is there in the current affairs. I'll be covering those. But the exogenic forces such as force due to the wind, force due to the water, or force due to the river, you will understand better because all these will be acting on the land surface, right? So to understand these things better, you need to understand climatology. Okay. So after the climatology, I'll be discussing this. Okay. So next topic which will be entering is the climatology. Okay. So any doubts you have in geomorphology, you can please ask.